Scandinavia have to have a much larger dish, which is pointed nearly horizontally. So that kind of all comports the idea that wherever you're pointing at is over the equator. Geometry just works that way. Similarly, as I was trying to say earlier on, if you've got a steerable dish, the path of the axial rotation of the dish is aligned to the equatorial plane. In other words, the axle for the dish within inside the bracket is at an angle offset from your plumb vertical wherever you are, which is an equivalent of your longitude position. So, and when you steer the dish, it affects.
I'm sorry.
Okay.
You're talking absolute bollocks.
Yeah. Okay, fine.
I have a question for you, Positive.
Hey, can I ask one last question to the satellite guy? So, what was that?
Why don't you wait until after Napalm though? That way Napalm get his question in.
Yeah.
All right. So here it goes. So now I want to see what things have actually been confirmed to pass through the atmosphere. So like we have, supposed rockets. We have, the Tesla rocket that, kind of arced over the Earth, but we didn't actually see it go through. We just seen that giant light at night. We have things like this, right? And then we also have nuclear bombs. So if we were looking at a nuclear bomb from like say an angle or like above, or even like that volcano tongue escape the atmosphere, but you're claiming things can come in and out of it. So how have we even established that? What if it's some, impenetrable dome that we just can't see?
None of this precludes.
Go ahead, man.
I don't think any of this precludes. But the point I'm making with this discussion is I'm not an expert on other types of space exploration. All I'm telling you is that in all the time I worked on all these technologies, okay, there is no, I can't think of any meaningful way in which the fact that the way they fit, where these signals are sent and where they emanate from when you receive them, comports to any flat Earth mathematically. I can't see that, and on the basis that I know that all the mathematics aligns to what they say is a curve, it doesn't make any sense to try and simulate it any other way.
When you say the alignment, are you talking about elevations and azimuths that you would use to align your satellites?
Your dish, yeah, your dish alignment.
Your dish to your satellite. Is that the only thing that alludes to some sort of curvature when we're talking about azimuth and elevation angles of the dishes?
From a point of view of how it works on the ground, yes. And the fact that
like things in the sky, right? So if I wanted to point my satellite dish at the street light that's 10 feet above a flat surface when I'm directly below it, I'd point it straight up. Now, if I move further back from that street light, the elevation angle I would use for my dish to point directly at that street light would change as I got further away from it. Would you agree or disagree with that statement?
Of course, I'd agree with that statement. Who wouldn't?
Cool. So if we have what appears to be satellite dishes directing themselves over the equator or towards the equatorial region of the Earth, even if you look at it as azimuthal equidistant projection, if there was objects circling or traversing around the area we call the equator, what would be the difference in angling using azimuth and elevation to things that were circling over a horizontal plane in the area we call the equator? Or, what would be the difference between that and if the Earth was curved?
What would be the difference?
Mm-hmm.
Well, if you looked at the mathematics of elevation to If you look at the mathematics of working at the elevation of your perspective on something it's at altitude as you move backwards on a flat line, it doesn't comport with the mathematics is used for actual dish alignment.
So can you substantiate that? Meaning, what relationship do you have in degrees of drop over the distance?
Your elevation angle for a satellite dish is equivalent to your latitude.
Right.
Okay, so it's straight up at the equator.
Which
if you're
isn't necessarily the case, and I've gone through this with Matthew Learns, because we've gone on Google Earth and we've looked at satellites in cities, satellite dishes in cities on the equator.
Yep.
And that claim that they all point straight up is, first of all, patently false. But aside from that,
sorry,
go ahead.
yeah, you're right. I'll recorrect that. If your dish is fixed to a satellite dish, so a satellite which is at your longitudinal, which is geosynchronous above you at your longitude position, it will be straight up. When I align a dish, say at 19.2 east from where I am, clearly it's not pointing directly as the elevation. It's kicked off to 19.2 degrees east from 19.2 degrees from the direct south, and it will actually tip. As a consequence of me aligning it, it will actually tip slightly off to one side because like I said, the angle of the pin for the axial mount on the rotational axial mount on the dish is aligned with the equatorial plane.
Mm-hmm.
That doesn't make any sense on a flat Earth at all. Trust me.
Trust you? I mean,
Well,
I've just
you don't
given
have to
you an
trust me.
example of.
You don't need to trust me.
If
Actually,
you
go and
have
look at the
something.
mathematics.
Yeah, but Pazza, you
You're
haven't
talking over me, bro.
established the Earth
Let me
to be
say
a
that.
globe, Pazza. So everything
So
you said, Pazza, would only work if the Earth is a globe, which you haven't actually established, and you haven't established and verified that the satellites that you claim are up there are there whilst the Earth is spinning. There's nothing you've said has confirmed anything. That's why I object to everything you said. It's a begging the question fallacy
It's
and
not a
affirming the
begging the question
consequence
fallacy.
fallacy. That's all you're doing. That's what you're doing. You're begging the question and affirming the
well,
consequences from
Jen,
your
it's a
fallacy.
conflation of just like the idea of celestial navigation and thinking that the stars can only move in the sky in an arc because the ground that we're standing on is an arc as well. When we know from just very simple observations that we see things in an arc of vision.
Oh my
That
God!
doesn't make sense. That's meaningless in the context of what we're talking about. The mathematics behind aligning your dish is modeled on the globe Earth.
No, it uses the same azimuthal grid that the celestial navigation would use, which isn't based off of a globe Earth. It's just it's a drawing
It does nothing of the sort. It does nothing of the
celestial
sort.
sphere down to the
No,
surface and
it
equating
doesn't.
that the curvature of the celestial sphere is somehow the surface in which we stand upon.
Have you looked at the mathematics of satellite dish alignment?
Yeah, so if you can give me the mathematics where you take into account the perspective change that those satellites would have,
Oh my
and
God! Come on.
the change that you would have due to the curvature of the Earth. So you would have to factor in a curve and or degrees twice, not just once within your mathematics. Do you do that?
You want me to come up with an equation that just comports to what you just said rather than reality?
No, I'm asking if that's what takes place, because if we lived on a curved surface, right? So
Perspective
that would
is
be
geometry.
a change that we would have to take into account, as well as the fact that things present themselves in a curved pattern based on how we view the world in perspective, right? So when we have two curved, what we would call a surface below us, and then we have a perceptual curve, or the apparent curvature of the sky above us due to how we view in perspective. How are you taking into account both of these curvatures, both the perspective curving what we see based on our
There's no such
distance, as well
perspective.
as
There's no
the
such thing as
surface?
perspective curving. There's no
God,
such
so
thing
many
as perspective
words.
curving.
I'm sorry if too many words is confusing to me, Xanac.
No, not for me.
I was having a conversation with Paza. If I can just finish it.
We've talked about these angles to the certain object in the sky and how it comports with reality, and how we need to take perspective into account, because perspective is already taken into account because of geometry and trigonometry. If I look at something.
All right. Well, before Xanac comes in, Pazza was going to respond. I mean, I understood exactly what Napalm said, so I don't know why Xanac's scoffing. I understood exactly what he said.
Because he doesn't want the conversation to go that direction. That's why.
Yeah, I mean, if you have an XYZ like axis, like a hemispherical field above you, XYZ, that your field of view, how are you deciphering between that perspective field versus the actual curvature of the Earth in terms of the alignment of these satellites to somehow isolate that it's curvature of the Earth that is indeed the case?
Differential geometry,
Hold on, it was for Pazza. Maybe.
Oh, sorry.
I'm not trying to say that I was completely summarizing what Napalm said, but I was kind of giving a bit of my interpretation in a sense.
Yeah,
so
there's an arctangent there's an arctangent component to the elevation calculation that's used in these equations. I haven't got it to hand, but I can dig it out for you guys if you want to. You can go through it. But effectively, it is a set of the equation presumes a geometric model, which is a globe Earth of the radius presupposed. It also is giving you line of sight to something on an equatorial plane 22,000 odd miles above the surface at a certain longitudinal position based upon your longitude and latitude and your altitude. Okay. Now the mathematics behind that is freely available and you can look at it. If you can shoehorn that into a meaningful sense from a load of positions on a flat surface, and by all means demonstrate it. No one. I've never seen anybody manage to do it.
Because it can't be done. It's quite simple.
Well, that's that. Yeah. If it can be done, let's do it.
Right. I agree.
The problem we are not measuring curvature here on Earth. We're not measuring that curvature.
We are.
So all those mathematical formulas you gave us doesn't represent the reality that we live.
Differential mathematics does this because we know if we move across the surface, if these things we see change their angle and the angle follows spherical geometry rather than planar geometry, then you know that the surface has to be curved. And that's exactly what we see.
But why is it we're not able to measure it though?
We do measure.
Why are we not able to measure the curvature here?
Hey, can we let Napalm respond?
Yeah, so that's not the case, Xanac. That's a assumption based on the mapping of the stars that was done a very long time ago, right? So we know that we have a relationship to our grid that we use for mapping and the celestial objects, right? We know that there's a relationship there. And within celestial navigation, we call that the celestial sphere or the celestial dome, right? Which can only be within the observer's viewing field. So do you know how much of the sky in square degrees you see visually?
With what equipment? Your eyes? Telescope?
Your eyes. Yep.
I don't think that
an
matters.
observer with their eyes.
I don't think that matters.
Square degrees, yeah. Do you know?
It's just where you see the object, and the math gives you is related to your position on the ground, not the position of the celestial body or the satellite. It's related to your position on the surface.
In relation to the things in the sky, would you agree?
You're moving across the ground is what changes the numbers.
Is what changes how we perceive the sky, right?
Satellites aren't stars. They aren't anywhere near the proposed distances of stars. They're at a nominally defined height above the equatorial plane. They're above the equator.
Sure. So the mathematics for the satellites, do you have that available to be able to drop it, and I can look over it at some point?
I'll try and dig it out for you.
Cool.
I worked in this.
Now, Pazza, you do have a problem, Paz. Is that here on Earth we're not measuring curvature here on Earth? We're not measuring the surface of the Earth is not curving. We're not measuring that curving.
There is no casual observation of curvature on the Earth from the surface. Agree?
We're not measuring it. We're not seeing it. So everything you said that doesn't represent the reality that we live on the Earth's surface. That's what I'm saying. There's a disparity there, mismatch. Something's wrong. The Earth we live on, which is the actual evidence to hand, or should I say to foot, isn't measuring any curvature at all. But yet your equipment is reliant on Earth being a
It's not
globe.
strictly speaking.
That's
There are
that's what you're
evidences.
stating.
There is a range of evidences which you can evaluate each individually, and that's fine. If you want to do that, that's fine. Geodesics and ground surveying.
No, that's not satisfactory. That's not
Yeah, fine.
satisfactory for me. The hang on. The Earth itself must be a ball. Earth must be equipment to begin to even work and be substantiated in any way, shape, or form. If it's flat, then your equipment is just gone. Your whatever you've said for the last 30 minutes that I've been listening to, 30, 40 minutes, is all null and void. Because the Earth itself that we live on isn't a ball. It isn't spinning, it isn't curving, and we're not hurtling through the universe. That's not happening. Do you
That's your
understand?
presupposition,
That's the
Jim.
current
That's your
reality
presupposition,
right
Jim.
now.
I don't know where you're going with that, Jin. If I'm honest with you.
Well, you know where I'm going. You know where I'm going. No curvature, no spin, no ball. Simple as that. And if there's no ball, there's no satellites. All you're talking about, the signals, these are all coming from ground base on
Ground
Earth,
based.
not from the sky.
It doesn't. No, they're not coming
Yes.
from a ground based thing, Jin. They're not.
Most certainly are.
No, they're not.
They
Impossible.
most certainly are. Not coming from
They're not
any
coming from a ground based
equipment
thing.
that is out there. It's not, because one, you haven't substantiated that those things are there. You would have to go there to confirm it. That is the only way you would know.
Everybody's dish,
I
Jin, is
don't give
pointing
a
up
damn
in the.
about the dish. I don't give a shit.
No, you don't give a damn about the dishes, and that's your problem, Jin, isn't it? If you just want to.
Yeah, because radio signals,
You can do that if you want to, Jin. You can say, oh, the dishes don't matter, or where the dishes point don't matter, or where all the dishes across a city, or a country, or a continent point don't matter, and where they all triangulate to when they do point to something. If you want to say, oh, that doesn't matter, that's fine. Right, great. Let's move on. Let's talk about something else.
what I'm saying is that your dish that you're saying that if you move it a certain degree, you don't get a signal. That signal is not coming from the sky. It's ground based.
Fine. If it's line of sight and you're saying it's not line of sight from the sky, fine. I'm not going to argue with you about things that clearly are patently true. It's everyone's dish is pointing up a bit.
They're not patently true because it's relying on equipment. Hang on, it's relying on equipment that is supposed to be in space 22,000 miles out odd. But the thing is, you haven't gone out there. You haven't gone out there to confirm that equipment is there, indeed out there. You haven't established here on Earth that the Earth is a globe that is spinning.
Yeah, but Jen, the signal is coming from. But Jen, the signal is coming from those areas of the sky. I mean, I've set up like satellite internet systems, like not like in a professional way, but just for our own use and whatnot. And you do have to aim it at a particular part of the sky for sure. You have to align it with their systems and what they claim, the positions of the satellites they claim. If you're going to connect to one, you have to target it pretty precisely to that region of the sky. So. Doesn't mean it's coming from a satellite, surrounding a globe in outer space, but it does seem like that signal is coming from that section of the sky.
Yeah,
well, that's what I used to think myself. I used to put satellites in Crystal Palace, okay, and I used to think that it was coming from a satellite. It wasn't until I was a flat earther that I realised that we were aiming at telecom towers in Crystal Palace. We weren't really aiming at a satellite. You see. So I used to do that myself.
I'm going to dig out the equations now because I've got them somewhere.
Why can't they come from the sky, Jen, and still be over a stationary planar Earth? Why does it have to be?
If they're coming from the sky itself, it must be either bouncing, okay? Because the problem is we haven't established the Earth as a globe. That's the first thing. So that's definitely a flaw in their ideals. Okay, now if it's coming from the sky, then it's being bounced off the dome or whatever. It's because I'm saying that there is no satellite equipment that's out there hovering floating
But Jen,
around, giving us
what
signals.
what you
That's
have
not
to do
there.
now, Jen, is find evidence that these frequencies that TV broadcasting comes in at are able to bounce off the atmosphere.
Well, I mean, it's been documented that they were doing that during the Second World War, weren't they? You know, from Hawaii,
Low
apparently.
frequency,
These
Bouncing
specific
very
signals.
low
That's
frequency.
what they said.
Yeah.
So that's what they were saying then, you know. But the thing is, that's all happening on a flat Earth, is what I'm saying. I'm saying to you that the only way you would know if there's a satellite up there is for you to go up there to check that it's there. I'm saying to you, it's not there because it goes against natural law. It's not geostationary on the orbit of the Earth. These things are not true. Haven't been proven. There's no everything you've said hasn't been validated. It's just been said. The story.
I thought you said you were sending all the rocket builders to Slackers Island.
What I would do if it was a Gintopia, of course. I mean, this stuff wouldn't even be talked about. This would be a joke in a program you'd be watching. We'd be laughing. Comedy. This would be the comedy hour stuff because it's not real. And just think they used to think they could go to space. Ha 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 ha. As in the astronauts in space. You know, it'd be a comedy thing like that.
I feel like the conversation is taking 10 steps backward. That's what it feels like.
Well,
I agree,
yes,
Lovely.
and it needs to. It needs to take 2 steps backwards so we get a clean grasp of what's going on. Because I think it's running. It's got legs and it's running well into fantasy land. I'm bringing it in. That's what I'm doing. We're reeling it in. Yeah, of course, it's taking a few steps backwards. That's what
You say that, Jen, but then you're proposing a dome, which you have no specific evidence for, right?
Well,
and you're trying to
antecedent
dismiss
to having
the
air
fact
pressure.
that satellite dishes get pointed in specific directions and receive signals, right? So instead of actually like addressing the concept, you're taking it off into, well, it could be a bouncing off of a dome in this specific direction and blah, 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 with no, like you're literally taking it into speculation land just as much as the Glovers. Completely.
Yeah, reason being, it's been said, I believe, this is just something that's offered up there, purely speculation. I'm not saying it's a thing, but this is what was said during the Second World War, Hawaii and everything else. They were bouncing signals off of the stratosphere or whatever. They said that, didn't they?
If I may, Jin, I've just put a link to a site called Sat Beams. There's an absolute load of these things out there that give you the information about all the, should we say, alleged satellites, what their longitudinal position is, what cluster they're in. You can click on any one of them; it will tell you all the signals. It will tell you all the signals you'll get and the bouquet content, even the programs, radio programs, and data transmissions from that particular transponder. There's sites that give you alignment metrics which tell you how to point it at that dish. If you're fortunate enough to have a steerable dish, they are quite fun actually, steerable dishes. You can get to have a meter dish on the ground. You can pick up an absolute ton of TV. Sometimes you can pick up free sports that aren't designated for your area if you're crafty. You can get porn. You can get anything you want.
I know people who do that all the time. But the thing is, what I'm questioning is, of course, the actual satellite that's sending you the signal that's coming from.
Of course, and if you let me finish, that site I just gave you, it will give you the coverage areas for these signals. And if you care to plug that satellite into that coverage area and try put the eastings and northings and altitude of some towns or cities in that scope, you'll get the alignments for those dishes. And if you then care to propagate them back into a flat map, you won't get anything that lines up. I don't think.
Yeah, that's because we're living on a flat plane and your equipment is just not up there. You've said
it's definitely a line.
Hang on, now you've said your stuff. Let me say my stuff now. What I'm saying to you is that everything you said can be written down. That's fine. Can we prove it? Can we actually prove that the satellite is actually in space sending the signal down? That's what I'm talking about, the hardware. I'm saying everything that you're saying is happening here on Earth. It's not happening from space. So that's what I'm saying, because clearly people are receiving signals. The equipment is working. I'm saying it is not coming from the stars in space at all. That's not happening.
It's coming from stars. It's not coming from stars, Jin. Not coming from stars.
You said 22,000. You said 22,000 miles.
Yeah, that's not where the stars.
That's a long way. 22,000 miles. That's a long way from the Earth. 22,000 miles is a long way. We don't have anything out there. Okay, that's what I'm saying. We do not have that. Would denote that Earth is a globe, but Earth isn't a globe. We know we're living on a flat stationary plane. That's the first thing. Then we would need to go up there to see those satellites to make sure they are indeed in the place that they've said. We can't do that. We can't validate that. You've never validated it.
Or what you could, well, you say that, but what you could do is you could look at the cumulative triangulation of line of sight telecommunications to surmise whether you are actually all pointed in a coverage area at one thing and where it's likely to be and what its altitude is. You can propose signals being bounced around.
It's still not enough. It's just not enough, though. It's not
I know
enough.
it's not enough.
Because
It's
of the
not. I
technology, because of
understand.
the way.
Jin,
Listen,
Jin.
because it goes against natural. Hang on, it goes against natural law. That's the first thing. That's why I'm questioning it, because it goes against what I know is natural. These things cannot happen. It's impossible. So we would need, for me, we wouldn't, and I understand this. We would need to go to. I want to go there and see it, touch it, take a picture, selfie, and send it down. That's what
Lord.
that's the only way I'm
Fucking
gonna know.
hell.
Yeah,
You'll
I
never
get it,
know,
Jin.
Jin.
I know. I
No,
understand that.
I do know they don't exist. I know they don't exist. That's what I do know. Thank you.
Yeah,
I'll never know that they exist because I know they don't exist. Thank you.
Jin, we did for the sake of the room, we understand that, and you've said it before. Unless you went up there and you read a plaque on the side that said this is a satellite, you wouldn't be convinced. We understand that, Jin.
Yeah, satellite owned by whoever the owner is. Yeah,
Of course,
exactly.
yeah, of course, and that would be enough for you. I understand that, but between
That's
your
the only
position,
standard that I would accept.
no, Jin, and we understand that's your standard. We get that, Jin. Yeah, but between your standard and everyone else's standard, there is a bit of a distance.
There is, most certainly is. Most certainly
8
is.
inches per mile squared.
The distance of fantasy and reality. That's
Does
what that
Geo,
distance is.
Napalm, or
I'm
Noah, or
firmly-
anybody else have any more
firmly
questions?
in the realm of reality, boys and girls. You're in the realm of a fantasy that you think that things can float in space. It's just impossible. Impossible to replicate. That's why NASA took a massive risk sending astronauts out to space, if they did. When we know they didn't, because that would be an adventure beyond belief.
I mean, I
Take a
would
massive
talk a little
risk,
bit
Jin?
left lane, but
Jin, did they take a massive risk, or were they pretending to take a massive risk, Jin? Come on.
Well, that's what I'm saying. I know they're
consistent.
pretending. They're pretending it would be, but I know that we know they never went. We do
So
have
they
a
didn't
man
take
by
a-
the name
so
of.
they're not
Hang
taking a
on, let me
massive
get it
risk,
right.
are
Let
they?
me get it out there. Let me get it out there now.
Oh, Jin, hold
Yeah,
up, Jin.
we do have
There's
a
a
man
super
by the
chat.
name of. Let me get it out there now. We do have a man by the
Coco's
name of
birthday.
Cyrus Eugene Akers,
Come
right?
on, Jin.
Who was a Air Force police officer for the United Air Force, working at a place called Clovis, spelled Clovis, New Mexico,
Policeman.
at Cannons Air Force Base. And he
Can
was
we go to
there
questions and
to
answers?
oversee and secure the moon
Q&A.
landing
Oh.
hoax.
It's
Okay?
Jin, we
been
have a
going
caller.
on for
We have a
6
caller.
There you
hours,
go.
man.
Yeah,
Everyone's
Jin, maybe
talking.
we got you, Jin. Maybe could you take a break for a bit? I think some other people want to get in. Go ahead, Rakia.
We gotta get this train back on the track.
Yeah, let's light train.
no trains, bro. No trains. We don't need to go back.
And anyway, that's that's what I'm presenting really. It's line of sight technology, and if you extrapolate all of the information, it all lines up to being a globe basically. Even the delay differentials between the signal uplink and downlink signals, they all pretty much line up to the distances involved.
Even though we don't live on a globe, even though we don't live on a
Jim,
globe,
we get it,
we
Jim.
line up on the globe, yeah? Okay.
Well, Rocky, I don't know if you had a question, but what I was going to ask Del Pazza, I mean, okay, so coming from the perspective that the Earth isn't a globe, obviously there's a group of entities who are running the deception, and therefore, doing the imagery that NASA's putting out, the kind of media company of NASA, and obviously being connected through the military and so on. So the whole GPS system and the satellite system would be ultimately run by the same entities, run through their systems. So of course they're going to model it to fit a globe, and they're going to sell it as a globe in that sense, in terms of like the timing and the signals like you were just describing. So in terms of like thinking outside of what they're showing, I guess my question to you, is it possible in your mind that there's any way that they could have communication devices in the sky that are built within a particular system to sort of portray a certain model of the Earth, but are programmed to do so? Meaning, like they're being spoofed, essentially, like an electronic, spoofing, where there can be signals and systems that are not actually authentic to what they are, but are being modulated, almost like a video game, or modulated in a way to portray a different story than what actually is the case.
I can't contrive anything that would do that. I mean, from a point of view of from the point of view of the line of sight topology of the signal, I can't think of anything. You'd have to have something massive. If you got like London or England, and every dish is pointing to what would be, if the mathematics is correct, 1 point at the distance we're talking about, then if you go up, say, so you've got all these dishes which are aligned in that conic topology in an area of 300 square miles on the floor. If you go up to a height of like several hundred miles, the scope of that conic that conic range of lines is still quite vast. So you'd still have to have something which is, whatever you'd have up there would have quite a job to synthesize something equivalent to that direct line of sight to that point. I'm not saying it's impossible. I can't, what would that be? What on earth would that be?
Yeah, I think I know what you're saying. Yeah, if you have like a triangle, if you're triangulating something, if it's closer and local, then those angles are going to be different than it would, if they were far out.
Imagine an ice cream cone, effectively, an angle plonked on the surface. And there's a point at where it meets somewhere up at high altitude. If you cut that ice cream cone halfway down or 2/3 of the way down, you've got a big circle of something which has to transmit what looks like lines that look like they're propagated from a long, long way away. That's quite complicated. Secondly, a lot of the B-Sky B signals, I mean, those were built by companies like Astrium, like big corporations on the ground, granted, with loads of tech and loads of engineers. They were then payloads on, some space agency equipment, but like Ariane is not necessarily directly aligned to space agencies. You've got a big, vast group of people involved in like manufacture, uplink equipment, downlink equipment, verification equipment, payload equipment, the payload transition equipment, the satellites, the rockets that put it up there as well, the launch sequencing. I mean, there's an awful lot of stuff that has to be deceptively constructed. It is.
Well, yeah. Well, Bill Casing alluded to that, didn't he? He said everything is compartmentalized. I posted a video a little while ago with the ex-NASA contractor, Cindy Holland, explaining exactly her role in working in NASA, and they all have badges and color-coded, just like the military. It's all sectioned off. Only those who need to know are.
Yeah.
Jen, I muted you. Sorry, Jen, I muted you because Gio was having a conversation, and then you just got in there and just started monologuing. Please wait your turn. Everybody said, please give him take a break. Please take a break.
There's an awful lot there. This way, you got to really.
No, I don't disagree. It would be a big network, but I mean, after the Titanic was sunk, they got control over the Federal Reserve. So at that point, whoever those entities are basically have infinite money. So what I mean by that is that like money where you have like, let's say a bank account that has just infinite digits. So you could just buy anything you want. You can go buy 50, yachts, $50 million yachts if you want. So I'm just saying with that type of scenario of that, having that kind of those resources financially, World War I, World War II, and then the development into the current sort of industrial military complex to where a lot of these communication devices and, the kind of space exploration claims and satellite and all of that would have had tremendous funding behind it. I mean, way bigger than Jeff Bezos or Elon Musk or whatever, so.
Sure. Be gigantic amount of money. But I mean, ultimately, think about this. All right, I get what you're saying, but if you think about it this way, they control all the purse strings. Okay, and at that point, all of our TV and all of our radio and all of our telecommunications is ground-based and it is traversing through aerials across the surface, and everyone's completely convinced by that, and everyone's happy with that. Yeah. Why would they go? Why would they go to orchestrate an enormous pantomime? They could at that point say, "Oh, we've evaluated space, and the moment anything gets above the height of 400, 500 meters, 500 miles, 1,000 miles, okay, right? It disintegrates. There's some sort of like X wave, call it whatever. They could tell us what it is from the sun. Everything disintegrates. No one's in a position to refute that. No one's in the position to verify that. No one's in the position to even doubt it. It just becomes the boundary. Yeah, they could have done that. In which case, they wouldn't have had to do any space agencies, any pretending of anything like that. They could just say, "Oh, we got that high, and it's that way." And by the way, the Earth is round. Why? How? No one would be in a position to doubt them, would they?
Yeah, that's what they should have done.
Well, that's kind of a complex. Okay, you're saying that the Earth would be a sphere, but then they would have just claimed, "Hey, we can't get up there. There's some kind of boundary. There's some limit." The problem with that, though, is that if the main agenda is to push the sphere, the globe Earth, I think there's many reasons. One, if there's more land that's being hidden from us and more resources, that would be a huge reason to push the globe deception, because the globe is a limited thing. There it is. It's a ball. We see these continents, little ice on the top, ice on the bottom. That's it, guys. This is your Earth. Don't worry about going to space, because it's really hard to do, and we're the only ones doing it. SpaceX and NASA and these other space agencies are the only one doing it. Now we can get into the whole thing of civilian space travel and whether that's legit or not. But I'm just saying, like, in general, they're the ones going to space and probing and doing that. So, we aren't really in that journey. Yeah.
If they were pretending, this is what I don't get yet. If they could have, if up to the point when people believed it was round, and that's good enough to see people to not go in and look at these distant lands that are valuable to them, nothing's changed. No one's going to the ice walls in the south. You don't need to.
Can't.
You don't need. You wouldn't need to go to the space pantomime and in the space program pantomime.
I mean, the last part of it. Well, I mean, I kind of think the last part of what I was.
Can I interject with something?
Well, hold on.
No, Jen. No, you may not.
Hold on, Jen. Well, I was just saying the kind of conclusion part of it, though, is that if the space story is essential for the globe story, and if the globe story is like the main dynamic in which they're controlling people by, and et cetera, then the space story would be essential to that. Because now, hey, look, we're out here, we're the James Webb Telescope, we're over here, we're over there, we're probing, diamonds on Jupiter and all of these different components. So the space story then becomes like the essential fuel for the deception.
In the post-Copernican era, you had all the academics wrapped up thinking it was a sphere. So clearly, before the space program, before the technology of that era, they had it all wrapped up anyway, didn't they?
I'm not convinced by that at all. I think that even in the 1800s, the globe idea was being fiercely rejected by if you want to call it mainstream science at the time. You look into Michelson, Morley, and all of these. Well, there's Michelson, Morley, and a lot of other things that were happening around that time. I don't think they had people convinced at all, even in the 1800s. If you walked up to someone on a street in the middle of nowhere in the 1800s and say, "Hey, do you live on a spinning globe in outer space?" What would their answer be? Why would they believe it? There was no theories of gravity at the time. There was no pictures of it. There was no reason to think that was the case.
But you had everybody wrapped up who had any influence in the way things are done. Doesn't matter what the man.
What you're saying is what you're saying there, Paz, is the controllers understood that it was this quote unquote globe, right? And perpetuated that idea down to the peasants eventually, and then got the peasants convinced that we're on a globe, and then started laundering a bunch of money from them, convincing them that they're exploring space or some shit. I mean, there's a plausible concept there. But my thing is, all these conversations that we're having, and it seems like, you want to talk about satellites or we talk about celestial navigation, all these quote unquote globe proofs as it relates to the angles that we perceive things in the sky somehow being qualitative proof of the surface below our feet, I think is just utter nonsense. It's like we throw out.
That's fair enough. But if the people who evaluate the geometries don't think that's the case.
So here's the thing, though. When you say evaluate the geometries, so there's multiple geometries that I guess we're evaluating. which portion of the geometries is spherical? Are you taking into account 2 spherical surfaces within your equation, or are you taking into account 1? And if you're taking into account 2 spherical things within your equation, can you point to me both of those spherical assumptions within the equations?
No, you are dealing with the 3D geometry of an entity at an altitude which is described perpendicularly to some surface. If the surface is flat, there is a geometry of your elevation and its position relative to your position on the surface, and your contextual height on nominal contextual height at that surface, and you can formulate equations and you can extrapolate what the behavior of the changes in those angles are as you traverse around that surface. When you look at the equations that you're required to do that. So when you look at the equations you need to do.
Go ahead.
So if you look at the way those equations actually comport to spatial change around the surface on the flat model, and you look at the spherical model, one of them aligns to the mathematics we use for things like what I've just described, satellite observations.
So within satellite observations or even celestial navigation, is there any confirming from 0 to 90 that all of those subsequent degrees do in fact equate to a perfect 69 miles?
It's not
from
perfect,
0 to 90.
I believe it's not. I believe it's not perfect because there's an obliqueness about the nature of the curve anyway, isn't there? But basically, that the fact that there is a near, and I say near because I'm not going to suggest it's exact, a near linear proportionality between your angle to something and the distance you travel in the vector perpendicular to its perpendicular surface position and yours. That only works if you're traveling across a curved surface. It doesn't work on a linear surface.
Well, it works on a flat surface, right? So would you say that
I don't think it does because
the deviation from the assumption would be most exaggerated towards the horizon?
No, I don't think that works on a surface in any situation. If you move towards an object at altitude, and the rate of change of elevation is linear in reality, it wouldn't be non-linear on a flat surface.
You say it's linear in reality, so can you give me an example of this being mapped out with like the stars?
Sure. I mean, if you stellar cartography and celestial navigation has encapsulated the change in distance on the ground against a change in elevation of something as you move towards a GP, and
I would
demonstrate
say that it's fairly close from 90 down to about 30 degrees, but then you start seeing vast differences that they have to take into account corrections because it starts to fall apart. So when you say it works perfectly on something like celestial navigation, that's just not a correct statement.
Of course. So let's take away the I'm not sure what it is 30 degrees, but let's take the 90 to the 60. Yeah.
Mm-hmm.
If you're directly underneath something and you start moving in any direction away from that GP, yeah, that's actually when it's most pronounced. The angular changes are most pronounced when you're underneath it and moving away, not at the other end anyway.
If it's a closed object, right?
Sure. Well, if it's an object if it's a close object, or it's an object even as in a meaningful range. But if you do that on a linear surface,
what do you mean meaningful range? Can you give me what a meaningful range is? Because you said that with such confidence, as if that's some sort of refutation.
Let's suppose the object in question is 1,000 miles up, yeah, and I'm directly underneath it. I see it 90 degrees above me. In reality, if that was the case, and something is 1,000 miles up, and we move 1,000 miles in a straight line in any direction, we know the elevation to that is 45 degrees.
Sure. So let's say it's a point source of light, right?
Yeah.
And let's say that point source of light is something like 4,000 degrees, or I'm sorry, 4,000 miles, or 10,000 miles away. If that point source of light that's 10,000 miles above us, if it moves 3 miles, would we even be able to see that change?
When you say it moves, it's physically moving between my measurements, or it's actually
physically moves itself, not you as the observer, but the object that's 10,000 miles away makes a movement of 3 miles. Would you even be able to detect that movement within that object?
I'm not sure. I won't be able to give you I won't be able to qualify an answer to that because I don't know what equipment they'd be using.
Yeah, because if you think about it, the amount of movement that something 10,000 miles away would need to have in order for you to see changes could be an extreme amount of distance, right? For it to change 1 degree in the sky, it's not necessarily itself moving 60 miles. It could be
sure.
moving 600
Of course,
miles.
yes.
Right?
If it's a very, very long way away and I move across a flat surface, the angular change to it is very, very, very small.
Mm-hmm.
That's a function of either a sine or cos function. It's cosine or sine function, depending which measurement you're making. But clearly, in the world in which we live, that's not the case. These things are a very, very long way away, and when we move, the elevation changes in the proportionality of that, which is consistent across the entire movement. The fact that
it's not consistent across the entire movement, otherwise we would be able to definitively say that holds true all the way down to the horizon. Do you have any confirming evidence that does take place all the way down to the horizon?
No, because down to the horizon we get other distortions, don't we? We know there are massive distortions at the horizon. We can observe things. We can make an observation of something which we inherently know is static, like a mountaintop, at the horizon, one day, which is completely inconsistent to what we see the next day. So we know there is a massive variation at the horizon.
Right. So ironically, the area, 20 degrees above the horizon is not very close to the horizon. But ironically, when we start to see deviations is as it gets closer to the horizon, but then yet we claim that it's a perfect distance incrementally throughout the whole entire travel from 0 to 90 degrees, as if that has somehow been substantiated, but it hasn't, right? So why would you allude to it being consistent if even you know that we can't necessarily measure that to be true?
The bit that goes from 90 from directly above you to say 30 degrees out, and how you move across the surface underneath you, is the important bit. The resolution of the angular change as you move from it being directly underneath you to as you move away in every direction reveals more than it does when it's a very long, long way away and your elevation angle to it is acute.
No, the same can be done for a flat surface and what we would consider a celestial sphere above us.
It doesn't
if
work.
we measure the change based on elevation angles, right? We're taking azimuth and elevation angles to these objects. Would you say that an azimuth and an elevation is dependent upon the observer's location?
Well, that's exactly what it is, isn't it? You've got an object you've got an object at an altitude, yeah, and you are measuring you are looking at your elevation and azimuth to it with respect to your position on that surface. As
Correct.
you move,
So we're mapping the elevation angle, which if we took stars, let's say we had a line of stars, or even whatever you would want to take. So we have a line of stars on a specific direction that we look, both east and west. Let's take that as an example. And we have stars that are in alignment directly above us that appear as though they're a straight line going down to the horizon on both sides of us as we turn around. If we were to map these stars and we looked up and we just put a point at every single one of these stars as we went from the horizon all the way up to our zenith, and then we went from our zenith all the way back to the other horizon, how would we map that? what would be the shape of that?
Well, if you're measuring the elevation and the bearing to it, which effectively what you're doing in that respect, and you've got two values, so you're gonna have to use a two-dimensional mechanism.
Would you say that would represent an arc?
Well, the celestial sphere isn't actually a sphere in the sense that it's just a two-dimensional matrices, isn't it?
No, I mean the celestial sphere would be a like a three-dimensional, right? Because we can see all the way around. So if we did that line, but then we faced north and south, and we did another line, and then when we filled in all the lines in between, what would that create? Like an azimuthal grid above us?
Yeah, it's a sphere. It's a sphere, isn't it?
Yeah, yeah. And that sphere that we see in the sky has somehow been put below your feet to convince you that the sphere is below you. So as you walk on the sphere, the things update. When we know in reality that things appear to rise and fall towards the horizon due to what we call perspective and the way that we see in what can be dubbed as an azimuthal grid of vision, meaning we plot out all those things that we see visually in what we would call a dome. And that dome would follow us as we would traverse a flat surface, updating as if it was like a gerbil, the little plastic balls that you can put a gerbil in and it runs around the room. Just imagine that being your azimuthal grid of vision. And every time the little squares on that little gerbil ball, as it moves, it's just updating how the stars present themselves to you. It's pretty simple.
In other words, there's a half the map of stars is below you all the time, like the gerbil ball.
No, it's not below you. It's above you. You just have a limit to your vision.
That doesn't make any sense because when I map the stars, that doesn't make any sense.
So if you were to take this azimuthal grid, right? Mm-hmm. What would you say? And I don't know if I know the answer for sure. What would you say the amount of square degrees of the sky that you could see as a human being at any observer point? So when you go outside and you look at the night sky, what would you say is like the percentage of the sky that you would see, or the amount of like square degrees that you would see?
Are you talking about the field of view with the human eye?
Yeah.
No idea.
As it relates to the blanket of stars.
No idea. Does it make a difference?
Yeah, I don't know. I think it's roughly about 10% of the visual surface.
Sure. They say it's 5. 1. They say it's 50.
Right. So if we can only see that much, like we're limited just solely based off of our limit of vision or our limit of perspective, then to say that those other stars have to be like on the other side of the ground below you is kind of a stretch there, right? Because they can just be out of our limit of view.
No, not at all. The limit of our view and what you see, no. Your instantaneous scope of what you can see with your eyes is not the same as the instantaneous scope of what you can see if you look around in the night. As I look around in the night sky or even the daytime, I'm looking around a room. Just because I'm only looking at one portion of a bookshelf, it doesn't mean to say the rest of the stuff is somewhere else in a wacky position. It's all spatially coherent and consistent. Just because I'm looking one part of it.
Yeah, well, we have a limit to our vision.
Of course,
would you agree or disagree with that?
We have a limit to any means by which we meaningfully try and measure or evaluate the world in which we live in.
Right. So what sets that limit, would you say? What is the principle behind setting our limit of vision?
If you're talking about our eyes, we're duty bound by what the good Lord's given us. But if you're talking about optical equipment, we're talking about the depth of accuracy of equipment we use to manufacture optical equipment.
Well, let's just talk about our eyes, right? Because that seems to be fairly consistent amongst everybody who would be listening or involved in this conversation, right? Like we all understand what our eyes see. So we don't have to even comprehend, various focal lengths or aperture size or anything like that, right? So we kind of know what our human eyes are. So what sets our limit of vision within our human eyes? What principle kind of says this is why you can't see forever and for always?
Your eyes, but the optic construct within your eyes' ability to focus coherently on things at distances, depth of the quality of the resolution of your optical cones at the back of your eye, your brain's processing capability.
Yeah. Okay. And the way that presents itself to us, right? The way the world gets presented to us through our eyes. Typically, we call that like perspective, right? I know there is the idea of the drawing concept of perspective, but we also call how we view the world as our perspective as well.
It's an observational context, yes. If you talk about the dictionary definition, yeah.
Sure. So we have a limitation as to like how far we can see. Things obviously get smaller with distance. Things appear to either rise up or appear to fall down towards our center of our field of view, depending on whether they're above or below our center of field of view, right?
Sure, but even if you're just dealing with things in one plane, as you look at it across it, they can move away into the distance and just disappear altogether, can't they?
Yeah, so we have like railroad tracks below our feet, and as we look off in the distance down the railroad tracks, these parallel lines that we know are parallel appear to converge in the distance. And if we took those railroad tracks and we set them on their side, and we were looking at it from a side view, meaning we had like a bank of lights or something like that, those would appear to get smaller and smaller. And even though we know that those parallel lines don't converge, they would appear to converge in the distance. And that convergence point is what we would call our limit of vision, right?
Yeah, well, it's the vanishing line is what's called in perspective, isn't it? Or the vanishing point.
Yeah. So
But
the same thing would happen for things below us, right? They appear, the ground kind of appears to rise up towards our eye level, right? Even though we know for a fact that the ground doesn't actually ramp up to close to our eye level physically, right? But it appears to fill roughly, just under 50% of our field of view as we look straight out, at like the beach or something. The water will appear to fill roughly just under 50% of our field of view, even though we know the water is not actually rising up, right?
Of course, your optical train has a in its epicenter, it has a vanishing point, and every vector of everything which is moving, or has an visual artifact which moves away from your position radially will effectively align with that vanishing point wherever it may be. So you talk about train tracks and underneath you and the way they disappear. You don't have to turn the train track. You don't have to turn the whole construct 90 degrees. Just turn your head 90 degrees. It's the same thing.
I think, Pizak, you're also missing a pretty important characteristic of that when it comes to things that are in the sky. You think about it a little longer. I don't want to give you the answer. You could try to deduce it, maybe.
Who let this degenerate in?
Who's a degenerate? Me?
Oh, it's a fine.
Did someone mention it? Did anyone mention a train just now?
Tracks, but not the train. The train has derailed.
All right.
It's no longer on the tracks. It has left the station.
But how about things in the sky, Pizak? Is that maybe different? You see something different with them that you don't, that's different than seeing train tracks converge?
Oh yeah, so things in the sky, obviously, depending on their distance, are going to adhere to things that we see on the ground, to the same concepts, or if they're actually outside of our limit of vision, they appear differently. Yep, and those would be like the celestial objects, right? Based on their distance away, they are technically outside our limit of vision. So as those objects present themselves to us, they almost present themselves in a more fixed pattern.
From your position in the center of the 3D space, which represents your visual cortex looking out, every single thing has a property of perspective and parallax based upon its position with respect to you, and they're all geometrically consistent.
Let me give a clue to Pazak and only Pazak. What if you compared the sort of those street lights or the railroad tracks maybe to how we see the moon? Let's just say the moon, for example.
Do you think that those things would present themselves in a similar fashion?
Mr. Pazak, I'm trying to.
Oh, I don't know who Pazak is. Are you talking about Paza?
Oh, Paza.
Yeah, me, yeah. No, they I think they do present themselves in an identical fashion, yeah.
Which is why you guys always get fooled.
You might be missing something there. But I would respectfully disagree, Mr. Paza. But there's something about angular size there. Something about angular size. But
yeah, I think everything we see in the sky as celestial bodies that aren't planets close to us or whatever are just points of light. I don't see how we could apply this perspective to those things.
Sure. So points of light above you, as you move around, are points of light going to change how they relate to you based on your movement, regardless of the surface you're on?
You're talking about parallax?
No, I'm talking about how they would present themselves in your field of view. So if you say there's a point of light directly above your head, do you think that point of light is always going to be above your head as you travel? Or do you think it changes?
Depends.
Yeah, that's the problem right there. It does change, and the relation that it changes to your distance across the ground is the issue.
Yeah, if you travel on a horizontal path, go ahead, Napalm.
I was just going to ask Left Lane, can you present me with real world evidence from 0 to 90 degrees that is some sort of exact direct relationship from 0 to 90 degrees?
Yeah, the closest that I can do with personal experience when this conversation was going on and I was running on the East Coast, running I-75 north to south, I would get out and guesstimate. I couldn't get accurate, but the angle of Polaris over the horizon, and I would drive like 140 miles, and I'd stop and I would look back and measure again, and I saw the relationship of the 1 degree per 69 miles kind of thing.
So based on Highway 75, you would never have a point on Highway 75. I live extremely close to Highway 75. There would never be a point in which Polaris would be below 40 degrees in your night sky. Would you agree with that statement?
Close.
Yeah. So what about from like 0 to 20 degrees? Have you seen Polaris in those positions?
No, I've never been that far south.
Okay.
If you're traveling away, if there's a light above your head and you travel away from it horizontally, that light, barring any refractive effects, would never cross your horizontal line and be underneath your horizontal now.
What kind of clown travels horizontally?
I'm just saying, if you were
on a flat surface, that's definitely the case. It should always be above the line of your vanishing point,
barring any refractive effects, because we actually have. Okay.
All right, of course, barring any of that, because if it's above you, the mathematics alludes that there is an if something is above you on a flat surface, above your eye line, and there is where however far away you go, there was always a component of elevation between you and it. It might be very, very, very near, asymptotic to the horizontal, but it is still there. Whether you can see it or not, or detect it with the acuity of your eyes and your brain, is one thing, but it is always there.
Yeah, perspective doesn't cause things, or the way we see doesn't. I don't think it causes things to cross out. that horizontal line. So
well, draw. If you're presuming that the ground is flat, that's a straight line. If you're presuming that the photons of light emanate from the object, which coincident with your eye, travel in a straight line, there's a line. That's all you need. You have to break one of those paradigms to make it any other way on a flat surface. The angle between two straight lines. That's it. One of the lines is the horizontal. The other line is the line between your eye and that object, presumably at a higher altitude.
I mean, you should have paid attention to what Chronic said. He's basically in charge of what happens in space. So,
not true. Pazza, I gave you a picture in the text chat to try to.
All right. So sorry, I wasn't looking at the text chat. My apologies.
That's okay. Okay, it's at
Hey, Chronic.
17 after the hour. What's up?
I gotta ask you a question when we get a chance, and I'm afraid I might have already asked you. So just keep that in mind.
Uh-huh.
Well, I'll just ask you now. Hey, did you hear about that? It's like a new idea that dark energy might have some relationship with black holes. Like there's a correlative relationship between them. It's like a new finding. You've seen this?
Mm-hmm.
Chronic, I have a question about your image there.
Yeah, I've seen that Kosho. Let me.
Is it a big deal?
I mean, we talked about it in some journal meetings. We talked about both. There's 2 papers. Yeah, it's cool. There needs to be a bunch more work to do, but
yeah.
You
gotta send them.
I'll DM you the papers.
Chronic, do you think that the vanishing point is a optical effect?
Could be. It can be.
So,
it is an optical effect. Nothing is vanishing. Nothing is physically and immaterially disappearing. It is entirely an optical effect.
I agree with that. So, when we're looking at your picture, and we've all been obviously outside and had a field of view similar to this. In your picture, what would you say the distance is that's filling up roughly that lower 50% of that field of view? What would you say the distance to what we would call the vanishing line, where things kind of appear to disappear?
In this pictorial diagram, I have no idea.
Yeah, just like on average, like a 6-foot observer looking out towards like the ocean or something like that.
Depends on what you're looking at. Go ahead, Chronic.
There's refractive effects, like Jeremy was saying. There's, I mean, sure, whatever the, your 1.22.
Why don't you let me field this one, Chronic?
Yeah.
Chronic, why don't you let me field
Yeah,
this
go
one?
ahead.
It depends on what you're looking at, because if we're looking at a building,
say we're looking at the ocean.
I'm not sure how it has to do with the angular size not changing of the something in the sky, but
we're looking out at the ocean.
1.22 whatever, but you have to. But that's it's not a perfect parabola, so there's some modification to it. Blah blah blah, et cetera, et cetera.
We're out at the ocean. We're where B-ball is in Hawaii, whatever, and we're looking at his building. The ocean, you can only see the ocean for X amount of miles, but there could be a building way past that, and we'll still see the top of it.
Okay.
Yep.
That's interesting. Is it not?
It's fascinating.
We talked about this. It depends on what we're looking at. It depends on what you're looking at for how far you're. It depends on what we're looking at for how far you're going to see.
I guess.
We talked about this the other day about how if there's a beautiful woman, a very sexy woman, and if she goes far away enough, just because perspective, you'll only see her torso, just due to perspective. You'll see a perfectly formed torso, arms, and a head. Clearly, you won't see the rest of below her body. And if she goes even further than that, you can only see her head because of perspective. Right? Perfectly formed, no distortions, just her whole body's missing.
Mm-hmm.
Yeah, if I may interject with the satellite thing just for a couple of minutes.
Were we talking about satellites? What?
No, we
Yeah,
weren't talking.
because I wanted to interject earlier with Paz's question, why would they exaggerate going to space, etc., etc.? And Gio did answer the question, but I thought he missed the point, and that was it's almost $1 trillion industry now. Okay, this space exploration now, and we've got some. I'm going to need 2 minutes of uninterruptions here to get this out. I've kept
that. You got
in my
45
head.
seconds.
I'm going to need 2 minutes, so please just give me that time.
45 seconds.
Yeah,
Go ahead, Jim.
just use
I'm gonna
45
need
now
2
and then 45
minutes.
later.
I'm going to need 2 minutes to articulate what I got to say. Definitely. So now, basically, there's some newcomers to the space industry now, the space exploration industry. We got who is it now? We got Israel, we've got India, we've got New Zealand, Saudi Arabia, United Emirates, UAE. Japan is now claiming to be putting something on the moon, a probe, but that's now been abandoned, right? Because they've lost communications with their probe. It was supposed to land next month. Fourth country to land on the moon, scheduled, okay? They joined the Artemis 1 mission last year, November 16th. They took off with Artemis. They separated from Artemis, and it was supposed to go on this elliptical orbit of 1 million miles or whatever and return and land on the moon. That's now been abandoned because they've lost communications. The point is, the question was asked, why would they exaggerate going to space? It's a lucrative business at the moment. And the lie about that's it. That's all I've got to say.
That was 2 minutes right on the dot. Great job, Jen. 2
Okay,
minutes.
thank you.
Down to the second. Let me just get one quick question to Puzza. Did you catch the figure that I was referring to?
The one, the perspective one.
Yes, exactly. Yes.
Yeah,
All of those objects, moving away from the observer, have a very similar defining characteristic to them.
They do, yeah.
However, that thing in the sky is doing something very, very different.
Its behavior, yeah, in terms of the vanishing point, is different, yeah.
Certainly, even before the vanishing point, as it's moving along, its a little trajectory. It's not changing in blank.
If you use a telescope with an optical filter, it's not changing in size.
There you go. Yeah, angular in size. Yeah, perfect.
Oh, or maybe you can't detect its change in angular size.
We have some decently good instruments though, so I might trust the instruments. Yeah, I would trust the instruments over someone's like eyeball or something. Not just for the sun, but maybe for like the moon, maybe for other objects.
Sure. So if something's 1 million miles away, what's the it's moving 1 million and 1 miles away, or 1 million miles away? What's the angular distance change?
Well, I don't know.
I'll wager that's beyond the angular resolution differential you could measure with a piece of equipment on the Earth.
I don't know. Is it? What's your so what is that? If you calculate that difference in position on the sky in angular units, so in degrees or arc seconds or whatever, then I can give you the best instruments we have on Earth that can measure positions within with an accuracy of X, and if that accuracy is of the same order as that distance, that angular distance difference, then I would argue it could measure.
Sure. I don't know what those are though. The point is, if it's very big and a long way away, then it would keep a consistent shape in the sky.
Chronic, how long you got tonight, Chronic?
That's interesting. How long do I got on my shift?
Yeah, how long is your shift?
Hanging out for
Be careful, Chronic. Be careful, Chronic. He's going to ask you about some stupid bullshit.
If it was very,
we're going to go down a 1 hour long
Let me put it this way: if it was very local to you, if it was distance to you was an order of a very near order of magnitude to the distance to your vanishing point, then it clearly would change size.
Yeah, you're saying a lot of interesting stuff right now, Puzza. All this, yes, very, very insightful stuff you're saying. I'm not joking. Yes, you're saying a lot of interesting.
That's the proposition they give us, isn't it? It's fucking big, but a fucking long way away.
Indeed. I got some time, Jeremy. I don't know if I have rabbit hole time with you, but we'll see.
Well, let me know when you get some rabbit hole time, and we'll go down it.
All right, happy to.
Yeah, he's gonna take you on a crazy train. You know what I mean?
Yeah.
No, in the image in question, everything that you can see, which is the telegraph lines, the fences, the railways, the airplanes, they're all reducing in. They're going through a mathematical transformation of reduction in both axes of the field of view, horizontal and vertical, in direct proportionality. In other words, the plane doesn't get. You look at the planes going away. That is consistent to what you'd see, because the plane wingspan in proportion to the height between the wheels and the top of the wing is a fixed ratio. It doesn't get squashed as it goes away. It maintains the same shape topology. It just gets spatially smaller in both axes.
Well, some people would say you're continuing to say a lot of good things in more and more specificity, but I don't know. There's some people that would say kind of, I don't know, magical optical things start to happen at some point. So
they do near the horizon. They definitely
With
do.
what, airplanes?
No, just
well,
with
just
our
anything.
Yeah.
With anything? Who can you give me examples?
Of vision, I think, is the term that is used.
Yeah, can you give me examples of what people would say weird things that would take place?
Yeah, superior and inferior mirages are manifests of inconsistent anomalies at the horizon. Refractive components occur at the horizon.
Tons of optical illusions right around, like literally right at the horizon itself, right?
Yeah, well, I mean, they have a
maybe in some cases, not always, but sure.
I believe they have their most significant manifest effect at that elevation. But clearly, it's an analog system. They don't. If you go up a couple of degrees, it's a snap off and it's there. It smoothly transitions out to a more accurate representation of what you're looking at as the elevation increases slowly.
At least a consistent one.
Yeah. But we know they're looking to the horizon. Forget what you believe about the shape of the Earth. You look at the horizon. You look at a distant mountain across the sea. You look at an island. You look at some artifact. You know you haven't. If you go and visit it on several days and you photograph it, it can look radically different. You know you haven't changed. You know your eyes are the same. You know your camera's the same. You know the light's still in the sun's still in the sky. You know that the mountain hasn't changed its position, and you're not going to come to the conclusion the Earth is flexing underneath you, breathing like some massive geological lung. So there is some anomalous property a variant property of the reality in which we live, and it clearly is either the light or it's the transport mechanism of the light to your eye.
That's why we don't take one singular measurement and then call it a day and pack up and we're done.
Of course.
Yeah.
What are you guys talking
Take
about?
an average. What you do is you take an average of the apparent positions.
A
And now you
measurement of
have an
what?
average apparent position.
Strictly speaking, what you do is you don't take an average at all. You take a ton of measurements, and you look for this. You do things like standard deviation models, whereby you look at where the majority of the measurements sit, and any disparate ones that are radically different from that, you soundly reject. You don't even average them into the model because they'll just throw off your mean.
Yeah, you get a whole bunch of apparent positions, and then you do whatever you want. You get a whole bunch of apparent positions, then you throw some out and you average the rest of apparent positions out, and you think you got an actual position now. We know.
Yeah. It's the best.
Apparent meaning not actual. Apparent meaning not actual.
Of course, that's the case. If I measure something with a ruler, and 10 times I measure it, it says it's 31 centimeters long exactly, and then I've written down on one measurement that it's 32. The sensible approach for me is to reject the 32 outright and go with the rest that come up with an average of 31.05. It's the best method I have to do that.
Technically, that wouldn't be your average, but
of course not. No.
Yeah. Have you figured out how averages work?
Well, an arithmetic mean is you add all the numbers and divide it by the number of numbers there are. The mode is different, and so is the median. There are different averaging techniques. Standard deviation and these sort of things are an escalation of that in a mathematical model, which takes distribution models into consideration.
I don't mean to be a stickler or waste anyone's time, but I'm just saying, you said you took a bunch of measurements that were 31, and only one that was 32. You wouldn't end up with an average that's 31.5.
No,
it would
no,
be.
of course not.
It would be still wrong, but it just wouldn't be that high.
No. Of course it
Yeah.
wouldn't. If you took 100 measurements to 31 and you had one measurement to 32, and you did get the average of those, it'd be a lot closer to 31 than if you took 4 measurements of 31 and a 32.
Yeah, right. Like I said, I shouldn't have said nothing.
No, it's fine. It's fine. Work in the electronics, and we measure touchscreen performances on mobile phones. That's why I designed touchscreen technologies for phones at the moment. And we take thousands and thousands of robotic touch measurements. We don't do 10. Pointless.
I also thought Napalm's example a little earlier about the point source of light. You put it at whatever, like a fixed, like 6,000 miles away or whatever, and then you move it 3 miles. Would you be able to detect that? And the answer is the same along the lines of what we were talking about a minute ago. If you just you just calculate what that angle, what that separation would be on the sky, and in degrees or arc seconds or whatever, and then I can give you an instrument that could measure that, or could not if we don't have the,
Yeah. So if you're looking out straight ahead to the horizon, would you say that the ground takes up a little less than 50% of your field of view as you're looking out towards the horizon?
I think that if I'm honest with you, and I'm, for instance, on your famed very long roads in your flat states, I wouldn't be able to tell the proportional distance between one and the other. I may not be able to detect that. How would I measure it? I mean, I'm not very good at measuring angles.
Yeah, I'm just saying, like,
it looks to be 50-50, doesn't it? But here's one thing I would. Here's an evidence that that's not the case. Is that when you use a sextant and you use it to observe the horizon, and you refer to your calculation tables, it gives you a dip angle. The dip angle is as a consequence of whatever you think about the horizon. A dip angle is a compensation for the fact that the horizon is slightly below you.
Yeah, I'm not claiming. I never claimed that it's at 50%. Right?
No,
I'm
not saying
always
I'm not saying
below the horizontal, because if you are above the surface, your horizon is always going to be slightly below your center field of view as you view off in the distance, until you have atmospheric effects that can make it rise or fall above that due to certain atmospheric conditions. Those withstanding, would you agree that as you're looking straight forward, like at the beach, the water, the sand, all of that would comprise roughly almost 50% of your field of view as you're looking straight ahead?
Yeah, and I didn't take what you said to be, anything other than the fact that, I didn't bring the dip angle in. That's an evidence that obviously it is slightly below, as a different example.
Sure. So when we're doing that and we're looking out, we don't have a surface on the top side, right? We only have a surface on the bottom side. And the surface on the bottom side, so let's say I'm standing at the beach and I'm a 6-foot observer, the surface is just 6 feet below where I am. And as I look off in the distance, from 6 feet below me all the way out to a certain point, that information is being filled up by the ground. Now above us, we don't have a surface like a ceiling that's the equivalent distance from our eyes above us, right? It's just nothing. It's expansive, right? So the top portion of our vision that is not filled up by the ground, because the ground is going to set its vanishing point based on my height above it. So even if we go up into something like an airplane, the horizon line is slightly further below our center point of our field of view, but we still get the appearance of a ramping up of the ground below us to fill a large portion of the lower aspect of our field of view. So when you think of things conceptually and objects that are very high from you, meaning like typically for most of us, the highest we've gone is like 40,000 feet in a plane, right? So that's our only relative vantage point to get an idea of a ceiling that might be 40,000 feet above us as it would go off in the distance. Typically, we're only going to see like the clouds creating that ceiling for us because they tend to be at the same elevation above the surface, right? And we do see clouds appear to go down towards the horizon just the same way we see the ground appear to go up towards the horizon due to our perspective. So if we take an object that is extremely large and extremely far away, the movement that that object would make to start to interact or come close to our horizon would be a pretty significant distance, right?
Oh, well, it depends. Yeah, if it's massive, obviously, yeah. A mountain would shrink. If you're observing a mountain, you can see the foot of the mountain in front of you and the peak of the mountain. Then you moved further back. You kept moving back. If it's a flat plane, you would expect to see all of the mountain in its entirety until it reached the vanishing point from a perspective model.
Sure, like not the entirety of the mountain, but yeah, because there's certain things that take place as things get further away, where objects appear to just kind of blend together because we can't resolve them due to, you know, the angular limitations of our eye, you know, the fact that we can't resolve certain things as they are a certain distance from one another, right? So the bottom of the mountain and the valley that would be leading up to it they're so close angularly that they kind of appear to blur together, and right, we get these weird effects on the horizon. I'm talking about above us in the sky, right? I'm not talking about the ground, because the ground appears to roughly make up slightly just under 50% of our field of view, and it's typically made up with, let's say, like 10 miles of information is making up the bottom portion of our field of view, and then the top field of view, we have this exponential expanse above us, right?
Yeah, but something that's on the ground and something that's floating above it 100 feet above the ground, you can move away. They're both
you're going to have similar effects, right? But if we have things that are extremely far away, let's say we have an object that's 10,000 miles away, right? And it's extremely large, meaning it's maybe takes up like 1 degree of our field of view.
Yep.
We have a limitation to our vision, right? The way that we look out in the distance, we have a limitation to how far we can see. So we have a perspective limit, meaning we only have a specified area that we can view in. And once you get past that point, the way that things present themselves to you is going to be different, right? For these objects that are extremely far away. Would you agree with that?
It still has to conform to vertical and horizontal transformations in a consistent manner. But yes, obviously a mountain.
Right. So in the way that you might claim that the stars are so far away that we can put them at a effective infinity position, meaning all of the stars, even though they are vastly either closer or further away from one another, we put them at what we would call the celestial sphere, meaning we set them at a distance to where the deviation of parallax or anything like that is not going to come into play. Would you agree with that?
No, because they're not manifest. We don't manifestly measure them at the horizon, do we? We look at the spatial distances across the sky of them.
Mm-hmm. And we call that the celestial sphere, right? Because the celestial sphere puts these objects at a near infinite distance, effectively infinity distance away, so that there's no discernible change to us in our relationship to those objects as we move.
Well, it's only a conceptual thing. I can create I'm in a room in my house. I can create a spherical map of the artifacts in the room in this house by rotating myself around and looking at the elevation to the corner of the rooms.
Yeah, I'm not talking about things at that distance. I'm talking about the stars. I'm not talking about how we
the
see
planets
things that are within our limit of vision, so that they come under certain aspects of perspective that would cause them to follow certain laws that we adhere to within perspective, right? So the stars above us, we don't plot them in the same way we do an airplane as we're getting an elevation angle, do we?
We don't. We can do. You can measure the elevation to an angle. You measure a bearing and elevation to a plane as it goes away from you.
Okay, so how would you draw all of the stars and how you see them if you were to draw lines of sight directly to all of them? What we do is we effectively put them on what we call a celestial sphere, and we measure to that, right?
This is the misconception. The celestial sphere is a conceptual way of modeling the two-dimensional mechanism you use to measure your position with their position with respect to you. The fact that you measure an elevation and a direction to them, sorry, a bearing to them effectively.
That's three dimensions.
And it's granted it's a measurement in 3 dimensions, but you have two components to it. It's a 2-dimensional measurement. There are 2 dimensions: an elevation, a bearing. You are measuring in 3D space.
So there's no distance aspect to it at all?
Not at all. No, a celestial sphere.
Hmm.
Celestial star maps don't tell you how far away any of these things are.
Correct, right, because they put them at near infinite distance, which we don't really model that way. We put them on a sphere that updates based on the observer's position, right?
Well, no, that's not actually true.
Yes, it is.
If you take no, it's not. If you measure if you stand, you sound like an astrolabe.
Do you want to hold on just a second? Hold on just a second. I don't mean to interrupt you. Witsa, can you take over for a minute, man? Like, I'm getting exhausted.
Yeah, I guess. Yeah, Pazza, can you just go look at Stellarium, man?
Yeah, Stellarium. I can look at Stellarium.
Okay, cool. Does Stellarium show you a little dome over top of you?
It can do. You can switch it on as an overlay.
Yeah, that's how we mapped out the stars.
It's a hemisphere. Yeah.
Yeah.
Right.
Yeah.
It's actually a sphere. It's not a hemisphere. It's a sphere. You can only see one half of it.
Okay, so what's half a sphere?
A hemisphere.
Okay, so it's a dome. So based on what we can see, we get a dome by taking all of our positions. So do the positions of the stars go down on both sides of you?
What do you mean, go down on both
Like
sides?
if I look at my zenith, do the other positions of the stars go down relative to the zenith?
If I'm looking at the zenith, then any change in the elevation is downwards, yes.
Yeah, okay. So it's based on what we can see from our position?
It is, it's based, well, the reference point of the thing is for the North Pole.
It's based on what we can see from our position.
Which grid are you
How
talking
we
about?
take the measurements, Pazza?
Which grid are you talking about? You're talking about which grid in the sky you're talking about?
The azimuthal grid, dude. We take an azimuth and altitude readings based on what we can see. Hence taking the measurements.
Let me get Stellarium fired up just so I know I'm on the same page.
Okay. You drop a diagram, man.
Wait, I'm killing them on this SR shit, bro. They're dead in the water, dude. I tried to watch that video you sent. Bro, I couldn't make heads or tails of it, what that dude was saying. Half of it.
Oh. Basically, there's just a paradox in the idea that there's the instantaneity paradox within his paradigm, that there can't actually be an invariant of C according to his own base
So
postulation.
what you talk about now?
Oh no, I don't want to derail it. Go ahead and get back
I'm
to
not
this.
trying to talk. You guys don't get it. You guys go watch the video I sent to Jeremy and see if you can debunk it, but you can't.
I'll watch it because I honestly I know I can't because Jeremy's massacred me. He slaughtered me, so I'd like to see it so I can maybe get on board with
Slaughterhouse.
Just look at
Anyways,
what
go
he's
ahead
doing.
with your azimuthal grid thing. I don't want to derail the whole thing.
So the star map is off the equatorial grid, yeah.
We're talking about the azimuthal grid. Why are you talking about the equatorial grid?
Okay, so the azimuthal grid is relative to you, yes.
Right. Okay. And so it's relative to what we can see specifically. That's how we make the grid. That's how we make the coordinate system.
We don't use the azimuthal grid to measure stars.
Buddy, we take angle measurements to stars. That's how we get the azimuthal grid.
Yeah, sure, but the actual star map is consistent to the equatorial grid.
Oh my God. We have a coordinate system based on how we see the sky relative to an observer's position, and that gives us an azimuthal grid.
Yes, I know that.
Okay. So based on that azimuthal grid, when we change positions, we are now viewing the stars in a different azimuthal grid relative to that observer. So the fundamental distinction here is that on a plane, it would be based on your limit of perspective. You take what you can see, you take angle measurements to what you can see, and then you map that out. You guys say, yeah, what we can see changes as we move, but it's not based on what we see. It's based on the Earth physically curving. That's the fundamental difference.
You know why we say that?
Because you think you can see forever and back into time, and that the edge of the visible universe is 46 billion light years away, and you think there are people antipodal to us defying physics.
That's not why we say that. That's not at all why we say that.
I was just getting started.
Okay, not why we say it though. If I pick one constellation of stars and I measure the angular distance between the stars, my perspective where I am in the world, and you do it from wherever you are in the world, they're consistent.
Yeah, that's right, Paza.
So there is a coherent topology to all the stars.
Are you not getting it?
You're not saying anything.
No, you're just not getting it, I guess. So if I have a limit to my perspective, okay?
What does that mean? Your limit to your perspective. You haven't got a limit
Contrary
to
to what you people say, we can't see forever. We have a 360 field of view.
No one says you can see forever.
You guys say we can.
No, we don't.
Yeah, you do.
What do I see? We can see. What do I see? What do we say you can see that's infinitely far away?
Everything.
No, we don't.
Stars.
You say that we could see the edge of the visible universe is 46 billion light years away, and the only reason we can't see the rest of the universe is because it's expanding faster than the speed of light.
So is 46 billion light years away infinitely far away?
You claim the only reason we can't see the rest of the stars is because
you can't answer a question. You can't answer a question. That's the trouble with you.
No, see, you're not going to be able to address this point. I've already refuted you.
Is a mathematical quotient equivalent that's not infinity equivalent to infinity? Is 46 billion miles away an infinite distance away?
First of all, it's
yes or no?
46 billion light years. Okay.
Right, and is 46 billion light years away an infinite distance away? Yes or no?
Do not interrupt me.
Oh,
My God.
I'm done with you.
Don't interrupt me. Don't interrupt me. Now, you see, this is what you guys do. This is what you guys know I'm about to destroy this dude, so you're like, let's censor him.
No.
Interrupt
I'm happy
him.
for you to
Why are you
destroy
interrupting
him.
me? Why are you interrupting me?
Just give him the courtesy of answering just one simple
Well,
question.
I
Before
already
you
did
destroy
answer
him.
it. Now,
Before
why are
you
you talking
not
though?
gonna- he's not gonna
Now
answer
it's
the
his turn to
question.
talk again. Do you see
Not
what you
gonna
guys do? Right when you realize that I'm about to expose you, you both incessantly interrupt me.
It's rather annoying to just hear you dodge the simplest.
I haven't even got to say 3 words yet.
Yes or
Okay,
no,
Pause. Stop, dude. I already answered that. Dude, I already answered it before you asked it. So I'm not dodging anything. So according to you, we can see forever. There's no limit to our perspective.
says that.
And please
says that.
stop interrupting me, dude. The only reason in your paradigm that we can't see beyond the edge of the quote-unquote visible universe, it's not a limit to how far we can see. It's because the universe is supposedly expanding faster than the speed of light.
Okay, well said, well said.
No
Now,
one said we can see forever.
Is Pazza and myself going crazy, or is Witsit refusing a yes or no answer?
Yes.
No,
Okay.
already. Yeah. Wait.
We've got to be going we're going nutty.
Yeah, because you guys were
You can't
interrupting me.
answer if 46 billion, the number, is equal to infinity. You
I
can't say
already
yes.
said no, Chronic. See,
Okay,
this is
there it is. Okay, no.
No, I
Thank you.
already said that.
The first time you
No.
answered no, you said it. Thank you. Now
Okay.
you can commence
I want you
destroying
to
it.
listen very
Destroying it.
carefully, Chronic. Okay, the reason I said don't interrupt me was because I knew I was gonna say no, and then he was gonna immediately jump in and start taking victory laps like a retard. So that's why I said don't interrupt me, and then I was going to say no, but that isn't what we're talking about. But as soon as I said the word no, you guys were gonna just immediately start interrupting me again. So as I told you, please don't interrupt me, then you both started interrupting me.
Okay, that's
come
all fine
on.
and dandy. I'm just glad to hear finally an answer.
Well, I
You
was
can
trying to answer
continue
it.
the conversation.
I had already acknowledged the difference before he asked the question. So, do you get the difference now, Paza? Do you understand the difference that it's not a limit of perspective in your paradigm? It's because space is expanding faster than the speed of light. So, in your paradigm, you think there is no actual limit to how far we can see based on perspective.
No one says there is no limit to how far we can see. Who said that? Citation, please.
So, what is the limit to how far we can see based on perspective?
It's not down to perspective.
So, perspective doesn't have a limit.
What do you mean perspective doesn't have a limit? There's a limit to the strength of whatever signal you're looking at distance. I don't know what you're asking. If I've got a light source which is bright enough at a distance, I'll see it. Even if at its source it's a pinprick in size. What are you asking exactly?
Just a second. Okay, sorry. I was talking to my wife. Dude, it's like we're saying we have a limit to our perspective. We have a 360 field of view, and that what we take, the measurements we take to the stars in the sky, is based on that limit of perspective. You can only see so far. We have a 360 field of view, and it's limited. You guys do not think that.
No, I'm pretty certain that I only see 360 degrees around me. That's what 360 degrees means. So I don't know what you mean by what angular limit do we put on ourselves? We don't say you can see an infinite number of angles. There's 360 degrees around us.
See, that's a straw man. That's like the fifth one in a row. It's like, how about you really concentrate on what's actually being said instead of just trying to shut it down and win?
Say again then.
Okay. So we're saying that we have a limit of perspective. We have 360 degrees field of view, and that in each direction, there's a limit to how far we can see based on our limit of perspective. You guys do not think that. You think that the limit to what we can see in the sky is based on the physical curvature of the Earth. Do you understand the difference?
No, it doesn't mean it's meaningless. The limit to whether I can see something, is how far away it is, how big it is, and how bright it is. That's it. You can tap dance around with your poetry, how big it is, how far away it is, how much light emanates from it. Those are the factors to whether I can see it or not. End of story.
Okay, now I get that that's what you think, right? Hence me saying for the fifth time now that you guys think that there isn't just a limit to our perspective. That's what we're saying, though. That's the difference in our positions.
No, there is a limit to our perspective. That's what that just described.
I'm saying no, there's a finite distance that we can see in curved visual space. We call it azimuthal grid. We have a 360-degree field of view.
The grid is an angular grid. It doesn't talk about distances of objects within that grid. Where you get that from?
Buddy, It isn't about what the physical distance is. The point is that we can't see forever. We have a 360-degree field of view. And so when we turn around and we view the full 360, we can only see so far in each direction. You guys think that that's not the case, and that it's simply based on stuff like the brightness and size and whether or not space is going faster than the speed of light. Dude, do you not get the difference?
You are
Oh.
confusing the angular scope of the realm in which we can observe the world, which is 360 degrees in every direction, with the angular resolution of something at distance. That's
No,
not
straw
the
man.
same thing.
Fifth straw man.
Okay, fine.
Can
You
I
can
ask a
straw man if you
clarifying
like.
question? It's very related to what Pazza just strawmanned, according to Witsit. Kind of clarifying question.
Mhm.
So maybe a simple example with you know, it's night, you're out in a field or whatever. You have a small telescope, you have a large telescope, and you have your eyeballs. You with your eyeballs, you look at a bright star, you can see it. You see it exists there. That light in the sky, whatever it is, call it a star, a heavenly body, or whatever. You can
Doesn't
see it
matter.
right. You can see it right there. Then you take your small telescope and you look at that bright star. You see a little neighbor star right next to it that you couldn't see with your eyes. Then you take the larger telescope, you look at that same, two stars, and you
Mhm.
see half a dozen more stars in that
Yeah.
large telescope. So
Mhm.
is that related in any way to your argument of the limit of perspective?
No, so, like,
Okay,
yeah,
so
obviously you
Pazat,
can
so what
you can
Pazat just said
resolve
right
things
before.
that are brighter better. That's not a binary. So that was called a false dichotomy. So
Okay, then
it's like,
clarify,
I don't think you
elaborate
got
for me.
Okay, look, let's do this. Do you
Why
guys
talk to
know
Witsit?
do you guys know what anti-crepuscular rays are?
Sure.
Okay.
God, no, all right. Let's go
Okay,
there
so
then, shall we?
I mean,
yeah, this is very
the rabbit
relevant.
hole.
So
What's that got
if
to do
I
with
look
what he
at the
just
sun,
the
I
example he
look
just gave? The example he just gave has got nothing to do with crepuscular rays.
No, you
Nothing
got
at
it.
all.
Okay, so can you please
Just
stop?
let him divert, Pazat.
Yeah, you guys
it's
I'm
just
not
just let him speak uninterrupted, and then you can see how
Okay, fine.
what he
Sure.
wants to.
Okay.
Yeah.
I'm not diverting. So when we see the sun in front of us, okay, you guys claim that they're parallel rays, although of course all light rays from spherical objects are not parallel, they diverge, but since they're such a big radius of light that relative to the Earth, they're basically parallel. Okay, so we have parallel rays that look like they're diverging, right? You guys say that this is just an optical effect based on perspective, right? So then, if I'm looking at the sun and I see this optical effect, if I turn 180 degrees away from it and I look behind me, I can see anticorpuscular rays that look like they're diverging up from underneath the horizon. It looks as if there's a sun behind me, 180 degrees away from the sun, under the earth in your paradigm, with rays coming up from underneath it, right?
Okay,
I've
So
never
what
witnessed
causes
that.
that?
sure, but this
What
seems
causes that?
but again, it's unrelated to
It's
your
not
original
unrelated. It's
conversation.
not
It is.
unrelated
It
though.
is. It is.
So
I'm
you
looking at the
guys know.
stars in the sky.
It's not unrelated at all because it can't be the physical curvature of the earth that's causing the light to no longer be visible at some point behind me because the sun is physically in front of me, which means even in your own paradigm to explain anticorpuscular rays, you must invoke a 360-degree field of view with a limit of perspective.
No, not at all.
Yeah, I
Not
still
at
want.
all, he says. Why not?
No, I don't agree with anything you're saying. That's what I
Why
don't agree
not?
with what you're saying.
Well, why not?
I don't see corpuscular rays behind me if I can't see the sun in front of me, can I?
What does that have to do with anything?
I just posted a
Well,
video. You see the corpuscular rays coming from the sun, and then if you turn 180 degrees, you see them. So you see them like diverging out from the sun when you're looking at the sun. When you turn around, you see them
perspective.
converging on 180
Perspective.
degrees opposite.
Perspective.
Right.
Yeah, that's my point.
Yeah.
Okay,
That's
so
got nothing to do with
we
that's
don't
got nothing
disagree.
to do.
Yeah, so
If you
there's no
didn't,
disagreement. We both agree it's perspective.
but if you didn't have like a limited perspective range that you're seeing, if it was a 93 millimile away sun with these parallel light rays, they would all just look like parallel lines across your sky. But
I don't
instead,
know.
they're
Is that the
converging.
case though?
But
I
instead,
don't know if I
they're
agree with that.
all right. They're
Sorry.
converging and diverging within a local field of vision.
So your perspective, your local perspective, it's got nothing to do with how far away the sun is.
Yeah, I mean, the way
your
train
initial
tracks
claim, I'm not
converge.
sure.
Yeah, train tracks do as well within your local, region.
But this is this is where the death blow lies. So if we stand on the earth in the middle of railroad tracks and we look on one side and look on the other side, sure, they both appear to converge in the distance, although they're technically parallel, right? Okay, cool. But the difference here is, say that I have the light coming from the sun on the horizon, and then I have the light coming from this, looking like it comes from the sun on the opposite horizon. Right? So if I take a point from that position where the sun is, and then I draw a line going over my head, because you guys claim the parallel rays are going over my head. So if I draw that line going over my head and then come back down and draw it to where it looks like the sun's coming from on the other horizon, what do I get?
Tell me, what'd you get?
A dome.
Brilliant, brilliant. What you're
Dome,
saying
dome
is
confirmed.
two parallel lines under your feet come from a single vanishing point in the far distance, open up at a set rate to your feet, which is where the gauge of the railway get measured. If you turn 180 degrees, those two parallel rays dissipate off to a vanishing point the other side. Two parallel light rays are slightly above your head, do exactly the same thing, and you somehow think that derives the dome.
You don't.
It's brilliant. It's
not,
brilliant, Witsit. That's
A
brilliant.
curve.
Airtight. It's airtight. It's airtight, Witsit. It really is.
You said something about under our feet. Like,
The
no.
train tracks are under my feet. Yeah. I'm not.
Yeah,
I'm
what does
not
that to do with the sun?
Yeah. Above your
two
head.
train tracks coming. Two train tracks coming towards me in the distance.
Yeah.
Okay? They come from a vanishing come either side of me, and then if I turn 180 degrees, they go back to a vanishing point the other side. Corpuscular rays coming, arcing out above my head to above me, and then dissipating off to a single point the other side. Perspective, exactly the same thing.
It's not
No
the same
difference.
thing. It's not the same thing. It is the same thing, but it's
Not to you,
technically
it is.
slightly different, because in your paradigm,
Technically slightly different.
Pezza,
Same thing,
you gotta
but
let
technically
him.
slightly different.
You gotta let him respond. Then.
because you guys claim that the light rays are actually going over my head. So of course, the railroad track is not physically going over my head and then looking like it converges into the horizon on the ground on both sides. It's on the ground. Okay, so this shows that there is a 360-degree field of view in all directions that has a limited perspective, and it creates an optical illusion of convergence behind me, away from the sun. Right?
That doesn't make any sense at all.
Okay.
It doesn't. Going back
Well,
to the
Plaza,
point
you know
about
how
the
things
sun.
like when you're looking down a hallway and everything converges?
Yeah, there's vanishing point perspective.
Right.
Linear perspective with the vanishing point. Both
Right.
sides.
So if you were in a big hallway and you're in the middle of the hallway and you're looking down one direction, you see it converging that way. And you turn 180 degrees, you see it converging that way. That is because you have a limited field of view, and the perspective is being like constellated within your local region. So if you just expand that to the sky, it's just larger, but a similar concept.
Right. When does the hallway that I'm in become a dome or look like a dome?
No, the difference is that if you look where the sun appears to be, it's on the horizon. Okay.
Yeah.
So like it looks like it's on the ground, going into the ground, underneath the ground.
Yeah.
Okay. So we're gonna draw a little point there. Okay. Now we're gonna turn around 180 degrees. It looks like the sun is over there, coming from underneath the ground. Okay. So we're gonna draw a little point there. Now let's connect the 2 points. According to you, the light is actually going over my head. So I can't just draw a straight line. It has to connect from point to point going over my head. Do you understand?
Going over your head.
Yeah. Yeah, going over my head, which means that it's going to be a dome.
Aza, I illustrated this for you earlier, right? So this is like round 2. Are you still failing to comprehend?
I'll be honest. When Pezza had said the thing about the sky and compared it to the railroads, I mean, I felt like it made sense to me, at least. Like the analogy seems like you would get the same effect. Like if you only put something right below your feet and something only right above your head, like a railroad right above your head and a railroad right below your feet, it seems like it would behave just like those rays where they would converge on both sides.
But they would have to look like it's converging onto the ground.
Those corpuscular rays, are you saying that they're horizontal?
In your paradigm, they have to curve to even get to the other horizon.
7 minutes past the hour, Geo's picture, those corpuscular rays, they're horizontal from the horizon, are they?
What? What a straw man.
Well, 407, there's corpuscular rays. I can see light rays from the horizon.
Okay.
Are they horizontal or are they projected up into the sky, up into the skyline off the horizon?
I think you know the answer.
Right.
Yeah, this doesn't help you.
Yeah, they're up in the sky. Like there was a video I posted earlier, and the guy pans the camera from one side, and then from looking at the sun, and then 180 degrees, and he points the camera up and over. So yeah, you can see the lines that are going up above him and then converging on the other side.
This is just like if you look at a plane flying away from you, it's going to look like it's like dipping down. It's obviously not looking like that because it's going over a curve, because that would make the Earth like 1/8 the size you claim it is. So when we see things in the distance, they compress into the visual curve of our limit, visual
Where
space.
does it, in that video, where does it show the lines converging behind you?
Okay, this is not exact. You're now denying 180-degree anti-corpuscular rays?
Well, I don't see that. I don't see them converging in that video.
Okay, so wait,
Yeah.
cool. So you would concede though that if they do exist, then your original point has been nullified.
If I see anti-corpuscular rays converging to a point on the vanishing point, exactly on the vanishing point, the same as the sun, then we got an issue. Yeah. Got a
Okay.
video of that?
Well, yeah, sure, I'll find it. This is a well-known phenomenon. It's been covered on the news. And it's not really a big deal. It's just that your paradigm has to invoke that there's an optical illusion happening based on a 360-degree field of view limit. And once you invoke that, then you've conceded our argument, and now you have to concede that we can explain the Southern Star Trails and everything else.
So they describe it as an optical illusion, and you're saying it comports to some actual physical reality.
No, I'm saying it's an optical illusion.
Right. So an optical illusion, by definition, means it's not a representation of reality; it's an illusion.
Yeah, that's my point.
Right.
Yeah.
That's good.
Just like the Southern Star Trails appear to converge.
Well, I can see an optical illusion and mirage, and that means that there's big gaping holes in the ground in which upside down cars are coming towards me. Is that what you're saying? It's an optical illusion, but it reveals some reality, does it?
I guess you don't get it. My whole point is that
show me the corpuscular rays that are converging on a single point. I'm not saying they don't exist. I just like to see it.
All right. Well, yeah, sure. I'll find it. So, can you just understand though that that's what I'm saying? Is that what we see in the sky is actually just based on our optical limit? So we have optical effects based on our optical limit, our field of view, in all directions. We see in a giant circle around us. And it's not because the Earth's a ball. It's because our eyes are balls.
That's all well and good, but everywhere you look in the sky and you look at the constellations, any angle, any elevation, they have an angular topology and coherence to them, which everyone else simultaneously observing it in every single position everywhere else on the Earth sees the same. So there clearly can't be a localized distortion relevant to you because everyone sees the same thing.
Oh, first of all, you don't seem to get it, dude. Everyone has
you can ignore what I just said.
No, I'm trying to respond to it. Everyone has their own individual limit of view. So if I'm here and you're over there, you don't see the stars in the same position I do.
I see exactly the same angular topology in the constellations as you do. There's no distortion to me.
But are they in different positions in the sky?
The constellation is a different position, but clearly if what you're saying is true and there's an optical distortion, that means that the way I see a topology at the extremes would be topologically different to someone who wasn't seeing them at the extremes of the distortion.
First of all, everyone that sees the stars are looking through the limited field of view relative to them.
You are suggesting that there is some way in which we look at the sky, which means things get distorted over our head into a curve.
If you want to phrase it as distorted, sure. Yeah, that's right. It's called hyperbolic geometry of visual space. Yes, it will cause plane shape distorted in the distance. This is well known.
Right. So a distortion of my observation of something which is in the most significant part of the distortion field means that the angular topology of a constellation will be different to someone who is not seeing that constellation at the same distortion point, but clearly we all see them the same. It's a distortion.
Buddy, we all have the same limited field of view. Okay.
We don't have the same distortion field, though, do we?
Why would we not?
Because when I look at a constellation and it's near my horizon, it's clearly by your standing of your model in the most distorted part of the field of view. When someone else in another part of the world looks above their head and sees the same constellation, they're looking at it through a different part of the distortion field, according to your model.
That doesn't mean anything, dude. If the
It
stars
means
appear to optically decline relative to our field of view, okay? Everyone
they're being
has a little
distorted.
dome put over top of them for each observer, a 360-degree field of view, right? So if I have one and then you're 400 miles away and you have one, you're going to view the sky based through that. You're going to see optical declination of the stars based on that. I'm going to see it decline at the same rate based on that. You guys take that linear relationship and claim that that optical declination is actually not because of a 360-degree field of view, but it's because the Earth itself is actually curving.
Let me, Pazal, let me try. Give a one sentence, revised explanation of what you're trying to say, Pazal. Is that taking it, for example, observer on the ground somewhere where like Orion's belt in the constellation Orion is at their zenith, is right above them. So the three stars that make Orion's belt, right above them. And then you have a second observer somewhere else on the surface that has the three stars of Orion's belt at 45 degree, 55 degree altitude, whatever, above their horizon, their local horizon. Then if you measure the angular separation of those three stars, how far away they are from each other, very precisely, and then you should get a different distance between those three stars of Orion's belt at those two different positions.
Why?
No, that's your model that you're claiming on your
Why?
with this limit of angular of perspective, in 360-degree view perspective.
You mean reality, yeah?
Yeah.
Reality. Provable
Yeah.
reality. Yeah.
Yes, but when you do measure those three stars, their separations from each other are the exact same, or to the limit of your instrument precision. They're the same.
Okay. Yeah. We see the stars through our limit of perspective. Your paradigm doesn't even account for the 360-degree field of view.
I just tried to reword what Pazal was saying. That's all I'm saying.
You guys just understand that your paradigm doesn't even account for the 360-degree field of view. It doesn't even account for it.
But what
doesn't make any sense? That doesn't make any sense.
Because it needs it though. The globe.
That's the ironic part. So it builds its entire coordinate system off of it. It utilizes the construct to even map the sky. It uses the celestial sphere that comes from that. But then they claim that there is no optical effect at play regarding this azimuthal grid of vision. They actually claim it's physically the Earth curving that causes the declination.
Sure, but Pazal's point that I try to reiterate is that as far as I'm trying to follow your logic and your argument and your understanding, and the example that I posed doesn't comport with what you're claiming the effects of our limited perspective and vision is. It is like it's at odds with what you're describing. That's all. So why is it at odds?
No, it's not at odds.
It is. I'm telling you, those measurements are made all the time, and there is no measurable difference.
Listen, guys.
Oh my gosh, man! Like, okay, articulate specifically why there should be a difference.
Yeah, I feel like it's assuming like the distance of them and like what assumptions.
I just tried to follow. No assumption. I simply tried to follow from the most basic points that Whitsitt is making about anti-corpuscular rays. They imply a dome, et cetera, et cetera, et cetera. That following from that logic, you should see a measurable difference in that example.
Why can't you articulate why then?
What do you mean? It's your argument. You articulate why. What do you mean?
You're the one that's saying that it would.
It's your argument. It's your dome argument. And I'm posing an empirical measurement that can be made, that's made all the time, that's at odds with your argument. So I'm asking you, how about you elaborate and explain?
Why can't you articulate why it's at odds?
Because it's not my claim. I don't have to. Why?
Well, I don't think he claimed what you're claiming. I think you're kind of creating like a are you trying to think of an idea that the stars are actually in a local dome, like a low altitude dome, to where
No,
if they
no.
were further away versus closer, you'd get like a different angle. You'd be seeing it
No.
from a different angle, so they'd be spread out versus sort of like if you drew like the number 6 on a piece of paper and stuck it to your ceiling. If you're right under it, the 6 is not going to look distorted. But if you're farther away from it at an angle, is that what you're trying to?
No, no. All I'm simply doing is using Witset's first principle logic about anti-corpuscular rays and these other optical illusions or whatever, or lack thereof, that imply a dome.
Okay, I'm again. What you're apparently saying is that when we look at the spacing of the stars, they don't change, but that they should, quote unquote. I'm asking you to articulate why you are saying that they should.
Because if
He got out.
if they differ, hello?
No, he's good. Napalm, maybe you can't hear him.
So if they differ due to the same phenomenon, the same effect, the same illusion, the same whatever that you are describing in your argument that implies a dome with anti-corpuscular rays, based on the limit of perspective and your perspective angles viewing the sun at the horizon, converging and anti-converging corpuscular rays, based on that specific argument, then I can pose a measurement that's made that is in the sky at different locations that should give some result that is consistent with this dome idea theory, that in reality, when the measurement is made empirically by people with telescopes and high precision instruments, is not seen. That's
all of
all.
that, and you still didn't do it. You can't do it. Like if you actually had a point,
I took it point by word
no,
exactly.
all you did was just say it again. You're just like, if it was a dome, it would change, and we can put this up with empirical blah blah blah. I'm
Isn't
asking
that-
you, if it's a
that's what you
dome, why
started
would
with?
it be different? If it's a dome, why would it be different?
You argued for it 5 minutes ago. You
When did
argued
I say that
exactly
the
why.
spacing of the stars will be different?
Okay. Do we need to repeat your entire thing and Geo
Oh my
posting in
god,
the
I'm about
text
to
chat
tap out
about?
now. Napalm, you want to take? I'm about to eat.
I mean, come on, man.
You can't even articulate your alleged
I'm
critique. dude.
elaborating exactly on
Guys,
what you're asking about, man.
Guys, it's been good to talk. I've got to go. It's 4 a.m. where I am.
All right, catch you later, man. Get some sleep.
I'll come back. I'll come back. Yeah.
Later, bro.
I mean, I'm saying I don't know
Why
what you're
would
asking for.
it change?
Because that's exactly how you're describing it would. That's how it would be measured and
So
observed.
steelman him and explain why it would change.
Okay. All right. Here we go. So starting from the first argument, my own. Starting from the first argument of, we see these anti-corpuscular rays. We see this convergence and divergence in the direction and anti-direction of the sun. Okay. Because we see this, and this may be an optical illusion, this may be real, and it could imply that there's a dome and whatever refractive or however the rays are working through this dome, whatever that specific explanation may be on Witset's side, on that argument. Given that these are the observations that are made of these anti-corpuscular, corpuscular rays, whatever, given that, then if logically we should continue down other measurements that are made in the same way, other observations that can be seen in the same way as that, then let's pose one example of how this would be in this paradigm. I'm just posing a simple example, that's all. And this is how these measurements should be based on the original argument. And then I'm comparing that to what is actually observed in reality with instruments, empirically measurements that are taken. And there's a difference. They're at odds with each other. They're not consistent with each other. Why is that? That's all. That's probably still not sufficient enough, but I tried. I don't think it's that difficult to kind of follow, but maybe it is, I guess.
I think he's asking why it is that you're saying that.
Because I'm trying to follow his logic. That maybe I'm following it incorrectly.
Yeah,
Yeah,
I mean,
if I'm following
obviously,
it incorrectly, he should be correcting me. But I think he's just asking me to just like say more words or something instead of.
well, I don't think that was part of his claim, like at any point. But you said that they're doing this measurement, like with two separate observers looking at Orion's belt and not seeing any indifference between the stars. So I'm just saying, like, do you have a source for that or something? Is
Yeah,
there something further we can look into on that?
of course, yeah. Let me just say one
Okay.
more time that the origin that it comes from is the idea that anti-crepuscular rays imply some sort of dome or optical illusions or whatever his original arguments were. That's the seed of the example and why I give that example and how it's inconsistent with reality and measurements that are made. That's all.
All right.
I
So you're
could
gonna
be
post
following
this?
it wrong.
You're gonna post that
Yeah,
citation though?
yeah. I don't know what it'll accomplish, but let me get it.
Well, Chronic, let me ask you. I mean, I think I kind of get what you're getting at. Are you trying to say that if things were constellating in a local dome to us, the reason I use the word constellate is because constellate means to cluster. That's why like a constellation of stars, a cluster of stars. It may not be the best word for this, but it's what comes to my mind because, in a sense, if we're on a massive planar Earth with a massive sky above us that we can only see a limited version of, like we're only going to see a limited part of the sky and so on, then it's like essentially it's like the larger expanse of the sky out there because you can't see everything. It's sort of like it's almost like clustering together, like it's constellating. It's like structuring into your local region. It's, like the sky is sort of you're seeing like a cluster of it in a sense. Like I said, it may not be the best term, the most ideal term for it, but so in that sense, it's like you're seeing which then I was just going to say, like, imagine like if you had like just a massive, flat planar surface and you had a bunch of little ants, tiny ants, and then you have a bunch of stars that are like 2 feet or a bunch of little dots that are 2 feet above the ground. And it's just very expansive. Any one of those little ants is not going to be able to see all of it. You're not going to be able to see the stars that are 100 miles away on that kind of setup. They're only going to see a local area. Now, if you were to put a little camera or be able to look through the ant's eye, what is it going to look like? You're going to see like a cluster, a kind of constellated region of a little dome thing of your field of view. That's what each little ant would see. And things would rise and set as they went over, the ant. And it's exactly how it would appear to us or to the ant.
You lost me halfway through. I'll try to. Sorry, I want to get these papers for Dice Law, but
yeah, you know when you kept saying Chronic, when you kept saying dome, you realise he's not talking about a firmament. He's talking about. That's why Geo said a local, like a dome of vision. You realise that, right?
yeah.
He's not talking about a firmament, something like that, a dome over the top. I mean, it might be that for all I know.
Yeah, I mean, he didn't necessarily he didn't specify or elaborate on that, but my point still stands though, even if it's the personal dome argument.
Yeah, he's talking about perspective, basically. I thought
Sure.
I thought you missed that. That's why I thought.
I mean, I think I've followed it, but I think my point, my argument still, my example can still stand with either either example. Sorry, one sec.
So your thing is that if it was doing this in your viewpoint, that you're saying that like the stars of Orion's belt should measure differently if you're in different little personal domes, seeing it from different angles.
Even the tiniest of difference, though. But yes, not zero, but even just the tiniest of difference in their positions relative to each other.
Parallax.
My food's showing up. I gotta go grab my food. Sorry.
All right, but you're talking about parallax?
No, not at all. Not at all. It's simultaneous measurements made at the same exact time from different locations on Earth, not at different times of the year. Be right back.
You guys know what Chronic does, right?
Yeah, gets you high.
Well, I think probably where he was going with that is that that's his reason as to why Orion's belt is light years away, and that there's little change. I'm assuming is where he was trying to go with it.
In the meantime, we're on a train. I'm just kidding. I can't get into that right now. The whole shit's falling apart, piece by piece. That's what happens when your foundation's shaky. Your shit ain't gonna stay up long.
I've been in and out of being able to hear what's going on. I had a question. Like, if I said that there was a limit to something, you would understand that that something would have what we would call a limitation, and beyond that would be outside of the purview of whatever it is that's inside that limitation, right? Does that make sense?
If you said there was a limit, I'd say I'm a no limit soldier.
No.
What I told you.
Speaking of no limit, Dyslow, boy, XRP is performing quite nicely these days.
To the moon.
Dude, I was just looking at that shit.
Yeah, it's been moving.
But,
told you, man.
Did you guys see those lawsuits?
What's that now?
With Coinbase and Binance?
Coinbase, Binance, and then I think Ethereum.
Yeah, they want to crack. They're going after crypto again.
Do what now?
The
Back on,
SEC.
but we could. I mean, we could change topics to that. But just to, I want to, because to keep on the topic, what Napalm said. Yeah, like Napalm, it made me think of when you said that. Like if you were to extend your arm up, and you were just to put your arm at the extent of how far you can extend your arm, and then you were to move it around, up, down, left, right. There's like a limit to how far you can move it, and you can create like a sphere essentially, up, down, left, right. And if somebody is just beyond that range, you're not going to be able to punch them. You're not going to be able to, hit them. So is that kind of the idea? Like, is that what you were alluding to?
Yeah.
Like, if we have kind of a limit to something, then that limit is the limit. Therefore, there is no extending beyond that. If that's what the limit of the eyeball or your arm or whatever it is, can extend.
Precisely. In the same way that the globe model will set the celestial sphere for the stars at what they call near infinite, which means that effectively at some point, and that point seems to be outside of the sun, moon, and our planets, the stars that are beyond those objects remain fixed in the way that we perceive them as they traverse the sky, because they are outside of our limit of perspective. Does that make sense? Where the laws of perspective that would apply to objects that are near to us cease to exist because the objects are so far away, or that they present themselves to us in our small portion of the sky that we can see. The small portion of that they traverse appear to fall outside the rules of perspective that we have within the limit of perspective.
Yeah, I
And
think I'm
that's
following what you're saying. Yeah, it's like a transform. It reminds me of where you could take like a frying pan or something with water, put like soap in it and kind of get like bubbles in it. Then you could take like a flashlight and like circle it around it. And all those little bubbles, now those are actual like more physical bubbles, whereas we're talking about like a field of view or perspective. So, whereas in this case, it's actually little soap bubbles. But as you like circle the light around, the reflection of the flashlight on the bubbles is different than just the circle you're making. Like it's like rising and setting in each of those little bubbles at the particular angles. It's like a different transform than what you're actually doing with the light, with the flashlight.
Correct. Yes. And the objects that would be inside that, if you could put yourself inside that little bubble, the objects as they would move closer and further away from you would fall under kind of different rules of how you're viewing the things that would be outside of that little bubble. Right?
Yeah, that's why I think of it as like first person and third person. Yeah. Like when you're in like God mode or something, like the third person mode, things are going to look a certain way. Whereas if you then zoom in down into this little bubble thing, it's going to look quite different, like from the first person viewpoint. Which could mean like, let's say with an AE map and a sun circling Polaris and all of that from above, if you were like in total God mode, you would just see the sun circling Polaris, whatever that would exactly look like, but it would sort of be like the hands of a clock would be circling. But then if you were to zoom in to a little human on the earth, well, now it's going to look like what we're talking about, like a field of view, or your own kind of personal dome as you kind of step outside and look around. The sun is going to be rising and setting, in kind of like a dramatic way, because as it gets closer to you, it's going to like come on the horizon, like it's rising, and it's going to have its declination angle depending on what season you're in. And it's going to be dramatic going across the sky. It's going to look like kind of it's not going to look like it's like circling Polaris, not at least that directly. Like it's going to look different. Now, if you're in the North Pole in the 24-hour sun in the north, it kind of does look like it's circling you. You can basically just point to it, and it does have more of that kind of circling. But even at that, it still kind of doesn't look like it would if you were above it, looking from above.
Yeah, because if you're looking from above, you would be looking from outside the perspective. And the perspective is set by a limitation. And I think that limitation is set by like our limited field of vision. And anything outside of that limited field of vision tends to present itself in a way to where it would hold true to the positions of the other things around it as it traverses the sky. And it just is solely kind of like rolling across our perspective. It's not really within our perspective that it falls within the exact same rules that we seem to see with things that are close and near to us. Yeah, I don't know. I think people struggle with conceptualizing this, or they intentionally avoid the conversation. One or the other. I can't figure out which it is.
Well, it is kind of like it's, like that term grok, like to grok something. Like it does kind of take a certain level to kind of. I mean, I know for me, it took me a bit of thinking to really kind of put it into place in terms of how. Because like I think too about where, well, this is kind of a different topic, but where the moon, like the angle of the moon, sometimes the light looks like it's kind of shining down, like the moon's being like fluorescing sort of in a downward angle, and other times it looks like it's kind of angling up. It's kind of a whole nother topic, but like, I think that has to do with there's a difference in altitude between the sun and the moon throughout their cycles. And so I don't think this moon is reflecting the sunlight, but it is fluorescing in the direction of the sun. So if the sun is at a higher altitude above us, the moon's angle is going to be angling up a little bit at it. Whereas if it's a little bit below, the moon's, above the sun, then it's going to be angling down. Anyways, it's kind of a different topic. And I mean, I'm not trying to go too much on that, but it just reminds me of that same thing where like, if you were looking at it from above, you would see like, let's say like the hour hand and the minute hand, the sun and the moon, and they would be at slightly different altitudes, and you would see that. But when you're down on the earth, like in that, like being an ant on the earth kind of thing, now you're in this like small perspective mode, and then you're seeing these huge things that are happening in the sky. It's a very different viewpoint. And even like with the ant thing, like if that whole thing I described of a huge open with it's like if you were looking at that from above, it looked like one thing, but from the ant's perspective, it's like quite a bit different. So yeah, it kind of does take almost like, you almost have to like go like in a portal in your mind or something. You kind of have to go from the third person outer perspective and then kind of zoom into that tiny little dude and how that would actually all, configure around you.
Yeah, the first thing you need to be able to like understand, I think, to even begin to pull yourself out into that view is that there is a limit of view to begin with, right? Like the idea of Walter Bislin's model, which does great things as far as transforms are concerned, but I think that like if you were to put it to scale, the little bubble that rolls around as you move around that map, right? The little dome thing, because there's effectively two domes that he has in there, but the small one that he has, if you think about the size, like I was trying to look into this kind of the other day, like the size of the area that dome would have to be for like an individual observer just using their eyesight, normal human eyesight, that bubble wouldn't be that big effectively. Your little dome or your little bubble is fairly small compared to the overall known surface of the earth. It's not huge. It's not as big as it looks in his model when you can scale that thing up and down. It's a very small dome of perspective that you would see. And I think a lot of people don't comprehend just how small that field of view is. That's why I was asking Zanuck earlier about the, what is the amount of the visible space that we have above the earth? What amount of that in square degrees do we actually see from our perspective? It's a small percentage. Where they would like to think, let you believe that when you walk out your door, you're basically seeing, if you look to the east and you look to the west and north and south, that this parameter, you're basically seeing 50% of the sky. And that's just not the case. It's not even close.
So then in your mind, it's not expanding all the way to, like, if you can see Polaris, like if you're in, let's say, Texas or wherever, and you can see Polaris, you don't think that the individual dome is extending to Polaris, right? So would you say that like Polaris is reaching your dome basically, and then constellating within your dome, your personal, field, your personal dome field?
Can you rephrase that?
Well, like in Walter Bislin's thing, for example, like the size of the dome, if you just have it on like the standard size when you start his thing, that obviously doesn't reach to Polaris, but you can see Polaris from, the United States or whatever. You can see Polaris. So, like, do you think the personal field of dome in your mind extends all the way to Polaris for you to be able to see it? Or do you think it's smaller and Polaris is traveling to the limit of your dome and then you're able to see it?
The latter.
So, yeah, I would say that the dome doesn't actually like your limit of perspective, your dome of perspective, it doesn't actually reach to where that object is or the zenith of that object or the GP or whatever, anything like that. It actually, it's a very small field of view that sets kind of this bubble around you at a much smaller distance than things that we can see are from us, kind of in the way that you were talking about earlier, taking like a glass dome or something like that and a flashlight over the top of it, right? That concept would be the same, right? That glass dome that you're doing that example with isn't necessarily extending to the flashlight, and it doesn't have to, but the extent of that glass dome is what sets how the light from the flashlight presents itself to the person underneath that glass dome, if that makes sense.
Yeah, like the light's reaching that layer, and then that layer is the meeting place between the distance of your limit in your field of view versus, yeah, and then that layer is like the meeting place, and then that's essentially what creates that personal field, dome, essentially, or that personal.
Yeah, you're trying very hard to explain to somebody why their mold doesn't work or why they're, yeah.
The Globers have no choice but to just like fight this no matter what, because like if you ask them what can they do to allegedly disprove that the earth is flat,
how can I make it real?
every single thing that they will say will be bringing up the sky.
Yep.
Oh, yeah.
And your position on the earth as it relates to the sky. And they avoid, either intentionally or subconsciously avoid fully grasping the concept that we're putting forth, because if they're able to fully grasp it, then you understand, right? You're no longer like nescient. You actually become ignorant of this concept. Grasp it, and you decide that you don't want to adopt it.
Okay.
Yeah, 'cause at that point, it's like, okay, the entire sky works over a planar surface.
That's just
Exactly.
something they could never even say those words consecutively out loud, I don't think.
God bless them.
It's like a huge, like in the cartoons when these, it's like gulp. It's like gulp. It's like
Yeah.
a huge. It's like, oh shit.
Because then
That's
the
all
fact
up
that
the
we
window.
use like a planar assumption for everything all of a sudden hits a lot harder, right? Like, everything, like sea level, even PhD Tony was like, yeah, the best actual direct observations that we make with the measurements is based on a flat earth seismology model with horizontal layers extended out 150 kilometers in each direction. Same thing with everything that they do. Even their little geology fairy tales of sedimentary layers, they're all horizontal layers. Sea level is adjacent to a landmass to get elevation. Barometry, the way that we map the ground or the ocean floor, we send out signals from the surface of the water, assuming everything horizontal, get the layers of the water horizontal. Everything we do, of course, all engineering and building canals and bridges, and it's like all of a sudden it's like, whoa, right? I mean, if you don't have the fairy tales of the sky where you can just pretend they don't work on a flat earth, then you really got nothing. I mean, you're like quite literally getting destroyed in the debate at that point. So I don't think that we'll ever hear a concession about even just the concept.
Nah.
Oh, give one example using actually using the concept to do anything. That's the start.
Celestial navigation.
It's just using that as a coordinate system. Not using that.
Oh, hi, Bacon.
It's just using that as a coordinate system, not using that as what?
Is anything that does any difference for a map plotting of ground positions, a flight plotting
Anything
of ground
that does
positions.
anything different for mapping out ground positions.
Well, Bacon, I mean, the difference, okay, one difference of it, like if you're standing in a room and you have the ceiling and the ground, you have like, let's say you have a flat ceiling, flat ground, you're just chilling there. That's a certain there's like a certain size of that. And if you walk around, you can get these different angles. But if you were to make the sky massive, 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 far beyond what your eyes can even see, and make the ground massive, now you're in a huge room. It's not going to do this. It's not going to be the same. You're not just going to be looking at a ceiling. Like, it's so large at that point that now you're going to have some limited field of view that everything beyond that is going to be configured within. And so I think a lot of people with, trying to quote unquote debunk flat Earth with the sky, they're thinking of it as if it's just like the ceiling of a room, and they're like, oh, it doesn't work that way because the sun would look like it's just curving around the bend, but that's not the right ratio. Like, you have to get the ratio of the actual size of the human and the size of everything, and that you would not see the sun just curving around the bend. You would see it rising and setting in a dramatic way, just the way that we do. So once you like reconfigure your coordinate system to actually be your local field of view on a massive planar Earth, it allows all of the observations to fit, and the kind of hemispherical field that you are seeing within is then being inverted and converted, to be sold as the ground is curving in the globe model. And much of the globe model is based upon that very reified inversion concept.
The whole thing, yeah.
Right, yeah, but like scale doesn't change ratios. Like, if you scale the sky and the Earth, that doesn't change any ratio. Like when you're doing trig for perspective, you're not using a different ratio. You're using the ratio you should use. Like, I'm not getting it will be different.
Do you think that there's
what we should be doing differently, given that the Earth is big?
Oh man, and like this is the real thing. Like you can just show what the real like motivation of denial is by asking simple like intellectual honesty test questions. Like, do you agree that if what we're saying is true and we have a limit of perspective that creates this little celestial hemisphere or personal dome or azimuthal grid, that we only perceive things that are at a great distance once they enter within that limited field of view? So when the sun moves away from us throughout the course of the day on a flat Earth, we wouldn't expect it to change angular size. See, like they'll never answer. They'll never be like,
Was
"Oh,
that
yeah,
a question?
yeah."
Was
Yeah.
that a question?
Yeah,
It sounded like a sentence.
No, it's well, did you follow it? I mean, it's a huge, what you just laid out is a huge difference compared to what, some attempts to try to debunk it, or you guys are trying to use angular size change in a way that's not actually correlative with how we actually see.
Yeah, I think he first needs to grasp the
wasn't.
concept of like a limit of perspective. Do you understand what's being said when the term limit of perspective?
I've heard different concepts using those same terms.
Well, that's why I kind of described it like, if you
No,
take
you have to be specific.
Well, that's why this may be a simplistic description, but like if you take your arm and you just hold it up above your arm, maybe your arm can extend 3 feet or whatever. If you then you keep your arm straight, put it out in front of you 3 feet, to the right 3 feet, 3 feet, 3 feet, all the way around. So that's like the extent at which you can stretch your arm. So if somebody's standing 3.5 feet away from you, you're not going to touch them. There's no way, you're just at the limit. So if we were to then view like the eye, the perspective, the vision, and our vision as having a limit, instead of your arm stretching out, now it's your eye stretching out, obviously much further than your arm goes, but there's still that limit. There's a
right, so the distance limit.
Yeah, there's a hemispherical distance limit of what you see and how you can see, because we're mammals, we're humans with an eyeball that we can't see. We're not Superman. We can't see forever.
All right, so whatever goes further than that, what happens? It disappears. It goes black.
No. What takes place is it no longer falls under the rules that we typically have, right, for what we call perspective, because it is outside the limit of perspective.
So our rules apply to a certain radius. After that radius, it's different rules.
Mm-hmm.
Is that what you're suggesting?
Correct. The same as in your celestial navigation idea, right? So we treat
there's nothing
treat
like
the
that
sun
in
and the moon
my
differently
celestial
than the
navigation
stars,
idea.
right? Or the sun and the moon.
No, we don't treat them with
differently
different perspective.
I'm sorry, go ahead.
No, really. They're not treated with different perspective. It's the same perspective for both, for all of them.
Oh, so there's no parallax or anything like that concerning the moon and the sun?
Yeah, you can simplify equations when the distance are great enough, but that's not a different perspective. If you don't simplify, you use the non-simplified equation that you have to input the distances, works exactly the same. It's not a different perspective. It's just a simpler equation because the distance no longer matters.
Do you agree that if we have a dome that is a limit of perspective over top of us and the sun moves away from us on a flat earth, that it would not change angular size?
I don't know. He just said that outside the dome the rules change. I don't know what the rules are after the outside of the dome.
See what I'm saying, bro? Like, that's
how
what I'm
things
saying.
are gonna look if I don't know the rules.
Sorry, but you can get straight to the heart of it, right? Like, they won't even peer behind the curtain of, oh well, I might disagree with that.
Just explain what
Hey.
the thing is.
I don't know how many ways we can explain it for you guys to let a fraction of it be
Any way that you
comprehensible.
have a back and forth instead of you ask one question and say, see, that's what they do, and never like go deeper into the
That's my
subject or
point.
make
Wow,
it
I could sit
more.
here for 5 hours with you, and you won't straight up answer yes or no to that question.
Well, I don't think. I don't think
It's a question convoluted with a lot of baggage that I'm not just gonna say yes or no because there's a lot of things that don't make sense within the question itself.
All right. Well, maybe you have more questions, but would you not at least be able to say possibly if you had the other piece of information that you needed?
Yeah, I said I don't know. If I don't know, then possibly yes, possibly no. I don't know. That's what the I don't know means.
I'll give you a picture. You can just use a program. Actually, I'll even give it to you.
Yeah,
It's
that doesn't
called,
happen in programs. Programs doesn't.
Yeah, it does.
Programs don't use a different. Programs don't use a different perspective for things beyond a certain radius.
Okay, so here's a program that everyone can use just on the internet. And you can actually put a dome of perspective over top of you. And then you can use light rays. You can also add extended light rays. And you
Where are
can
you showing that?
change the ray density. And you see that if
Where should I be looking at?
In the live stream text. So if you move this in the program, you can actually see, of course, it's not going to change angular size for you in your personal dome. Same thing with Walter Bisland's model, of course. So you can just look at the sun within the dome as it moves further away from you and maintains angular size because it's always at the same distance from you optically.
Can I see an example where after a certain radius the laws of perspective change?
Can you answer this question?
What question?
So if I have a personal dome, that's a limit of my perspective, and the sun's moving away from me, do you agree that even though the sun's moving significantly further away from me, that for me, the sun would not change angular size?
You already asked that. I already said I don't know. I don't, if this limit of perspective is a radius in which the laws of perspective change, I'd have to know what are the rules of perspective outside of that to judge your question. You're just like that's what Napalm's answer to me, that the laws of perspective change outside of this dome. I don't know what those rules are, so I can't judge how things are going to look like outside of that dome.
You can 100% answer this question.
You're not telling me what the rules are.
You can 1,000,000% answer this question. So
of course not.
Yeah, you can. It's just
outside of the dome is just a black box. I have no idea how things work there.
You're not gonna get it out. You're not getting out of it. Here's a picture. So this is our limit to perspective. You see this little dome? This is our limit to perspective. Are you with me so far?
No, it's not.
I didn't ask you to whether or not you think this is happening. Okay, I'm seeing if you can even show.
That's not what I answered,
buddy.
Oh man, just let him finish, Bacon. Don't interrupt.
That isn't a limit of perspective.
Well, dude, just let him lay it out.
Oh, he asked me a question.
No, again, this is a intellectual honesty question. Like this is if you put yourself into our shoes with what we're arguing, right? We're seeing if you'll even actually follow it to the conclusion hypothetically. I don't think you will. So this is the limit of our perspective.
It makes sense to get there.
This is the limit of our perspective. Okay, we have a little dome over top of us. We have 360-degree field of view. We have a celestial hemisphere relative to the observer. We have a little personal dome, an azimuthal grid. Okay, this is the limit of our perspective. As that sun moves away, it's going to still always be perceived at the same distance, perspective limit for us, the observer. On the outside of that dome, you see that yellow line that goes over the dome? That's the path.
Why?
And therefore the same angular size.
Exactly. You agree that if that's the
Why
case,
is it going to be perceived
do
as the
you
same
agree
distance?
that if that was the case, it would keep the same angular size?
So you're asking if it keeps the same angular size, if it will keep the same angular size?
I'm asking if this if the sun is being perceived to that perspective limit for the observer, do you agree that the sun would stay the same angular size?
I can't answer that if you don't tell me what this limit does.
This is crazy. It's just wild to me,
Because
bro.
Napalm said that all I got so far is that the laws of perspective change outside of the dome. That's all I know so far. That is
So-
not enough to answer that question.
Well, I think he didn't say they changed. I think he was perhaps. I mean, I don't want to speak for Napalm, but he was saying there's just.
That's what I asked.
Like, well, okay, like there's a difference between first person and third person. You know about that, right? You know what those are?
Right? Yeah,
So-
I'm first person. You are third person for me.
Yeah. So
he's third person.
So when I say
You
that,
is second person.
I'm saying it along the lines of your idea of perspective would be that as things move away from you, optically they appear to change angular size, right? Would you call that
Yeah.
perspective? Right. So if there's a limit to
That's
perspective,
one of the
but we still
implications
have
of
the
perspective,
ability
yes.
to view something and it's outside that range and it appears to not really change angular size as it goes away from you.
Why
then
would you do that?
be-
right, if it's beyond the limit, it's not going to change beyond its maximum angular size.
Okay, what does this limit does? It's the limit in which things stop changing angular size? Is that it?
I would say for large objects, yeah, probably. It's what it appears to be. There is a slight angular size
Okay.
change of
So
the
let's
sun,
say
right? But the angular size change of the sun is not what you would think it would be based on this idea, right? Because you're not conceptually understanding a limit to your perspective or a limit to your vision that kind of sets your perspective in this dome.
I've got maybe a thought. Let's say you're in like a greenhouse. So you're in a house that's like a glass dome, let's say, and you're just chilling in that house. And let's say the glass dome represents how far you can see. Your eye has that extent to it. But there's a lot more out there beyond that. There's a sun and there's other stuff. But you're only going to see the edge of that glass dome. So if there was a sun passing over you, it's going to rise and set, and the angular size will be quite similar. Like it does change a little bit. There's fluctuations in the atmosphere and so on.
the dome represents how far I can see, and the sun's outside of that. How can I see the sun? I don't get it.
Because it's reaching you, it's reaching your field of view, and then that's why I use the word constellating, because it's like the word constellate means cluster, but in a sense that's what I think of it as, because if you're in like a dome there, it's like the whole thing out beyond you is like clustering to your local region. It's constellating, just like a stars constellate together. Well, your field of view is constellating. Whatever is beyond out there, beyond it, you're just able to take in the kind of clustered field that you're in, the cluster of the field of your view field.
All right, look, I'll share my screen. My goodness. All right, here we go. The sun's moving towards us. There it is. Now we see the sunrise. Okay. Now look, that's where we can see the dome. That's our limit of perspective. Now, as the sun moves away, the sun is staying on the
I understand
outside.
how this model works.
Right, but do you understand that it doesn't have to? The light does not have to bend. That is actually how it would constellate to that little personal dome thing?
I just need to know if you can admit that.
If the line between me and the sun was straight, the intersection between that line and that sphere, or that grid of vision, wouldn't be where the sun is being projected there.
I just need to know if you can acknowledge that.
The sun is being projected not where a straight line. Yeah, the sun is being projected on that dome, not at where a straight line intersects the sphere and me. So if it was not bending, if it was moving in a straight line, then that's where the sun should be projected, not somewhere else.
Do you acknowledge that if we have a limit of perspective in this azimuthal grid, that for the observer in the middle, the angular size of the sun would not change?
According to less definition of limit of perspective, yes, because Leslie asked if that's where the angular sizes stop changing, and then Pope said yes. So according to that new definition, yes.
See, it's like that's the best we're gonna get. If we can only see so far, then that's the soonest we can begin to observe things. Even if something's significantly further outside of that, we begin to actually perceive it once it enters within our field of view. And if it's further away from that, it's always going to be at the outmost limit of that field of view that we can begin to perceive it. So no matter how far away it gets from us, it's going to remain equidistant in our field of view. So it's not going to change angular size.
When it's inside, that doesn't make it. It's like, what is that distance? Because you can change that dome to be any size. It doesn't change any of the azimuths. Doesn't change any of the elevations. It's drawn as a sphere, but it has no radius. It's just to show that you have those directions in all directions around you. So why would be a certain point where things just stop changing angular size?
What you just said is completely non sequitur to my point. It doesn't matter how big it is. The fact is that it is a certain field of view, and therefore the angular size of the sun wouldn't change. Like if you could just
yeah, but I could make that,
and then we could just it would be.
I could make that as okay. I could make that sphere a meter away. It would still be my hemisphere dome of vision.
Well, how about
things wouldn't stop changing their size after a meter?
Well, how about let's make it a radius of, I'll just come up with a random number here, 3959.
Yeah, I'll rock with that one too.
Very random. That sounds very random.
Yeah, because you got that number from the sky. You didn't know that.
And the surface.
Actually, from the sky. How'd you get it from the surface?
It's how the sky relates to the surface. The sky alone wouldn't give you that.
So you got the number from the sky, and then you assumed that the reason the sky appears the way it does is because the Earth is curving. And
the lights are so far away that they're essentially infinite. They're coming in parallel, and once you add a parallel geometry, now you're using they're just transferring the planar Earth and the hemispherical field of view into the infinite distant stars are now parallel. That's the planar part, and then they're making the Earth the sphere.
Yep.
Okay, so to address that, the sky is being used for the 3959 with no any measurement on the surface. There would be no 3959. That can only be calculated once you have some measurement of the surface. You need both to get the 3959.
Yeah, let's just how about this? Let's use a planar surface. Just take this, grab that out of left field or something. Can I use a planar surface and get that number?
What do you mean?
Are you serious?
Yeah, I mean, as I understand, you get the number because Earth is a sphere. If it's a flat surface, you could get anything else. Now I need to know what you're doing to get the number, to tell you if you're going to get the number or not.
So math.
We're just going to use the rate at which
the measurements.
The rate at which the stuff in the sky falls relative to the distances we travel and how much they seem to decline at the same time. Measurements are taken from different positions, and we're going to get a ratio of change relative to distance, and then we can actually get that ratio and say, oh, that's how much that our optics change.
Yeah, but that would be different on the flat surface. You wouldn't get the same number. I mean, you could get depending on where you are.
Well, but what
because
you
the distances are different. So depending on where you.
Right, but if the star is light years away and essentially coming in quote unquote parallel, now you're calculating the distance on the Earth spherically. In vice versa, if you were to have a hemispherical field of view and the star
in a flat surface,
you're on a planar surface and you're now a hemispherical field of view. And just like on the animation that he's showing on the screen, where the sun is rising and setting in your sphere, that's the sphere. That's the declination. Like that angle is the angle that's correlating to the distance on the ground in your hemispherical sphere, rather than the star being a parallel light ray coming from infinitely far away and hitting a spherical Earth surface.
Well, you lost me.
You're just measuring the star's declination in the hemispherical field of view sphere. That's where the sphere is. It's in your.
Well, how is that to do with? Well, what does it have to do with the 3959, or doesn't? Or it doesn't? Because I thought it did. Maybe that's why I'm lost.
Oh yeah, we can just take the ratio of the stars in the sky, and then we can easily get the number of the stars being what we perceive the stars at a limit of around 4,000 miles. So, and really, you just have to use the ratio. You can do all kinds of different numbers.
You think you can get the 3959 from the flat surface?
Yeah.
Well, Bacon, you know what
the distances are different. I'm not gonna get the same number.
Bacon, you know what the radius is on a equator with 24,901 on a flat circle? What the radius is to the North Pole from the 24,901 equator?
It's 3959 times 2 pi divided by 4.
It's 3959.
It's the radius of the equator. No. The radius of the equator? Oh. Mic check.
Yeah, I can hear you. Can you hear me?
I can't hear you.
Okay.
Did anyone hear me?
So yeah, what I was saying, I stepped away for a sec. So what I was saying is that
no problem.
If you have a circle that's 24,901 miles, the radius of that circle is 3959.
Yeah,
so,
the radius.
So if
the radius of the circle is 3959, then the radius is 3959.
Oh my gosh, I'm not even sure you're even following what I'm saying. I'll go slower. If you have an AE map,
all right.
Okay, you have an equator, right?
Mm-hmm.
Okay, if that equator is 24,901 miles in length, still with me?
Right.
Okay, the radius of that circle to the North Pole is 3959.
All right. Yeah. I think I misunderstood before.
Okay. Well, just because you asked about where the 3959 comes in, so I'm not saying that is what it is, because I think because there's some additional components of that, so there's more complexity to that. So I'm not just saying it's as simple as that. However, if the equator is 24,901 on an AE map, then the radius is 3959 to the North Pole.
Okay. You said 24,901?
Yeah, that's the claimed equator of the Earth.
Got a different. Okay.
24,900 miles. That's
would you get, Bacon? Let me guess, Bacon. You got 40,000.
No, I got 24,875.
Yeah.
The number Geo used would be bigger than 3959, because the 3959 is the average radius. The radius of the equator is bigger.
All right, so I
just said 24,901.
Yeah, the first one that actually came up, maybe they've changed it a little bit. I just typed in circumference of Earth. They say 24,855 is what this one's saying. But there might be now this other one from Wikipedia says 24,901. But yeah,
That's
I mean,
confusing. It's confusing because if that's smaller than 24,901, and if the equator should technically, if that's the average, the equator should be even bigger. I don't know.
But it is. The average one gives you 34,875, and the circumference that Gio gives us
24.
Yeah, 24,000. Yeah, 875. That's smaller than what you.
Yeah, but 24,901 is the average, right?
No, 24,901 is using the polar radius, I think. Oh, sorry, the celestial, the equatorial radius. I think that's how you get the 24,901. Because if you divide 24,901 by 2 pi, you get 3975.
Yeah, I mean, this is a huge. So whatever we call the equator, like where the sun travels, at the equinox, there's definitely you could walk under the sun on the equinox and or you could travel or take an airplane and go right under the sun. Like it's definitely tracking along the Earth. If that distance is 24,901 miles and the Earth is planar and it has Polaris at the center, then the distance to the North Pole is 3959. However, on a globe, because of the way that with the globe, it actually calculates more to like 6235, I believe, something like that, 6,200 miles. So it's dramatically different.
It's the number I said before. 3959 times 2 pi divided by 4.
Which then means there's deeper components to this. They may be hiding more land at the North Pole than they kind of show us. So there could be some.
But then the distance between latitudes would have to be 3959 divided by 90. Let me see. No, it would be. Yeah, you'd have. You would have 44 miles between between a degree of latitude instead of 69 miles. It would be much shorter. It would be easily noticeable.
Well, either that or that there's there's either 2,000 miles missing north to south, or there's 15,000 miles missing at the equator. One of the two.
Yeah, it is something like that. Yeah.
Was it a dog?
No, I got scared.
Yeah, I mean the equator obviously has to be something in these realms because I mean people you can get private chartered airplanes and travel around the Earth in different locations and be within that range. Like if you did a couple 5,000-mile trips, you'll get around it. So, as it were.
I have to say, people asked me the other day what's like the number one evidence or my favorite evidence or something. I simply said longitude and latitude or coordinates or something like that. But the truth is, specifically, it's this one with the equatorial distance versus the distance from the equator to the North Pole. Because that one, to me, I consider a geometric proof, but that's I know it's debatable. I don't want to put a nail in this coffin, but it's just there's certain places in the world, like from Africa to Finland, to the rest of the North Pole. Like you can basically find maps that go back thousands of years for this whole for a range from basically the equator to the North Pole that confirms the distance. You know what I mean? But that's neither here nor there.
Well, it is about 3959 on Gleason's map. I mean, the radius from the equator to the North Pole is 3,959 miles on a flat circle radius. So the fact that they claim that's what the globe radius is kind of a dead giveaway. And we were talking about how the sky links with that. That's where that got started from. So Brian Leakey's also done math, and he's shown how you can calculate the height of Polaris to also be 3959, which is interesting. So there could be some like sacred geometrical overlap structures to the way this realm is built. and there's certain like
Yeah,
numerological.
he used. Sorry. Go ahead.
No, it's all. It's all ratios, Fibonacci sequence, golden ratio, vortexes, the vortice structure of reality that creates this like sacred geometrical fractal that has certain resonant frequencies on multiple harmonic levels that correlate with numbers in these different distances as well, and the way that I think the ether is manifests.
Hey, can you go ahead? I wanted to say something about the Gleason's man, but I know you were trying to say something big.
I was just gonna say like if you use the 6-9 miles per if whatever miles per degree you use, that's how much that's gonna turn into like if you do exactly what Brian did, so you walk just 1 degree over the surface, or and
he derives it from measuring
a triangle. Yeah, if you drive it, you get the triangle you form by going that distance and getting 1 degree of drop. That is going to follow the small angle approximation. And if you use, for example, instead of using 69 miles, you use, I don't know, 10 miles, it's going to give you the equivalent radius of a circle. Or if you divide it by 360 parts, it gives you 10 miles. So because he used 60 nautical miles or 69 miles, then he get the circle that would give you that, which is a circle with radius 3959. Like it's not much of a coincidence, just like what you should get given small angle approximation.
Yeah, if you do small angles, expect 3959. But if you do 2 different angles, like for instance, what Aristophanes had done, like 90 and 82.5 or whatever, you get something different. Well, he actually he did do that equation. So, but anyways, sorry, go ahead.
Do you think you would actually be happier to find out that the 3959 was not completely a delusion, meaning that it is a thing, that like, there is something to that 3959? It's just not the radius of the Earth. I'm just saying, would you be happy to find out that there actually was something to it in the end?
Yes, of course.
Even though it's not the radius of a sphere Earth. In that,
I fell on my head in 2016. Not a lot of people know this, but I fell on my head, and I had a concussion. Or not a concussion. I went into a coma for 2 weeks. Actually.
Oh, sorry, I didn't mean to laugh at you. It just sounded.
Hey, it's very funny.
I thought you were. No, dude, I thought you were joking because you were like.
What else? My girlfriend broke up with me when I got out of the hospital. That happened too. You want to laugh at that too, man?
Seriously?
Yeah, she did. But it's funny in retrospect.
Well, no, the way you said it sounded like a joke. You're like, oh, I fell on my head when I was younger. Like, I thought it was one of those type.
Yeah, I know, man. I know, but like I said, I laugh at myself all the time, so I'm just messing with you. But it is true. But I'm just messing with you. I'm not really upset. But the truth is, that happened. Anyways, before that, though, I used to be enamored with mathematical, just symbols like math and magic symbols that exist in the universe. I was like searching for like prime numbers and all this other type of stuff, golden ratio, and the only reason I brought falling on my head is because after that that kind of went away. But yes, to answer your question, yes, I would be. I would be very elated if there was some magical to the 3959, even if it wasn't in relation to the radio.
You'd be thrilled that Al Baruni was possibly doing something within the realm of something, or or not. I don't know. Ruhif says that Al Baruni is a fraud, so I don't know.
You've seen Princess Bride, right?
But all your 3959s, because you guys like to link things back to that, and I mean, yeah, it is a part of the sky system. Like I said, Brian.
I actually don't like 3959.
Brian did a good breakdown. You did what?
I said I don't like 3959. I prefer the 6371.
You like the kilometer?
Yep.
Would
sorry, go ahead.
Would it be like the end of the world if you discovered that maybe that the Earth is not what you were told, hypothetically?
It'd be the end of the globe.
Oh, it'd be
exactly. It would be it would be the end of the world. Yeah.
Jesse was first.
Would you like freak out?
Nah.
No.
Check it out, bro.
Yeah,
I
whole
found
new
a
world.
picture of Einstein the wizard. Yeah, I don't know. I feel like you guys would maybe take it rough. It's all good.
Maybe.
It's always nice to understand that something you thought you knew was wrong, and it's something much more like deeper. Like there are a lot of notions in physics that are completely wrong.
Like
and
all of your
understanding
paradigms.
the like the way we usually think about it intuitively is usually wrong.
Well,
But if that was the case, if you felt that way for real, like, it's awesome you said that, and I agree with you. I resonate with what you said there, but it seems like you would conduct yourself differently if that was the case. You'd be way more like, oh, how does this work? Let's figure it out, guys. Like you would actually want, it seems, to actually accomplish that, because you were saying it'd be great to know something that's true, or to find out that something you thought was true is not true. Because that's like, it's like getting a splinter out. Like if you have a splinter in your skin, it's causing pain and infection, whatever else. Like you have to get the whole splinter out, and then obviously you can start to heal. But it seems like if you really had that perspective, then you would be much more like open-minded and like interested in conceding. Like that's what I'm like, interested in conceding. I mean, I definitely assert what I think is the case as well. But like if I'm possibly wrong on something, like you don't
think I'm excited enough, right?
You'll admit.
But I'll be much more excited if I feel like you guys are onto something. Like if there's some resemblance of like there might be something there. It seems that these guys are on the right track. But every time I come here and I hear you guys debating, I feel like you're all over the place, never on the right track. Like,
all right, well then that's your conflict. Then you don't think we're on the right track. That's your conflict.
Yeah, but it's very easy to expose that though. Like, so you don't think it's even possible that it's very easy. Yeah, you don't think it's even possible that the Earth is actually geocentric?
No, I think it is possible. Yeah.
Oh, okay. So like, because there's really no strict evidence that it's not, even in your own paradigm.
I think it just simplifies physics a lot. Like it being geocentric would be kind of weird physics, very arbitrary.
Yeah, except you wouldn't have the dark matter and dark energy problem. I mean, who cares about that, right?
What the hell is that?
No, I don't think that's related to like geocentrism versus.
You're incorrect.
We would just need the big magic.
I might be.
Well, Bacon, here's the thing though, dude. Well, let me ask you this then. If you don't think we're onto something, then, and I don't try to say this, like, I'm not trying to like, it's not an insult or anything, but like, what are you doing with your life truly? If you're hanging out with a group of people and we're discussing all kinds of very deep, all kinds of topics on multiple levels, if you don't think we're onto anything, then truly what are you doing?
I'm pretty sure that's not the first time asking that. You mean like by coming here on the server?
Yeah, dude. Like if I woke up one day and I was like, oh my gosh, I'm going to hang out with a group of people that I think are just not on to anything. They are just
I wake up.
They are just so off the path here, and I'm gonna go hang out with them for hours. Like, it's like if you really thought that, then you would be the opposite of a truth seeker.
Do you go to a baseball scrimmage and just make fun of everybody doing it? Hey, you look so funny pitching that ball. Why do you even play? Like that's what it is.
To be fair, Bacon doesn't really make fun of any of you guys.
That's not
no, you don't get it. By the way he speaks, in his own way, he mocks us for
he
sure.
Just did it. He literally just did it.
Although sometimes Bacon goes into a mode where he really is like helping us look, and he's like, it's actually pretty solid. Like sometimes you go to a mode with like your programs, and then you're able to be like, well, yeah, if it is planar, it would be like this, and so you've had some peak moments.
The stop clock tells the right time twice a day.
Like this whole, you guys are never onto anything. You're all over the place. Right? Like, let me give you a perfect example. I've been trying to tell these Glovers here for years now that gravity is definitely just electromagnetic when that term is properly defined. Intrinsically electrostatic. It's 100% electromagnetic. And until that's embraced and understood, you will never make any progression with the understanding. You will never find it on the quantum scale. 100% electromagnetic. So intrinsically electrostatic. You're an idiot. Oh, you're so stupid. Cavendish. Why can't you change the charge and change weight? Oh, things should fall at different rates. You're so dumb. Oh my gosh. Right? And I have papers that I found just today from the top level of your paradigm writing specifically that. in vivid detail, excruciating detail. Exactly what I say. So that's one of the examples.
None of that was me, right? Because you responded to something I said. When you gave examples that wasn't related to me, like I never
I'm giving an
debated this subject
example
with
of what you guys say we're never on anything. Oh, you mean like solving the biggest
Yeah, I said
problem
that.
in all of physics? That's not anything. That's nothing.
Oh, I know you believe you're doing that, but
Well,
I mean that's not my field of expertise. I wouldn't be able to judge whether or not you're on the right track in this subject. But when you talk about perspective and I don't know, orbits or whatever, I can see you're all over the place and you don't get the basics. So I mean, how could you be the guy that is actually onto something about the shape of the Earth if you don't get those simple things?
Oh,
No, I do get that. I do. In reality, you think you get orbital mechanics, but you don't understand that it's actually like a shit show. And
Yeah.
you can't have something in free fall changing angular direction perpetually in orbit. And your only evidence for that even being physically possible is to just say that it is. That's it. To say that it is and then point at the sky. That's literally it. You can't even demonstrate it
actually
ever in any
logically
scenario
follows.
ever. What?
It logically follows. If you have an inverse square, an attraction between two points or two bodies that follows the inverse square law, you could easily put them in orbit. That follows logically that they would be in.
No, it doesn't follow
in orbit.
logically that something can be in free fall and change angular direction perpetually.
It does.
No, it doesn't.
It actually does. I mean, for
Oh,
example,
it doesn't.
if say I'm walking around someone, I'm making a circle path, right? What is the direction of my acceleration?
Are you free falling?
No, I'm walking around someone
Okay, so that's irrelevant.
in a constant speed. What's my acceleration?
Totally irrelevant.
No, I'm showing you the concept of what you're talking about.
You're not showing me
And
the
then I can
concept
apply
'cause
that to
we're not
orbits.
free falling.
Yeah, but I'll apply it to free falling. I'll show you how it logically follows. That's why I'm asking this question. So you can at least get the concept first, and then I can apply it to free falling.
No,
So if
you
I'm
need to
making a circle
demonstrate that
path,
something can be free falling while simultaneously changing angular direction.
don't answer the question. See what these guys do? They can't answer
No,
basic
you're the
questions.
one that's not answering the question. I asked you to demonstrate something free falling, changing angular direction perpetually, and you said it logically follows. So that you're the one not answering the question. Now you're
That wasn't my answer to you
you're
asking
pulling a
to
Xanic. It's
demonstrate.
called the Xanic. We actually named it. It's called the Xanic.
That wasn't my answer to you asking me to demonstrate it.
Yeah, you didn't answer. You're asking me questions.
That was me. Yeah, I'm saying it logically follows. You say you can't be free falling and have angular direction, the direction of the motion changing angularly. That actually logically follows if you have two bodies and an attraction between them. It's simple as that. I can demonstrate it to you if you answer simple questions like what's the acceleration of someone going around another person, walking in circles.
What's
Or
the
what the
acceleration
acceleration
of
points?
someone going around another person? That's your question.
Yeah, where does the acceleration point at?
Towards the center. You have an
Right.
angle around the
So
center.
that's the direction of the change in velocity. What? Okay, is the velocity of the person always tangential to the path of the circle?
Are you going to show me someone free falling?
See, you just noticed where the conclusion leads, and you're not answering.
It's called the
Well,
Xanic. It's called the
You could have
Xanic.
just answered, dude.
Well, Bacon, dude, we were actually having
You
like
have just answered.
Bacon, we were having like a more productive forward-moving conversation. Now you're like trying to quiz someone on what you think they know to then possibly give.
No, it's not quizzing.
You want him to like
This is
prove.
quizzing.
You want. Hold on. You're trying to get him to like answer questions about orbital mechanics to then give you some further because you were saying like that you feel like we're not onto anything or whatever, and so now you're trying to like use this to try to claim that if we don't know this orbital mechanics, how can we know anything about the shape of the Earth? Is that what this is all based in? Because that's what you said.
No, I was specifically trying to address his claim that
Well, actually, what happened
you
was I
couldn't
brought
have
up
angular
gravity.
direction.
I brought up
You couldn't
gravity as
have
an
the.
example.
I'm answering Jill's question, if you allow me.
Okay.
I mean, I would say on
He's
like
just-
we're onto something. That's why you're here.
To be fair, I think he's
Well,
just
you-
trying to.
if-
I know Bacon. He this is the way he explains things. he does it in a way where he asks questions to make sure that the person's on the same page. So I don't think he's doing it as like a quiz. He's doing it because he's trying to explain how it logically follows it when you're free falling and in orbit, or when you're in orbit, you would be free falling and change your angle, and what's it worded?
It's called the Zenith.
Yeah.
Yeah, that's why we're calling it the Zenith special.
Well, I recommend Bacon instead because it seems like if he doesn't want to, play ball the same way you're trying to perform, I would just ask if the questions you're asking, I would just answer them yourself and then go through the whole explanation or whatever. Might be quicker.
Maybe just actually answer if you can give me a demonstration of something in free fall perpetually orbiting without begging the question of the sky. Like you could just answer the actual original question, right? And this was all a diversion.
That wasn't the original, but I can answer it. Yeah, the answer is no.
Thank you. Okay. And so the only reason orbit came up was because you brought it up in response to me just making a point. It's just the overall meta of the conversation was like, you must know we're onto something. You made the claim that we're not onto anything and we're always all over the place and nothing we ever make any sense. That's what you said. But then I pointed out, no, like here's an example, right? I get ridiculed and mocked by all of the Globers for years, bringing up electrostatics and electromagnetic effects actually being the cause of gravity. And that's what gravity is. And everyone's like, no, you're so stupid. No, we know what gravity is. And then they bring up mass attracting mass, an outdated principle of intrinsic gravity built within matter in their own paradigm. Because Cavendish uses Newtonian mechanics. And then we fast forward to where I'm looking into the depth of your paradigm. And they're like, the only way we can explain all the anomalous behavior on the quantum scale is to invoke it being electromagnetic. So that's my point. My point is like we are on this stuff. We're talking about we're focusing on the unanswered questions that your paradigm just brushes under the rug, and we actually put the magnifying glass on them, and we talk about dark matter, dark energy. You guys say I'm not an expert in that. We're not talking about that. We talk about gravity. I'm not an expert in that. We're not talking about that. Both of things are required for your paradigm. We talk about them, right? And we point out that there has to be something else that is added or changed or updated for anything of all of physics in your paradigm to work. So we are onto something, right? Because we're offering grand unified theories. We're explaining physics from the small to the big. We're actually giving an answer for the phenomena called gravity. We're actually addressing magnetism, electricity, and light. We're talking about the etheric background, which is inevitably going to be incorporated into your paradigm. We're talking about the biggest parts of physics, the biggest, most missing components of physics, right? So how is that considered nothing onto nothing big?
Oh, that's never something I said. I didn't say none of that is big. I said you guys are all over the place when you talk about things I know, like orbits. And the only reason I mentioned orbits was an example of things that you guys are all over the place. You get it wrong and it should be simple. And then your answer to say was that it was impossible. I tried to address that, and then you start asking by demonstration. And then you start with this monologue, talking about how big is the things you're offering. I mean, I don't see how that relates to anything I was trying to say so far.
You brought up the orbit actually in response to me bringing up the gravity, which I brought up the gravity being electromagnetic in response to Gio's point about how, we're on something, and then you said we weren't. We were never on anything. You brought up the orbit as like a little jab, an under the table jab to claim I incompetently don't comprehend orbits because I don't believe in your understanding of them.
No, not because you don't believe. Because when you talk about it, when you critique it, you make very basic errors, like some things that people who would.
You're sort of like a pig, bro.
What? Did you say something?
Yeah, sorry, you're so snide.
Oh, yeah. Never mind. I thought.
And you have actually absolutely no fucking compunction to give anything to the Mole Earth at all. None that I seen. So why is the Earth the ball again?
I didn't catch that.
Why is the Earth the ball? Because
you're not interrupting an ongoing conversation, right?
Well, Bacon, everything that was being discussed was all interconnected. When you said that we weren't on anything, I don't know whether you meant, because now there's like two things. First of all, there's the shape of the Earth. So you could have meant, because if you think it's a globe, we're not onto anything that's not a globe or something. You could have said that or meant that. But then there's the other side of what would the paradigm, what is the actual new paradigm? Meaning, I think it would be like a reconnection to the ancient, and I think to the ether and so on. So it's going to be new, but not like brand new. It's going to be like a
renaissance.
Yeah, there was a lot of words to describe it. Yeah, like a next level
Rebirth.
phase integrating the ancient and the modern and the current.
All right. I mean, I'm not opposed to that.
And so what I'm saying is that there's the shape of the earth component, but then there's also like, is humanity heading into an entirely new paradigm of related to physics and cosmology and many other related components?
Like the current thing of orbits doesn't even account for inertia properly. And
How does it
it's
not?
like, yeah, so I'm saying like the point is though that like we could go into that whole deep conversation and we could, but it's like you might think I don't understand it, but in reality, I know what's wrong with it. And that's why I brought up geocentrism. I'm like, oh, I get it. You fight the planar Earth part a lot, but like can you not even acknowledge geocentrism because that would have drastic implications on physics as well. See, that's my point. If you don't realize that there's anything to this, whether that be a geocentric stationary Earth or an electric universe, or that space isn't what you've been told it is, if you don't think there's anything to it, then you're the one that is clearly missing what's right in front of you, Bacon. It isn't the other way around. I can assure you.
That is possible, but it's very hard for me to believe that at the same time, as I hear you say some stuff that to me is very basic mistakes on something that is much more basic than what you're offering. And at the same time, you're offering the new big thing that is actually more true than this or better than this. This is very hard to believe.
Okay, look, I'll give you
But maybe that's
depictions
true.
of the orbit.
Yeah, but things can work that way, dude. Like we were talking about Eric Dubé last night, not to go on a whole thing, but he's like a yoga teacher that was very instrumental in activating this entire truth. Like he wasn't like the first. I don't think he's like the king of flat earth or anything like that whole terminology or that idea. But he was. So I mean, yeah, and he's just like he wasn't some PhD. He's just a guy in a sense. So there are things in the universe that have like certain polarities. Like somebody might be very advanced in a particular category, and it can be like abnormally unique in a way that has truth to it.
Yeah, I don't think that's impossible. I'm just saying I just find it hard to believe, but maybe that's true. I mean, I wouldn't be able to tell because, like, I know what I know when there's a proposal of something to be like, well, this entire knowledge is wrong, and I got it right. The people who say they got it right got it wrong, and it's something I don't understand, like very little. I understand very little or nothing about it. Then it's entirely possible that person is actually right, and they're actually changing the knowledge in that area. But that's not true for things that I know about. And then when the person tries to say that I found something revolutionary would change that field forever, and when they present their argument, I see a lot of basic mistakes. I know that's not the case for that field. I might be wrong about the other ones that I don't know, but I usually don't talk about them. I usually talk about the ones that I know because I can explain why I don't think they're right.
Well,
oh boy.
Yeah, but I mean, it seemed like you were kind of trying to isolate, like, because certain people didn't know certain things. You know about something, they can't be right about other things, and that's a fallacy.
Well, no, yeah, it would be a fallacy if I said he can't be right, but I didn't. Like, I'm just saying it's hard for me to believe. It's possible, but I mean, given it's something about given that it's something related to something I don't know much about, I can't judge. So I can only judge based on the things I know about. And if I do not judge about the things that I know about, that doesn't sound convincing to me. Which might be false because that's a different subject. But I think you guys get the point.
I'll be honest, I've committed the same. If it's a fallacy, I've committed the same fallacy when I watched Jeremy's retarded video he made me watch, the Karl Monk thing. I watched the video. I see that everything this guy says is wrong as far as I know. And so I conclude
you couldn't name one thing.
I named a lot of things, dude. And it doesn't matter. But anyways, I concluded that everything he must say must be wrong.
All right. Well, and the thing I was saying, I did mention Eric Dubay. Otherwise, I know, Bacon, if you were referring to Whitsitt, I was not. And the thing I said, I was not referring to Whitsitt. I was just saying in general. But I mentioned the Eric Dubay thing because Eric Dubay is like a yoga teacher type dude, just like, who basically, had found Robotham and some of those writings and then basically put it together. And then, in his mind came to his own conclusion spiritually on it. And then, basically started sharing it. And, he was really one of the first to kind of really initiate. He was like pretty much like one of the first actual content creators, like Matthew Powerland was doing a couple videos, but he wasn't really laying it all down. Yeah, he wasn't really doing, but there were others as well, like around that same time. It wasn't really only Dubay. There was actually several others, but Dubay ended up being one of the ones that, because he was putting together a lot of those videos and stuff. Anyway, so it's like, dude, when you think about it from that side, like, what are the chances that all of mainstream science and this whole heliocentric and all these genius people and all the scientists who quote unquote know the Earth's a globe and they're flying around it and probing or whatever, what are the chances that some like seemingly random yoga teacher dude is going to speak about something, begin, and many others as well, speaking about, it's not coming from the PhDs. So I'm just saying, like, you could think, what are the chances of that? But it is the case. The PhDs are not always the most advanced.
Yeah, I'm not discarding the possibility, but I want to accept it just because someone's saying it's right. Like it either I learn about it enough that I can judge whether or not that makes sense, or I wait until the topic that is raised, it's about something that I do have the background. I can judge whether or not it makes sense, and then I'll do that judgment. But I simply doing the judgment honestly. That's all I can tell you.
Yeah, just so you know, Bacon, if you look at the diagram here, the fact what you brought up about how everything is pointed towards the center is actually what defies physics within orbital mechanics. You actually have to completely disregard inertia in all of Hell's depictions of orbit, which is what you currently use, by the way. And you actually completely disregard the IC, or the instant center of rotation. That would be coming straight from him saying, and no, the IC is not the pivot point of the rotation. So in your paradigm, you actually, now on the left, we have the diagram of real engineering and real physics. We have the inertial force going out, not going directly in only. You have the inertia that's not even accounted for in your orbital mechanics.
What do you mean the inertia is not being accounted for?
Right. Can I address that? Like,
Can I just,
when
I just get a clarification? I'm just curious.
I'd like to respond first.
Okay, if you want to go first, go ahead. I thought I'd get a quick one from him.
Right. Yeah, I wrote many in-body simulations. It's one of the easiest simulations to write. And I usually start with inertia. It's the first thing that is implemented. You have a velocity. The velocity isn't changed by anything unless there's an acceleration to it. And then you add the accelerations. And that's how you get the orbits. It's when you add the acceleration to inertia. It's not disregarding. Inertia is completely necessary for the orbits.
Does inertia of an object put a load on, if it has mass? Does it put a load on whatever it is that makes it go around the curve?
What do you mean put a load?
Yeah, like it's fighting against it. It's putting a load onto it.
Inertia is a resistance to acceleration.
So then the answer is yes. Then.
Yes.
Okay. Is that load
okay,
always
let me see if I
perpendicular
understand.
to the tangent on the curve?
Pardon me?
Is that load always perpendicular to the tangent on the curve?
It's always
No, it is tangent to the curve. It's not perpendicular. It is tangent.
Radiating outward from the center of the rotation.
Direction of inertia.
Yeah, from the center.
The inertial force is going to be outward.
Mm-hmm.
Oh, it's going to be directly outward? Radiating from
I think you're talking about... Zenik is... Well, no, Zenik. Why are you bringing reference?
You guys can't defend this, by the way. I just want you to know.
Well,
it's easy. Like,
you guys think orbital mechanics makes sense, but it's like
does.
you haven't actually researched the history of it and the things omitted from it. No.
History is relevant.
Okay, Zanik, talk me through the two diagrams and tell me why they're different.
Where are the diagrams?
One doesn't have
42 minutes after the hour.
Oh, okay.
Yeah, one have the centrifugal force and the velocity, and the other doesn't.
Right. It doesn't have a velocity at all. It just has a force. It has weight. The object has weight, and that weight is equal to big G, M1 M2 divided by R squared.
Wow. So in reality, for engineering, we use the one on the left. That always happens in physical reality. We always have that force actually going out away from the curve slightly, right? Because of the inertia.
F.
The
No,
inertia
the inertia. No, inertia is not a force, and what's pointing out there is it's just a. Okay, what is pointing out there?
I didn't say inertia was a force. I said that the inertia causes a load to be put on it, so it would be, a centrifugal inertial force. So yeah, it would go.
Inertial force.
He's saying the inertia
But
is.
I mean, those two arrows only exist in separate frames. We can have this conversation.
Why are the diagrams different?
That's a pseudo
both
force.
at once.
That's a pseudo force.
Why are the
because
it's a
in one
pseudo
diagram
force.
they just
Because it has no
because in one diagram they're just showing one force.
Yeah, why is it not accounted for in the official diagram on the right?
It's reference frame dependent. It has no source.
Yeah, those two arrows, those two forces don't exist in the same frames.
Correct.
In the simulation, don't have to create centrifugal force. You only use there's only centripetal force.
Right. So you just ignore it. You omit it, just like I said.
No.
You just use the word
No,
reference
you don't
frame to
ignore
make
it.
you smart or something. That's not how it works. See, this is the
It's
problem.
exactly how it works.
Use catchphrases. No.
Those two forces. 1 second. Those forces don't exist in the same frames. They only exist in separate frames. And when you're writing a simulation, you pick one to draw. You pick one frame to draw the simulation in, and you do that in the inertial one.
Is the centrifugal force going to be present in physical reality whenever we do something like engineering?
It's centrifugal force.
Yeah, but it's frame dependent.
But not in orbits in space, though.
Is it a proper force?
Also in orbit in space once you use a non-inertial frame.
Bacon, what would you say if I said that you are compartmentalizing reference frames?
As you should.
I say I have no idea what that means. Yeah, I'll say my simulation works.
Okay, you don't know what that means. Okay, so you know what compartmentalization means, or like disassociation? You disassociate things. Yeah, you can disassociate and isolate and compartmentalize. That's what you're doing with reference frames. You're extracting them all from the actual reference frame of reality, or you're extracting them from some fabricated one.
There's a reference frame of reality? Where does that come from? I never heard
Yeah,
that.
dude. There's one universal reference frame, which is the ether.
There is no one universal reference frame, that's for sure.
Everything else is all these other ones you guys are using for models and extrapolations and only using centripetal and taking out centrifugal. All of these, it's like you're compartmentalizing reference frame in order to create a reified model.
No, first of all, let's get back to that. An inertial reference frame is what you may talk about. That's not universal. That just means something is not accelerating or rotating.
How about this? I'm going to share the screen.
Hold on,
We'll go through it.
You have to understand. Let me finish. If you talk about centrifugal force, Geo, that is a pseudo force, and it's a pseudo force because of one major reason. It has no source, and it is reference frame dependent because that force would not be there if something wasn't holding it in that particular path. Also, pseudo forces are also like in your car. If you slam on the brakes, pseudo force is you hitting the windshield. That force wouldn't be there unless that windshield wasn't there. So there's no source of that. It's got to be caused by something else. And that reference frame, it can't be. It has to be I don't use that term, but I know what you're saying. Compartmentalizing of the frames is something you have to do in physics because that's what reference frames are all about.
Hey, can you see my screen? You want to go do this?
Do you understand why they call
centrifugal? I didn't ask you to ask me.
I'm going to go to your screen, but do you understand that centrifugal force is a pseudo force? Do you agree with that? It's a fictitious force?
No, I'm not an insane person. So
you really don't think it's a fictitious force?
No, I already answered that.
Okay, so, I just let the witness.
Yeah.
By the entire board and by the jury that he has already admitted that he does not think that centrifugal is a pseudo force.
Centrifugal.
Can you tell me why it's not?
I'm not insane. Yeah, just look at magnetism.
Without saying
look at magnetism.
Names, can you tell me why? Just for you.
Oh my God! See, there's a lot that's into the orbit discussion, so if we're gonna get into it, we gotta get into it.
Why do you think it's a proper force? Why do you think it's real?
Magnetism. All right, let's. You can laugh all you want to.
I swing a ball around my head, and it's magnetism that's pushing it outward.
Wait, does centrifugal force not exist in magnetic field?
There's a centrifugal force. No, not necessarily. It can.
Oh, okay. So
You
who's
can
who's laughing now? All right.
I'm
so
laughing.
why? Let's just read it, man. Let's just read it.
Yeah,
So,
just join this. Yeah, Zanuck.
Got it. I just wanted to let people.
we can go through it together. Okay.
No, I mean, the word pseudo and force just there's no such thing as a pseudo force.
No, they come on. If you've
I
taken,
know that somebody has used that term. They try to use that term for a particular thing, which is like centripetal, and centrifugal.
Not centripetal.
movements.
Centrifugal only.
Well, but they're part of this. They're part of a duality. They're a dipole. There's a dipole polarity between those two.
A dipole polarity.
Yep.
Centripetal force.
Yeah, they're intricately interconnected through.
Centripetal force is a proper force. Centrifugal force is not a proper.
They're like two aspects of the vortice.
Well, to
ultimately.
people that okay, let's talk about motion of a vertical circle. Talk about I mean, there's so many things you have to go over to understand the differences, and they're pretty intuitive actually.
Oh, man. Let's just get into this.
Yeah, let's look at what he's.
There's so much in here. I know it's gonna be like pulling teeth to get through each paragraph.
Well, let's talk about the radial component of
Why
acceleration.
are trajectories of projectiles parabolas, but the orbits of planets ellipses when both are governed by Newton's law of universal gravitation? When
they're actually all ellipses.
Oh. Wow. Okay, projectiles are ellipses. Okay. So, well, they aren't. That's the problem. A parabola has an angular space of 180 degrees, same as a straight line, whereas an ellipse has an angular space of 360 degrees, same as a circle. Thus, a parabolic trace can be left behind by an object traveling with two superimposed but independent of each other rectilinear motions, like cannonball trajectories, whereas an ellipsis is a rotation by definition. Rotation and rectilinear motion are incompatible, and thus a parabolic trajectory is fundamentally different from an elliptic, and there is no physics to connect them, as is so often done and has been done ever since a young Jeremiah Horrocks, who died in his early 20s in 1641, proposed that a parabolic trajectory is actually truncated ellipse. Almost 400 years later, Torsten Hell here falls into the same mind trap that is a thought experiment when he posts this image of the proposed situation. Okay. We all agree, of course. We agree with this so far, right? That rectilinear motions are different.
What are you reading there? What are you reading there? What's it?
No, I'm not listening to you. Poison the well.
I want to listen.
No, I'm not interested in your genetic fallacy. Okay. So let's give this a thorough examination and start with what is observed and measured. A cannonball shot from, I don't know how to say the word, promontory, shot from a promontory of height, reaches the ground in time, blah, 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 no matter how fast it leaves the muzzle. That means that the range of the ball is a question of how far it can get in this given time interval. I want to get down to the actual orbits, but I feel like we have to cover the beginning. Okay, so let's now push the cannonball out the muzzle and barely any velocity. This is basically, if we can just agree with this right here, then we can skip this part. Do we agree that rotation and rectilinear motion are incompatible and fundamentally different?
Yeah, well, which one would be rectilinear motion?
Well, we agree.
With that sentence, like isolated, yes, I'm not sure what it's meant there because none of those motions are rectilinear.
Oh, we're gonna so another glitch in this utterly flawed analogy.
See what that actually means? Just
it's
the answer to the question isolation.
What?
Seriously?
Yeah, it's about to be explained.
You don't really want to address which one is like rectilinear.
It's going to be explained in just a second. Okay, is that okay?
Okay.
All right, cool. Another glitch in this utterly flawed analogy is the value of g. The math of orbital ellipses operates under the assumption of a g that changes with the inverse square of the distance to the focus of the ellipse where the attracting force is anchored, which is not applicable to the above image. That's why the cannonball would perform a symmetric to the center of Earth trajectory, not the one shown here. What's wrong with this statement? I'm sure you guys disagree, so can you explain it? I'm open to you guys telling me why it's wrong.
Oh, it's saying that the two approaches are different. which is true. Like if you treat it as a constant g, and the direction of down is the same everywhere, you get a parabola. If you use like the inverse square law, and you get the g points to the center of the Earth, you get an ellipse, and they aren't the same. That's true, but it doesn't mean both of them are reality, right?
The math of orbital ellipses operates under the assumption of a g that changes with the inverse square of the distance to the focus of the ellipse where the attracting force is anchored, which is not applicable to the image above. So this is you have to disagree with it. Whatever, we can move on. So we're back to square one. What we observe and measure is flat Earth physics, and that is exactly what Hell calls it, which means the trajectories are parabolas, not truncated ellipses. I'm guessing you guys disagree with this as well, right?
Yeah, and
I really want to get to the part that just destroys your whole religion.
Well, they're approximately the same, so you can use one or the other for like these smaller scales. But if you want to use like big scales, one can't be used as an approximation of the other anymore.
Okay.
Like those are mathematically, it's just like the 8 inches per mile square. It forms a parabola, not a circle. So of course, a parabola is fundamentally different than a circle. A circle can't be a parabola, and a parabola can't be a circle.
There
but
you
if you're
go, yeah,
using
that's
like a small fraction of the circle, you can pretty much use the parabolic function.
Yeah, we'll get into that. Yeah. So, but Hell also
Alright.
calls it, and I kid you not, lying to children as if they wouldn't understand globe physics at a young age. Same with Galileo invariance, which is flat Earth relativity only applicable to inertial systems, which a rotating sphere per definition is not. So now, if we look at Kepler ellipses, they are always symmetric around the semi-major axis, and that is because Kepler leaves the behavior of masses in motion totally out of his considerations. What he does is kinematics, motion of theoretical points without mass and force. You guys know that, right? Like Kepler proposed kinematic theory with no dynamic relationship whatsoever.
But yeah, but like if you apply masses and a force, you still have an ellipse where there's symmetry in the axis.
Okay, let's not forget that Kepler.
This seems wrong. Well, who wrote this, by the way?
It's wrong. Why? Why are you always?
Because
you guys are always just trying to hone in on a genetic fallacy.
I just explained why. Like, I mean, I've simulated this stuff.
Okay.
You still get those asymmetries. You can still get symmetry if you apply masses and forces. It gives you the same ellipse.
I know you think that, Bacon. Trust me, I know you think that.
No, I wrote a simulation. I know this.
Oh, okay. So let's not forget that Kepler kinematics operates with acceleration, which is displacement of space in time, and not the Newtonian notion of acceleration as force per unit mass. You agree they're fundamentally different things, right?
Sorry, say that again?
Kepler kinematics operates with acceleration, which is displacement of space in time, and not the Newtonian notion of acceleration as force per unit mass.
And they bring that mass in there.
So they're not equivalent.
That's right, they're not the same. Okay, the moment real-world bodies with extension, mass, and inertial behavior enter the picture, it is totally impossible to get a symmetrical orbital ellipse. At the perihelion, the object reaches its maximum velocity and thus its maximum momentum. P equals mb, which it wants to conserve both in direction and magnitude. The direction is tangential to the ellipse, which means gravity cannot slow down the object, which now is moving perpendicular to its line of attack. That means the object will continue shooting past this point until a sufficient angle is reached that can have an effect on its inertial behavior. And already we have a massive asymmetry, which would turn the solar system into a chaotic mess.
No, that's false. It's false.
Why?
It wouldn't break the symmetry. Like, why would that be symmetry?
It just said why.
No, yeah, no, it didn't say why. It said that after when it's at tangential to the motion. Just hold on a second, Jesse. When it's tangential to the motion, the gravity wouldn't slow it down because it's perpendicular. right? But like the next moment, it's no longer tangential to the motion. So when it says when it how do you say it? How does it sound like? When it gets sufficient angle, which is pretty much immediately after it's no longer tangential.
Doesn't matter how close, how long
and
it
none
is.
of that breaks the symmetry. It just says therefore it will break the symmetry. But
It doesn't
say
matter
why.
how long it is. Oh, pretty much immediately after. We're talking about the fact that that would have to happen, which would break the symmetry. Oh, but pretty much right after it doesn't.
No, you wouldn't.
That's irrelevant.
Why wouldn't? Show me how it would be an orbit if that happened then. Because when I simulated it, I got exactly an ellipse.
So you just keep on bringing up a simulation.
Show me how to do it right.
All
Yeah,
right,
because no, it's not a fairy tale. It's something that happened in real life. I actually created the simulation. And all the simulation does is to apply forces, masses, and inertia. That's it. That's all it does. So according to what he's saying, if you would apply forces and masses, you'd get chaos. You wouldn't get symmetrical ellipse. That's exactly what I did. And I got symmetrical ellipse. So why did I do wrong? What is the correct way to form an orbit then?
You just said that it's only momentarily, and then right after that it changes, so it's okay, and I used it in a program. Okay, so nobody has ever shown experimentally that gravity can. Dude, just trust me. I just want to get through it, and then we can talk about all of it. It's just a lot. Nobody has ever shown experimentally that gravity can do what Newton claims it does. On the contrary, when gravity was put to the test in the 1930s, Fritz Zwicky had to find out the hard way that it actually does not. Galaxy rotation curves are a prime example of a flawed theory crashing into the wall of solid observation. And so here's the observed versus the predicted Euclidean chart. So the rotational speed, and then the radius from the center. So here's the Kepler's prediction, and here's the actual observation. Yeah. This is when everything was just you guys just ignored this for almost a century now, by the way. You still don't have an answer for this.
Yeah, I don't know what that is, but I think Jesse was trying
to
join.
Fritz Zwicky is the one that discovered your dark matter problem. One of the people involved, at least.
I didn't say I don't know who that is. I don't know what that is. And I still don't know what Jesse wanted to say.
I just told you what it was. It's that the galaxy rotational curves didn't actually match the prediction based on the rotational speed and its radius from the center ratio.
Yeah, I have no background to analyze the measurement of galaxies, but I do have the background to tell you that what is saying that the ellipse wouldn't be symmetrical is complete bullshit.
Okay.
Jesse want to get in?
Oh yeah. What's it? Are you saying that something could not orbit if the attractive force between whatever itself and it was orbiting was on a square inverse relationship, like gravity is supposed to be?
It couldn't have a perfectly symmetrical ellipse.
Why not?
All right. Well, let me just make one more point about the next article, and then we can talk all of it. Okay. So we come down here. And this is what I want to talk about. Oh, the diagram above shows three different muzzle velocities, V1, V2, V3, that is horizontal velocities with which the balls leave the cannon. These velocities remain untouched in magnitude and direction during the free fall. Okay, cool. All right, free fall just adds a vertical component according to V equals GT, right? We all understand that. Okay. This is what you learn early on in school as a fundamental principle of nature, and this is unbeknownst to you because you were not trained in school to think, but just to repeat flat Earth physics. Would Earth be round, the velocity vector would not be constant. It would go to 0 at the equinox point of the ellipse, where it also changes direction. Okay, now this is the fun part. Now, inertia has an issue with both change of speed as well as change of direction, which you all know from driving, and inertia is not a factor of the direction of gravity. Inertia does not consider the perpendicular to gravity as horizontal. That is a Galilean Cup shuffle trick when he introduced the term circular horizontal to claim exactly that. Oh, just made up physics, just made up anomalous space physics. Here, this is how Galileo tricks you very cheaply because all he has to do is count on you not applying the fundamental principles you already learned in school. The rhetorical ruses are even underlined, so you realize them even less in your accustomed deference to authority. Left, we read common inertial motion of the Earth, and that clearly means no spin because spin is non-inertial motion. It is accelerated motion. Dun, dun, dun. Then on the right, we read sailing uniformly straight ahead, and that means no curvature, despite the cartoon showing the ship sailing over a curved surface, which is the antithesis to uniformly straight ahead. The path is per definition of a curvilinear, not straight, and the motion is accelerated as all curved motion is. Now, in physical reality, inertia is what gives the ruse away, and therefore the notion of inertia has to be muddied to the point where nobody has any idea any longer what to think of it. It is called all sorts of things. The most unscientific is calling it something pseudo, fictitious, when in fact it is the only real-world arbiter of motion. Yikes, Zenek. Here, in this particular example, in the left image, the
Who
top
are you
of
showing
it-
this to, though?
What?
Who are you showing this to? Just
What am I showing this to?
yeah, because if you want a response, I try to. Yeah, but
Oh, you want to respond to
I
what
mean,
we just read?
Would you like? Would you like? Yeah, I tried to respond like.
Well, dude, he was
in the
presenting
very
it.
beginning,
He was,
and it didn't. It didn't want to stop there. You wanted to move on without.
I was actually, yeah, because
trying to-
I wanted to read this part of it. This is what I actually wanted to bring up. I thought it was closer than it was.
Yeah, but there are so many mistakes accumulated. Why would? All right, go ahead.
well, dude, in the future, like we could do like even like a spontaneous event, even if it's just like a 20-minute long, and like you could read this for like the full time you want, and then do a question and answer after. Because then it would be because yeah, Bacon they're trying to jump in and stuff, and then or you could still read it and have them jump in. But it seemed like you wanted to get through it.
Yeah, just almost over. I should have read lower down, so that's my fault. I do get it's been a while of me reading, but I mean, I'll be frank here. Like there is no rebuttal to what I just read, so I have a feeling you just want to go back up and argue about the other part. But I want to talk about this part.
Yeah, but it is going progressively with wrong assumptions. So like, I don't bother.
This is unrelated to the first thing we read. I was reading from the wrong
So
section.
why did you read this then? If you wanted to read the second part, it was related to the first part.
I just explained that.
Just let him finish, Bacon. God damn.
That's my bad. I'm sorry. We can talk about that one too, but I want to talk about this one. It's only like a couple more, like paragraphs. Okay, and I want you guys to tell me where he's wrong. Okay, can you just be patient with me for like maybe 5 minutes? We can go through all. Now, in physical, okay, we already read. So you just call it pseudo or fictitious. Okay, here in this particular example, in the left image on the top of the mast on a spinning ball sphere would move faster around the center of rotation than the bottom, which becomes obvious when you drop a ball from the top. Inertia would make the ball land forward of the mast in direction of rotation. So by doing so, you could determine the direction of spin.
That's true, yeah.
Okay, we're nice. So in the right image, the boat would either move east or west, and thus its angular velocity would be greater west or lesser east than the angular velocity of Earth. Inertia would then make the ship weigh less going west and weigh more going east because of W equals M times G minus
That's
V.
also right. It's called the Odysee effect.
And on top of that, inertia would make the boat drift towards the equator because gravitational acceleration and centrifugal acceleration due to spin are not aligned. One is central, the other axial, resulting in an equator pointing bias. We're almost done.
That's wrong.
Okay, cool. We'll just remember that. Because I actually have to rock Aaliyah asleep. So, all right, let me just come down here. In a very practical application, you have the Abuha flight. I know you guys don't like that. The Great Meridian debunks your religion. How that plays out for orbits in a conversation with a professor demonstrates the desperate and frantic cup shuffle performed in front of your eyes at the town fair that goes under the title of Science Today. Here below is the diagram Hell always uses to demonstrate his cup shuffling away inertia from the orbital discussion because it would just ruin it. He meant to say from. Okay, here's the depiction that the professor shows. So here's how Hell explains it, and then there's 2 more paragraphs, and then I'm done. Okay. Let's hear Hell like we looked at Galileo description and see what we get. A velocity does not keep its absolute value if there is a parallel equal accelerating component of the acting force or anti-parallel decelerating component marked orange. Okay, if there's a force component perpendicular called directional force marked yellow. Sorry, I hate that you can't see both. Where are we at? And no, the direction of velocity component perpendicular called directional force marked yellow to the direction of the velocity. If you know what this is, then the direction of the velocity changes. And no, the IC is not the pivot point of the rotation. It is the Earth for the satellites and the moon, or the sun for all the planets. The green arrow is called gravity to the sorry. Okay. The green arrow is called gravity, is dependent on the distance and direction to the fixed central pivot point and therefore called central force. Does this answer your question? And why do you claim that we hate inertia? It pulls out the pivot point, no doubt. If we would switch off gravity, the orbiting object would leave the orbit in tangential direction with its present speed due to its inertia, and also, no doubt. But gravity is there, and therefore it always the blue orbit with a visible track. Okay, I have to go help her. So just to basically the whole point is here. That's your model, just basically ignoring inertia and just saying like, oh, we have a fixed inertial reference frame here, therefore no fictitious force, i.e. centrifugal force, which is what Zanuck said. First of all, where is the body represented here? That is, where is the inertial reaction of a body forced around a curved linear path? The inertia of an object of nature having mass always puts a load on whatever it is that makes it go around a curve, and that load is always perpendicular to tangent on the curve, radially outward from the center of rotation. You know that very well, as if you paid the experience many times and keep coming back for the kick, the inertial kick. And where is that kick most forceful? You also know that, of course, it is in the exit of a through where velocity and curvature, 1/r, are greatest, where mass is forced around the tightest curve at the highest speed. So, which would correspond to the perihelion, for example, in Hell's diagram. Here, too, the planet exists the tightest curve with the highest speed, but wants to continue on a tangential path with the speed it has at that point. Because the planet reaches this highest speed exactly at perihelion, the force which counteracts the inertia of the planet needs to be greater after perihelion than before reaching perihelion if the path is to remain symmetrical. That's the kicker there, okay? So in the physical reality of a roller coaster ride, the structure of the track takes up that extra load, and therefore the exits of throughs need to get extra strength and reinforcements, or rather the whole ride needs to be calculated with these loads in mind. But in gravitational orbits, gravity perihelion plus 1s is the same as perihelion minus 1s, yet the inertial load on the track is different, which must result in an asymmetric orbit. So here below is a simulation of the dynamics of an orbit with its asymmetrical accelerations, the red, and the velocities orange due to inertia. Only a solid track can accommodate this asymmetry by taking up the asymmetric loads. Gravity cannot. Therefore, inertia is always missing in depictions of orbits. So here it is, but they are always present in real-world engineering diagrams. And then here's the centrifugal inertial force. You guys just ignore it.
Yeah, that's on point right there.
But I gotta go help Rockalia sleep real fast. I'm sorry, I'll be right back.
Wow. I mean, like he said, he went through the whole thing. Gio, it'd been really interesting because the guy's using a lot of physics terms and he's applying them incorrectly. But it'd be nice to go through each item on that paper because he has a habit of just going, on and on and on. He's got very lengthy.
Well, I mean, that end part, that's when I was saying that's on point. That end part was absolutely correct.
It's not really on point. He's using terms like inertia. He's learning things like non-inertial and inertial interchangeably, and they're not related in the respect. And all the terms he's using, he's talking like he's never went to school. He says he's an engineering degree, but he doesn't talk like he does. I've actually interacted with him.
Yeah, I mean,
this is Michael Brenner, by the way. I can know by his writing. I know him very well. I've interacted with him for years. He's. I mean, as far as I'm concerned, he's completely clueless. But he he throws out some things out there that are interesting to talk about, especially orbital mechanics. It's not simple stuff, Gio. But Witz has taken this, like, this is the guy that knows it, and he's exposed the entire world for their errors in their methodologies and their understanding of physics of orbital mechanics. And I think it's a big stretch to give someone that with that low of credential level, even though I don't want to appear to credentials, to have that be that's the high bar we're going to go with. Wouldn't my uncle, who actually sent Voyager, the Pioneers 10 and 11 out into space, wouldn't he be a guy you'd want to talk to rather than Brenner? Real life experience?
So
Or
for
maybe
me, I would say for me, any information that anyone says, I take it for that piece of information. Now, it doesn't mean I don't take into consideration who they are, what their history is, their experience. Of course, that can all be taken into consideration. But ultimately, I come from the perspective that, anyone could be expressing various levels of truth and accurate information, or things that are not true or false or not true information. And probably could be said that everybody's some mix of those on some level. I mean, unless
Right.
someone knows everything.
But he's using terms. So in physics, these terms have meaning, and so he's using a lot of the terms, some of them erroneously or.
Well, I feel like he's using them in a bit more of an advanced way, actually, than they're commonly understood.
Nowhere in the description of orbital mechanics do you hear about things like inertial forces. I mean, not pull that chapter in a basic high school or college physics book and see if you can find the word inertia in the first 5 pages of orbital mechanics. It won't even show up. Yet he's talks about it every paragraph.
Well, maybe that's the problem.
maybe he's the problem. Maybe he really doesn't understand it.
Well, yeah, but that's you have to consider, because that's what he's saying. He's saying the high school books aren't teaching it the way that it actually should be.
Yeah, he's basically showing how. Well, like in
there's a contradiction that's not being acknowledged, right?
Well, he's saying that we cannot have a symmetrical orbit. He said a lot of wrong things. Can't have a symmetrical orbit with the force, this weight that would have an inverse squared relationship, which is completely untrue. He also says that certain structures on a roller coaster would have to be stronger after the. Go ahead. Want to interrupt for a second?
No, go ahead. Sorry, I interrupted you. You should finish.
No, it's okay. I don't mind being interrupted, and it's a good discussion because this is like college physics level stuff.
But Zanuck, is he wrong because he's not saying it the way it was taught, or is he wrong because the logic is what he's saying is not right?
The logic is horribly flawed.
Well, Zanuck,
according to you,
yeah, according to anybody in physics, anybody.
Zanuck, well, okay.
Well, in the regular, in the way that physics is usually taught. The way that physics is taught may be wrong, and he may be right, but you wouldn't think so because you're tied. You basically have admitted. You said all I'm doing is repeating 7th grade physics. That's all I'm doing.
Well, high school physics. High school usually. High school. Well, let's take one of his terms. Let's say he said. I wish he left. I was trying to find his papers. I've read so many of them.
I don't know if we're going to be able, unless we pull this up ourselves. I don't think we're going to be able to scroll through it. There was a lot in there, and there's a lot of different parts. Right, I mean, we may just want to have a general discussion on it. So what I was going to say, one thing is that just in a very basic sense, and sorry if this is a little side thing, but if you don't want to respond, it's fine. I'll just say it, or you can go on whatever you want. But just from one perspective, I'm just kind of trying to bring it down to something really just simple and just like tangible that we can think about. If you have like a ball of some sort, and you have another ball orbiting that ball, and let's say you have it attached with like a string or something, which is the only thing we could think of to get something to orbit, because that doesn't actually exist. Like things don't do that. Even you guys admit, like you can't recreate that. So even if we take the idea of like a string with like a ball on the end of it, and you're swinging it around, you're going to have centripetal and centrifugal real forces, no fictitious anything, real forces. Now, those forces have to do with the fact that it is rotating and it's creating a vortex pattern. And in that vortex pattern, there's going to be the inward and outward flux of the forces of the weight, including what could be, the weight of it. We could use the term gravity, although, of course, that term means a lot of different things to different people, but just, the actual, like the weightedness of it as it's spinning. Now, with these elliptical orbits that you guys try to claim that these planets are doing, as you call them, those are not obviously attached by a string, and they're making these very unique ellipses patterns. So you need some way to explain that, because that's not in real. Hold on. Describing it that way with spheres rotating spheres is not actually happening in nature. So the fact that it isn't happening, you guys have to attach a concept to it. And in that concept, that's what he's talking about with Kepler's laws and the kinematic components of Kepler's law. So, and Galileo's involvement as well. So it ends up in a situation where you have to create these kind of like basically fabricated ellipses patterns that don't correlate with any actual real physics. And then you have to, they end up coming up with the whole theory of gravity to explain how that could be happening. But the whole thing is fabricated. And he was showing that in real reality, you have the real centrifugal and centripetal forces that are actually involved in spinning or vortexing rotations.
Well, you would agree that this mass times velocity squared divided by radius is going to be that centrifugal force, and equally centripetal force as well. They'll have to equal, like you said.
I don't think anything involving the term mass is valid.
Well, that's what gives you the force. So we can equate.
That's the problem. Mass is not. Hold on, let me just say, mass is not correlated to anything in the physical reality. It's a theoretical concept.
Well, that's not true, because we orbit satellites. And we know how much they weigh. And we know how fast they have to go to orbit at certain altitudes. But let me just say that the G.
And then you just claim the reified model. Sorry, I've been talking.
The GM1.
Get into your new perspective. I don't know if I could be Xanicked right now.
All right. We know the GMM divided by R squared. We know that has to equal the MV squared divided by R. Those will equal. Now, whether you want to call them fictitious forces or not, I at this point I don't care about that.
No, you call them that. I don't call anything that.
Well, it's a way to describe a force that actually is real. I mean, it has an effect. It's a fictitious force, and so it just means that it has some instantaneity that we can talk about. It has no source that we can talk about, but we don't need to. We can say it's real, because when you smash into your windshield or into your side window on a turn, we know that hurts, so we know it's real. So let's just say it's real. No big deal. I don't have a problem with that. But when we try to solve for this velocity, what it has to be, we know it's a square root of that gm. Little g over r. We know that's the equation of it. So we know we can give this orbital relationship in this form of these equations, and they work because we have.
Yeah, I think what you get, what it is okay. If you take like an AE map type of a layout and you put let's say Venus, for example, it will be traveling between the tropics, between the Tropic of Cancer, the Tropic of Capricorn, and the equator. Those three main bands on the Earth. Venus will always be in between those. It goes back and forth. And it, like a record player, it makes slightly larger circles when it's going out to, in the outer, and then slightly smaller circles when it comes into the center, just like the sun does every year. It takes 1 year for the sun to go through its whole cycle. So as Venus is going through its cycle, and all of these things are, the sun, the moon, Mercury, Venus, etc., all of these, wandering stars, as it were, wandering bodies. And when you're in the when you're on the inner circle, the Tropic of Cancer, let's say you're circling there. It's like summer for people in the north, so it's really high in your sky and it's hot, and the heat lamp is right on the inner Tropic of Cancer. Every day, and it goes out to the equator slowly, a little bit every day, like a record player, and then it goes all the way out to the Tropic of Capricorn. Once it gets all the way out in the southern region in the Tropic of Capricorn, on the solstice, it pauses there, for a little bit, as it were, for a day or two, and then it starts coming back inward, and then it goes over the equator again during the equinox, and then it comes all the way back to the Tropic of Cancer on the inner circle. Now that whole thing I just described, from inner circle to outer circle, back to inner circle, back and forth, that is the ellipses pattern.
Okay, but that's a lot of words and a lot of story for you talking.
I know, but let me just finish it though.
It's worse than that's worse than me, by the way.
It's an ellipse. It's an ellipse because
it's an ellipse with no. You have a change of direction, Gio, with no imaginary conceptual force that would be required of any time you have a mass. Anything. Hold on, let me finish. Anything that changes direction is a change of momentum. It requires a force that is dictated by that change of momentum. Dictated. Okay. You cannot change direction. You cannot have a circular path without a force. Period. End of story.
Right. And so where's the force, Xanick?
To drop a ball. Jump on a scale. Do you have weight? That's your
Hold on.
force.
Oh, I'm gonna
weight is a
for
force.
just let me
parabolic.
say
Wait,
one
let-
last
Doesn't
thing.
matter.
let
Yes,
Gio
for
finish.
parabolic, of
guys.
Let
course.
Gio finish, Zanuck.
No, just
Please.
let me. I actually do have to step away for a minute. I've been talking a lot for a bit, and I do need to step away. I got to do some
No,
stuff.
you're making a good point.
I mean,
I can hear it.
It's horrible.
well, I'll be
How does
listening.
it pause and then come back, right?
Yeah. I'll be listening. I'll probably be back on my mic in a minute. Let me just say the last part of it. So as that object is going from the Tropic of Cancer, the Tropic of Capricorn, back and forth, it isn't an actual ellipse. Meaning what it actually is just it's on the inner circle. It goes out to the outer circle. It kind of pauses there. It comes back to the inner circle, pauses there, back to the outer circle. It's just expanding and contracting. It doesn't actually. It doesn't. Hold on. It doesn't actually pause there. It just changes direction. Like it goes all the way out to the outer, and then it starts coming back in. But it kind of seems like it kind of hangs there, which is like what the equinox is when it hangs right on the Tropic of Capricorn. So, anyways, because it does that, pinging back and forth between the tropics. It isn't actually an ellipse. However, in their model, meaning what it actually is just expansion and contraction in that kind of vortex, it's really electromagnetic fields, the contraction and expansion of the magnetic field. But in the heliocentric model, they have to account for the movement of the Earth around the sun, the moon, Mercury, Venus, Mars, all of those. They have to account for those by making them spheres and throwing them out in a heliocentric, world like they've tried, or whatever they want to call it, universe, space or whatever. So if you make them 3D spheres and you put them all out with the sun in the center, well, now you actually have to make those orbits elliptical to account for the fact that what they're actually doing is expanding and contracting between the tropics. So they kind of have had to, and that's where that ellipse comes from. But the thing is, that ellipse doesn't actually exist in any physics. So that's why they have to make an entire model that fabricates it. And what Witsit was reading that was connected to what Michael Brenner was saying, especially at the end part there, is that showing how that doesn't correlate with real physics, with like the actual centripetal and centrifugal dynamics of spin. Like what they're explaining doesn't correlate with that. It's like its own reified model of an ellipse in space that is just a fabricated concept based upon the actual expansion and contraction, like frequency of the actual luminaries and the way that they're moving. Like it's just extrapolated from the frequency. And I think pointing out that actual, if you make it into a 3D ellipse, that doesn't actually exist in any physics. That's where it's a fabricated concept. All right.
No. My God, no. Elliptical orbits can easily exist. In fact, they should exist. Very difficult to get a perfectly circular orbit. Although most of my physics books will all give us, exercises and assume a circular orbit because it's easier math. But no, if you have any, hold on. If you start,
it's why Kepler's laws were kinematic. It's
these words you're just using them without any kind of reckless abandon. Here. It's just ridiculous. Come on. Ridiculous. You're talking about physics.
It's too damning. That's why you call it.
We can simulate this.
Who sounds like they're in reckless abandon? Who sounds like that? Zanuck or anyone else?
Well, you're making up things that things are elliptical. They appear elliptical, but they're not elliptical. And elliptical orbits can't, because Brenner says elliptical orbits can't exist in physics. Suddenly, Witsit thinks he's the
Zanuck,
guru.
You're melting down, dude. Let's not go into melt mode.
Yeah. It's like PhD Tony said he's a flat Earth seismologist.
I'm talking to Gio.
He's a flat Earth seismologist because the math is easier.
I'm talking to Gio.
You sound like you're having a fucking mental breakdown.
Let me talk to Gio before he goes. Okay.
Well,
so Michael Brenner, I get a little triggered by people that don't use physics correctly, and he made so many errors along the way. I was laughing.
He's taking apart your physics. He's saying that your physics. Of course, you're going to think he's in error, because he's saying your physics is actually in error.
But he says it's wrong for the wrong reasons. He can't even explain the reasons.
Okay, well then you have to,
for example,
then explain why.
I've gone through his papers before.
Look at what he's saying.
Don't just make broad claims. I will. I'm going to.
You have to say this is why it's wrong, and this is why it makes sense, and this is why it doesn't make sense.
Oh my God!
Instead of making broad generalizations or broad statements about him and muddying water, apart,
point by point. And give like a red line correction. Okay. If I was a physics teacher, believe me, I've taught physics before, he would get an F on that paper. An F.
Well, of course, but that's the point.
He's saying that
getting an F for the right reasons.
He would give
He's not
the
getting an
people
F
that created this
he's not
fucking
giving.
nonsense
He's not
an
getting.
F
Hey, we
himself.
can't both talk at the same time. I'm not giving him an F because he wrote his writing is bad. He's getting an F because he used the concept, even the basic concepts for which he derives his conclusions from, are all incorrect. Right to the point where he started equating inertial masses with a non-inertial frame. Those don't mean the same things. It's like converting. It's like
I don't think he's saying they do.
with inches.
Do you understand what he means, Zanuck, when he says that
what is it when he says
the problem is the main problem is that
I have.
Bro, someone's got to tell this guy to take a breath.
Yeah,
he's melting down.
I temporarily muted you, Zanuck. Give us at least 2 minutes break, bro. I'll unmute you in a second. But my gosh, you're
you're taking my religion away.
I mean, I don't want to talk about Zanuck when he's muted for a second, but bro, you are. It's kind of a whole meltdown. Let's just chill with it and just get to some actual information. I just mean it's like a hyped up. It's like beyond hyped here.
Well, Gio, that's why
I'm stressed out, and I just got in here, and I'm already stressed.
Gio, that's why I said at the beginning is he's saying he's wrong because it's going against what he has been taught in school.
Yeah.
Or is he wrong because logically he's just completely wrong? And it sounded like Zanuck, he cannot admit that it's only because it's going against what he's been taught, and that's it.
Right.
But he's not getting it. He's not grasping that what's being shown here is you've been taught wrong. Here's reality. Here's the way things really work. But he can't accept that at all.
What Brenner's doing is pointing out specifically why it works according to what they're taught, right? He's saying this is what they're taught, and this is why it's wrong. And of course, he's going to get an F according to the standards you have, Zanuck, because it's not. He's saying that what your standards are wrong.
No, but he's
so
using
then get specific about what he's wrong about.
Okay, we can go through every one of them. I started at the beginning. Just the fact that he equated a non-inertial frame with it not having inertia. the non-inertial.
Show that part. Show where he does that.
Yeah, I gotta find. He's got so many. He's got hundreds of articles. I gotta find that particular one. Which it was. He should have left the link for it.
No, I posted the one that I posted the one that which it was reading.
Hold on, I'm talking
I posted
now.
the one that which
I'm talking.
Listen,
Come on,
you just asked. You said you gotta find it.
Let me finish.
Listen,
Why
Zanuck,
do we gotta talk at the same time?
You just said I gotta find
Why
it.
do we gotta talk
it.
at the same time? Why?
Because you said I gotta find that one, and I posted it. I'll repost it right now, so you'll have it at hand, and you can look at it specifically.
Thank you.
That's all I'm saying.
The point is, I'll go through it, and I'll take every one of those points, and I'll explain to you where he is in error. Things like a non-inertial frame being compared to inertia. That is just nonsense. It doesn't, and everything he's basing his logic on, like the fact that physics can't allow for an elliptical orbit because it's magic or because you're, no. Just because you have a force that varies with the square of the distance doesn't mean you can't have an elliptical orbit. That's just nonsense.
It's funny. It's so ironic that you call something nonsense because what you believe in is nonsense.
Well,
that's the
wow. I love you, brother.
Only you had evidence.
The only one that
up.
Nonsense.
Hold on, Zanuck, dude. You got to chill for a sec. I think Gemty was trying to get in.
I was gonna say that isn't that an all of nothing fallacy? Like, oh, that guy says something wrong, therefore everything he's saying is wrong.
Yep.
Okay, I posted these parts too. If you scroll up a little bit, he says, bottom line, Kepler's laws are kinematic abstractions, mathematical descriptions of objects moving along a solid elliptical track powered by a force anchored in one of the foci. But Kepler's laws are not dynamic laws. They have no executive power in the world of real bodies. They cannot produce and maintain gravitational orbits because gravity cannot be loaded asymmetrically as inertia would do and still produce a symmetric path. And it is therefore the concept of reference systems that has been invented. So you can keep keep cup shuffled out of your wits and tracked into believing that you can easily know for yourself is not possible. Ironically, Heel freely admits that nature does not know and doesn't care about reference systems. Yet he always uses them to weasel out of the argument. That sounds familiar, doesn't it, Zanuck? That is,
Well,
the shufflers.
please.
That
Why go
one more
on?
sentence. The
No
coin
one wants to
under
listen
that. The
to
coin
you on a
under
diatribe.
another cup. Put the coin under another cup. When it comes to discovery,
This
and
is
you're
lost,
always
Steve.
left standing like a fool at the town fair. That's what you try to do to us. That is what science has been reduced to, sadly, and it is as Newton and Copernicus admonish us, up to the caution and consideration of the reader to figure things out.
What? Listen, new perspective. Listen, I love this. You obviously know the passion I have for the topic. When you read something like this, and we're going to discuss it, that does no one any good. We all can't remember what you're saying, and we can't address.
I posted
the point.
this.
So you said you can't have something have an elliptical orbit with the laws of gravitation. For example, the relationship of objects as they get further away from a mass. That inverse square relationship has no bearing on whether you can have an elliptical orbit or not. That's number one. Number two, he's confusing inertia with frames of reference, non-inertial frames. And rotation suddenly has inertia. You can have a rotating body that has inertia. It's called rotational inertia versus translational inertia. There's a very understood difference between the two. But he's using all these terms incorrectly. His logic is flawed, and then he builds on the flawed logic to make his incorrect conclusions. That's all I'm saying. So you don't need to go read it to me. We can read like a paragraph and talk about it, why it's wrong. But if you just want to take it at face value, that's an issue for you. You're gonna be in error also.
You can also just go off on a rant and say a bunch of things that are just, not specific and not pointing out exactly what it is he's saying and why he's saying what he's saying is wrong. And it's the same thing as me reading something.
Well, no,
you're just making broad claims.
2, 3, 4 paragraphs. Just start at one thing. Let's get one topic. Let's talk
that was one thought. It was one thought. He's saying you can't have it both ways.
That was one thought. That's a problem. But go ahead.
Well, you've already read it. It was one complete thought about the fact that you can't have it both ways. You weren't listening. You were just waiting to disagree with things that you remember he was wrong about.
I was talking back.
So, real quick.
Stone, dude, you're hot micing again, bro.
Yeah, I was trying to figure out what that was then.
Stone's fucking having
That's fucking bizarre. This is push.
Can you link to the Quora link, because it's hard to.
All right, Zach, you have a fucking chance to talk. Jesus.
You have to download it to read it.
Asking new perspective. Sorry.
Fucking get
hey, Zanuck, if you download it, it's huge.
Yeah. So basically, is the claim that Kepler's system is not a dynamic system?
Yeah.
And gravity, is that what the claim? I didn't really hear all of it because someone in here wouldn't fucking shut their mouth for 10 seconds. But like, is that the claim? Is the claim that basically the way gravitation works, it's dynamic, but the way Kepler's system of orbits work, it's not dynamic? And so they don't match up? Is that what he's saying? Because like
Brenner makes that point in many of his comps that I put together, or many of his entries, and he says basically they're using geometry and kinematics as if forces are involved, but that's where you need dynamics, and they just totally ignore dynamics and centrifugal force as if it doesn't exist. They just skip over it. They skip over a lot of things conveniently and use what works to make it seem plausible, even though literally wouldn't work. Also, the one on actual orbital mechanics I just posted. But yeah, if you download it, Zanuck, it'll be huge, and you can read all of it very clearly. Is he muted again?
Yeah. Oh, yeah. Thank you for that. I know I could click on it. I wanted to get it in a form like you go to Quora where you can actually read it like you're reading a document, but that's okay. I can.
Dude, it would be bad, Zanuck. Dude, you gotta learn to just like pull back and mute yourself. Like Noah was clearly trying to get in. You've been talking nonstop for like quite a while. You gotta have some respect and just let someone else get in, because like, yeah.
Right, sorry about that.
Ideally, we don't.
No, I was muted for so long. I got a lot of pent up energy. Okay, sorry about that.
I mean, it's a whole extra 2 clicks that I have to click. Come on, dude. Don't make me.
No more clicking on me. No, I appreciate that, and I'll get. It's not that long. It looked a lot longer when Witsit was going through it. It's fairly lengthy, but it's easy. It's easy enough for me to go redline many of the things and back it up, not with just here's what it says in my book, but talk about what these concepts actually mean. Why elliptical orbits are possible. Why we do talk about centrifugal force. We don't whitewash that. That is a simple equation. It's the same formula and same equation as for centripetal force. By the way, you know that, right? We use it. It's part of orbital mechanics. We don't ignore it or shy away from it.
Mass times velocity squared divided by radius. I mean,
It's been all
that's
twisted up,
centrifugal
dude.
force.
It's been all twisted up. Yeah, they're throwing radiuses in there. It's a mess, dude.
No, but that's the equation for centripetal force. Same as centrifugal. And it equals
that's how you do it. You just exchange it. Yeah.
No, they are the same though. They have to be. Remember,
They're the same, right? I know. But
if you have a change
you're
of
acting
direction,
as if it doesn't exist.
so the change of velocity, right? The
Centrifugal
velocity
force
times the radius. The radius will give you a constant change of velocity. So that'll give you a circular orbit, but we don't have to do that. But if you want to just understand how centrifugal force works, you have the velocity and then times the radius, which gives you a change of radius, velocity times the mass divided by the radius. So it's velocity squared times the mass divided by the radius. That's the equation for centrifugal force. It's not that difficult.
It's not about being difficult. It's about the contradictions involved. I just posted the one.
I'll read it and I'll read.
Hold on. Yeah, I just posted the one on orbital mechanics, and then there's 2 sections here that I'm posting that we could actually go over if you want. I'm posting both of them. You don't have to even download them. You can just look at them.
That's part of the second one.
And what he says here in the first one is, here it is claimed that a body continually falls from a position it would be if gravity wouldn't exist, that is, from a position it would never be in, because free fall is not switched off intermittently. In a gravitational environment, a body wants to remain in an equipotential position, because anything else would mean a change of inertial energy, and thus a body falls from a circular path, which Galileo calls circular horizontal. Okay? Then he says, this is how that would look like, and then he shows that if a cannonball were actually, if you want to have gravity, it's going to fall. You can't just say it's not going to ever fall. It can't be continually falling in a circle. It can't.
Well, correct.
It doesn't work. Is what his point.
If you match its weight with the centrifugal force, then it will always be falling and never hit the ground. Now, let's talk about this. God, it's only 4 sentences. Let's talk about it real quick. Okay, hold on.
Okay.
It talks about here. It claimed that a body continuously falls from a position it would be if gravity wouldn't exist. Right? Here it is claimed that if a body continually falls from a position it would be if gravity wouldn't exist. That is, from a position it would never be in, because free fall is not that whole. Can you interpret that for me? Because it sounds like shit to me.
Well, he's saying free fall, gravity can't be switched off intermittently. So in the diagram below, he's saying this is what it should. This is what the cannonball would do, right? But they're switching it off intermittently to continue the circle, right? So that it can. Then you can have your falling and circling, continually falling idea of orbits, right? But even on the face, he's claiming it doesn't work, because you can't say it's falling. Okay, so then let's go through why he's saying that it doesn't work. Well, at the bottom of that,
he's got a couple things that are in error here. This gravitational environment. Okay, a body wants to remain in equipotential position. What does that mean? Equipotential position.
Well, a body in motion wants to remain in motion.
Okay, so I can have a body in motion that has a balance of forces, and if this balance has no net force, it will remain in motion, regardless of what path it takes. The equipotential path it takes is expected, is demanded in physics. So if it is balanced, it will continue that path, even if it's a circular path. Now he's saying it's a change in internal energy, not inertial. You said inertial, it's internal energy. What does that mean? How does it have internal energy? See, all this makes zero sense. This is from someone that's not really,
just because you don't know what he means by internal energy means that he's flawed.
He's lost. Yeah, he's very lost.
Well, maybe you're lost in what he's saying.
If I could tear apart like this.
Yeah,
well,
I don't think you're making the right analysis, Anik. I think you're right.
He says a body
we should continue on, because he clarifies.
What do you mean wants to remain in equipotential position? What does that mean? Is if I drop a rock off of a building, is it going to fall and remain in equipotential position?
It's gonna try to seek the least resistance, as you know, right?
What do you mean it's gonna seek the least resistance? Why would it seek?
Well, because it's gonna follow its most equipotential path.
That means you're
right. The path that has the most potential, right, for it to freely move in the same position these are things that these are basics. I don't know why you have a problem with that.
So it has a force. You're saying so it has a force
Wants
acting
to
on it.
read. Okay, so let's continue on. I think he clarifies at the bottom of that. He says,
So there
"This
we
is
go.
what it
There's
would
one.
look
We had a
like."
lot of
Right.
problems there. Next one, go ahead.
This is how it would look like, except the full circle, of course, as there is nothing in physics that would keep a body from losing height as it does in the first 5 trajectories. The pattern would of course continue, and only with an infinite muzzle velocity fall time would be infinite. That is, loss of height 0.
No.
Okay, so then, okay, what?
Infinite muzzle velocity, no. Because all we're doing is matching a velocity that gives you the radius, the velocity times the mass, velocity squared times the mass divided by the radius. That gives you a value, a force. If that force equals the weight of the object, just sitting there up, it's held by a balloon, and the balloon pops, and you have a scale there, and it lands on the scale, what does that scale read? If that's the weight, if I can make it travel in a velocity squared times the mass, and divided by the radius to the center of axis of rotation, then that will say that it will circle the Earth indefinitely. It's very simple.
All right, so then I've just posted the next portion of it, so we can look at that, because he does go into the equation in the next portion. The only way to achieve orbit on paper is to make fall time velocity dependent, right? So on paper, the only way to achieve it is to make fall time velocity dependent, or in other words, attenuate the rate of free fall with increasing inertial reactive centrifugal force F
What is
equals
that?
mv.
Come on. What is that?
With an increasing inertial reactive centrifugal force.
That's not a term.
You're getting so excited, dude. It sounds like
I know. I love this stuff, though. G,
it sounds like you're literally being tickled right now. That's
and I'm eating a chocolate cookie from Grandma too, so I'm like double excited.
Oh my God!
Well, look at that equation.
If I had my girlfriend
F
here, my head
equals
would explode.
Yeah. Oh my. Well, I think Xanax, you got. I think. Oh, I don't know, man. I think,
do you have your
Dude,
do you have your high school physics book there in between your legs?
College physics book. I have it open now. I just opened it.
Xanax, I see in your future that it's gonna end up just being like, well, if you can't beat them, join them.
Or maybe I will.
Xanax, is there
you might as well just get on board with the truth, and then you'll be good, bro. Then we'll have way more fun, and then there's more truth to explore. But if you're stuck,
I love it when you admit that we have points. You're like, oh, of course we're not orbiting. That would be ridiculous. We would feel that shit. Of course we would. I love when you say that kind of shit, because it makes you actually seem reasonable.
What'd you say? New perspective?
I said it makes you seem reasonable when you actually acknowledge that we have a lot of good points. Like, of course we're not going in several different directions without any kind of sense of that happening whatsoever. That's ridiculous. I've heard you say stuff like that before.
Definitely.
Real quick, Xanax, is there an actual altitude that you have in your model to where things begin to orbit or are able to orbit? And is there a maximum altitude or distance away from the center of your ball Earth? Is there a you know what I mean? I know you probably understand what I'm asking. At what height do things then begin this free fall around a ball?
Well, it's velocity dependent in the weight. So it's dependent on the weight of the object and the velocity squared times the mass divided by the radius, the turning you make. Now you can't do it at the lower. So to answer your question, we can't do it at the lower altitudes because we have wind resistance. So these things would have resistance to it, and you need a force to counteract that resistance, which is always acting on it, which will always slow it down, so it can never exist in the air. But once you're out of the air, where there's only a couple atoms here or there that are run into, you're golden. And that happens about 60, 70 miles up, even though they go about over 200 miles before they start really orbiting things in low Earth orbit. And in low Earth orbit, you'll have this velocity about 17,000 miles an hour. Now, if you want to go higher, you can go as high as you want. You'll continue to orbit almost indefinitely.
So you're saying that then something that's 5 million miles away would orbit around Earth? When,
Well,
at what
problem with
point
that
do
is
they start? What point do they start colliding with the other forces that are pulling from all the other masses in this great
right.
universe of yours?
Excellent point, and that's exactly what I was going to say next. Is that once you start going further away from the Earth, you start getting. We have influence from Jupiter. We have influence from all the other planets near us. So at some point, I can't tell you exactly where, but we could calculate that where, and then where the proximities of the other bodies are. They will screw up this orbit around us if we're too far out there, because we're going to intersect if we're 5, 10, 15 million miles away. We're going to start interacting with Venus. We're going to start interacting with Mars, and that's going to be a problem. So the orbit will change. Now we're talking about 3, 4, 5 body diagram, which are incredibly complex.
So in that diagram that Perspective posted, which Witsit was presenting, where it shows how if you shot a cannonball way high up, how it would want to drop back down towards the center of the Earth, but somehow there's this great circle around, and you would call that orbiting, but it's going against the logic of how the real physics of these objects that were been, these projectiles, whatever you want to call them. When it goes against it, how do you continue to believe it? Like what keeps you in
Because
this?
I understand. So having worked in wind tunnels and understand aerodynamic forces and aerodynamics, engineering, etc., I understand very well that this cannonball has a coefficient of drag. All objects have a coefficient of drag based on their shape alone, and it's scalable.
So then, what
That's why the
keeps
Wright
it up?
brothers were able to design an airplane in their freaking garage. So we have a cannonball. We have a coefficient of drag, and now based on its frontal area, we can actually tell you what that drag will be, and that drag will go up at the square of the speed. So the faster it goes, the much greater the force on it acts. So these things need an incredible amount of force out of a cannon, and the more force they have behind them, faster the acceleration, and the faster that muzzle velocity after it's released, and the greater the force against it when it leaves. So much so that it could actually melt the projectile if it's going too fast. So you can't go 17,000 miles on Earth. Nothing can.
Oh,
And
thank you for saying that. The ISS that
need
can't do that. I agree.
That's the
Thank
speed
you.
you need.
All right.
That's the speed you need. That's the
Thank you
speed
for
you need to
confirming that.
counteract its weight to keep it from falling based on the diameter of the Earth.
Zanuck, I just want to say I agree with you. Nothing can go at that speed. Thank you for saying that. You said it yourself. I'm going to save that audio clip, and I'll replay it for you whenever you want me to, okay?
All right, I'm gonna read the last part of this that I posted. So if Zanuck wants to make a comment, just let me read through the Zanuck, and I know you're gonna want to interrupt. Just don't, because it's a lot. But we'll talk about it all afterwards. Okay. Bottom line: orbital mechanics doesn't work because free fall cannot produce its own anti-free fall lift force as employed on paper by NASA, and also free fall cannot be loaded with a force like the medium, air, or water. And because free fall is not a medium, it cannot be used to produce lift like airfoils or hydrofoils do via orthogonal to lift velocity, a la NASA in V GM over R, where V is orthogonal to R. P.S. After the inevitable prompt derogatory explain away comments by Zanuck, the distilled core point of his school's deceptive approach, which is applied throughout any on paper only cosmology, that a velocity dependent dynamic term such as F equals mv 2 over r can be identical with a purely position dependent static term like F equals gm over r 2. That is, of course, the ruse. That is, of course, a ruse. The dynamic term is tuned to match the static term, while the static term, of course, remains unchanged. That destroys all notion of identity. In the case of the ISS, the velocity is adjusted until, on paper, it matches the static positional term at 408 kilometer altitude. And that means, of course, adjusted and static terms are not identical. They are two separate and completely different physical species, and that means the claim that only free fall is at play goes right out the window, and with it, all claim to the reality of gravitational orbits.
All right. It was a little long-winded. I got all of it, except for the end. I was following on the first
screen, but then you change to a different thing. You change to a different.
Well, he's talking about NASA, how NASA uses it on paper,
saw the NASA
right?
one, and then he said
With the
something
airfoils and
about.
using the medium as if. Well,
And
I
you said
posted this
PS. Then you said PS
screenshot.
about me.
You can
said
read what I
PS
just
about
wrote. It's right. You can just look at it and
All
take
right,
it
well,
apart.
let's talk about what you first said, because I want to stay. You want to stay close. So the only way to achieve orbit on paper is to make fall time velocity dependent. In other words, you attenuate the rate of fall by increasing inertial reactive centrifugal, which is not a thing. The force equals mv squared divided by r. Okay, that is a centrifugal force. That is a centripetal force, by the way, and it is exactly what NASA does when they balance gravity. Okay, so they already agreed with that. So now he's going to try to counteract it. Oh, he even has equations there. So just like any other forces, it's a force. So we know if we're going a certain direction, your perspective, and we have a mass, and we make a certain change of direction, which is the velocity changing, this velocity squared, divided by the radius, which defines the rate at which you would turn, that's going to equal a force. That will equal a force. And the velocity in the orbit will be this other formula, big G, m2 divided by r squared. Now, it says, just as any other lift or buoyant force, here's the two objects that are right balanced in the inertial of the above floating. So it talks about weight and buoyant force, sinking, rising, floating, etc. He thinks that for some reason, this force that he's very correctly described, this change of direction and a weight, mass, anytime you change momentum, and momentum is velocity times mass, anytime you change that momentum, that is a force. Defining a force, absolutely in physics, no question about it. So we're talking about a force. Which force is that? Which way does that force act? Well, it acts opposite, perpendicular to the tangent to the circular path, as someone said earlier where I got muted earlier. So if that was the case in the real world, projected satellite trajectories would be calculated with the dv square root of that's the drop equation. Okay, then divided by g minus velocity squared divided by r.
Zanuck, I think we're snoozing here on you, bro.
I know this is where it gets boring. Try to
Well, he's saying that he's basically saying that they're using they're what they're doing is that they're working it out on paper. So guys like you or people that just see the math and they say, okay, well that makes sense on math on paper, right? Because they're using it. They're tuning the math, the dynamics, right? They're tuning it to fit the static term, right? But you can't have both. The dynamics need to be there. They can't just say we're gonna skew it now, so that it fits the math,
right?
So that we can think of it as having dynamics, even though that's not really included.
He describes it. He says would make the projectile of a rail gun, for instance, fly a whole kilometer further than it does in the real world. Well, it has drag. It has drag, and that's why when you don't look at the other forces, then you go astray. Then you go off the friggin' reservation, off the beaten path. So Haley and Cole's favorite splainway for this is negligible. Falls apart his way. Well, I don't think it does at all, because I can give you the value of drag. For a projectile coming out of a railgun, the force is enormous. It's tremendous. It slows down really quick, and it doesn't go 1,000. It doesn't go farther. Bottom line, orbital mechanics doesn't work. Bottom line, no, it does work. And this is because he says, Michael Brenner says, free fall cannot produce its own anti-free fall lift force. It does, because that's called centrifugal force. And it's simple. And it's because
he's saying that wait, hold on. He's saying that you think it does, which you just stated. Yeah, it does. Because you think it does, right? But he's saying that free fall can't produce its own anti-free fall lift force as employed by NASA on paper. And also, free fall cannot be loaded with a force like the medium of air or water. And because free fall is not a medium, because you're treating free fall as a medium.
No, they're not. These are all words that are just being all misused. You know this to be true. You in your heart of hearts know this is not about flat around. This talks about just basic physics. This is not this force he already defined as a change of direction and a mass and a velocity. That determines the force, and it doesn't have anything to do with the medium. The medium is only going to work against it. And he says free fall is not a medium. Well, who said it was a medium? Nobody. It can't be used to produce a lift like air. It cannot be used to produce lift like airfoils or hydrofoils do on orthogonal lift to velocity.
a la NASA.
You
your
Orthogonal to
don't
Lipton
understand his
velocity
velocity.
arguments,
is
man. You
yeah.
don't understand his arguments, Sonic.
No, I understand it perfectly. It can
No.
because the force, a force is a force, of course. I can produce a force if I have a differential pressure on top and bottom of the wing, and I can talk about the mass differential of the two points on the wing, or I can talk about an object changing direction. If I have an object that's changing direction, it produces a force because change of momentum defines a force, and that's the force we're talking about. So
Hey.
it does exist,
Oh.
and it does make sense. It is logical. He's not. He's making up words and makes no sense at all.
He's not making up words.
Sonic, you remember when you used to ridicule me when I told you that gravity was clearly electromagnetic?
Yes, it's not electromagnetic.
Okay, cool. So check this out. Check out this nice little hostile witness I have. Sorry about it. It says, we show that the electromagnetic quantum vacuum derives directly from Maxwell's theory and plays a primary role in quantum electrodynamics, particle physics, gravitation, and cosmology. It corresponds to the electromagnetic field ground state at zero frequency, a zero-energy cosmic field permeating all of space, and it is composed of real states called keenons. Kevo equals vacuum. Photons are local oscillations of keenons guided by a non-local vector potential wave function and quantized amplitude. They propagate at the same at the speed imposed by the vacuum electric permittivity and magnetic permeability. What a coincidence that today I stumbled across a paper from the highest levels of your own paradigm using the same exact terminology that I used and you ridiculed me for. Wow. So anyway, the vacuum electric permittivity and magnetic permeability, which are intrinsic properties of the electromagnetic quantum vacuum. The electron-positron elementary charge derives naturally from the electromagnetic quantum vacuum and is related to the photon vector potential. Wait, we're almost there. We established the mass charge equivalence relation showing that the masses of all particles and antiparticles are states of the elementary charges and their magnetic moments. The equivalence between Newton's gravitational law and Coulomb's electrostatic law results naturally. In addition, we show that the gravitational constant big G is expressed explicitly through the electromagnetic quantum vacuum constants, putting in evidence the electromagnetic nature of gravity. We draw that big G is the same for matter and antimatter, but gravitational forces should be repulsive between particles and antiparticles because their masses bear naturally opposite signs. The electromagnetic quantum vacuum appears to be the natural link between quantum electrodynamics, particle physics, gravitation, and cosmology, and constitutes a basic step towards a unified field theory. Dark energy and dark matter might originate from the electromagnetic quantum vacuum fluctuations. The calculated electromagnetic vacuum energy density related to the cosmological constant considered responsible for the cosmic acceleration is in good agreement with the astrophysical observations. The cosmic acceleration may be due to both quantum vacuum fluctuations and matter-antimatter gravitational repelling. All the above results are established without stating any assumptions or postulates. Next, we advance two hypotheses with cosmological impact. The first is based on the possibility that gravitation is due to the electromagnetic quantum vacuum density of states fluctuations giving rise to a photon pressure at the characteristic collective oscillation frequencies of the charge densities composing the bodies, electromagnetic push gravity. The second advances that energy, matter, and antimatter in the universe emerge spontaneously from the quantum vacuum fluctuations as residues that remain stable in space, and we present the main principles upon which a new cosmological model may be developed, overcoming the well-known Big Bang issues.
Dun dun dun.
That's just the abstract, my dude. Get smoked. Why don't you guys deny all the scientists and all the physicists? You're stupid. Austin thinks that gravity's electric. He's so stupid.
Dude, it mentions it right there. It says in a Euclidean flat. It says
Can anybody tell me
explain
wrote that and where I can read that, because that's also the biggest bunch of boo-ha I've ever listened to.
Well, according to
By
what
the way,
you
what's
think,
that?
you know.
When you read like that, just for because we're friends here, when you read like that, nobody's paying attention. It's a bunch of nonsense.
I was paying
Just can't go
attention.
on
I
and
paid
on.
attention to every word. He did a great job of reading it.
Yeah, if
There's your reference. Why don't you just
it's the scientific research and academic publisher, the electromagnetic nature of gravitation and matter, antimatter, antigravity. Surmise on quantum vacuum gravitation and cosmology from the National Institute for Nuclear Science and Technology.
I love how you said it's a bunch of hoo-ha, and then you said you weren't even listening.
Yeah. Oh, I do want to read. Let me read.
I know that was. He did no, dude,
That's a bunch of hoo-ha. And by the way, I didn't even listen.
even
who
though
was the one that listened to it? Who was the guy that said he listened to it?
I was listening to all of it.
Really? What did he
So
say?
cool.
We all
I
were.
don't understand.
Could you give us a brief synopsis of what he said?
We all listened to the whole thing.
No, I didn't.
Yes, I
I'm
followed
curious
it.
what he said. Could anybody provide a brief synopsis of what he said? Yeah.
Dude, everything he read was.
Anybody want to give me a brief summary of what he said?
Dude, that was the brief summary.
Anybody want to give me a brief summary of what he said?
There's a lot there. There's a lot there. There's a lot there.
Okay.
Do you want to talk about the specifics of this M-Stone, or are you just trying to call people out?
Hold on, let's not.
I'm just asking if anybody can give me a summary.
You're
of what
not
he
just
said.
asking. You're just trying to cause a problem, and it's not going to
I
work.
just
because
want to
it's
know
too
if
much.
you could summarize
There's
what
too
he
much
just
to
said.
summarize in one thing.
You said you listened to it and you understood it and everything. I was just curious.
All right,
Yeah.
you guys,
let's go through it, M-Stone. Let's go through it line by line so that you can understand it, and you're not going to care. You're just here to troll, like you always are.
Hold on.
So, do any of you have a summary? Can any of you tell me what?
All right, I'm just going to mute you guys so I can talk for a second. All right, let's chill out and go one at a time, please. But M-Stone, all I was trying to say, dude, is that was the summary, bro. He just read the abstract of this paper. So that is the summary. That's what I'm telling you. You can't take it. I mean, if you wanted to try to summarize it more, I suppose you could. But he read the actual.
Tell me what he just said in a simple form.
Gravity's electromagnetic.
No, not you, Austin. Not you.
Well, I think the part.
Do you know how to?
Yes, the part he has highlighted right now, I think, is very.
Okay, so you don't know what he said. You just heard the words. They sounded neat to you. Okay.
Right, hold on.
The M-Stone's really not going to be productive in the conversation. I hate to just suggest that we don't include him, but it's not going to. He's just here to troll. He's never proven himself to be anything productive or ever anything enjoyable to listen to or be a part of.
You got to admit that the two flat earthers were like, wow, that's interesting. I was listening. And then the two naysayers are globers that couldn't understand it.
Yeah, basically, to summarize, gravity is electromagnetic, and there is an ether.
Yeah, and what I was saying is that the part that he has highlighted on the screen right now, the equivalent, and then you interrupted, but I was just going to read it. The equivalence between Newton's gravitational law and Coulomb's electrostatic law results naturally. So, do you know what that means? Do you know what Coulomb's law is and how that's connected to Newton's gravitational laws? Because that part, and then even the next part of it. In addition, we show that the gravitational constant G is expressed explicitly through the electromagnetic quantum vacuum constants, putting in evidence the electromagnetic nature of gravity. It's a pretty good little summary, just that part. Do you get that now?
Don't hope that M-Stone's actually going to be like.
No, you read something. That's not telling me you absorbed anything he said. But that's okay.
Yes,
man.
Dude, it's funny though. I just want to point out, right? Like this is the same. Like if I had have said stuff like this in here, everyone would have made fun of me and called it word salad and said I'm making stuff up. I just found this paper today, and it literally says like exact things that I've been saying for years.
I was just wondering if anybody that heard it could tell me about it.
Yeah, we just did. He just did. He just told
No,
you.
you didn't. Anybody besides Austin? Anybody that heard him read?
He just did it. He just said that gravity is electromagnetic and there's an ether.
Okay, I know this is hard for you, Austin. I know it's difficult, man.
The other guy in here just did it.
Yeah, that was me,
I know
Carlos.
I know nobody.
It's pretty simple to understand. It's way more simple than trying to work out Earth curvature.
Yeah, but look, it gets even funnier. So look right here at the very top. It's like, so the lambda cold dark matter cosmological model, which is like the mainstream model of cosmology, right? It's considered today as the most plausible theory that has the merit to provide satisfactory answers to a large number of astrophysical observations. It is based on the enhanced Big Bang concept, according to which the universe is homogeneous and whose main components are dark matter and dark energy. The last one is associated to the cosmological constant, which is considered responsible for the observed cosmic acceleration. However, besides the difficulty to conceive that the whole universe emerged from a singular point, some upsetting issues still remain, such as why did the Big Bang occur and what happened before it? Furthermore, in order to explain the horizon problem, as well as the fact that the geometry of the universe is Euclidean or flat, a cosmic inflation model has been introduced. But what are the physical reasons that inflation occurred in the very first 10 to the negative 30 seconds of the Big Bang, expanding the universe at a tremendous rate, many orders of magnitude faster than the speed of light in a vacuum? What happened to antimatter? Recent studies on gravitational anomalies detected on many hundreds of galactic systems revealed big discrepancies with both Newton's laws and general relativity, revealing the necessity of advancing new theoretical concepts. Finally, quantum field theory fails by a factor of 10 to the 120th to give a precise estimation to the cosmological constant, the worst discrepancy between theory and observation in the history of science. One more paragraph. The above drawbacks call the human intelligence to be humble in front of the immensity and complexity of the still unknown universe. All the cosmological theories, including the one presented here, are temporary attempts to explain the observations realized up to now using the present theoretical tools, and they are finally condemned to be completed or replaced in the future according to the new observations to come. So I just think it's so funny.
Which year was that written?
I actually don't know. 2022.
Oh, so it's pretty advanced for the tools that we have now.
Yeah,
right? You know,
June
it's like
2022.
it's up to date, man. It's right up to date.
Yeah, I know. I've been trying to tell them because I've read other papers similar, and they're like, "You're so full of it." And then I found this one today, and like they're just gonna handily dismiss it. I dropped the link in here. You know, it's a whole paper, so they could read it, right? But it's funny because I explained when it's talking about like the vacuum state, the quantum vacuum state, and how it's all about the vacuum electric permittivity and magnetic permeability. Do you know how many times I've told them that? You know, like that there's a dielectric constant and magnetic constant in vacuum, and it all comes down to the dielectric permittivity and magnetic permeability, which is in free space, which shows that like, you know, there's a background medium and everything's intrinsically electromagnetic, including the phenomena you falsely characterize as gravity. They're like, you're so stupid, you're just saying a word salad. It's like this sounds like me talking, but a little more elegant and advanced. So it's like just funny. I just think it's funny. It's like, you know, if a flat earther says it, it must be wrong.
Yeah, it's like they're stuck in their paradigm, and their paradigm is quicksand. And if they move 1 inch from their paradigm, they'll just get deeper and deeper into the quicksand.
It even says, Gio, you read it. It even points out like the naturally arising obvious connection between the gravitational law and Coulomb's law.
Yeah, exactly. That's why I read that part, because he wanted a summation. Like that was the part of, that's like the foundation of it. And yeah, we've been talking about that for forever. So yeah.
Exactly, bro. The flat earthers have been pointing that out for so long.
Dude, if you read that, I bet somebody would like try to say that it's like Ken Wheeler word salad, even though it has nothing. You know what I mean? Like,
yeah.
Oh my god, yeah, no, and it's a lot of the terminologies that like Deislo, many have been using, especially like you and Deislo are both like very skilled in terms of this and knowledgeable in terms of this particular field as well. But it even literally says flat as well, like the geometry. It introduces that, dude. Yeah, that is wow. That's okay. So like. That is very cutting edge. We discuss this all the time. Yet these guys are in here telling us that we're just off our rocker. Yet this is actually at the cutting edge of. I mean, this came right out of the which journal is it? Journal of Modern Physics.
Yes. The Journal of Modern Physics, June 2022, the National Institute for Nuclear Science and Technology. And dude, I know for a fact, like for a 100% fact, that their own paradigm will 100% have to move to an ether and towards an electromagnetic unification, including gravity. It's object. There's no way around it. Anyone that can just go look at the evidence, it's mind-blowingly obvious that that's the case, right? So, yeah, I mean, I don't just say that like it's just incredibly obvious. See, for us, it's very easy to accept that. We're like, yeah, of course. Like, look why the ether got thrown out, you know. But for them, it's like, you know, the anti-flat Earth script necessitates that you poo-poo on any idea of ether or electromagnetic gravity because flat earthers say it.
Yeah, they're like unconsciously gatekeeping. I mean, some of them might be consciously doing it, but the ones that aren't even conscious of it, they're still doing it by just trying to degrade anything that heads in that direction. Well, yeah, because essentially those entities are going to like lose power, the power that they have, and then there's people like trying to defend them.
Yeah, I mean, this is just like the first one. Like, I found this one pretty quickly. Just I'm like researching like 7 different subjects right now, so I get really distracted. I get like, I don't know. I just like get looking in a million directions, but I do have this on my list of things I'm compiling. I fell down the earthquake rabbit hole.
Weird concept.
Nice, dude. Yeah, well, you're picking up pieces from all these different.
Yeah, I just need to be able to. I need to like be better about like focusing on like a subject. You know what I'm saying? And then I fell down the like the gravimeter downward acceleration readings changing during lightning storms and thunderstorms, and that's very interesting as well. There's just so much.
Yeah.
Just, like we should all be on the same team, like trying to get to the bottom of it, you know. And it's like I feel like so much falls on the shoulders of a few people that it's like physically impossible.
Well, I mean, right now, like Zanuck and M Stone are on mute. So I mean, if someone wants to unmute them, I guess they can. But I mean, if they're just gonna heckle and harass and interrupt and stuff, then yeah, it's just.
Well, yeah. I mean,
I don't think that Zanuck should stay muted if he wants to comment, but M Stone, I muted him just because he doesn't ever do anything but troll.
Dude, he's saying, "Did you read the title of your article?" That's his response. Like, are you? Yeah. Yeah, I read it out loud, bud. Like, it thinks that since it says the word gravity in there, that I don't even know.
Dude, I mean, that laid it out though, dude. That's very cutting edge. Now that was 2022. So yeah, that's pretty cutting edge where they're at. I mean, it sounds like they almost were about to say, like, yeah, so the Earth is not a globe, and that's actually the problem. That's at the root of the problem why all this shit didn't work. And if we fucking bring back the ether, have the Earth actually be what the geometry of the Earth is, then there's not going to be all these missing holes in cosmology. So it's like they're admitting that it's like this is not going to last. Like they're stating it directly, like this has an expiration date.
Yeah, and it all comes from Coulomb's law anyway. You know, I mean, it's obvious. You can just look at the equation, and the torsion balance is exactly the same. It's just so obvious.
And they're using a bunch of like reifications of subatomic particles, but it doesn't really matter, right? Because like the phenomenon is real. Like the photon phenomenon is real. It's just the intersection of the oscillating magnetic and electric field. Now, like right now, I don't have like, you know, an article, you know, from like a major physics institute saying that. So of course that's still word salad to them, but it is the case.
It's not word salad. It's actually trying to put some rhyme and reason to the inconsistencies, basically confusions that they've found at the quantum level. Although that's amazingly understood, there are some loose ends, many of them. And this is one way of kind of tying up that a little by applying Coulomb's law, electrostatic law to some of the things they have at the very, very smallest levels of our physics. We're talking about.
Well, isn't it direct contradiction?
We're talking about cosmology, Zanuck.
Yeah, they reference cosmology, but the main article, if you read the article,
you haven't read it.
Well, I read it too, and it's talking about physics at the quantum level, and maybe extensions to the cosmological world as well. But mainly, they're talking about things at the particle level. This is particle.
Okay, I'm just gonna read it. I'm tired of you, but you 100% haven't read it, so please stop pretending you're gonna come teach us about the article.
I just posted another article by the same guy about the same topic.
What does that have to do with the fact you've read neither one of them? So,
because you're
Listen.
embellishing.
The gravitational constant, big G, is also related to the vacuum electromagnetic properties, implying that Newton's gravitational potential is equivalent to Coulomb's electrostatic potential. We deduce that gravitation has electromagnetic nature and that the gravitational constant, big G, is the same for matter and antimatter. However, the masses of particles and antiparticles bear naturally opposite signs, entailing a mutual gravitational repulsion. Matter, antimatter. What is antimatter? Ether. Anti-gravity may play a dominant role in the cosmic acceleration, has to be investigated experimentally. The electromagnetic quantum vacuum is a cosmic field permeating everything in the universe. Ether. And whose fluctuations last longer the lower the frequency. This could also explain the origin of the 1 divided by f to the n, whatever that is, noise observed not only in astrophysics but also in many other technological fields. Oh, I need to really look into this sentence because they're just talking about the ether. Whatever this background noise is the ether. I just think that's hilarious. It point blank says it. The gravitational constant is also related to the vacuum electromagnetic properties, implying that Newton's gravitational potential is equivalent to Coulomb's electrostatic potential. Oh, what's it? You're so dumb. Then how come when we change the charge of something, it doesn't weigh less? Dude.
I mean, I see it as like a slightly different spectrum. It's not the same spectrum as what they think of as electrostatics. There's more to it. I think there's more layers than they're aware of.
Yeah, I mean, I would say that electrostatics is actually the ether under stress, just like Tesla said. Like, basically, there's an energy source above us that's pressing down on the ether. Like, when people ask me like what I think gravity is, that's my actual answer. But I'm not going to say that in a debate. You know, like I'm being like very tactical with it. So I'm like, well, there's a downward electric current, you know, and everything's intrinsically electrostatic, and so this electrostatic bias gives us the effect that we call gravity. But actually, that is the effect of the cause, which is an energy source above us pressing down towards us, basically energy radiating down from that source, effectively rippling down through the ether, pressing down onto existence. And when that energy source pushes down and presses strain or stress onto the ether, that actually creates electrostatics, which is literally holding our world together. Like the creator's energy is literally pressing down from above us, holding the world together. That's what I think. And Tesla agrees. That's not God came up with all that. I took what Tesla said and like kind of tried to make it make sense to me.
Makes me think of like separating the waters from the waters, and also like the stamp conceptions, like stamping in clay.
Yeah.
Pressure, and then the waters from the waters, and then the all meeting at the plane, like the plane of existence.
Yeah, it's crazy to think about. Like that would mean that like he called it the prana or the life-giving force, but that would quite literally mean like in terms of physics that this life-giving force is actually the glue of existence, like physically speaking, like in terms of physics, like that strain pressed down onto the ether actually causes electrostatics to be like manifest in the material world, and that's what holds all matter together. And so in fact what it does is like it knocks the ether or portion of the ether out of equilibrium, and that's why it exists in the material world. So I'm saying like everything, and I said this in my this is what I gave a presentation on at the summit. I'm like, so like everything that exists is out of a state of equilibrium. It's in disequilibrium. If anything established true equilibrium, then it would cease to exist, right? It would revert back into the ether. So everything that exists is in disequilibrium. Nothing's at rest, and we know this, right? Because like that's why they say they can't find the electron, because like it's in constant flux. The energy, the electrostatics is in constant flux, trying to get to equilibrium. And I'm like, dude, what's so beautiful about that is how profound is the idea that that's just like us. Like we're made of energy. That's our true essence, our spirit. And we're trying to get back to a state of equilibrium which would be us leaving this material world and basically going back to the source. So like our life is basically us under stress in disequilibrium, but we know intuitively that we came from a state of equilibrium, and that's where we're trying to get back to. Just like all things that exist are trying to get back to equilibrium, and if they ever did, then they would revert back into the ether. Kind of profound to me.
Yeah, beautifully said. And like the way like makes me think of like manifestation and how like reality like is manifest through like I think everything is rooted in what could be said the spirit worlds, or really like light and sound and frequency. So yeah, like that, like what makes something manifest, like that actual process of manifestation to be in like this corporeal physical world, like the physical plane. And yeah, so that pressing.
Yeah, I think that's what like the all-seeing Illuminati symbolism is about, right? You have like the pyramid, and you have the all-seeing eye at the top, and then they have like the light coming off of that. It's like the energy comes down, and like so, say you have a point above you, and then energy comes down from that. Well, it's going to come down, and basically what could be drawn as a pyramid, right? Because it's going to radiate and it's going to spread out as it goes down. It's going to come down in like a pyramid, and that would be the creator's energy coming down, spreading out. So I don't think that this is like a new thing. I just think that, you know, it's been hidden. And then what Tesla said is that electricity and magnetism is the ether in motion. And Daiso and I think would both agree specifically torsion, like a vortex, twisting. So you have like it pressed down under strain. It's like if you take a bunch of gas pressure and then like you were to close the container, like if you were to shrink the container, right? It's gonna make it get stressed. It's gonna start to vibrate more and more, you know? Like the vibrational resonance is gonna increase as you decrease the amount of volume. You know, like if you had like a, I don't know, like a permeable container or whatever, like not permeable but malleable container, right? Where like you have two robotic arms, you have a container, it's got a bunch of gas in it, and then you start to press the robotic arms together and it presses the container in, right? Like that, the gas is going to like start to vibrate tightly, you know, like more, it's going to increase in vibrational resonance because it has less space. So more energy in less space. And like that's what the ether's basically doing. That's like what electrostatics is, from my understanding. And so like that's the ether under stress, that's electrostatics. And then when it's set into motion, that's when you get electricity or magnetism. This is actually what I gave Zanuck a test on. Took notes, then took a quiz.
Yeah, I heard that. That was great. That was an epic moment because it just turns Zanuck's like teaching thing back on him, and then like he was like being like the eager student at that point, trying to like take notes and remember it and stuff. It was awesome. Yeah. Should do that like every day with him because otherwise. But yeah, so the strain, it makes me think of yeah, like if you're like pure undifferentiated energy, if you were going to differentiate some part of your pure infinite energy into something more what we might think of as limited, or you know, some separate part, I like that concept of strain makes sense in my mind in terms of that, where there would be some kind of like activation or maybe pressure is not even like a full enough word to describe this, but some sort of like you were saying, vibration, like a vibratory state that would separate that undifferentiated unity into something that we might call matter, or anything in the physical world that then would be manifest through that. Then it makes me think of like the light, how light and sound would be vibrating with electromagnetic and electrostatic. Like the electromagnetic would be the flow, the electrostatic would be like the glue binding it together, and then the light and the sound are the actual like materials that are operating to make the physical world.
Mm. Yeah, it's such a trip, bro. Like a trip to think about that. Mm.
With like motion, strain, vibration, to be able to vibrate those and like keep them in that vibration.
It's crazy too because you see like these people that are inching closer and closer to this type of understanding. They're still like they're just cramming like particles down its throat, you know? So.
Oh yeah. Yeah, so why do you think they like what do you think is at the root of all this, the whole like drive to the particle concept? And how does that link to what you think physical matter actually is? And like why are they doing that? Like if you see it as a deception, what do you think like the roots of that are and like why they're what their agenda is with that part of it?
Honestly, I think it started innocent enough, you know? I think that there's it would be difficult to come up with an alternative for purposes of modeling, you know what I'm saying? So I think that like it was innocent enough and like it was a construct created to quantify phenomena like because like if you can't really quantify things, it's going to be very difficult to precisely replicate it. And
yeah, like the perturbation, like the rate of induction, right? Like it's not going from A to B, but how do you describe it, you know, otherwise quantifying, right? Is that what you're saying?
That's not terrible. I mean, yeah. I mean, you could quantify it as a rate of induction and you would be fine, but yeah, like more so like well, okay, let's use the electron for an example, right? Like people want to quantify electrons so that we can do things like make circuit boards and make computers. So what the electron was like the smallest amount charge, really discharge that they could isolate, like the smallest amount they could isolate. They called it an electron. That's how the quote unquote electron was discovered. So it's like a cathode ray tube just isolating the smallest amount of charge. It was a unit. You know, it was an agreed upon unit. That's what the electron was. Because they wanted an agreed upon unit, the smallest amount that they could isolate, so they could then quantify. Now they have a construct of quantification. And like, I don't think that that's a problem per se. I think the problem is people conflate the construct of quantification with reality. Like they say, oh, we use this construct of a unit to count electrons, quote unquote. And now they think that little balls of matter called electrons are real. See the problem? Like they conflate the quantification to them. Personally, I don't have a problem with the quantification. Is what I'm saying. I just like not understanding it's not reality. You cannot quantify the immaterial, and like to properly understand it, you would have to be able to detach quantification from what's really happening. And I don't know.
Yeah, Brenner does a good job of pointing out all the different aspects of all that. I posted his two ether comps that I made, and he says the electron. When it comes to the electron, in the same sense, electrons are not autonomous entities. They are also only attributes of other entities. This was again known by the discoverer of electrons, J.J. Thomson, who likened them to the broken ends of spaghetti, or rather 1,000 such ends constitute one unit called electron. Tesla was one of the same opinion. I hold that the electron, is a relatively large entity carrying a surface charge and is not an elementary unit particle. That's Tesla.
Yeah. Yep. Yeah. Tesla buries the electron. I think I have like 10 quotes somewhere where he just buries the electron. I think that to finish answering Gio's question, like the problem we run into is we have stuff like Michelson-Morley and Airy's failure, which forces them to introduce relativity, which forces them to say there's nothing outside the material world other than space and time, right? So if they say anything other than that, they have to chuck heliocentrism. They have to just throw away their cosmology. So that's not an option. They'd rather die. So with that being said, they're now rather forced to conflate the quantification to reality. And ideologically, that's why there's a huge disconnect between quantum and cosmology, because quantum has shown unequivocally it is not a tangible reality. That's why you have quantum field theory saying that there's background fields and everything's excitation or fluctuation, you know. So like that's kind of the problem is they're at a standstill. They are at a philosophical standstill, and that's spilled over into physics. So I think it started innocently, and it's now a philosophically tainted pursuit.
Well, and it all kind of, it's all about heliocentrism when it comes down to it, because they've now separated ether from heliocentrism definitively or defiantly, and if they have to like open the door to the idea that these concepts are all talking about, rate of induction or something that's not quantified in the same way, then they have to say, these other things might also be the case, and the whole house of cards comes tumbling down.
Yeah, well, that's the standstill they're at now. But it's like when we try to tell them, dude, these people can't hear it from us. What they're going to have to do is reluctantly concede as time passes and their own paradigm updates, but it will be really easy for them because it will go like centimeter by centimeter, like not even, like, millimeter, like it'll barely move a little at a time, where they can reluctantly update slowly, because in 20 years, if what we're saying right now becomes like accepted across the board, who cares? People arguing it right now didn't ever have to like eat crow, if you will. So it's a safe position. Like for
Well,
sure,
yeah.
heliocentrism has caused them to throw out the ether, has caused them to conflate the quantification of subatomic particles being material to reality, has forced them into a confined little box of materialism because of heliocentrism, and therefore has put all of quantum and cosmology at a standstill where they cannot advance with proper interpretation until they address the elephant in the room, which is the heliocentric confinement. That is for sure what is going on. I'm not saying that.
And they definitely, I would guess they definitely know what's going on, and the people that are maybe honestly involved in some of these studies are realizing that there's contradictions they can't get past, and these things probably way beyond figured out by now, and these people are just trying to run game to slow it down as much as possible and figure out how to adopt it so that they can then somehow, I don't know, twist it again. I don't know.
See, so you have like CRT televisions using an electron gun to fire electrons at the screen to display the picture. What the hell are you talking about? Electrons aren't particles. Why are you lying? What's it, right? I mean, obviously this dude's like a chat troll, but like my point is, it's like you can't have these conversations with. Just read this article's abstract to them, right? Because it's like if it's not coming from their own priesthood, like there's no way that they're gonna be honest. No way. Or they're not even lying, right? Because like he thinks that was a logical argument. Like, he believes that. So it's like, yeah, these are true earther exclusive convos, which isn't necessarily a bad thing in perspective. You talk about that a lot, right? Like you and Issa were just talking about that. Like what happens when it spills over, and like almost everyone knows, like it's gonna kind of suck in a way.
Yeah, it's gonna suck. gonna
No,
suck.
I don't
That's
think it all
ironically
happened.
that's where we're at. Go ahead.
I don't think it all happened innocently at all. I mean, otherwise they wouldn't be faking space.
No, I mean I don't dispute that they're fighting it, but yeah, I'm just saying that like it can be argued it's gonna kind of suck. But at the same, I think it'll be a net positive. Like I'm all for it. I'm all for it personally because there are so many people that are like bright and like open minded, and they realize that like just regurgitating archaic physics that they were taught in 7th grade doesn't make them smart. That archaic physics doesn't actually know all the answers, and they're like, if once they have the realization, like we're gonna make huge progressive strides as society. I think, right? You have
Hopefully,
like
yeah.
all these little Nikola Tesla people all scattered throughout society just being brainwashed. Right.
Right. It's just the right thing to do, whether it's going to suck or not. You can't just like, you can't just teach the kids the same shit that we know is wrong.
There's a book title. It's called Drama of the Gifted Child. And it's actually kind of about like guilt and shame and how those emotions like lock people away from being able to like express themselves. And that's what that's kind of the topic of it. However, just that word, like, or that phrase, drama of the gifted child, could also be interpreted where, yeah, like there's so many like you were saying, little mini Teslas walking around, like actually like the potential of intelligence that we all have and just the potential within us is being it seems like through the indoctrination and through a lot of these agendas is like being not like stamped out entirely. Maybe they want to entirely, which is maybe what, the whole like the new jab protocols and God knows what they're going to try to do in terms of trying to control people more. But yeah, like in a sense, like we're all gifted in a sense, and it's like systematically attempted to be stripped away from us and our youngsters as well.
Yeah, it's being siphoned out of them slowly but surely.
But in terms of the particle thing, I was going to say too, like, yeah, that was a great response that you shared. And it is very complex. Yeah, there's so many layers to it. And it seems like by isolating, like, do you think by calling these things particles, that somehow supports the way that they say the physical, like the actual universe, out there is so huge that if they can prove that it's all quanta, that they then have a way to prove that there's a lot of it, in a sense, rather than like this world being made of like energy or something that wouldn't necessarily correlate with like all of their theories of mass and the Big Bang. And they have because they have all these balls floating out in space, but then they have all these little balls floating down on the molecular level, but then they can't really explain everything. So then it had to branch off to quantum physics, which is really because the ether exists, and so they couldn't really ignore that, and so they've had to branch out. And then now, like that article you just read is like at the most advanced level where they're like, yeah, actually this is electrostatic, and there's this whole thing needs to be replaced.
Check out that ferrofluid speaker that I just put in the live stream. Fucking course. That had to be done.
Yo, look this. The approximated characteristic frequencies calculated for Earth and Moon lay in the UV spectrum and are slightly higher than the plasma frequencies attributed to metals. Now, obviously, it's built upon a lot of pseudoscience, though. They're understanding.
Yeah, they're still in the current model.
Yep.
Like overall, they're still situated in it. It's like they're in like, it's like the current model is like a car or a train or something. It's like they're in the old model, but they're like looking out the window and seeing what's out there. At least a little bit more than what they've done in the past. What does that say there? Flatness. It says flatness right there.
Yeah, a new cosmological model could be developed on the basis of overcoming the well-known Big Bang inconveniences such as initial state faster than the speed of light inflation, as well as the horizon flatness and antimatter issues.
Oh shit.
You're going to drop a link to that.
Yeah.
So how are they going to do this then? I mean, so this is a hostile witness who isn't going to say that Earth is flat. She's just going to talk about the horizon being flat. But how are they going to spin this or keep? I mean,
They're gonna
the
say
transition.
they're literally gonna say that this paper doesn't say the Earth is flat. This paper disagrees with you. Yeah, there's a talking point, just like a remedial talking point. And
But how
then
can anyone really read this and not see that that's what they're saying without saying it?
well, how can they not see that like what we've been saying about gravity is correct, or like at the least can see that it isn't as stupid as they try to pretend it is, right? But
Yeah. You said they can measure the downward flow of this electrostatic.
Yeah, of course.
Right. So if that could be measured, how can anyone deny that? Right.
Dude, look, okay, you can measure the downward electric current. You can prove that everything that exists is intrinsically electrostatic. You can prove that electrostatics is 10 to the 36 power stronger than it's even claimed gravity is on the smallest scale.
Right.
You can also cite tons of hostile witnesses, including Walter Lewin from MIT, explaining that it's really electrical forces that hold everything on the Earth together, and it's not until you get out into space on the planetary scale that gravity becomes a prominent causal agent. You can cite papers like this. You can cite all kinds of quantum physicists explaining an etheric background. You can cite that in a vacuum, there's free space impedance. It isn't empty, that you have magnetic permeability, dielectric permittivity, both a magnetic and dielectric constant. You can do all this, dude, and they'll respond with something like, then if something's negatively charged and I drop it, then shouldn't it float? You know what I'm saying?
Right.
And you're like, no, because intrinsically it has mass and weight, which is intrinsically held together by electrostatics. And it doesn't matter. It doesn't matter how many times you say it. They're going to repeat it tomorrow. Like, what's such an idiot? He thinks gravity's electromagnetic. So I don't know. I mean, it's obvious that it's not fruitful, maybe, right? I mean, it's only fruitful for like for the audience. Like maybe my next
anybody that wants to know. Yeah, anybody that's willing to learn and actually accept that there might be a contradiction in what they were taught.
Of course, there's references down here too that I haven't even looked into.
How did you find this?
I can't remember the phrase that I Googled. Googled a very specific phrase. Like, let me try to find it, see if it's still up.
Has this paper been buried? It was 2022.
I don't know if it's been buried. I just
Is
like
the person got credentials that are like? Is he the guy that wrote it? I mean, is he somebody that people respect in the field or what?
Yeah, he's from the Nuclear Institute of Physics. Like I typed a very hyper specific title of another paper I was looking for in Google Scholar, and then I found this paper. I can't find the paper I'm looking for. I got buried. Freaking
I'm gonna post the discussion you had with Zanuck a while back on magnetism and gravity.
I do also have, in case other people want it, like another paper I found was quantum gravity via supersymmetry and holography, unification of gravitational and electromagnetic fields in Riemannian geometry. Can one unify gravity and electromagnetic fields? Electromagnetic quantum gravity. The integration of gravity and electromagnetism in terms of Dirac polarized vacuum. So those are 5 of the papers I found. But I can only research for like 30 minutes. I got distracted. Rudy and Jaron did a business call. Quantum vacuum and gravitation, matter, antimatter, anti-gravity. This is what Zen just drew. I'm going to create like a motherload zip file though. All categorized. I drop all the stuff in my Telegram. Let me see if I can actually change the name of my Telegram.
I just found the biography for the guy who wrote that. The one, the Constantine Miss or Mice. Constantine Miss. Constantine Mice. This guy had some serious credentials.
Yeah.
Professor at the National Institute for Nuclear Science and Technology and Director of Research at the CEA, French Atomic Energy Commission. He's also appointed as an international expert for the CEA. He studied physics at the University of Paris 7, where he obtained in 1984 the Maîtrise de Physique with specialization in atomic nuclear physics. Then he got the master degree DEA in atomic physics, quantum optics, and lasers at Orsay University, Paris in 1985. He is a holder of PhD in atomic physics, obtained also at Orsay University in 1988, and of HDR, obtained by Marseille University in 2003. After his PhD, anyways, goes on and on about his career. So that's who wrote that paper that is literally saying a lot of the things that you and we've been discussing for quite some time, especially like a lot of the stuff that you've come with. Like, so I mean, the fact that these guys are just like heckling you and saying that, like, we should just moderate that, not even allow it, because dude, this is on point. There's no reason just to let people just try to drag other people down like that. It's just not even helpful for anyone.
Oh, funny.
That was a perfect example of muting a useless troll. Well done.
Yeah,
Fuck,
he doesn't
I'm
ever
late.
contribute.
I think I came 5 minutes too late. Fuck.
Just go back in the stream.
Yeah, I'm gonna have to, man. Fucking hell, you guys made it serious.
Well, the troll part wasn't interesting at all. It was just the basic stupid shit.
So
yeah, fuck them, man.
What is that article's status in terms of peer review? Like it's been published, right? So it's made it through the entire peer review process as well. The electromagnetic.
It's the Journal of Modern Physics.
So the electromagnetic nature of gravitation. So yeah, dude. I mean, you could cite this, and it's fully.
It's gonna be so bad for the next person that debates me. I'm gonna say, like, I'm gonna bring up Coulomb's law and electrostatics, and they're gonna be like, "Oh, this is a slam dunk. I've heard McToon talk about this."
Tell them it's word salad, then you come with a fully peer-reviewed paper in the Journal of Physics.
Credentialed dudes.
Yeah, from like literally like the most credentialed dude in this field that's pretty much out there, or amongst the high percentage of that.
Dude, how much? I mean, I guarantee you the response. Does this guy think the Earth is flat?
Well, he did mention. Well, he didn't quite mention like directly that, but he did seem to allude to that geometry.
It's called the flatness problem in cosmology. They have something called the flatness problem.
But he also mentioned, that and then that other part where he said Euclidean flat.
Yeah, same thing. Look, I'll pull this up.
Yeah, what's the flatness problem?
I don't want to misquote it, but it's like has to do with fine tuning and all kinds of stuff. So
the problem is people don't want to admit that it's obvious.
So the flatness problem is the interesting notion that the early universe had just the right amount of matter to make it flat. In other words, it had the initial density of the universe been slightly much higher or lower than critical density, our universe wouldn't be flat and would be curved today instead. And they ran the numbers, and it's like incredibly improbable that it would have had the exact amount of critical density needed, like initial density at the point of singularity from the Big Bang, for it to spread out flat.
Right, so it has nothing to do with the Earth being flat.
No, but it just completely destroys the Big Bang model. That's why it also falls under what's called the fine-tuning problem. Like running the numbers, it's like statistically impossible that it would have the exact amount of density needed to expand out and be flat, which means that it would require like a fine-tuner to do that. That's why it's called the fine-tuning problem. Yeah, oh, look at that. The flatness problem, also known as the oldness problem, is a cosmological fine-tuning problem within the Big Bang model of the universe. Yep.
We weren't saying that he was saying the Earth is flat in that sense, but we were just talking about the correlations he made and how that connects to this flatness problem thing, which is like a geometrical factor within cosmology. I mean, how it's interpreted can be interpreted in different ways, but it's how planar geometry can't be removed and is foundational.
Here, like the flatness problem is a cosmological fine-tuning problem, which everyone knows what fine-tuning problem is, right? Like it's the universe is so finely tuned when it should be randomly chaotic and indifferent to our position that it would appear to require a fine-tuner or intention, a designer. It's called the fine-tuning problem. Fine-tuning requires a fine-tuner. Anyway, within the Big Bang model of the universe, such problems arise from the observation that some of the initial conditions of the universe appear to be fine-tuned to very special values, and that small deviations from these values would have extreme effects on the appearance of the universe at the current time. Oh, yeah.
And the next sentence, the second sentence of the next paragraph, this value affects the curvature of spacetime with a very specific critical value being required for a flat universe. Current density of the universe is observed to be very close to this critical value. The density of the universe, right?
Since any departure of the total density from the critical value would increase rapidly over cosmic time, the early universe must have had a density even closer to the critical density, departing from it by 1 part in 10 to the 62nd power or less. This leads cosmologists to question how the initial density came to be so closely fine-tuned in this special value. Yeah, I bring this up too, but it always just gets dismissed. It's like, that's how science works. We don't know everything. And how science works is when your model absolutely sucks and gets clearly proven wrong, you throw it out. That's how science works.
And then when you question science like you're supposed to, they call you a science denier.
Yep. It's so hard to find freaking papers, dude. It's like,
You're a legend.
joke. It's like they're behind paywalls. It's just such a joke. All these people so proud of their credentials don't even use them. And I'm out here trying to read these papers and can't get them.
You need the .edu stature.
But even that doesn't always get you in there. But yeah, I think I might have found some way to bypass it, but yeah.
This kind of sums it up right here. This is on that flatness problem Wikipedia page. According to Einstein's field equations of general relativity, the structure of spacetime is affected by the presence of matter and energy. On small scales, space appears flat, as does the surface of the Earth if one looks at a small area. On large scales, however, space is bent by the gravitational effect of matter. Since relativity indicates that matter and energy are equivalent, this effect is also produced by the presence of energy, such as light or another electromagnetic radiation, in addition to matter. The amount of bending or curvature of the universe depends on the density of matter energy present. So it's like they're taking like what actually is, what they're trying to say small scales, that is, it's flat, but they're just trying to claim that, oh, what you can see is actually what it is. But on this larger scale that you can't ever verify, but we're just going to give you these theories and concepts. It's all being bent by the gravitational effect of matter. And it's bending and warping within their reified concept.
Saying this book is just $7.
Maybe they're just giving you an analogy, by referencing the Earth. Could that be possible?
What, analogizing the Earth to something flat?
Well, what Geo just read.
Would be a pretty good analogy.
It's not quite an analogy because they're saying on small scales, space appears flat, as does the surface of the Earth if one looks at a small area. I mean, I know what you mean, that it's sort of like an analogy, but I think they're actually just saying like it actually is just flat in the actual, what they're trying to say is small area.
Yeah, they do the same thing for space-time as they do for, like, I don't know, say geodetic surveying. You know.
Well, you've substituted the word "is" for the word "appears."
Yeah, even though we have to treat it that way, or we couldn't do anything. So, like even on in space, like whenever they map out space time, they map it out in really small blocks in a grid system, and they treat all the blocks as completely flat. And then they put the grid system together and apply an overall curvature rate with the space-time formula. The same thing on the Earth. Make plane survey measurements in small increments, piece them together, and then put the overall correction for the sphere on it.
Yeah, that's a sensible approach, I think.
Yeah, certainly when you're trying to make a flat Earth ball.
Or make a ball or something flat that you can easily deal with.
You don't have to make it anything. It's the only way you can measure the world, man. Don't make it weird.
Well,
Yeah,
to
your
give some
ball is
validity,
locally flat.
I'll give some, in my viewpoint, validity to what Blue's saying, because I mean, if it was a sphere, then yeah, you would need to flatten it out to have it be more usable, like to more, to be actually like, because as humans, we don't really work in upside down spheres. We work like, standing up is up, and down is down. So you would need to like put it on a table if you have a map or whatever you're doing, like actually have it be practical.
Yeah, of course. In their paradigm, their Earth is locally flat for intents and purposes for practical use. You know, it's funny, man. They do this with everything, right? So you have to treat the Earth like it's flat to get your angle measurements from Polaris. And that's how we created the construct of latitude lines. So we drew concentric circles out from Polaris with angle measurements to Polaris, assuming a flat surface all the way out. Then we took that and put it onto a sphere. And then we took the sphere and we made it like a little tube. And then we flattened it out. And you got the Mercator projection.
It's been balled up and rolled. It's like some dough, some bread dough. There, you're rolling up, flattening out.
Yeah, like literally, even the globe model and the Mercator projection required the first step of assuming a flat Earth. Literally.
And if you do that, no angle to Polaris will work out.
That's
except, well, you can find one.
Well, see if you could show that, Blue. That would be something. Can you show that in any way, or have
Yeah,
you ever
we've shown it many times.
Oh, I mean, we're talking about the Sean Hawking's argument.
I don't know whose argument you're talking about. I'm just saying, sit down with it and do the math.
When you do the math, have you considered that we see in a dome a 360 field of view with a perspective limit?
I'm not making any assumptions.
That's not an assumption. That's a fact.
I'm putting three points in space. A star, some point on this flat Earth, and some other point on the flat Earth, and I'm making a triangle out of it. And when you do that, the angles won't work.
Angles won't work compared to what?
You can't get the latitudes.
Oh. Back to my first question. When we go out on the Earth and we actually get these measurements, we do that by looking at the stars, right?
Yes, you do that by looking at that star, not
So
these
we get like
stars,
an
that star.
azimuth. Yeah, like we get an azimuth reading and then like an altitude reading.
Well, azimuth no longer has any meaning when you start talking about a single star.
Oh. So you don't establish direction?
You're looking at the star. That's, if you want to call that an azimuth, okay, 0. We're always looking at 0, or pick another number.
You need an
233
azimuth
degrees.
You need a horizontal.
But when it comes to the North Pole, that's what's key. The azimuth is what's key. That makes it the North Pole, and then the measurements that come off of that, which are all the right angle triangles, which spread out to create the latitude lines.
Yeah, well, just do what I said. Put a star at a point in space. Drop it down to a flat plane.
Yeah.
A line down to a flat plane. When you form a 90-degree angle under it, right? Just like Polaris does. Now start working out the angles to latitudes and see what happens.
Oh, you're talking about using like orthographic Muppet vision of Euclidean geometry?
Oh, I don't like terms like Muppet vision.
Okay, you mean like a trigonometric assumption of Euclidean visual space?
I mean, like, yes.
Okay, so
Euclidean space.
all right, so you know that we have an azimuth, and then we get our altitude.
Yes, I'm
Right.
familiar with it.
Now imagine that, say we did that for all the stars that we can see from one position.
We don't need to go to. Okay, go ahead.
What are we gonna be left with if we do that? We map it all out.
I don't know. I was talking about latitude lines and their relationship to the altitude angle of Polaris.
Yeah, no, I'm trying to help you out, man. Like if you do that, you're gonna get an azimuthal grid or a dome, a celestial sphere. So like the points from Polaris, the measurements to Polaris from different positions are all going to be viewed through this celestial sphere coordinate system. If we map out all the positions of Polaris, then we get it inside of a celestial sphere. Right? So you guys claim the reason that happens is because the Earth itself is a sphere. But actually that's just how our perspective works. We have a 360 field of view. So we see in a sphere. You know, like our eyes are spheres.
You think?
Yeah. Even, telescopes are curved.
Really?
Just like our retinas.
But Blue, how do you know it doesn't match up like that? Like, meaning if you were to do that, and you like, let's say you're using 0 as Polaris, and your azimuth all the way around 360 degrees, every star is going to be in a particular position. So it's almost like a pizza with many, many cuts in it. Like you're in the center, and every line to the GP of every star is like cuts in a pizza, and you've got thousands of them, or let's just say 1 per degree. So you have 360 pizza slices. I kind of get what you're trying to say. You're trying to say if you were to do that in multiple locations, it would require the curvature of the Earth for those all to fit. Is that what you're trying to imply?
I'm trying to imply that you take, let's just talk about Polaris and nothing else. Take Polaris and the GP of Polaris, and now start backing straight away from Polaris along the same azimuth, if you want to use that term, along that straight line, looking at the distance of the latitude lines, and try to make that work out on a flat plane. It won't.
Well, how do you know it doesn't? That's my next question. Because
the measurements.
Yeah, but have you actually compared that to the soil on the entire Earth to actually do that? Or have you maybe done 1 or 2 and then use that as a bit of an assumptive model to then plug it into the larger system that we're told the Earth is in terms of maps we can get online and whatnot, and then it didn't match that?
Well, I haven't. I have not absolutely not measured every point on Earth, obviously, and you can only measure Polaris from the equator up anyway. But I do know that I can measure the altitude angle to Polaris, and I will get my latitude every time. Everybody that's ever done it gets their latitude that way.
Can you see the voice text?
Yeah, dude, because it's all coming out. They're like concentric circles coming out from the center, like a dartboard. So you're going to be able to get that with the angles.
You see, even in your
Try to
paradigm,
do it.
you have the celestial sphere. That's what you're mapping out on, even in your own paradigm.
I'm not talking about that star you're posting there. I'm
That's a
talking about
star in the
Polaris.
night sky. What do you like? Let's just say that I walked away from Polaris. That would be it. That would be Polaris.
Okay.
Okay, so even in your own paradigm, you map it out on the celestial sphere coordinate system. There's declination down this arc. Right? Like even in your own paradigm, that's why there's a globe right there in the middle of it.
Yeah, I know.
Okay. So if we take this and we apply it to the picture right above it,
and
it's a dude on a plane with a 360-degree field of view, right? You got the 90, 180, 270, 360. That's how we see. Okay.
And the distances across the surface will not match the angles.
They will if you understand that we actually take the angle measurements inside of our perspective celestial sphere. It works perfect on a plane, quite literally. That's how we got the measurements.
Yeah, Blue, because the azimuthal grid is a planar surface with essentially like a dome or a hemisphere. And, you know, it's even on Stellarium. You could pull it up and be able to, you can look at any location. Now, I'm not even saying that the coordinates on all Stellarium are all exactly what the Earth is. However, it does show how it can be plotted and viewed from our positions, where you have that planar foundation and an azimuthal grid going out 360 degrees around you. So why are you saying that doesn't work when it does? And also in like planetariums, essentially the planetarium is kind of a foundational surface that doesn't have curvature. I mean, if you're on the floor of a planetarium, it's not going to have curve, and you can view any part of the sky in essentially like a hemispherical dome above you. So it shows that all spots on the Earth can be recreated just as we see them, and a sphere is not required.
Can you find your spot in your observatory by angles?
Well, yeah, in theory, if you didn't go off any like pre-given information of wherever those observatories are getting there, if you just went out yourself and took snapshots of the sky everywhere, you could plot that within your own planetarium and then pull up any location.
Now, if you're in a planetarium, you want to find like A7, and you know how far away it is. Can you use those stars to figure out how far where you have to go to get to that seed?
So is the idea essentially like the same idea as Stellar, whatever that fucking program is, where it really doesn't matter the map because you can just alter the map any way you want. The only thing that matters is the coordinates and the celestial spheres. I guess perspective to those coordinates, and like you could literally have a Mercator's or an AE map or a spherical map. You could have it like as a star map. You could have it any type of map because like the map doesn't matter, bro. It's a celestial sphere. That's
Math doesn't work. You can't have a 1 degree per 60 nautical mile relationship. That linear relationship depicts the surface being spherical. It cannot be flat. Can't.
That's the problem.
No way, shape, or form.
Did you guys read what I just posted? In your own model, it says it's projected on the inside of a celestial sphere. Your own model.
Yes, we know that. Thank you for pointing out the obvious.
Okay, then. What are you arguing about? I mean, it's right in front of your eyes, bro. Your own model states what he just told you. Your own model.
Saying my own model 20 times in a row doesn't do any good, SC.
Well, maybe he's just trying to help you out, man.
I mean, I posted what the quote, and I also posted you the picture. That's your model, Blue. I mean, you don't have to like it, but it is what it is, bro.
That's my model.
You know how bad this is gonna get. By the way, we have a
That's my model. That's my model. That's my model. All right.
Yes.
Now try to go 3 sentences without saying that's your model, SC.
I have a model.
Okay,
bro.
I'll tell you another thing. Every star is considered to be the same distance, and I won't say in your model.
That's yes. Okay, fine, SC.
Hey, can you guys hear me? I'm gonna just say this one thing, dude. Guess what's gonna happen, dude? Gio, you might find this very interesting. USC as well. You know, like we were trying to coin the Binks Walter, right? But because you got Walter Bisley, and he says like, oh, the light has to bend, right? Dude, to be continued. But we have a Cinema 4D model. Okay, a model in Cinema 4D using the azimuthal grid. And it doesn't have any magic light bending. It simply uses linear perspective. And it perfectly works on a flat Earth.
Straight lines. Uh-oh, Blue. Uh-oh, that's not good.
Nice.
Post it.
No. Just be patient.
No. Don't do that.
That's what I Blue, you can break down on your own time, but that's what I've been saying for years. That's how I think it's done.
What do you mean I can break down on my own time, Rocky?
Y'all hear you, dude. Like, this is recorded.
Yeah, I know that.
No, he just said he wanted to check it out. I mean, I guess it's ultimately it's like a stay tuned. We'll have to
That's a stay tuned for sure.
Well, that's the best comment we can get from them is they're gonna check it out. So yeah, well done, Blue.
Blue's really breaking down, man. He's asking because he just wants to see it.
Yeah, I wasn't talking about that comment. I was talking about how he was acting before, but that's all right. We can move on. But my point still remains is that's exactly how, in my head, I saw it for years. I just can't explain it.
You're the one responsible for this model.
Don't say model too often because Blue is getting stressed, Koshko.
He just didn't like the way you were putting it on him. But anyhow,
yeah, I think
yeah, that's interesting.
He's being very rational. He's being open minded. He's willing to check it out. That's legit.
Yeah, we got to give kudos where kudos is due. Now, how about you emulate that, Koshko?
Well, that's the thing.
Like
I mean, you're originally saying that you're under a thought that the angles to the stars don't work on a planar surface. Is that correct?
That is correct.
So if you saw a model that was able to do that, and then that model was able to correlate with the physical world, would you then adopt that model?
I'd love to see it.
Impressive. With the caveat, though, that like I said, because I make games, and like Grand Theft Auto, for example, like there's all sorts of games, but you can make a world in a flat that make it look like it's on a sphere using tricks and stuff like that. So as long as it's not like using like digital tricks that don't exist in reality. But if
Kosher,
it's
what
not
do you
doing that, then you
say
have to be
to?
impressed.
Sorry, I thought you were done.
No, I am done.
Okay, so fair enough. But what do you say to the thing I just posted, where in your own cosmological model it clearly states that when we look up, we see a projection, as if we're in the inside of a dome and the stars are projected, and they're all at the same distance. Like, what do you say to that? That's your model.
All right. So if I wanted to make a first-person simulator that was like a movie, but it was like a movie where you're in the POV of the protagonist, and I was just digitally creating the scenes for the perspective of that person, and I made it so that you can look around if you like. You can look around, turn your head or whatnot. Ideally, you would make something like that, where you did it exactly the same way, like a sphere of images all around the person. I mean, the distance is relevant because it's either infinite or there's zero distance, whatever you want to call it. Because it's just a sphere around the person.
Okay, fair enough. But can we be on a planar surface, and knowing this information now that I just gave you, which you already knew already, of it being a dome and projected as if we were on the inside of a dome, knowing that, what do you say? Can that happen on a planar surface?
No, because that's the same. It's the same thing we do with celestial navigation, right? We used the celestial sphere for things that Stellarium does it, but it has a one-to-one relationship with the surface, which wouldn't be the case on a plane, right? You'd have different relationship with the stars and whatnot.
You're not seeing clearly, bro. Have you ever, as a child, been in a planetarium?
And as an adult.
Okay. What shape was the floor that you were sitting in?
Pretty sure it was flat and round.
Okay, flat,
circle.
right? And the dome on top of you, what was it? I mean, the ceiling on top of you that the planetarium projected. So there you go, bro. There's an example right there for you. You guys asked for an example. I just gave you one, a planetarium.
It's a real life model that you can directly validate and demonstrate. It's literally a
There it is.
demonstration of geocentrism and having a planar Earth that one is standing upon.
Yeah, but in that example, you couldn't do celestial navigation to the ground in that room because there's not a one-to-one relationship with the sphere that's being projected to the ceiling and the floor.
That's right.
You could do it though. Okay, if you went out and got snapshots on the actual Earth, so not just some calculated system or some WGS84, but actually go out and take 360 cameras or whatever it may be, snapshots of multiple places on the Earth. You could then load them into a planetarium system, one of those ones that has those huge LED screens on the ceiling, and you can basically put anything you want on it. Anyway, so you would put the snapshots of those physical places on Earth. You could then use a sextant, theoretically. You could use a sextant. You wouldn't really have the horizon, so there's a couple kind of challenges. Maybe you'd use a bubble sextant. Nonetheless, you could do it to where you actually could navigate within like a computer system model that uses a planetarium.
Do planetariums work off where you are in your location looking up, or is it the actual planetarium's sky of the planets and stars? It's just a generic.
Oh yeah, they use the celestial sphere, but they place you in it basically, and they map the sky as if you were in that position, like using a planisphere. Yeah.
Yeah, and you're on a flat
You
surface.
gotta take that wrapper a little further
Well,
away.
you're not really on any surface. You're just in free space, wouldn't you be? If you're looking at any part of the night sky in any direction.
No, the reference I was making in the planetarium, right? You're on a planar surface, right? And above you is the dome, right? It's a dome. And if you were to go outside, if you were to recreate the sky that the dome is that you're in now, like you can recreate where you're at in the dome, in the planetarium, and then step outside and see the exact same thing.
So
You feel
it
me?
wouldn't work for me then.
Why not?
If I went to the one of yours, it wouldn't work.
Why not?
No, he's saying if you had a display on the ceiling of the planetarium that was the exact location of where you actually are on the Earth, he's saying you could look at it and inside the planetarium, and then you could walk outside and see the same thing.
Yeah, depending on where you are on the Earth, though.
Well, yeah, you have to be at that location, of course, bro.
Yeah, and it's
And
all
you get the idea. You get what I'm trying to say here. You're in a planar surface in a building. On top of you is the projection of a sky on a dome, just like the model states, right? And you can recreate that thing. Like you can say, I'm in Sydney, wherever you are at this time. Let me see the sky. Boom. It's going to project it in the dome, right? Then you walk outside and you're going to see the exact same thing.
It's called a planisphere. I don't know if it's a projection or whatever, but it's called a planisphere, and it'd be the same thing that Solarium would use, or what do we call that? One of those whatever those star rooms are called. Planetarium. Yeah, they use a planisphere, which is basically a local map of the sky.
Okay.
From your perspective.
There you go.
Yeah.
Yeah, that's nice. Yeah, that's a good one, Gio. Exactly that.
Also, I like that term because it could also be viewed as like a plane within a sphere. That's an actual term in geometry as well. Like it's the name for those star charts, planisphere, but also the word planisphere also represents like a plane within a sphere. Also can represent a sphere on a plane.
Yeah, well, I mean,
like that word.
That's how it's represented, basically. But it's like for a local. It's used for local descriptions of the night sky, basically. Yeah, Flat David, or Dallas David, was going on at planar spheres for a while as like evidence. It was pretty funny, but
So I was wondering. Oh, are you done?
yeah, I'm done. Go ahead.
So I was wondering if that satisfies Blue request, because Geo asked him if we were to show him somewhere where that works, right? Would he convert? And I don't know. I believe I did a good example. I did a good job of showing you that. So, what do you say, Blue?
No, it satisfies it.
What
Are
I
you
say?
converted or what?
What I say is what Terry posted displays exactly what I'm talking about.
Which
Yeah,
is
that's
what?
what I was.
You can't.
That's what I thought you were talking.
You can't in
Okay,
the
can I
real
ask-
world take altitude measurements to Polaris and find your latitude if you're on a flat surface. It will not work.
Yeah, well, we just explained why it will, but
No, you didn't.
real fast. So, say hypothetically that you could use this 360 field of view as a mental grid of observability to explain all the celestial phenomena and their positions on a flat Earth. Hypothetically, like if you couldn't use celestial phenomena, stuff that happens in the sky, as alleged refutation of flat Earth, what would you have to claim that you disprove flat Earth? If you couldn't use the sky,
Yeah, Blue, how do you think you would fare if you had to if all the sky stuff had to be removed from
Well, they'd have nothing.
I don't use the sky stuff anyway. There's plenty of other observations you can make right here on the Earth.
can we hear them? Okay. All I hear is Globers talk about the sky. That's it. Southern star trails, positions of stars, eclipses, the sun and the moon. That's all I ever hear. Sunsets, angular size of the sun. So
Yeah, we can't use things like was it LIGO, Blue? Places like that.
Yeah, well, that's one, but one of my less favorite ones actually. LIGO.
I would improve these.
Okay.
Don't say that word in public, Terry.
What would
Please.
be your number one? What would be your number one quote unquote reputation of flat Earth without using the sky?
What would be my number one? I don't know. I'd have to think about that a minute.
Okay.
Yeah, they were talking about my favorite one earlier today. I don't know who brought it up, but the distance from the North Pole to the equator compared to the distance around the equator.
Yeah, that's hard to explain, isn't it?
Yeah.
It doesn't seem to work on a flat plane.
You said.
Yeah, like the relationship between the distance around the equator and the distance from the equator to the North Pole. There would be a certain relationship you'd expect on any kind of flat plane with the North Pole at the center and the equator, around it somehow, and then the relationship that there would be odd sphere with that as a pole and the equator as the center point of that sphere. Yeah.
What would be the difference?
In one case, in the flat plane, you'd expect it to be 2 times pi. So the equator should be 2 times pi, the distance from the North Pole to the equator. And on a sphere, you'd expect it to be 4 times the distance. Yeah.
Yeah, so one of them is 3959 with the 24901 radius, right? Or, sorry, 24901 circumference gives you the 3959 radius. Yours on the globe is 6200 instead of 4000 instead of 3959, right? So then then what's, because I have heard this before, but then what's the final part of it as to how you think that the Earth shows one over the other?
Well, yeah, I mean that's exactly right. So if you decide, so you had to fix one of those values. You have to know one of those values. Let's say you know the distance around the equator as 24901. then the distance from the North Pole to the equator should either be 3959 on the flat plane, or it should be 6225 on the globe. If you have the distance from the North Pole to the equator is 6225, and you want to determine if it's a flat Earth globe, you'd be looking for 24901 for the globe, or 40,000 for the flat plane. So it's either 15,000 mile difference or 2,000 mile difference. Yeah. 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 I didn't really lay that out clearly, but I have a picture.
Yeah, I was gonna say, could you say
Like
that?
a Liddy.
Try to reword that, because I am familiar with this, but I just, yeah. Do you want to try to reword that?
Yeah. Okay. So, like I said, in the case of the difference would be either 2 pi or 4 times. So if you're going to decide on the equator, like choosing the equator as a correct distance, and determining what the distance from the equator to the North Pole is, you'd be looking for either 6225 if it were a globe, or 3959 if it was a flat plane. So you can make that determination right there. If you didn't agree that the equator was that size, but you did agree that the distance from the equator to the pole was 6225, then you'd try and see if the equator was either 24901, like we think it is, or 15,000 miles bigger. As so yeah.
Okay, but then how are you then verifying that it is 6200, whatever that number was, 6255 to the North Pole from the equator versus 3959? How have you isolated that without having measured it or gone to the North Pole?
It's a good question. The best route that I think is the safest, most confident, is from Africa to the Mediterranean to Europe, and then Scandinavia, and then North Pole, because we have plenty of maps that have been in all those regions for like the past thousands and thousands of years. So yeah, I use that to confirm it. Like basically,
You don't know the distance then. So so this whole thing kind of is just a dead end, because you don't. Yeah, I get you're saying where you could go do it or whatever, like, explore or whatever, but you don't have the actual distance to the North Pole to verify which one it is, right?
well, no, I'm saying like let's say that let's say it was in question whether that distance was 6225 3959. You then could get a map out and say which part of that area you're the least confident about, and I'd be surprised if anybody found any area around there that they thought was maybe up for question, because there is 6,000 miles there, and so somebody would have to determine where the flaw was, right, between like northern Africa, the Mediterranean, Europe, Scandinavia. Yeah, and I'm not sure where the 2,000 miles is. That's fake, but it seems to all be real, right?
And then your thing also is based upon the angles of Polaris too, right? And the 69 miles per degree.
You don't have to include Polaris or any of that. I mean, you don't need that. Yeah. It's really just the relationship of those distances. So, like I said, the most common refutation is just that you're not confident on the distances. But if you are confident on the distances, then mathematically, the relationship will determine whether it was planar or spherical.
Well, what degrees do you? 69 miles times 60 degrees is roughly 4,000 miles.
Yeah, but there's 90.
Right, which gives the 6,200 number.
I guess you could like where the equator was for question 2, but
Well, yeah, it's 5,400 nautical miles.
Oh, I will just throw this out. So, Jaren and I actually think the equator could be much closer to 21,000. You got the north being misrepresented, and then that carries over into the south as well. You could also have the north actually being a bit bigger and the south being a bit smaller. And then I have a video where this guy fully breaks down exactly how you could easily just take a flat Earth and then make it a globe. Doing just that. About 30%, 1/3 of a change. Oh, yeah.
What do you mean, eggshells? You think you got something here?
yeah, what was that thing you were talking about the other night? Sorry, go ahead, sorry.
What are you talking about, Kosho?
No, I just remember Gio had brought something up the other night about like if the sky being based on these like two toroids, like two toroids stacked with a plane in the middle. And
was Gio just talking? Because I couldn't hear him.
No.
Okay.
Was
one of
Eggshells
those
just
things.
talking?
No, I couldn't
Yeah,
hear it.
I was addressing Gio. Yeah. Well, no, because you addressed Eggshells, and I figured that you were just talking to him in the text chat.
Yeah, he was. I hear you though. I hear what. Yep.
Well, yeah. By the way, Eggshells was a part of that conversation too, anyways. But yeah, I remember we were talking about making the sky work using that, and I was wondering why nobody had ever like modeled that out, because I think that'd be interesting to. If there's a way to make the kind of the way we view the sky work using some sort of toroidal path of like the sky or something.
Yeah, you break it down into 4 toroids as well, the 4 cardinal directions, and then each one is one of the 4 corners of the Earth, the southern star rotations. So have like a dual toroid of the top and the bottom, like it's a dipole system vertically, and then horizontally a quadrupole. I'd love to see someone model that out. Someone that's got skills with the modeling like that. It'd be sweet.
Well, I mean, that takes more than modeling skills. It takes like
we can get all the wandering stars in there, like the Mercury, the Sun, Moon, Mercury, Venus, Mars, Jupiter, etc. And I can, if someone's going to do this, I can help.
I don't get it though.
Delineate how those are positioned, because they're in their quote unquote orbits, meaning their cycles between the tropics, and so those all need to be modeled as well, all within the system. It'd be sick to have that all animated to where it'd be like a more advanced version of, like way more advanced than Stellarium, where you could actually zoom in and zoom out and actually see the entire thing, and then animate all the wandering stars, and then showing how that from like a zoomed out perspective does actually fit in the individual, azimuthal field of view ranges on the Earth, showing how that all matches.
Yeah, but hold on. I'm just trying to understand what you said, because like I'm imagining first like the 2 toroids with the plane in the middle, but then you said have another 2 toroids perpendicular to that. But wouldn't 3 of those poles be I don't know, like on a flat plane, like 2 of them would be on the horizontal, one of them would be underneath it, right?
No, what
is that what you meant?
What I was saying is that on a vertical axis, if you have a planar center and then the toroidal field surrounding it, you'd have one massive toroidal field that is like the entire field. And then, but that breaks down. It's all toroids within toroids, vortices within vortices. So that would that would then start to break down into various different delineations, which ultimately this is what's causing the Foucault's pendulum, and it's all the ether, it's all the vortex.
It's toroids all the way down.
Yeah.
That are trains. That's what I was thinking when you said that.
Well, it's not a
Train.
coincidence that a turtle is also a tortoise.
Yeah,
So,
and the turtle historically represents time, which is why all the ancient etheric representations have the vortex, and the turtle in the middle. So there's time. It's like actually a depiction of physics. Like, yeah, it's very fascinating. Ancient Vedic cosmology depicts this.
That is interesting, actually. I never thought of it. When I think of Taurus, I always think about a bull, but actually that is true. It is kind of close to tortoise.
Oh, and it's like, of course, their back is a calendar, right? So their shell is a calendar, so they used it as time, symbolism of time.
oh right, yeah, that's another fascinating thing. Yeah, their shell is actually, it has like the year, it has the solar and lunar cycle in the shell of turtles.
Yeah, I have a picture of it somewhere. So like a Vedic cosmology. Ether physics. It shows like the two conjugate motions, vortex going down to the turtle, then water.
And of course, the turtle shell is shaped like a dome. Yeah,
Maybe we don't live on a turtle.
It's the
Maybe
lunar.
we live inside of a turtle.
Oh, sorry. I was saying it's the lunar cycle, but it has the solar cycle in it because the lunar cycle is set within the solar. Sorry, go ahead.
Yeah, I forget this. No, I've seen this before. I totally forget what this is about. Just the numbers on a turtle's back.
You know, like they're supposed to be 13 months. That represents a
Right, for 13 constellations. Yeah.
The outer part shows the days in a month, and then the inner part shows the months in a year, 13. So it's like 28 on the outer, the 13 in the center, which all make up which fit into the solar cycle of a year. But yeah, what I was saying before, so what I was describing, Coach O, is like if you have a planar surface with one large toroidal field, but then within that you would have you could have the toroidal field on the top of the plane and then the one under it. So now there's two interfacing, which are going to give you the convex and concave, centripetal and centrifugal flux lines of those two toroids that meet at the plane, at the ground, which reminds me of what we were talking about before, like the pressing down of the ether and like all of that that's connected to that whole system of that toroid on the top of the plane. And then that can then further be delineated, in my viewpoint, into 4 quadrants, so 4 toroidal fields of a quadrupole, which are then connected to the southern star rotation points. So it's like you have 4 of them horizontally, like north, south, east, west, which is how the continents are all coming out from the center as well. And then you'd have the one on the top of the plane, the one under the plane, and then the entire one as well. And I think there's even smaller ones that even break down as well, which are connected to the environment. But yeah, it's sweet to see how that all modeled.
You see the
Yeah, if I had
cosmology right there, where you have the turtle at the bottom, like time is the base, and then you have that the pillar up in the middle, and you have the vortex motions going through it, the two conjugate motions, all within a fluid. It's like ether physics. And if you actually read the Vedic text, of course, it's actually like physically accurate, as everything's intrinsically vibrational resonance, interconnected, etc.
Those also supposed to represent the zodiac constellations, or some other version of the zodiac constellations, like
Maybe,
those
yeah,
dudes.
there are 12 depictions there. There's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
But they probably have slightly different myths behind them. But like it looks like one of them is Gemini. but I can't really pull it up.
It's got all those concentric circles coming out from the center as well, and the central magnet, like that Mount Meru. Yeah, that's awesome. Yeah, the Vedics are deep. They have this whole system they call it Bhumandala, which is essentially like the entire Earth realm, which is defined absolutely as a planar surface, like the foundation of Bhumandala, and then all the layers of the ether above.
You know, Branch told me, and I had to take his word for it because he comes from a Hindu family, but he was explaining to me that like kind of similarly to Greek mythology, that like Hindu. The reason why Hindus have so many gods is because the same way they collect together, you know, cultures like in modern times or throughout history, they collect them together and they combine different religions together, different traditions together, and come up with this like this cocktail of, you know, just weird traditions. You don't know what comes from what. But that's like over time, like the collection of all the different peoples that were taken over. Eventually, they just added their gods together, and they ended up having like a bunch of gods. But he said technically, there's really only like one god in their religion. Like I said, I'm taking that from him. I don't know if I've heard that anywhere else.
Hinduism says there's like specifically like 72 gods in the 7 layers of the heavens, I think. I mean,
Yeah.
I could be wrong.
Yeah.
It definitely invokes like 7 layers.
Well, the Norse mythology, doesn't it also have like 7 layers?
Yeah, there's a
Like
lot of them.
7 Earths or something, or 7 whatever they call them, realms.
Actually, like many versions of ancient Hebrew cosmology as well. Yep. Pretty interesting. Because we have 7 chakras, 7 colors of the rainbow. Yeah, I don't know. It's pretty interesting.
Nothing Japan Apocalypse or
7 chakras.
Yep.
Well, 7 days a week. So even though it's the names, none of the names come from Hebrew. 7 days from the week it comes from the Hebrew.
Yeah, that's right. Did you know that the Romans actually tried to change that 2 different times? They tried to change it. The Roman Catholic Church tried to change it 5 days and then to 10 days, but they just couldn't get it to stick, even after murdering tons of people. So they just rocked with the 7-day Hebrew and then changed the Shabbat Sunday and then changed the names.
Yeah.
Hebrew people used to just count.
It's like what if
day 1, day 2, day 3 to day 7.
They literally broke all the 10 commandments. Like, there's so many 10 commandments we can break. That's what the Catholics do. Because like it's a day. Yeah, the simple to not break, and they broke that one. And then there's only one God. That's the first rule. There's only one God, no other God. And then they made 3 gods or 3 versions.
Yeah, I mean, some gravy really with all that is like the whole 10 commandment thing. The Hebrew word actually means words, and every other time that word is used in the entire scriptures, it's translated as words. It's the only place that it's like commandments, 10 commandments. It seems to actually be like a 10-word phrase, which would denote covenant that the Creator made with the people. There's obviously way more than 10 commandments. There are many more rules than that, of course, instructions.
Yeah, it's kind of like the Bill of Rights or the Constitution. And like there's like amendments. That's like all the stuff in Leviticus.
But if it's a 10-word phrase, it's like the word in Hebrew means words, and it would be like the initial statement in the Declaration of Independence. You know what I mean? It would be like the summary phrase. Apparently, Ethiopia claims to actually have this 10-word phrase engraved in emerald tablets hidden.
Is that available?
No, they just claim that they say it's hidden, that they can't tell anyone where it's at.
The hub, which they call a temple, I think, but it's in Ethiopia. That's like protected by this one rabbi sort of dude who, like when he dies, like they switch it over to another dude. And basically, he's the only person allowed to go there. He like protects it. I remember seeing something like that. And there's people who think the Ark of the Covenant is there. Mm-hmm. It might have something more to do with those tablets. Tablet you're talking about.
I'm so tired of these papers being blocked, man.
You know, most things that seem blocked, typically there's a way to fuck around and get access to it. But I'm not going to make any promises. But I can take a look and see if there's something I can do.
Coach was gonna go on the dark web and get a subscription to some back end article hack.
Someone actually sent me one. Allegedly sent me something that bypasses all paywalls. I just haven't even tried it yet because I'm like,
We have people in here that have close connections to university, like give lectures, know professors. They could get all these papers for you.
yeah, but they're probably not gonna like what the papers are about.
Yeah, it doesn't matter. If they're after truth, they could get the papers for you.
Oh, what a big if there. You drinking?
Oh,
Well,
Jace,
just,
for example.
or blue.
Oh, there you go.
Okay, cool. There's a paper.
Isn't that Professor Park's a university teacher?
No, he works in a
High school teacher. Oh.
I think he was a former professor. I think. But I could be wrong.
I think he still is. I think he still is. Yeah, he teaches. I mean, when
Tom
he
Parks is a teacher, yes.
Yeah, he was in here a couple of weeks ago, and he was like, "Well, I gotta get to bed. I gotta get up and teach a class in the morning." So yeah, he's still actively teaching. I believe at the college level. Do you know Blue for sure? Yeah, it's college level, right?
Yeah.
University
is he
George
Mason or somewhere?
Yeah, George Mason. Yeah. Do you know what level? Like
on my show, actually, I just haven't had a chance to get him on.
Is he teaching undergrad, or is he probably? Yeah, I think undergrad. I don't know if he does any grad school level as well or not.
I don't know. I think it's undergrad. I'm not sure.
Why do these professors want to talk to flat earthers?
Because they require intellectual stimulation.
Put that in your pipe and smoke it.
You know, my point is that Blue could reach out to some of his buddies just by email and say, "Look, we're having trouble, firewalls and whatever. Can you get these papers for us?" Pretty easy.
Yeah, I mean, most of them give you the option to access them through your institution. But honestly, I would annoy them. I have like maybe 50 that I currently need to get. So
I mean, I've asked Jace. I've told him. I said, hey, if I want paper and if I send you the link, and I don't say anything in the message. I mean, like basically, do you mind fucking just opening any paper I send you? And he usually opens it up pretty quick, sends it back. Although, like I said, I mean, he's at a pretty good university, but yeah, but a lot of them, they'll send it to you depending on your university. So they don't send it. They won't give you access to every university, from every university. You just get access to most papers.
Help a brother out, man. You hear Woods is struggling.
Unified theory of gravity, electromagnetic force, strong and weak forces, and their applications. Theoretical explanation for dark matter. 2022. Austin, you're so stupid. You're so stupid, Austin.
Chronic was supposed to send me 2 links that he did not send me, I don't think, regarding his crazy new findings. He said that there's 2 pictures just came out that people are enamored with currently, but it's a relationship between dark energy and black holes. There's like a strong correlation, but they don't know the reason for that correlation, but they're suspecting that there's a strong just a strong connection between them, and there's still further research that needs to be done. Yeah,
I know what it is. So, the black hole is actually just the center of the magnetic field, and dark energy is nothing more than part of magnetism, electromagnetism. Just like that one paper that I just referenced earlier says, based on the magnetic permeability and dielectric permittivity. If you look at the center of a black hole, of a magnetic field, I mean, that's a black hole.
yeah. I just started looking at that. I gotta open it back up because I deleted it, but I was trying to bookmark it. But yeah, I had asked somebody about
Drop the PDF too if you want it.
About like the fields. Yeah, the PDF you said. I think that's what you sent. You posted it. Like you posted. Well, I guess you posted the link. Yeah.
Yeah, I mean, I got both. I don't know. Like links are annoying, and I gotta keep up with them.
I have like 8,000 bookmarks saved.
The paper here from 2021 is titled "Dark Matter Interacts with EM Waves." Sounds like a cosmology.
Sounds interesting. Because that's the big claim. I mean, that's the one thing about dark matter that they, suspect. So if it is a real particle or real matter, then that's the one thing that they know about it is it doesn't have an interaction with the electron field or photon field, electromagnetism.
I mean, just ether, and of course, electromagnetism comes from the ether, so of course it has an interaction. But I guess the problem they're going to have is all the celestial observations where dark matter is needed in like immense proportions, not interacting with the light based on that amount of matter. Like, I can't see this paper being good for cosmology. I haven't read it though. It's crazy, yeah. Finding lots of papers from the last like 2 years specifically that are like, screw it, modern cosmology is wrong.
Yeah, it almost seems like during maybe the whole pandemic deal, there's been some kind of resurgence, or something being some shift of some sort, perhaps. I'm not saying directly related to that, but it just almost seems like like just the way that they like sort of like they're trying to lock everything down, but then it's like it's actually just like it's coming out even just like the changes are coming even stronger, in lieu of them even trying to kind of shut things down in that way.
I hate when I click on a link and it just automatically downloads the PDF. Like, what?
That's your settings, Witzy. You gotta edit that if you don't like it.
But do you think they might be trying to absorb the electrostatic nature of gravity to then work into, like, if they have some alternative plan of what they want to try to
They have
roll
to.
out to?
They have to. But
Yeah.
a couple hiccups though. When you try to apply it to the full scale of cosmology, it doesn't work. Duh. But yeah, it's literally the only way forward. They're gonna do something to the effect of unify all the forces, including gravitation, under the electromagnetic umbrella. And basically, you got like the electrostatics being the central resonance that causes that vortex around it. And the problem they're gonna have is like the collapsing effect being gravity. I just don't know how they're gonna apply that to cosmology, but I'm sure they'll try. I just don't see how they could do it without changing the medium. So, you change the medium, you change the distances, you could do it. You could keep a sphere if you change the medium of space. But that requires you admitting like you are way off about what space is, especially when you claim you've been there. So that's why they love this dark matter thing. They can claim that they've been out there, but still were completely, didn't know about like tons of substantive medium, right? Like, I don't know. It's just interesting. We'll see what happens.
Like, they've been out there, they just don't know what it is yet, but they know it's something. It's kind of what, yeah.
Yeah, like you could just be in a vacuum and you have all this material around you, which isn't entirely untrue because you have the ether, but they have these immense distances, and if they're going to try to unify the forces, make gravity electromagnetic in nature, then you need to explain how these bodies are doing that in relation to each other. Yeah, I don't know. Seems kind of like a stick of dynamite. They will have to do it, though. Yes, they will have to admit that gravity is electromagnetic, in my opinion. Who knows? Maybe that's after everyone's robots. I got all the robots now. Who cares?
It would be after they've run out of options, because there's one truth, right? And then there's a bunch of limited but a large number of variables that are bullshit, right? So what they keep doing is they just keep going through all the variables that's not true. Like 1 + 1 is what? It's 2, right? But all the lies are what? You got a bunch of different lies you can go down. It's 3, 4, 5, 6, 7, 8, 9. Because to me, that's the way I, unless I'm picking it up wrong with it. That's the approach I think they're taking. They just keep adding lie upon lie, and at some point it's gonna collapse. But you can lie a lot before that happens.
Yeah, but I mean, they're already to the point where they have no choice. So
Todd would say, but Blue's not going to help you. He wants me to pay for him.
it's okay.
Sorry about that.
I don't care.
Wait, he wants you to pay for what he was already got for free?
Well, no, I was just saying if only we had someone that had connections to a university or professors, they could maybe get these papers that Witset's saying he's having trouble getting. Like he could reach out and just send an email, but he says no, if they're charging for the papers, he's not going to help, and I should just pay for them.
And I mean,
Are they limited to a
it would be kind of
specific
like an
university?
embarrassing position to like email people and be like, I don't want to pay for this paper for $40. Like, can I get it for free? I don't really blame them, to be honest.
Are they limited to a specific university, or are they just accredited groups and stuff?
It's just like new, like cutting edge articles they charge for. Sometimes you can access them through your institution, but they just put them behind paywalls.
Give me a title. Post a few verbatim titles in the text, and I'll see what I can find.
I can drop a few.
Because sometimes there's other options depending on how Yeah, I'll probably
Telegram,
do
man.
it.
Wow,
I do, but I don't have access to it today.
Is
yeah.
that not the problem? Or was
I'm
did I
on Discord
misunderstand?
only for the next like half day, but tomorrow perhaps.
Yeah, I drop them all in there so we can like as a group effort try to get them. I've already had people help me get a lot.
Okay.
I'm just like kind of on one right now, so I'm like
No, I get that.
trying to get a lot of them. Yeah.
Get them all.
Well, maybe I misunderstood. I thought the papers are available. They're just behind a paywall. Is that right?
Yeah, they are. I'm not paying $40 for each paper. It would cost me like $4
Okay.
grand based on what I want to get right now.
Have we heard of Sci-Hub?
Ruhif will cover it.
Have we heard of Sci-Hub?
But it's just Sci-Hub. Yeah, I tried it. Yeah.
Yeah.
Sci-Hub is cool. It's definitely a cool idea. A bunch of people trying to help give the papers to them so people can get them for free, but it doesn't have a lot of these papers in it.
Okay, cool.
It is cool though. It has had some of them. Their catchphrases is even scientists are pirates.
Yeah. Do you want to go through some of those quotes in the PDF?
No, right now.
No.
I'm not the
Cool.
navigation quotes.
Yeah, I've done
No,
a few of them.
but
Pretty hilarious.
No, I don't.
Anyway, another day.
Yeah, another day. 4 in the morning. I'm just trying to get these freaking done.
Have you exhausted that paper you were dealing with before, Witsit? About the measurements and all that?
Electromagnetic gravity?
No, remember, I don't know how long ago it was, a few weeks, about the measuring of the North Atlantic and stuff.
Oh, no. At all. The transcontinental.
Yeah, that one.
No, I mean they use the least squared method based on preliminary reductions using the spherical model.
So you're done with it, yeah?
Right in the citations in the survey. Cite the method that they use for the least squared method. Shocker.
Just gonna get to the point where they could make such absurd claims that a couple generations down the line, people are gonna, without even question, just go, yeah, of course it's a banana. What do you mean?
You know, that one paper is still the best find today. Straight up says gravity is electromagnetic in nature.
Yeah, peer reviewed. The highest credentials of that guy. I looked up his biography.
You guys heard of emergent gravity? Interesting. What theory?
What is it? like a prehistoric gravity before it evolved into whatever it's become.
It's from 2016's theory by Eric Verlin. It's about basically that like gravity's actually comes from like a holographic interaction in the background, and gravity emerges from this entangled underlying structure.
Is gravity a spirit now?
Pretty much, yeah. But it is actually it's trying to throw electromagnetism in the mix to replace relativity slightly. Like, if relativity is so awesome, why is everyone trying to replace it?
Because they got shit to do. They can't keep pretending that that the nonsense is true. I think maybe the era of just quote science for quote science sake is coming to an end, and people actually need to produce results. So it's like, yeah, you can lie to the rest of them, but you can't lie to your employer. You got things you have to make. So remember, a lot of this stuff comes from grants for no other reason than just they're just giving grants out. They're not actually gaining anything from it. It's like a circle jerk. But the original purpose for these kind of nerdy adventurers was to get results that powerful people could implement to gain more control or access more resources or whatever. And I think the era's kind of switched a little bit. Nobody's got time for frivolous stuff that much anymore. That's my interpretation of it. I don't know. Because it would be just easier for one of the, quote, authorities to just open their mouth and go, well, we're rewriting it all. And then how everyone just accepts it. But maybe they don't want to be that honest. I don't know. Wait, hold on. Wits, are you there?
Yep.
You know when they seized all of Nicola's papers? How long ago was that?
80 years.
Is there some kind of limitation on how long they can keep that
No,
under
it's supposed to be
wraps?
around 50 years, so they can always step in and just say, never mind, this is the exception.
Okay, just arbitrarily. No, I'm just curious as to whether maybe under their own rules they've been kind of forced to.
Well, if they say it's for national security, they can extend it.
Okay.
Yeah, freedom. They were taken in 43, this says. I don't know. So, yeah, right at 80 years.
The stuff these guys say, dude. This Mandelbrot set dude just said that he read that paper and he said it seems not to be serious. What does that even mean?
He read the paper in 2 minutes, yeah?
It was published by the Journal of Modern Physics. So is he claiming that they're just posting papers that are quote unquote not serious? They're just joking around?
I mean, if you can even read it, it's very obvious that it's.
I think the mistake would be entertaining the text chat, Gio.
Yeah.
It's just like white noise when I look at it.
Well, that guy's particularly just one of these text trolls. Seems to offer nothing but just attacks. So yeah, probably just.
Yeah, if they don't have the balls to to get on the mic, so for what reason? Because it's definitely like it splits your mind when you're trying to engage with punks on the text while you're sitting in a voice call.
Yeah, it's totally not serious. That's why it has that as the reference list.
Well, anyway, context usually answers that. So if the context is academic, whether it's a lie or not, doesn't mean it's not serious. For it to be unserious, the context would have to be something like a comedy set, and then perhaps one could make such an argument.
Priest.
Sorry?
There should be a revered priest in their paradigm. No, Gio looked up his credentials. Whatever. It's not serious because it agrees with what's it.
Ah, see, there's the logic. It's a whole host of links you're posting.
Well, that's all the references, just to point out. It's not a satire article. It's got 27 references.
Yeah, it's a lot of background for a bit.
And then this is the guy's biography.
Let me have a read.
And then, I don't know if you could hear me before when you brought up emergent gravity. My mic wasn't working. I thought it was, but I had said something about that. That was emergent gravity is what's been come up by Eric Verlinde, and it's interesting because it actually accounts for dark matter. It's probably one of the most promising replacements for general relativity.
Yeah, it's not bad.
So this geezer's an old hat at this game.
So, Kosha, what do you predict it's gonna change into then? Once they just completely have to just fire relativity off into non-existent space.
Yeah, well, that was his 1 centimeter closer towards the truth.
Well, if I can answer that question, Gio, I'd probably get the Nobel Prize. Anything else, it'd be basically just guessing, making it up. I have my assumptions, but like I said, I know as much as the next guy about what's going to be the replacement for general relativity. So I think gravity and I think what might be the case, like what they might end up discovering, is that gravity, space-time, and dark energy, they have like a different relationship than that of like the other known forces. And it's just something a little bit more exotic than what we like a relationship that's more exotic than what we currently know about in physics. When the paradigm changes from.
Sorry.
So what?
I'm gonna send Leo or Gio a really dope website. Maybe you would like it too, Elijah. About Ron Hatch, and it's got 28 technical papers just taking relativity out back.
What, like George and Lenny, yeah?
Yep.
Nice.
I like it when people can do that in a sophisticated communication style. It's like when you read the way Tesla would talk about Einstein. Like we would just be like, man, he's an idiot. But Tesla just put it to him a whole different level.
Says so you hear almost every day how GPS is a practical example of the use of Einstein's relativity. It must be true, right? Wrong. Just ask Ron Hatch. Ron, a critical thinker, holds over 30 patents in GPS and one of the most decorated GPS scientists on the plane. And he says that GPS doesn't support relativity, but actually shows flaws in the theory. Why don't we hear about this all over the news? Because no one, not even those in the billion-dollar GPS industry, want to reveal to the world that humankind's most beloved scientific genius may in fact be, dare we say it, maybe wrong. Yeah. Actually,
Yeah, Coach, you're into GPS. Have you looked into all this? Yeah, there's a lot here. Wow.
I actually have his book on PDF as well, so a Flat Earther bought it and scanned the whole thing.
What's the It's too complicated a question. Just bear with me.
This book is called Escape from Einstein. I'll find it.
Oh, that's not that easy. Not that difficult. Sorry. If you're gonna do anything that's practical, then you're escaping from Einstein and his thought experiments. So while you're over there thinking, my guy, I've got things to do. Real life to live.
It's uploading.
Well, I think fundamentally when it comes to GPS and stuff, it's just telecommunications. So the notion that it has anything to do with any of these esoteric theories is just laughable. Because for it to work, it has to be based on what they already can observe and interact with. Just because it's unseen, people like to use it and go, well, we can ascribe a whole bunch of theories to it. But they're only surface level. Scrutinize just a little bit, you find, okay, well, this has got nothing to do with reality.
Yeah, I'm just freaking. Yeah, I'm just dropping so much stuff in my Telegram. It's hilarious.
Hey, you said you renamed your Telegram?
Would you say Megatron?
Yeah. Your perspective, your mic is not.
You call him Megatron.
You sound like a transformer talking through a tin can.
Bro, I sound like Darth Vader or something. I'm like, you're like creeping me out.
Yeah, what's up with this Escape from Einstein PDF?
You mean what's up with it?
I'm trying to open it, and this thing's going backwards and forwards. Maybe it's just my app. It was going it was going up 15%, then down minus 15% in the download.
I don't know
It's
what
okay.
they do. This dude's a legend, man. He scanned the whole book.
That's peak. I like that.
Fire.
Page by page.
Yeah.
Now, that's a funny thumbnail or book cover. That's great.
You said you renamed.
I was gonna rename my Telegram, yeah, but it won't let me. So it's still t.me/witsitstreams. I
Wait,
might
you
just make
stream?
another one that's like t.me/witsitgetsit and drop like memes and stuff in there, and then just drop all the stuff about streams and all the PDFs and info in the other one.
Is the one
Okay.
that you have, is the main one that you have one that people can interact with?
That one's called t.me/misswit.
Because you can drop one where it's just you drop stuff and people can only read it. They can't actually comment or whatever. And you can use that as like just a data dump. I think in Telegram it's called, I think those are groups or channels. I can't remember, but they have different designations, right?
What's up?
You know, when you want to open up either a group or a channel or a server on Telegram, depending on which one you choose, you'll have different application. So some of them it's just people have them as, they say it's like a YouTube channel and they just want to have, every time they're posting something, people can just be made aware of it and maybe they can comment on the post, but they can't post anything independently. And then other ones, it's just people can communicate back and forth.
Yeah.
You can do one that's just a data dump.
That's
for the
that's
whole-
what the Witcher stream ones is.
Ah, okay, I see.
Boom. I got Witcher gets it, son.
Boom, pow.
Let's go.
4 o'clock in the 4 o'clock in the morning is liver time, so do something good for your liver.
Why is it liver time?
In Chinese medicine, every hour of the day has influence on specific organs. And 4 o'clock in the morning, that's liver time. That's the time when you need to be sleeping so that you can boost your liver.
Then why are you lot still awake? I'm
'Cause I'm
assuming
in New
that's a
Zealand.
local time thing, yeah?
No, that's Witsit's time. I'm in New Zealand where it's 9:30 at night.
Yeah.
Just go and pull out a liver from a lamb and fry it
I'm
up.
about to
There you go.
crash in a sec, because I actually got to get the tires changed super early. So I'm very responsible. You know? I just stay up. I always get caught up doing stuff. Don't make it weird, bro.
So you said that you guys are going to rework Hunter's interactive log, so make it more accurate from the way it works in the flat Earth.
I for sure don't know what you said, bro.
Is my audio still fucked up?
Sort of.
Yeah.
Is it? Oh shit! I thought I fixed it.
You underwater or what? Man, they're stealing your bandwidth.
It's
All
like
right.
Uber time. You should make a remix instead of hammer time.
Does it suck still or what? Better? No.
Yeah, it's better.
Better. Okay. I was asking, you guys were saying that you're gonna rework the Walter Biswin model, make it more flatter friendly.
There's already something that exists.
I thought you said you were gonna redo it so it didn't have all those bendy lights, or
That's right. Yeah, it already exists. Apparently,
oh, someone's already done it.
yeah, flat earthers.
Okay,
I'm
it's
still
just
gonna
not.
after till I die though. It's hilarious. I don't know about till I die, but have you guys seen the Thanks Walter meme?
Yeah. If you know anyone that wants to go through any kind of like work to do it, I thought that, just maybe even just a few cities in different areas in America, showing the angles of the runways at the airport with the latitude and the speed that the plane would have to be going and the angle that the plane would have to be in when it lands for like, maybe 10 different airports, just the United States. Just visually looking at that, seeing the angle that it would have to land at, how it would be completely different than the other one. The speed would be completely different. The calculations would be impossible. Like having to make sure that the plane's moving eastward, which is impossible anyway. It's not
impossible for you, new perspective.
Oh, would you? Oh, you want to? That's a project maybe Ruth would like.
No,
Just
you
show
should
all
not
the
say.
angles for all the runways that they land on, and then to show how the plane would just simply be in that same tangential velocity at that angle, and wouldn't have to treat any runway any different than any other runway. That would be amazing if you could show that.
That's a good point.
Yeah, it's just my problem. Actually, it's the pilot's problem. It'd be all pilots' problem if we were actually on a ball spinning. Be a big problem.
Yeah, but airplanes have really expensive tires.
Oh, that's it. Like Dyson ball tires. Is that what they use?
The hell does that mean?
They read them.
So it doesn't matter about the tangential speed. It's all about the rubber.
The rubber meets the road.
Yeah, man. Like if this place was spinning, that they'd just be blowing tires and like breaking all of their gear, and planes would just
And
be
killing all the people inside the plane. Yeah, exactly.
yeah.
I think we're jumping a few too many steps. If this place was spinning, I don't think anyone would even consider going in a plane.
Yeah, if it was actually
They'd be
spinning, no
like,
one would
let me
be
just
brave enough.
hang on for dear life. Hold on.
Right? We wouldn't actually be alive anyway. I mean, none of it. All of it
let me
would
just
be supposition
let me
that
just
it would work.
concrete my feet to the floor. I want to live
Right?
this one out.
Hilarious.
I don't think anyone really got Demok's explanation about that tire spinning. Because it's just an absolute joke, really. Because in reality, what he said is 100% true.
I
I
don't even know what
understand.
you're talking about. The Demok moment we missed.
You talking about when he was talking about using a tire to represent or to basically make a tire spin, which you should be able to do if you are on a rotating body. All right, transferring the energy to that tire, capturing some energy. Is that what you're talking about?
Yeah, if the Earth was spinning, the tire would spin.
The tire of what?
Like if you were able to hang a tire in static in space, like above the ground, like on a helium balloon or something, the tire would start spinning when it touched the ground.
Sounds like a Demok idea. Yeah, but that's the whole idea. I mean, if you had two vectors, I mean, if you had the even just the slightest Earth movement in one direction, the ground movement sideways as the plane is, landing, it doesn't work. Even just the slightest difference, and there's no way for the plane to just be constantly in that same reference frame when it's going over a gradient of tangential velocities. It just doesn't work. It kills the globe so emphatically. I'm not going to get into that argument. I'm not even trying to start that argument because I'm about to shower and go to sleep. So that's just my opinion. I think that I was asking Jesse. There was a video game that had the spinning ball Earth with planes flying on it, and then the stationary Earth with planes flying on it. Would it be the exact same video game? They wouldn't even need to make two video games. It'd be so similar that you wouldn't even need to make it. It would be the same thing, right? The dynamics would just be totally exactly the same. No reason to even worry about it or train the pilots to worry about it or even practice one game compared to another. You'd be just as good at one game as you would be at the other. They're so similar.
Yeah, because if there was tangential conservation of momentum, then Coriolis wouldn't exist.
Yeah, even that the atmosphere with the ground doesn't help it because then the plane wouldn't be able to fly against the spin.
Does anybody know in Microsoft's Spaceflight Simulator? Does it simulate the what do they call that? Like the wind and the what's that called? New perspective when the wind pushes the plane sideways, wind drift. That's the boat.
The tangential velocity?
No, with the wind. Like when the wind pushes the plane ways up from not from the front.
Crosswind.
When the wind takes the plane off course.
Crosswind. No.
Crosswind. There you go. Does spaceflight or does airplane simulator, air flight simulator, Microsoft's game, do they simulate the crosswinds as well?
Well, I'm sure. I don't know how many, but I don't think that they even mentioned that there's an idea that Coriolis effect or force or whatever you want to call it, the Coriolis displacement would be hidden in the winds. But there's a good song about it. So, Hidden in the Winds.
Yeah.
Hidden in the winds. The Coriolis just hidden in the winds. Don't worry about that, Coriolis. It's hidden in the wind.
That's not bad, man.
Right now.
Yeah. Yeah, it's not bad at all.
It's terrible.
But
perspective, was that the game that you were talking to Jesse about? Microsoft's Flight Simulator?
No, it's like based on how you and Zanuck were both saying that that it would be so similar that's the reason they don't need to train the pilots how to deal with Coriolis because it's all hidden in the winds and it's just so you wouldn't notice it, right?
I have
like that, right?
You still haven't. I mean, that's not what we said.
Oh, okay.
But
What
that's
did you
not
say?
how you interpret it. But yeah, it's not that it's hidden in the wings. It's that the effect of the acceleration is going to be lesser than what the effects of the acceleration caused by wind drift. And so the corrections you make for wind drift, you're naturally going to make. I mean, you're just making those corrections because you're off course. you'd assume it's wind or not wind drift. I keep saying crosswinds. You can assume that it's crosswinds doing that, but you're basically just going to get the effect of being off course. So anything that takes you off course is going to give you. They're going to correct for that regardless of what it is, and it's safe to assume that it's crosswinds doing it. It's going to be the largest effect.
Safe to assume what?
It's going to be the largest effect, and especially what you said about the landing, like a plane's landing, and let's say there's no wind at all, it's just flying through the air. It's going to have a pretty safe flight. This pretty easy landing. But now let's say there's any crosswinds, like normal crosswinds during landing.
Right.
They're still going to land. They're still going to land. And the Coriolis is going to be a much less, again, acceleration than at crosswinds. So if they can land while there's, slight crosswinds or whatever, I don't see why the Coriolis is going to create a problem when they land.
What are you talking about? What Coriolis?
Because Kosho, there are sensors and other mechanical devices on the airplane that can tell you whether or not it's a crosswind, but there's nothing to tell you anything about Coriolis. There's no sort of a gadget on the plane that's telling you about Coriolis. Nothing to measure it.
Well, it would be important to know, because you have a gradient of tangential velocities of the movement of the ground below the plane, and the plane's not completely in lockstep with the Earth ever, and it couldn't be because it couldn't fly against the spin if it were. It would be important for the pilot to know how fast the ground is moving so that it could make sure that the plane is moving in lockstep with the ground, which is just a ridiculous concept that it would ever be possible to do that. Because you have to somehow accelerate the plane sideways faster than it's moving forward to land. And if there was any slight difference whatsoever and you had two vectors, the wheel would break off and crash and die pretty much every single time. So it doesn't make any sense. They have a reading of where the plane is in relation to the runway, but if the runway were moving and it were dealing with crosswinds, it would be disaster. And they would definitely need to know those things if the Earth was spinning.
It's just I don't understand how if we're telling you that you can calculate the value of what that offset would be, the acceleration, so you can see, okay, what acceleration would I be predicting if I should go, and you'd find out that acceleration is surely a lot less than any average crosswinds, which they do land during. So if they can land during that same acceleration or greater, then I don't see why it's all of a sudden a problem just because it's a different name.
Okay, well, tell me this.
Acceleration.
Okay, but if the ground were moving sideways, right, and the plane wasn't moving sideways with the ground, right, the way that we would assume it is when it first takes off with that conserved momentum. If it didn't match completely, there'd be a problem, right?
Like in Thailand, there is no crosswind. Like you can let a lantern up in the air in Thailand and it'll just go straight up, as straight as you can imagine. There's no crosswind at all, and they're landing planes there every single day.
Yeah, well, even the crosswind has nothing to. You can try as much as you want to conflate it with the ground moving, but if they had to deal with crosswinds and the ground moving 15 degrees in one direction eastward, and that would be two different problems, right? It'd be two separate problems. One would be just the crosswinds they always deal with, landing on a completely stationary runway. The other would be like the crosswinds and also trying to land on a moving runway, which plane pilots never have to worry about. And there's a chance they would have to worry about it if the Earth were moving. So they would be trained in case that would be something they'd have to encounter. But they're never trained to deal with that because they never have to encounter it. And The only way that could be is if the Earth were stationary.
Yeah, wait, let's say you're a hang glider and you're trying to land from a cliff down to a ship.
Yeah, like
It's actually it takes the same kind of effort to try and make that landing. If while you're going down, you're drifting to the right some amount, and you got to try to still land on the ship, versus you flying in a straight path to the ship and the ship drifting somewhat to the left. That's the exact same scenario or same effort required will be required to make that landing. It's the same thing that you're saying about the plane. Whether the plane's accelerating or has a wind crosswind in one direction, or the Earth actually technically moving at different speed in the other direction, both would be the same effect if they were the same amount. But it turns out that the crosswind is actually a greater amount. So if it can handle that, it can easily handle the former.
So you're saying that if the runway were a drifting ship, it would be just the same as a stationary runway?
Yeah, if the runway was a drifting ship and a straight hang glider versus a stationary ship and a drifting hang glider the other direction, both would require the same effort and it would be the same task to try to land on that ship.
I don't think so. No.
Yeah, because you'd know the difference between a crosswind and Coriolis, because if it's a crosswind, it would be lifting one wing up on one side, and if it was just Coriolis, you'd still stay level.
I don't know why Coriolis is even referred to as a crosswind.
It's not.
Yeah, it's hidden in the wind, right?
It's not being referred to as a crosswind. These are just two.
No, I know.
Different
I know that
examples
it's conflation.
why it would accelerate.
Not at all. The conflation isn't at all appropriate. But yeah, Carlos,
That's not a conflation.
If the Earth were moving sideways, right, and the plane were trying to like roll onto that surface forwards, and there was a moving surface sideways, it'd be totally different situation than just the wind moving the plane in relation to a stationary Earth, which would make it possible for it to actually deal with that. Totally different. You're talking about the Earth moving. I understand that you can conceptually think of it as similar, which you kind of have to if you think you're on a spinning ball and planes land on it. But I understand why.
You'd know the difference between a crosswind and Coriolis, because if it was a crosswind, it'd be lifting one side of the airplane up. If it was a crosswind, that's what it means. It's coming from the sides. So
yeah.
It's going to lift one
You're
wing
right
up.
about that, Carlos.
Right?
Yeah, and it can
You're right
control
about
the plane's movement, and because it has the wind to gauge, the movement of the plane, and then it can land on the stationary surface because it feels the wind or whatever it is. It deals with those winds and stabilizing the plane. But if it were just landing on a randomly moving surface, angle wise as well as speed wise, you'd have to know exactly how fast the Earth is the ground is moving at what angle, and even if you did, there'd be no way to calculate that. Then you're having to move forward, and you're going to have a sideways moving surface, which doesn't work. There's no way to gauge that, like a wind. So it kind of debunks the globe.
Not kind of. It does.
Yeah, emphatically, right? Kind of like, I don't know how anyone could really believe in the globe after that is really presented in the way I just.
Wait. Present it. What did you say? Present. What did we say again?
There's no gauge for them to know how fast the ground, if it was the ground moving, as opposed to the wind, the ground moving in whatever angle, at whatever tangential velocity it is, there's no gauge for the plane to know how it's going to, handle that kind of surface contact as it's moving forward at some miscellaneous angle. There would have to be all kinds of like very, 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 very intense training, as well as guides and all kinds of shit for that to actually be possible or, you know,
Yeah,
safe.
it'd be interesting to know if there's any north-south facing runways on the equator, because that's the fastest part of the spin, isn't it?
Actually, that would be the easiest part to deal with.
Well, if it was facing east or
To
west,
look
you mean? Instead of north or
north
south?
or south.
Or
South
north,
would be
northwest, or it could be any angle. It could be like 60, 70, 10. I mean, like so many different varying angles that would be
yeah, but
impossible.
towards the equator is the easiest part of that problem. And the issue that you're describing, that would be the easiest place to tackle it, because I have a picture I made, but if you consider the rate of change of tangential velocity versus distance, the rate of change in tangential velocity versus distance is greater towards the poles, and it's the smallest near the equator.
Right. Yeah. So if it was spinning, it might be easier, but it wouldn't be easy at all for any pilot to land on a moving surface. If it was actually spinning, I don't know how you can believe it's spinning after you realize it wouldn't work.
I mean,
And that
that's
the
it.
pilot's never
It's
disclosed their
calculable.
range with that. Hmm? I didn't hear what you said.
I said it's calculable. But what do you think is what's the
Really?
speed?
Oh, that'd be cool to
Yeah.
see the calculation for that.
Well, what's the speed that planes typically land at? Maybe like 100 miles per hour, or 80 or something.
Yeah, something like that. And then the Earth would be moving like maybe 400, 500 miles per hour faster than the original conserved momentum that the plane had, or whatever. It could be just a little bit off, and it'd make a big.
That's not how you should be looking at it. That's part of the problem. Is if you look at it that way, it seems like a very difficult thing to overcome. But you got to look at it from moment to moment. It's not going to be comparing the initial tangential velocity to the tangential velocity where they're landing. They've had time to, for that to be taken care of. That's going to show up on the flight.
You've gone from them like consciously correcting, right, to
No.
it's taken care of, as if it's just going to magically happen.
No, it doesn't magically happen. I explained this to you the other night. If you have a flight path, it's just like the jet ski that I described. If you have a flight path, then as you deviate from that flight path, you make sure you get back on that flight path. You get
The
back
flight path
on that
makes it
route.
happen. Taking care of the flight path.
Flight path doesn't make it happen. The flight path
Staying
doesn't
on the
make anything
flight
happen. But you correcting for anything that takes you off of the flight path will take care of anything that gets you off the flight path.
So if you
it's
were
only
so stray from your flight path, you're going to crash a plane when you land. Then, is that what you're saying?
no, not you won't crash a plane when you land. I don't know what was you suggesting.
Well, you're saying it's taken care of by staying on the flight path. Otherwise, there'd be a problem, I imagine, because you wouldn't be in the right tangential velocity, and planes don't fly that way anyway, and the pilots aren't trained to worry about it, so it doesn't make any sense.
Well, you would just end up landing somewhere else.
On a moving surface. On a moving surface.
Yeah, on a moving surface, yeah. But when you talk about the tangential velocity...
Oh, yeah. Moving surface, no big deal.
Yeah, but like I said, when you move through the atmosphere, you're talking about your tangential velocity, and you try, even a ballistic, its route will change. It'll end up somewhere else, but it's not going to, for some reason, let's say it lands like from the North Pole, or say like right near the North Pole. It's not going to be like like missing its. Like, let's say it was going slower than 100,000 miles per hour to get there. It wouldn't be like it wouldn't get there and then start basically moving sideways. Is what you have to imagine. But the entire time it's in the route, it's dealing with the air and the winds, and that's going to act as crosswinds because it's going to have that tangential velocity. Yeah.
You know, crosswinds go in every direction, so you wouldn't be able to know how much the crosswinds help you or don't help you. You would never. I mean, you would have to know if that was helping you. I mean, you would have to know how much it's helping you. So that doesn't
Yeah, but we're
happen.
not talking about regular winds though. We're talking about the winds that would be caused by the
the
fact that you have a
prevailing wind.
different. Yeah, we're talking about the winds that would be caused by the fact that you're actually traveling at a different tangential velocity. So as you travel north and your velocity eastward is faster than the ground beneath you, that's gonna, show up in how the air around you is.
Right. So you should be able to gauge how fast your original conserved momentum is by the winds that you feel, all in one direction. That should be something that we could figure
That's
out. That
if
was
you,
happening all the time.
yeah, that's if you are bombarded by the air all at once. But this is something that's continuously happening the entire route. So it's not like something like easily apparent.
But if you were in the jet stream, that's 200 miles faster, supposedly, right? And then you jump out of the jet stream, wouldn't it be kind of all at once?
I mean, if you're in the jet stream traveling westward?
Whichever way. Saying there's a difference if you're traveling eastward with the 200 miles per hour faster, right? Then you jump out where there's 200 miles per hour faster. The ground is moving. You wouldn't know how fast the ground's moving compared to how fast you're flying, because you'd have to know how fast you accelerated due to the jet stream, and then you'd have to know that land you'd have to be out of sync with the Earth. But they never have to worry about that.
Yeah, but you're talking about something completely different now. If you're traveling east or westward, you're not going to be worried about your tangential velocity changing, right? Like, it's only if you travel north or south is the tangential velocity of the Earth changing. If you're just traveling east or west, and
but if the baller logic that banking east, right, somehow adds to that momentum, right, then just flying east would also add to that momentum, and flying west would take away from it. Yeah.
Yeah, what is the correction they make for a crosswind? That would be banking, wouldn't it?
Well, they bank every way. Correct. Stay on course towards your stationary runway, but going towards a moving runway would be a slightly different situation than pilots ever have to deal with.
yeah, but like I said, you got to really try and account, just so you get a feel for what they're going to be dealing with. Like, account for that amount of acceleration, see what value it is, and see if it's meaningful in any way. Which we could do. But you can't look at it from the start of the trip to the end of the trip. You got to look at it from a moment to moment
I can't imagine being an international pilot flying a commercial airliner with 500 people on it at fucking nighttime, and you're dealing with crosswinds, and you have to deal with Coriolis and the fucking Earth spinning at the same time.
Yeah,
that must be just so anxious, all these people,
especially when you're never
responsible
trained to deal
for
with it,
500
right?
people.
Yeah, you're never trained, and all of a sudden, okay, it's going to be totally different than the simulator. The Earth is actually moving in the situation you're going to be in, so good luck. Make sure that you don't kill anybody. Totally different. It's not stationary in reality. Well, at least we don't think of it that way.
Wind itself debunks Earth spin. There's no way around it. Just wind alone by itself debunks Coriolis and Earth spin.
Why do you say that?
Yeah, otherwise everything would be in lockstep, and it's not.
Depends on what you mean by lockstep, but if the average winds are like 10, 5, 10, 15 miles per hour, and like the most extreme winds are, you know, on the surface at least, are like 75 to 100 miles per hour. Less than that usually. But if that's the range of winds in any direction, usually east, west, north, south, whatever, then those are just relative air speeds, right? Relative air speeds after you put the atmosphere in lockstep with the Earth.
Hey, Kosho, you've seen this little graph that I made? I just put it in the live stream. Have you seen this before? It's like a rough depiction of what a pilot would have to deal with. Like, so the light green line is like if the Earth were stationary and the destination where it is 1,000 miles an hour, and the plane takes off from 200 mile per hour latitude. Right. If it was flying straight to the destination at 1,000 or at where it is on, the stationary Earth, then it would just go straight there, and that would be the green line. But if it was like a 2-hour flight just to get to that red dot where the green line is, well, then you have to think about, okay, well, 2 hours of 1,000 mile per hour rotation of the Earth would put the red dot way over in this other area. And the pilot would end up having to make it to that spot because the destination is actually moving faster than the original conserved momentum or latitude that it took off from. So all the flight paths would be totally different at the Earth.
That's not how relative velocities work, though.
Okay.
Like when you conserve the momentum, like when a plane goes up in the air, it doesn't have to catch up to the Earth before it lands.
But the destination would be spinning faster than
the surface. Yeah.
Surface, yeah. So it would have
the surfaces.
To worry about where that surface is going to be that it lands on when 2 hours from the time that it took off, which would be further away than if it was stationary.
That GIF I made you a year ago, the simulator where the thing's traveling through the wind, and the wind's moving faster and faster, or slower and slower, either way. As he travels there en route, the wind slows him down or speeds him up.
Yeah, that would be great if reality worked that way, but it's just wishful.
Why wouldn't it?
Well, tell me why it would.
Yeah,
I made that based on the same principle. The principle is that the wind.
I can't see how conservation of momentum can be held in any other way except for in a linear, straight one vector.
Yeah, you can't add.
You might want to research. Angular momentum.
No, you have to like.
This is linear momentum conservation, regardless. But to continue to answer the question you asked,
you're saying the winds would just make it automatically in the new tangential speed of the gradient that it flies through?
No, it's not that it automatically does that. It's that by virtue of through a wind that's successively getting faster and faster, or slower and slower, whichever
way is needed,
eastward or westward. No, it's not whichever way is needed. It's whichever direction you're flying. If you travel north, the winds are going to be traveling eastward, slower and slower. So it'll be like receiving a westward direction wind as you're traveling north compared to your plane. And same thing the other way around if you're traveling south.
Yeah, but we know winds don't do that.
We know that?
Well, yeah, winds going every which way. We can't predict exactly how the winds are going to affect the plane.
Especially if you turn around and go back the other way, how are you going to calculate that?
It works perfectly either way, according to Kosho's graphic that he likes to show.
Okay, so if like we said, it's about 18 times the other night, and just
doesn't matter
times tonight. I know, but it's important that when you repeat back what I'm saying, you don't continue to get it wrong. But if the plane is experiencing the winds, right, the crosswinds, and the regular winds, they're not winds caused by the fact that he's got a different tangential velocity. Let's say the crosswinds are 15 miles per hour, just naturally, right, without the fact that it's a different tangential velocity. If that's the normal crosswind, and he's experienced, and he's also experienced a crosswind because of Coriolis. As we've said already, that acceleration is going to be much less than the already apparent crosswinds. So it's not that it's going to show up consistently one way or the other. It's going to add or subtract to that value that's already less than.
Yeah, totally unpredictable. There's be no way to know exactly how the winds are going to affect the plane because the winds go. Yeah, you would never know.
So you just
no
deal
way
with
to
it in real time.
help or not. Yeah, you have to. I mean, if the Earth were moving, disaster.
Say again? You cut out.
The winds aren't going to just help you like consistently and predictably at all with the Earth moving. To keep you in that same tangential velocity. That's just fallacious completely.
It's really it's really an easy thing to understand. That's how I made that GIF too.
It's
shows it
not about understanding
perfectly.
it.
It's like if you put yourself in the paradigm, where it's true that the Earth is rotating, and it's also true that the tangential velocity changes as you go north and eastward. The eastward air and eastward ground, even they're going slower as you go north, slower than your eastward velocity. Then naturally you're going to start bombarding a westward, relative to your plane, a westward wind, just the entire route. And it's going to be much less than the already present wind that would be at that location. So it's not going to show up as the net result may not be a westward wind. It's just be a westward wind subtracted from your whatever your other wind is, or added to whatever your other wind is, which could be end up still being eastward.
Yeah, the winds could affect the plane totally unpredictable ways. Wouldn't help. But you see in my graph there, like you see the red dot in 2 hours time would be at a different spot if the Earth were spinning, right? And the plane would have to totally change completely.
Which one? Where's it starting off at? It starts off to the right.
200 miles per hour, right? 200 miles per hour of conserved momentum.
I'm sorry. Where's the plane starting at?
You don't see my graph?
I see it, but is it the blue? Is starting where the blue dot is?
Yeah, the blue dot, right. And then if it was stationary, the green line would be if it was stationary, it would just fly straight there, right? But because the red dot is on the 1,000 mile per hour equator line, it's going to be moving faster than the plane's moving to begin with, right? So 2 hours from the time that the plane would meet that red dot normally, that red dot would be way over to the side because it would travel 2 hours of time, 1,000 miles an hour. So it'd take the plane a lot longer to get there and be a totally different flight path. And if it was on the other side, I mean, the plane would possibly take the exact same route just that it would for the red dot if it was the other direction. It would just fly south to meet the city that's coming towards it, right?
Why did it say 800 miles?
What's what? Oh,
so is that
total
like start
distance?
to finish?
Well, because it'd be 200 to 1,000. I see. I have.
You mean like
miles?
miles? So 200. You're showing about 800 miles per hour. Is what you're saying, right?
No. I have another one. See on the side there on the left. It's like if it was 100 miles from the center out to that first line, another 100 miles out to the second line, another 100 miles out to the third line, another 100 miles out to the fourth, fifth. But, see what I'm saying? So you're talking about 1,000 miles from it'd be 1,000 miles from the center out to the 1,000-mile equator line in this depiction of it, just to make it simple.
What's the speed? What's the speed where he's starting?
And then the other one's 200 miles per hour.
Oh, so that's not 200 miles. It's 200 miles per hour. That's just because it's
200
not.
miles per hour. It may be confusing because I made it 1,000 miles to the equator, as well as, incrementally going from 100 to 1,000 miles per hour.
It'd be more like
5,000
miles.
Yeah.
Yeah, so it'd be like a 10-hour flight, 12-hour flight.
Yeah, it'd be more like a 12-hour flight. Yeah. Yeah, I should change those numbers and make it a little more realistic for what the globe would expect. And then 12 hours, shit, that red dot, man, it'd be a totally different. You might as well just fly north to catch your red dot then.
Well, so this what I'm saying is, in the way that you're describing it as if it travels, basically in a frame that's not interacting with the Earth at all, and then when it gets close to where it's supposed to be, it all of a sudden is confronted with the fact that the Earth has rotated, but it's traveling the entire time with this rotation. So its speed is also its tangential velocity is adjusting with the Earth. You know what I mean?
Well, it would have to increase its tangential velocity somehow, as well as speed up to the destination that started out traveling faster than it originally started with itself. Is the point.
That's what I'm saying. Is like that's why in my GIF, like you can see it does the same thing too. It takes like basically a curved path, even though it's going directly south, because of the fact that the winds are gonna affect it in the same way that it would if it was going north.
Yeah, I'll have to do a better graph. It would just be a lot longer, and it would be a totally different flight path, because you have to agree that the destination is traveling, in this depiction, 800 miles per hour faster than where the plane took off from, which is something that would happen on a regular basis for flight travel.
Yeah, you're talking eastward though, or westward, but try to like you think that acceleration is extremely large, but it's actually quite small.
Incrementally, if you think about it that way, yeah, but it would still, have to do the math for it, and also just look at the realistic spot of where this would be. The globe we're turning, and the destination would be at a certain point, 10 hours from the time that the plane took off, and then the flight path would totally depict that destination being at a different spot than right in front of it, which you could you could shine like a laser beam to where your destination is from your original starting point. You could aim it right at the destination point. But if the Earth is turning, then it wouldn't be there any longer, and you'd have to totally change your flight path. You wouldn't go in that straight line.
Just doing some rough numbers. It looks like 1/5, so like about 18% of a mile per hour per second would be the acceleration that would be required to make that trip. And that's eastward or westward, depending on which direction. I guess eastward.
Even thinking about it incrementally over time, the flight path would indicate that's what it would need to do. And the pilot would be trained to know exactly what it needs to do. It would know that it's not flying straight to its destination. It's flying to the destination where the destination will be, not where it just plots it from the the way that.
Yeah, but the flight path is already on the Earth. So the flight path is a line that's on the Earth. and if they deviate from the flight path, they're
Yeah, but
correct for that.
it wouldn't have a cruising speed then. It would have to change. It would have to be like accelerating to the degree that we don't normally experience in flights.
Oh, it would have to correct for a wind that was taking it off course about, like I said, a fifth of a mile, or not take it off course. That's
Wind. I'm talking about
it would have to increase its.
I'm not talking about
Go
wind.
ahead.
I'm talking about wind.
I
I'm talking
know,
about
but that's what it would be encountering though. Is that wind? What I'm telling you is assuming there's no wind at all, but there will be, so it'll be plus or minus 10, 15 miles per hour. But assuming there's zero wind, as it travels going south, it's going to have a eastward wind that is going to be increasing the entire time.
Yeah, that would be
So,
something that the pilots would experience.
well, yeah, exactly. It'll experience it as an eastward wind. It'll have to correct for in addition to whatever the actual wind is.
Yeah, because if it was westward wind, then it would throw it all off because you were expecting eastward wind.
No, it would just subtract because it's going to be less than the actual crosswind, like I said. So the eastward wind would be increasing because of that, and then if there's actual westward wind, you just subtract it from that westward wind, and that would be with the actual crosswind experienced by the plane.
That would be something you'd have to train pilots to figure out for sure.
Well, no, they wouldn't be. It wouldn't be like two different things. It would be like one. There would be one net effect.
Well, that you'd like to hope so, but it wouldn't work that way if it was actually moving. I mean, the pilots are trained to treat the Earth as stationary, right? So why would it be even thinkable that it could be moving, and the pilots wouldn't be trained to deal with that? But I got to take a shower. Thanks for working that out, I guess. Good night, everybody. Carlos, good
Isn't
night.
your shower going to use gravity in your perspective?
Cheers, brother. What's that?
Isn't your shower going to use gravity?
Yeah, it's a gravity shower.
I'm just
It's an electrostatic. It's
Could be here for
electrostatic
another
shower.
hour.
I'm going to get electrocuted. All right,
All right,
snack
tangentially out there, man. All right. Peace.
Hey, it's the Snack of the Future show. No pressure.
Taking over.
Tangentially.
What are you guys talking about? I should subconsciously, maybe I should try to guess. Are we talking about flat Earth?
No, something along those lines.
I'm a terrible guesser.
Most conversations about the flat Earth, though, circle around the globe. So, no pun intended.
You're too quick-witted for me right now. I'm gonna need some coffee to equalize this. What are you probably going to sleep anyway soon, right?
Yeah, I sleep when I'm dead.
I don't know. Will you? Will I sleep, Dave? You don't get sleep back. Like, you can't rest up. Isn't that weird? They say you just, like, if you're sleep deprived, you just remain that way pretty much.
Kind of. So sleep is very important, but it's really dreaming that's important.
You know, let's say you're a young lad and you decide, like, hey, I've got tons of energy. I'm going to do an all-nighter or 2 all-nighters. Who knows what, right? You know? But apparently you never get that sleep back. You're just out. Is that just some shit people say? I can't figure this out.
I don't think so. Like I said, I think sleep, dreaming specifically, it has a room and is necessary. it's like I mean, I personally, I think there's evidence for this, but I think it's your body's way of storing your long-term information. And if you don't sleep, then you're not going to retain much.
You got to physically repair. You got to rebuild that shit. You know, the Doozers and Fraggles doing their thing.
It's funny to think that most people spend a third of their life asleep.
Yeah, it's funny you mentioned that. What would your life be if you discounted all the sleep and just all the waking hours? How long would your life actually be?
Shit, that'd be 22.
Or if we just like sleep less, or like old people sleep less, right? Aren't they living like more year out of their year?
I'm not sure that they do sleep less. I mean,
Well, they sleep
like,
less.
oh, but like I said like the dream. In my opinion, dreams are the important component of sleeping. And average dream cycle is about 90 minutes. I think that as long as you're sleeping in increments of 90 minutes, just about, then like a 7.5 hour sleep versus a 6 hour sleep is almost just as valuable.
Well, like 90 minutes, that's very close to like what a movie runs at. So
Movie,
it's a little bit like
exactly.
watching, yeah, like Fast and the Furious is a little bit like taking a nap.
You're exactly right, dude. But I don't want to get into this whole thing because I'll go on forever because I study sleep and dreams for a long time, and for like all my friends, the girls I've dated, I've if I'm awake and they're sleeping, and I used to study like their
You're a dream freak.
Yeah, maybe. But yeah. So if you notice like the REM state, it's basically like the climax. And the same analogy that you gave about the movies, it's like the climactic point of the dream, and then the end is like the slow part, and it's almost the exact same thing as a dream.
Huh. I didn't think it was quite such a literal thing.
I think there is. I think there's probably something to the fact that movies are on average, or they aim for about 90 minutes.
I was talking to somebody that thought that there was, or didn't really explain it very much, but he thought that there was like a temporal reasoning for movies' length having to do with the day length and the hours and stuff.
I don't get that.
Like it's necessary that hour and a half is an hour and a half for a greater reason than it's a coincidence, I guess.
Well, that's what I mean. I mean, I think it might be analogous to a dream.
But it's baked into the physiology or the circadian or however you want to try to use.
I mean,
describe that.
I mean, I personally think that's it's, like I said, like to sleep. If you sleep in increments of 90 minutes, I personally think that, like I said, 4 hours or no, 4.5 hours can be as valuable as 6. It can be as valuable as 7.5 or 9. But if you wake up in the middle of a sleep cycle, that's when you have like a bad. That's when you wake up groggy or upset or whatever. But if you wake up at the end of a sleep cycle, usually you feel well rested.
But doesn't your body go through like different like healing cycles and stuff too, like while you're dreaming? Like, is it possible you wake up because you're like mid cycle or something, like a repair cycle or something like that, and you wake up and you feel groggy?
Well, I mean that's what. So when you're in different sleep cycles, or when you're in different different parts of your dream cycle, your body is behaving differently. And so if you wake up at the end, it's like after the REM state, your body's going to be calm and relaxed. But in the REM state, your motor functions are almost they're I don't know, they're taken over by your dream almost. So your body can be tense, your muscles, your neurons, all that kind of shit. Yeah, because I think your muscles are what are repairing during your sleep, or your neurons, I mean, including the ones in your muscles.
Yeah, does some like neuron stuff go on like while you're sleeping?
Yeah, absolutely.
You can make a connection with something. You're like, you imprint on it. You grow some kind of spontaneous neural connection, and then at night it grows into a more solid connection.
Well, let me tell you what I've come. Go ahead.
Go ahead. No,
let me tell you what. Sorry, go ahead. Are you saying go ahead? Okay. Well, let me tell you what I've come to learn. And even though I could be wrong, this is based off what I've studied and also what I've seen. You know, of actual scientists in the field, and it's about memory and dreams, and that's like so. You know, when you have a thought, for example, it's actually expressed in your brain as a neural pathway, like a collection of neurons. Like any given thought, any memory, it'll be like a collection of neurons, basically. And if you can recall something, it's basically experiencing that same neural pathway again. And so it's like when people say like muscle memory, the muscle memory happens when you repeat that that physical action again and again and again. The neuron is strengthened. That pathway is kind of held together. It's more defined, basically. So the more you think about something, the more you practice something, the stronger that pathway becomes. And so when I say that the purpose of dreams is to store your short-term memory into long-term memory. It's to build like a mnemonic technique, like the same way mnemonics work. If you build like a crazy story behind something you're trying to memorize, like a pathway is going to build that it'll be easier to remember that. So in a dream, it's like building this, like connecting those neurons again and again, so that you retain that information. You know? That's a long answer to what you're saying. But yeah.
Yeah. Where it's like, yeah, it's weird to think about. Sorry, memory and those kind of things. So I sort of feel like, well, like apparently the way that like mammals like have memory is that they just basically have a picture or like a sound, but like a JPEG or a WAV file or something, right?
Mm-hmm.
To associate to something else, to be like, oh, that's what grass looks like, or that's what the slaughterhouse looks like, or whatever, right? They just have a picture of that. And then they associate some kind of meaning to that. I think we do things pretty similar. That's like why people have like a photographic memory. It's like, well, their memory mostly works photographically. Some people have auditory memories where they just can remember whole, groups of that kind of data. So, yeah, it's interesting about like what we create a memory from. It's like you could create it from a tactile experience or something like that, and then your body finds a way to like peg word that up or whatever. What'd you say, mnemonics? So you can use mnemonics to like kind of like anchor it to something else, and then cognition.
I lost my sense of smell a few years ago, but you ever have that experience where you smell something again that you like haven't smelled in a long time or whatever, and it immediately brings you back to a
You
distinct
get
memory?
the remix to cognition, hot and fresh out the kitchen. And when you smell the smell, it triggers the thing. Go ahead.
Well, right, but that's what you said is I think exactly right about the JPEG or the audio file. Is you're right, like that. If you have one sense associated to an experience, it will. That's how it will store itself in your memory. That will strengthen that neural pathway. But if you have an experience with you mold sensory, you know, stimulus that are triggered, then that memory is going to be strengthened. Which is why mnemonic techniques work. It's like, you know, the more things you can attach to a memory, the stronger that memory is going to become. So that's why I think that smell does that, is because like you hear things all the time, and you see things all the time. So it's like you don't really smell the same thing all the time. So if you haven't smelled that thing, you know, since that experience, it'll immediately bring you back to it. It's kind of crazy.
Right on. It's just like on speed dial. Gotcha.
I kind of miss
It's like,
that.
or it's like riding a bike. You don't forget it, but the once you've encoded the memory, it's like on speed dial, and like if you catch that, you'll be able to reference it or get, you know, use your memory anyway.
Yeah, well, like most colors you see all the time, so it's not like, unless there's like a specific color that you only see once, then you see it again at some later point.
Yeah.
It might trigger. It might trigger that same whatever experience you had the only time you seen that color. But
Right.
you know, so smell and sight, or sight and sound, aren't going to have the same
Yeah, that could be a little bit of how that,
uniqueness as a smell.
like that deja vu thing is gonna happen sometimes. Maybe the conditions of light, conditions of time of day, different things in there. You may have had a dream or set of dreams based on this set of things, and and so you feel like, I guess you get that wake up where it feels familiar, and it's not.
Yeah.
It's like, but yeah, on muscle memory and stuff, and like we get some kind of sense information. I feel like I'm a little bit on the banana right now, where it's like the banana typically always going to be yellow if we're talking about that, not a plantain banana.
Okay.
I almost expect that when I look at a plantain banana, it should eventually turn yellow, even though I don't know. It probably just turns brown. But my expectation is that bananas are always yellow, and that they always should be yellow. And if they're not yellow, it means something, that they're brown spots. Those are bad. But it should be yellow, right? And just imprinting on all that. Anytime I see the silhouette of banana, you're already thinking it's yellow if there was no color, because you know in context that it is. So it's an interesting sort of thing too.
There it is. 'Cause, yeah, you're assuming if you see it, it's like the green color or whatever, it's just not ripe yet.
Yeah. So you'd be like, oh, is this banana in green light, or is that just a green banana that's not yet yellow? And you can see yellow through like all different other colors. So you can tell that something is yellow even when it's like hit with blue light, red light, you know. So it's an interesting color in that. But whenever we think we're seeing the thing, we enforce that muscle memory, if you like, whatever. This is like a visual thing, but the rule becomes more and more true that grass should be green. Like every single
Well, yeah,
day.
I mean, your brain makes assumptions based off of, you know, that's why it's easy. That's why magic tricks work and stuff like that, because your brain's gonna fill in the blank with like what it thinks it already knows.
Right. What it thinks it already knows. There we go. All right.
Have you ever heard of that experiment that they tried with these basketball players, and they basically had a group of them practice free throws for like a month or 2 months or whatever, and then they had the other group not practice at all and just meditate during the same time. But during their meditation, they're supposed to be imagining they're doing free throws,
Right.
and
Okay.
they scored them before and after, and actually the ones they they weren't only just as good, like some of them were better even, but they definitely weren't worse. Like they improved at the same rate basically.
Yeah. Well, I think free throws are an interesting thing because you know, a lot of the most incredible basketball players, you watch them in the flow of the game, they can do amazing things. You take them, stop time, put them in front of everybody. Now they got to think about how good of a free throw shooter they are compared to everybody else. All right. Like there's all these mental checks that go on in yourself that affect your performance because they can affect your confidence and things.
That's a good point, man.
So like
you can be in the flow state. You get in the flow state, but you can also, you're not in the flow state when you're doing free throws.
Well, that's what you have to eventually find that because like if somebody's like, hey, you're only a somewhat percentage, free throw shooter, and you're like, you have to get better. Now you're already thinking that, which may not really be true. You might be a great free throw shooter, but your brain's fucked up, right? So we can try to like conquer that with muscle memory, and you could just have somebody shoot 1,000 free throw shots a day, and if they're in their head, they're still going to get nervous. It's still going to fuck up their flow state. So it's all about your resting neural net and being able to respond with what you already do and not respond out of like fear. If you're responding out of fear, you're going to limit your response. Your whatever your choices are limited. If you're just
So
in your so in the dream, you always are visualizing that. So the vision of just free throw shooting, the whole process, like how you're going to get up there, how you're going to laugh it off first, how you're going to like look at some guys, giving them a what's up, and you're not going to like be like inward. You're not going to be like, oh shit, am I going to do this? I hope my team wins. I got to get this point because my contract is good, and I just got to. My knees hurt. Whatever. You don't think about all that stuff. You just go with the dream scenario here, and then you can do it. Yeah.
You know what I'm realizing too is when you're doing that experiment, or if you're the team that's meditating, like when you're shooting those free throws in your head, like I think you're gonna make it every time, right? Like because you're imagining doing it, so you can just make all of them in your head. So it's kind of just funny to think about.
It's the same way with like, I mean, with me and like my experience in playing pool. It's a lot of it's when you're not thinking about it and you're not stressing about it that you can do the thing. But it's like when you're critically stressed about it and you try real hard, it's just almost never gonna fucking work out.
Yeah.
Do you know what I mean? Like you almost have to, if you're gonna make it look like you're trying hard to shoot the shot, that's all you're doing is just trying to make it look like flashy. But it's essentially a simple mechanical action. And you're not thinking about it too much, So I'm better with like quick muscle reaction things that I just only think about for a brief second of time and then try to do it. And if I think about it for too long, I will overthink it, and I'll think that I'm doing something else. It's like I confuse what the process is. It's more instinctual, and so yeah, if you take somebody's instinctuality out of it, they become silly. They're bad at something. You know what I mean?
Well, no, that makes perfect sense to that you say it like that, because like if you take like I said the example of the free throw test, like the people meditating and people practicing, like if you can gain the same muscle memory from just thinking about it, from meditating on it over and over again, or dreaming about it even, and that muscle memory is what's really going to determine whether you make it or not. Then when you actually go to make a free throw, if you can tap into literally just your body's reflex, like just the muscle memory alone, without the actual thought, like those are two totally different neural pathways, and the successful one's going to be the muscle memory, and not the one where you think about doing it and then try to will yourself to
Oh right.
aim
Yeah,
in.
it might be just like actually using the muscle memory as opposed to like still being in the cycle where you're actually imprinting on it every time, but that a lot of that's based on your psychological approach.
It's interesting stuff, man.
Yeah.
I mean,
I hope that anything you do can be improved by just by the process of like not overstressing it and just trying to go with the flow of it, which is like, yeah, you could just dream about it all the time and eventually refine the experience down to where it's like it feels just about as right in your head as it does when you do it.
It is going to get weird.
Oh no! Now it's going to get weird.
Oh yeah.
Right.
Well, I know exactly. I've told people this before, but I don't know if they believe it right away. But it's 100% the truth. I told you I studied people's dreams and sleeping, with their permission, of course. And I have this one friend. She sleeps a lot, and so often I'd be chilling with her. She'd be sleeping, and she talks in her sleep a lot. And so I would like experiment with like trying to talk to her while she's sleeping, and like usually if you disrupt, like if they say something and you kind of jump into what they're saying, but you're it's not congruent with what they're saying, it causes them to kind of wake up out of it. But if you can say something that is in line with what they're already saying, then it'll almost like immerse you into their experience. And so I did this a few times, and I got down to the point where like I was influencing her dream because I'm interacting with her while she's talking. And at one point, I'm even guiding her dream. And that's when I realized that it'd be cool if I could have a bunch of people to test on, like an actual like scientific experiment, because I wanted to develop this thing where you're
You
basically
should
do
have
like
been born in
inception.
like you should have been born in like Victorian England with
Yeah.
You could have done some really unethical, awesome, exciting shit. But I'm not saying it's unethical. You're not like telling them to go like grocery shopping for you, something like that. But yeah, I've had that experience too. Actually, one time I was able to just kind of just interact with somebody while they were already speaking, and from just trying to like reply what I thought that they said, which sounded crazy, and then they kind of took that on, and then almost started to move around, and I was like, wow, is that just like that's the only one experience I've had that, and it was with somebody that may have been playing around a little bit, but it was just like a younger sibling, whatever. So.
No, but that's the thing, though, is it's very difficult to do. That's why it took a lot. It's like she happens to talk in her sleep a lot, and I realize this only works on people who consistently talk in their sleep. But if, like I said, I got a chance to practice it a few times, and when I finally was achieving it regularly, and that's when I realized like if you're congruent with what they're saying, then they don't reject you, they don't wake up, and at that point, like you're free to take their dream wherever you want.
Okay.
But if you're ethical, like I'm an ethical person.
So how is this? How does this then? Because I get where you're going with all of it, but like, what about like shamanic trance? What about like, what's another one that's kind of similar? Hypnosis, right?
Yeah, hypnosis.
Now, hypnosis, right? They've got like tapes, like audio hypnosis tapes. That idea. Well, does that really work? I'm not really sure.
Yes.
But is there something about dreaming that is like hypercognition, that is really hypergnosis? Like if I can like recall from a dream a point at which tactile interaction in the dream is indistinguishable from actual reality to myself, right? Like I actually believe I'm touching the thing.
Yeah. Well, dreams can be really real. Like they feel so real. I mean, have you ever woke up and
like I dreamt I was touching? I was touching somebody's hair, and there's no way you could tell. I could distinguish between that actual moment of reality or real reality, but all of that reality is built off of my memory of that reality of actually, feeling that person's hair. Right? It's just a very fine memory to have. You know what I mean? It's not something you think about very much. It's kind of almost weird, but it's also included in it. So that's it's just odd that a dream can capture such detail because we do record those details.
Right, but that goes back to what I was saying. The purpose is like retaining these, because if you really think about it, what's happening while you're dreaming is it's like a computer. It's like there's a mouse and there's peripherals on a computer, and you could actually remotely control all those things. So it's like if you shut down the peripherals, the stimulus that you can give a computer with the mouse and the keys and all that stuff, and you instead like program, like give it like a hotkey where it's like those things are happening internally, but it's still experiencing the same thing. It's just not experiencing it because of external stimulus. You know what I mean? So it's like the result is almost the same thing. Like it's gonna feel like it's gonna feel like all those things are really happening, or at least emotionally it'll feel that way.
Are you trying to takes place in the brain? It could almost be real. Is that what you're trying to say?
It's not that it can almost be real. It's just that to you, there's no distinction between what you experience in reality versus that experience.
Yeah, there's no difference
while it's happening.
True.
Like a dream is like it's close to being real, but because it's based on the things that we sort of perceive and things that we think of in conscious and unconscious ways, right? It's like you might feel uneasy at the job, you got to put on a face or whatever, you know, but your brain in the back is like, oh fuck, that guy Brad looks like he's fucking aggressive. He's gonna try to take me out of my role here. You know what I mean? Like you think these things anyway, and so you're gonna think about them while you sleep. And maybe so you have nightmares about Brad, and he's like, okay, well, you can borrow my scissors, but not my stapler. And I don't know. Then what is that dream about? Why am I dreaming about that?
But that's what I mean. It's funny why your dreams become what they become. But I don't know if you know any mnemonic techniques, like memorization techniques, like when you try to memorize. Like,
You're saying demonic techniques? No, I don't study that.
Not demonic, but mnemonic techniques, like.
You're just saying you're using spells.
No, like.
So, but two words that spell alike or to sound. Okay, forget it. No, okay, mnemonic techniques. Get you.
Yeah, if people want to memorize like a deck of cards, for example, if they want to memorize pi, all the digits of pi, like ways that there's like simple mnemonic techniques that people use to do that. Like they associate each number with it could be like each number is associated with like a 6 would be a G, for example, and so they just combine
like 1 is fun, 2
three
is
numbers.
Yeah, I don't know.
Well, yeah, they know that exactly. Well, yeah, they know that. Yeah, that's another trick. Like you have a list of 10 things, and you can try to memorize them by associating each thing with, like you just said, like 1 with gun, 2 with shoe, 3 with a tree, and you just make a picture in your head or tell a story in your head that will associate whatever words on that list with a gun, and then the other word with a shoe, and you make an elaborate story, and then what ends up happening is it's simple to memorize whatever those 10 words were. I think the dreams are doing the same thing basically. They make this elaborate story, you know, with the events that you know that entered into your processing brain during that day, and that basically works to store those as long-term memories.
Quantum memory. Is all memory flat?
Interesting question.
Well, like mind maps are flat usually, but I guess they could be 3-dimensional slices. But then each one would be flat. It's a little tough to navigate like 3-dimensional space, like to like have a bunch of like lists or something like that. I mean, imagine if you just had like a bunch of data items in a box in a 3D space, and you're trying to navigate that data and access it. If you have to zoom around to like move, it's just like more confusing to add that extra access. Anyway.
It's funny you say that because that's actually another mnemonic technique. I do that when I try to remember like a grocery list. I'm not going to tell you all my mnemonic techniques, but
yeah, or you could think about something in terms of like an architectural layout, and then
exactly.
Put your eyes and envision yourself there and walking down the hallway from one topic to another.
So you know mnemonic techniques then. Yeah. That is exactly it.
Yeah, I don't know. Like I don't try to apply them, but sometimes they're helpful. Like really, actually, I don't. Like I really could, use them all for like music and all kinds of shit, and I never do.
Music is useful. I do. I used to do like
I guess it's like I've
magic.
confused like aspects of like really musicianship with other things, and that is like basically that you want to learn as much as you can, you want to know as much as you can, and then you would like to forget all of that shit so you can just do what you do. Right? Like not be like stuck in some other thing, you know. But you want to know like how Gregorian chants work, but you don't necessarily want to be playing like them all the time.
Yeah, as a drummer, that's why it was important. Like I basically played like every style. I got into playing every style. I mean, it's because I didn't want to.
Right.
You don't want to be stuck on one style, so I would continue to like adjust to like new styles, and then that way you end up, you know, with your own style at the end of it, you know. Hopefully.
Yeah, that's the idea, man. For sure. Just
Yeah, but
always got to be about doing that stuff. It's like all the time. It's all the time you do that for like 10 years and you can make a career out of it, I think. I just never had that because I move around for too many different things. But let's move to another topic. What's going on?
Well, before I want to put a bookend on this dream inception thing I'm talking about, because ultimately the goal that I'm actually still trying to accomplish is I wanted to make like an AI, like an app even. So, you know, it would only work on people who talk in their sleep, but it would like listen to them, and if it caught them talking in their sleep, it would try to communicate with them based on what they're saying, and then it would ultimately, if it was successful in gaining, you know, participating with that person's sleep or dreaming or whatever, it would guide them to whatever they wanted, whatever they, you know, programmed it to guide them to. Like if you're a basketball player, for example, and you could do this successfully in your dreams, it would always guide you to like practicing your free throws in your dream, basically.
You and
Or
frickin'
also,
AI, Kosho. What is it with you and AI, bro?
Well, I mean, if you incorporated that technique with the MIT lab dream project, like you could just use some sort of electrode setup, determine when somebody's about to hit the like pre-sleep, you know, or like that moment when you're still awake, but you're just on the edge, you know, right about to fall asleep. And you'd be like, okay, it's time to go to practice. You know what I mean? And you hear a bunch of sneakers running downstairs, or you know what I mean? Something auditory cue. You know what I mean?
that's one. That's yeah. One way to do it, and that's why the guided meditation things, like some of them say that listen to it while you're falling asleep, is because that's the same state as the state they put you in when they put you under hypnosis, the induction state. But I think that only has like I'm just comparing the success rate of that versus like so it's like you indeed can influence somebody's dream by suggesting something. It's not guaranteed. It's like, you know, it'll kind of basically if it is successful, it'll barely influence it versus talking directly to somebody. Like you're actually having dialogue with them, and they have no choice but to, you know, follow whatever you take.
Could you get a robot to like whisper in your ear, "It's flat, it's not round," or "It's round, it's not flat"? I mean, could you get one of them robots?
Good, I guess.
You know, yeah. I suppose there's okay. So first of all, there's like some similarity here between what you're talking about and a guided shamanic meditation. You know, with like a shaman beating a drum to get your brain into tonic, to where you're in relaxation, like sleepy land. You know,
Yeah.
and burn some sage, whatever. Maybe smoke a little reefer. Maybe something more exotic. Who knows? But anyway, once the drum stops, then then that's like when the suggestion stuff gets loaded in. You know, it's like blanked out your mind basically. And now we can start to space a little bit. Mm-hmm.
Nope.
Okay. Like drum beats will and tempos will in themselves like create like waves in your brain, auditory waves, concussive waves. Like you tactile can feel the hits of the music, and so you start to get in that state, and that's like this doorway to a certain type of thought pattern, you know, or the brainwave. We could like get to like an alpha wave or to these different brainwaves.
There's alpha, beta, gamma. I think it's alpha, beta, gamma.
Yeah,
like a delta.
Well, delta and theta. I don't know if there's gamma.
Oh, theta, yeah. Well, there's
And
gamma
REM
males.
state. Well, there's a gamma in the letter, but I'm saying the brain states, there's alpha, beta, delta, theta, and then REM.
So when like in waking life, we're supposed to be in like a beta state, I guess, and then we sometimes alpha out.
Yeah.
But I guess that doesn't.
Yeah,
I guess that's a possibility of just like staring into a bowl of Cheerios and going delta on that shit and just really process. Because that's like what it is. Like it's almost like there's this aperture for the strength of experiences. We can express them through these different wavelengths, the alpha, beta, whatever. Fine.
There's actually
there's a weight of experience.
maybe
Alpha, the memories, right? We're talking about building pictorial memories. You know, because if you see something and you really imprint on it, you're in like this gamma state. You know what I mean? Have a 15-minute staring contest with a bowl of cereal. I'll imprint on that for sure.
Put some coffee in my cereal.
Do that before.
Because then, like,
so bad.
Well, it must be. So you're supposed to like be doing something every time you blink. You're chunking down the whatever picture series that you just saw gets squooshed down, and it gets like in some way, like there's a marker that gets like a bookmark that gets put in our process. You know, so between every blink, that might get filled in with a dream piece. You know, as we like don't have the complete record. The junctions that we blink at, because otherwise does that make sense, Kosho? If you're talking about building a memory, like I might have a memory of just snapshots. Maybe it's entirely of like a GIF or whatever, or I can remember exactly what it looked like when somebody slipped on a banana peel.
Yeah. It's very possible. Honestly, I think that memories are often strengthened by intensity. So it's like if it's like trauma based thing, I think it's like multiple senses at the same time. Like I said before, if it's a real meaningful experience, then yeah, it's like your brain will capture it in a way that's going to imprint on you.
Like that Big Bang Theory show, right? It's broadcast. It's like teleplay. It's satirical. It's poppy. But with that audience laugh track, it's almost like you feel like you're a baby, like you're a little kid in a room where there's like a party and lots of adults that you don't know about because you don't even know who you are. You're just a baby shitting in your own diapers. Like it puts you in that's like this one state of being, or weird. I'm gonna make another pot of coffee.
That's funny though.
But doesn't it feel like well, they say like that sitcom television puts you in a certain type of brainwave state because of these things, you know?
Yeah.
And then
Absolutely.
what are we gonna get some chips and snatch on them, you know? So like, whatever.
There's another reason for that, and hypnosis. No, because I studied hypnosis for a long time. I still do actually, but
But you do agree that like the dreams are a type of gnosis.
Well, it's the same. It's the same. I guess what is it, theta? The one that you go into right before you fall asleep, or as you're falling asleep. That same brain state is the brain state that, like, it just inducing you, or get you into it to induce you into that suggestive state. And it's also the same thing because almost all marketing is based off of the psychological principles that they learned from the early hypnotists in the early last century, or late 18th century, or 19th century. And so all the same principles are applied in TV and commercials and stuff. And actually, when you're watching TV or a movie, you're put in the same state because you're isolating your senses. Like you're basically turning off all your other senses except for your sight and your sound, and then they're completely focused on this one thing, and it puts you in that theta state. And so they suggest whatever they want to you in the form of commercials or product placement.
Mm-hmm. Or like when to cut to commercial is just when it's interesting.
Oh yeah, sure.
And so sandwiched in the middle of this narrative is an ad for T-Mobile or Pepsi or Butterfingers.
That's why I hate. I like that. I don't watch cable anymore, but I used to watch that channel, AMC or TMC, whatever the movie. So they put a lot of good movies on there. And
There's a Turner Movie Classics and an American Movie Classics. I believe they're under the same Turner Broadcasting ownership. And yeah, they as an interesting part, they also kind of began to grow rapidly. Like at the time, post 9/11, when there was a bunch of money injected into the television industry to produce film and media because it had suffered a nasty.
That's the same network that Breaking Bad came on.
I would
AMC
say
or
that
whatever.
I would say that to some degree, 9/11 financed Breaking Bad to happen, and Better Call Saul, and that whole universe of shit, and whatever all those other like biker gang shows and American Anarchist and whatever, you know what I mean? That's like the zone for that channel. That was the meat and potato until what? Walking Dead, which is like another anarchist like free for all. Yeah, go ahead.
Yeah, same channel though. Well, our Anarchist I think was FX. Walking Dead I think was also AMC, whatever that network is. But yeah, the point is, what's so annoying is the movies when they put it on that network. They put great movies on, and they play like the director's cut oftentimes, and also like the first 30 to 40 minutes of the movie, there's like no ads, and so it's like you're really watching the movie like not on cable, but then after that 40-minute point, like the commercials get progressively more frequent up to like the end of the movie, the climax, where there's like a commercial like every 5 minutes, a set of commercials, because like they suck you into the movie and you're like sitting there fucking every 5 minutes there's a commercial break.
Wow,
Waiting
it's
for
a
it again.
heck of a paywall, but yeah,
Yeah.
Soft paywall. And that's affecting entirely, I believe, how like film and television is being written now, because it's being written for ad space and ADD.
Yeah, with shitty movies. Yeah.
Mm-hmm.
I don't watch ads at all.
AI, it's like I thought AI could really like help out a lot. Maybe in a way it can, but like it's not like ever going to take over like the primary authorship of any kind of show or anything like that.
So
it's too bizarre.
Bet my money on that, but I know that people.
You can use it
like
as
Scott
an
Beach, my buddy.
But to tell it to content generate, just be like, write me an entire 14 episode series about a sci-fi time police, right?
There's a reason why advertisement is so expensive, because it works, bruh.
Yeah. Also include like like internal peaks into the show that get me every like 30 seconds, so I can drop a Coca-Cola, Butterfinger, or Liberty Insurance commercial.
Well, like those AI models, like they're progressively getting more and more useful and intense. Like it's just now possible for anybody to very easily gain their own locally
Here's what's
trained
interesting,
model.
and although I will always give it, this is like Steam Train versus John Henry, but John Henry eventually understands like how to make train tracks and switches and all kinds of other things, because John Henry doesn't have to fucking worry about hitting the fucking hammer on the spike. It's like all the other shit just gets laid out. It's nice. It allows us to deconstruct whatever the fuck we're doing when we can automate it. We're just like, we can always stand back and be like, oh shit, yeah. But
Right.
what about this? You know, frees us up a little bit. So I appreciate that. You know, that could be helpful for. But it's you would be spending years of development trying to get it to where it can just shit a show. But ultimately, that's possible.
Well, I mean, it's like video games.
Or it's like the new writing pool. Well, or just let me last thing. It's like, well, wasn't a video game or TV property, right? You're gonna have like a writing pool usually, like different people that contribute. But if each one of those people each had access and good skills with ChatGPT, that'd be a pretty interesting return. You know what I mean? It came to like, oh, here's what 10 people came back with ChatGPT. It's gonna be more than they would have had on their own. But is it necessarily better quality? I don't know.
Well, right now people are using it, like artists are using it to help them influence their works. But when you say about like freeing up your monotonous work, that sort of thing, like for video games, that's become like, if you look how Mario Brothers was made when it was first made compared to how you can make Mario Brothers today, you can make the same game without doing all the tedious work that was required before. And so, yeah, that definitely frees you up to be more creative. Even.
Oh yeah, like trying to just remake Super Mario Brothers in Unity is probably a treat.
Yeah, right. Yeah, and so it's like, using the same skills as somebody who made the original Mario Brothers, that same person with the tools today, they have been freed up to do whatever they want. With the time
Or
and
even
energy.
like Game Maker or something. Yeah, like it's way easier.
There's that. Yeah.
Someone else has already like extended certain principles, created a tool set, and now you can just like dive into that treasure chest. Whereas like, in the before, you got to like fashion all these like kind of bits of code to handle processes if you want them to happen, and so it would change dynamically change the construct, the hardware, the programming language, but you're still doing the same things. Yeah, you're gonna have a more efficient system.
There's a bunch of artists. There's a bunch of artists now who are making a movement against this AI thing. Honestly,
Okay.
because
they're afraid.
Yeah.
But I think we've
not
sort of like,
afraid.
I think digital art has like hit this wall before, with like effects and stuff, right? Or it used to be like listen to the Beach Boys, right? Pet sounds, like they were experimenting with as much as they could have, to create this like weird acoustic thing. Now people can do all those things essentially just with like all the software bits, So it's like, does it take it away? That we don't have to have the actual, chorus hardware, the box of it. Can we? Do I need the amplifiers? Can I just create a filter that makes it sound like that? So, like you put like compare A to B, the real thing versus like what we can do digitally. It's always going to be better to really have the real stuff, obviously.
It's going to be better. You're right, to some degree, but to the like I said, like the more effective or the more the thing that's going to win out is going to be the easier, maybe less quality thing. So I'll give you an example in this AI.
One's dynamically flexible, and I can have it like everything I could think about might be an infinite inventory that I could fit digitally, like on one disk. Whereas, like, I need a warehouse to hold all the fucking bullshit.
Yeah, right. Too much work for the slight increase in in quality.
I mean, same thing's true for like if you're trying to do digital productions. Was it better to have like the 3D models that fit on a disc, or better have a warehouse full of floats and fucking, crazy sculptures and shit, that you put in a movie, whatever. Yeah,
Or
obviously, the digital warehouse is fucking much easier to manage.
you know how an actual filmmaker like Christopher Nolan or Quentin Tarantino, I like their movies because it's like their real vision. They put a lot of work into putting their vision onto the screen. But then you have people who already they don't use AI, but they are basically they got a pool of people writing like a shit movie or a shit TV show that are literally just trying to just put something out there that just ticks the boxes and
yeah. Well, I think it's like a little bit because
it's not hard to do.
Well, somewhat of it I think would improve a lot if AI had a more like human like memory chain. So if it were to build a memory up over kernels of iteration, let's say approximate to a sleep cycle, which is kind of what it does, right? Because it's like modeling over iterations to like get to synthesis, which is sort of what we do too. I mean, a lot of it's sort of built off of our sort of cognitive framework,
Yeah.
but I don't think it has the necessary programming root structure to like anchor a data item like a picture of a flower, and then it can have a tree of associative meanings, as it might be able to search such thing, understand human reference. It's like the Fifth Element almost, like but it's trying to like understand like what our relationships might be from like what it can search.
Yeah,
but that's not the same. It's just getting a quanta of what it means for us, but it doesn't itself understand the thing. So in order for itself to understand the thing, it needs to have its own relationship table. So it needs its own cognitive map. You know what I mean? Which maybe we'll get to. You just have an add-on pack where it's like, oh yeah, or we could like make them think that they're people. Have an add-on pack where, oh yeah, this is AI plus like human frailty. Oh no, it is a lot like a person. Or do you know what I'm saying?
Yeah, I do. John Searle. I don't know much about John Searle except for he's made this argument. I guess he's a philosopher. I don't know what he is, but he made this argument, this thought experiment called like the Chinese room experiment, or Chinese room thought experiment, and he basically describes a person who's in a room with no windows or doors, but people communicate to him. They send in a slip of paper written in Chinese, and he's got a book that basically has it takes whatever input he has, and it has a response for it. So all he has to do is copy, look at what he's been sent, look at what it says, the responses for that in the book, and then write it out and copy it. And so the person outside the room, to them, they're actually no distinction between communicating with somebody who's communicating back with him. But from his perspective, he could be doing this for a million years, and from his perspective, he can't understand anything he's saying. And John Searle was using this as an analogy for AI on our logic-based computers, which is like they are going to have the ability to communicate using syntax, but the semantics they're never going to be able to interpret it in the same way we can. But you can say that they can think and feel, but they really wouldn't are never going to have meaning to what they're.
I mean, I guess it approaches like
computing.
This side of it is really like for like a general intelligence, which may work with like a chat GPT general chatter, So like if you could just build like a more targeted machine underneath ChatGPT to sort of utilize it, it would really improve what the outputs are. And yeah, so just like having a general intelligence underneath it would be really cool.
Yeah, and see, one thing that they kind of do with OpenAI, it's like they have it trained on the internet up until 2021, sometime in the middle of the year 2021, and the thing is, if it were if it were as it was being used, actively training itself, sort of based on even its experiences, which I think GTP4, I think might have the ability to actually retain its the whole collection of memory. I'm not sure if that's GPT-4 or a different model, but either way, yeah, when it's able to do that, it, it's kind of it's kind of simulating that sort of memory retention thing, where it's not only already trained on all this data, but it's actively training as it's running.
I'll never talk to that bitch. That bitch is biased.
Are you afraid of the AI?
No, I'm not afraid of it. I just think it's biased.
What do you
Tell
mean?
me.
You're saying bass?
No, wait to hear this. You must have heard this, Gojo. Give me a poem about Donald Trump. No, I'm sorry, I can't because that's political. I'm not allowed to. Give me a poem about Joe Biden. Oh, Joe Biden,
Listen, dude.
he's a fantastic guy.
Listen, you're talking about ChatGPT, which is utilizes GPT-4, but it actually is. So they made that framework so it was user friendly, and
It's a
they
political
also made it
fucking.
so they made it so you can't. There's like a lot of restrictions, right? But you don't have to use the models that way. So you don't have to use ChatGPT. You could use GPT-4 directly, right? And there's almost no restrictions. You can even get your own version at home, like a local model of GPT-4, and there's absolutely no restrictions. And so, you can get it to do anything that you ask
Bullshit.
it to do.
Bullshit.
I mean,
No
I'll show you right now.
Absolutely no restrictions. Bullshit, bro.
Yes, there's no. If you have a local version of it, there's no restrictions.
Who you talking to, Ma? Who you talking to? Who you talking to? It's gonna sit.
You.
It's gonna sit in your laptop and fucking whisper things in your ear while you're sleeping. Joe Biden's brilliant. Joe Biden's great. I can tell you.
Does it actually is it programmed to
Totally.
reference Joe? Is it programmed to?
It can't tell you. It can't give you a poem about Donald Trump or any Republican.
Let's see what he's asking about.
I mean, we have to think at a lot of mental acuity like processes. The AI would be Joe Biden.
Like I said, they
That's
have
most
it tuned.
presidents. Most presidents, though. So it goes to show it doesn't really matter.
Yeah, it doesn't now. Obama, Bush.
Wouldn't need
all
that.
the
I would go with like Obama versus AI. I'd like to see that. George
I'd
W.
rather see
I'm sure
AI
he gets-
robot
I'm sure he gets-
as POTUS rather than fucking a human being. It might actually have more fucking compassion. It might actually give a shit.
When you're using GPT directly, like outside of ChatGPT, you can have it behave as anything you want.
You could have it lie as much as possible. Be like, hey, be disingenuous and two-faced. And
Do you know if you get a chip,
Oh,
and
you're
you
exactly
put it,
right, though. Yeah.
you can actually let the AI think for you.
If you were down for that, but most people enjoy that doing it themselves. But regardless,
I mean, that itself is maybe like a good way to use it for writing. You know what I mean?
Yeah.
Like if you wanted to have a character that's always conflicting what their statements are, but like says it with confidence, you might be able to like just look at some. It would uncover some things that you could try, or maybe.
So if you have,
I've done that. I've made it. I've had it write several things, using like a bunch of different things. And then I was talking to Scott Beach about it because he's a writer and he's also a coder. And I was asking him, if he's using it yet to write shit for him, and because the quality is not good, he said no. But he also said that what he does do though is he will he'll get it to be a certain character or certain thing, and then have it to have a dialogue with it, because it's dialogue. It'll be a natural dialogue in whatever character you tell it to be. Yeah, so it'll do it that way. You can use that dialogue in your writing. It says it does.
So let's just have AI write all our books and paint all our paintings. How about that?
Right. Said that
So
that might be on the way.
So is that
On the way?
already happening though? Like in a way, because it's like if you were, let's say I was a teenager at a certain point and I wanted to be like, I'm an artist, I'm a digital artist. Like I might go to like the Deviant Art site, right? To be like, that's where digital artists go. Right? I mean, where else does like look for like some inspiration or like a community to be?
Right.
But then all that stuff like looks like that style of people that post on that stuff over time. It's like
Exactly.
developed its own curated sort of look. And from there you can basically extract all of those sets and then just speak deviant art to the visual system of the computer, and it can shit out deviant art stuff. You just fit right in. What's the difference? Because otherwise, what am I looking for? I'm an artist. I want to just make my stuff look distinct from other people's, or I want to make it like blend in. Maybe my skills aren't that good, or whatever. But I'm gonna try and fit within the stuff anyway. I'm gonna mine the good stuff. I think basically do what the AI is doing, and you could just do
Right.
that descriptively. Because if it's actually inherently simpler when you're a copycat artist, that you can just describe it in a very few amount of terms, and you get what you want out of it. And the more specific you need to get is the more. I think that's the closer you are to art. When the AI can't replicate it, then you've got some shit. But yeah.
But that I was making though before, when I was saying like the movie styles of a real movie maker, I guess a singular movie maker like Quentin Tarantino,
What?
Christopher Nolan, like who they really almost get their whole, it's like their vision onto the screen, because they write it, they direct it, and it's like it's like their vision on the screen, versus people who put out these cookie cutter, especially like horror movies, like really cheaply written and produced movies that people eat up. But it's basically built off of either like things that work, that they things that like people in that industry know that work, or they are all influenced by the same thing. So it really is the same thing as what the AI can produce, or it's going to be very easily capable of producing. I think that's going to be the difference in the styles. Like it's going to definitely be able to produce the type of works that people already spend money on today. It's just probably not going to be able to create like the actual
the script
best
is the
movies.
script. The script just has to make sense under it, right? But then the cinematographer comes in and he decides like what kind of lenses are going to go on there, and then director of photography has got the lighting guy and gets the mood going. So all that can go against what the script says. It can be just those choices, and then the editor comes around and he's like, "Oh, I'm going to clip this out. I'm going to change. I'm going to whack the lighting crazy now." And so multiple other layers of human hands get to integrate in this process before it ever, from AI. It's not like, farm to kitchen shit just yet. You know what I mean? Like the AI can't shoot the movie or be the actors or, determine what choices they all make.
Oh, they can't. Well, if you allow them to make the script up, why not just let them act it too?
Yeah, exactly. That's exactly, that's a good point, and that's exactly. It's not, like I said, this stuff is not far away, dude. Because
I'm
you
just saying,
can.
like, overall, the craft of filmmaking, like, a lot of times, some scenes just don't fucking matter, really. They just be whatever.
Sure, yeah. But for movies that are cheaply made movies, like a really good movie maker will compact everything, every dialogue, every scene has meaning and
I don't know,
purpose.
man. I feel like there needs to be parts where they're undefined and where there's sleepy parts, otherwise, because you need to breathe. Otherwise, it's just like this adrenaline, like, rush. You're just, like, white knuckling it through the entire film or some shit, And not everybody enjoys that kind of roller coaster. So,
But what I'm saying is a good movie maker will hide context in those or subtext in those scenes, like in everything that's said or done is like it adds to the
I understand.
Adds to the whole story. You know what I mean?
Yeah.
So that's only like I said, only like a really skilled movie maker can accomplish that seamlessly. Whereas some people attempt that, it's like easily visible.
Right.
Some people don't
But
even
I'm
try
saying,
that.
right, and that's just like letting the movie kind of breathe a little bit. But an AI doesn't have that kind of ability to like sort of crank the bellows with it or pace it. You know what I mean? Like AI might be able to suggest all the text, but I don't think it's capable of creating like pacing structures, and that's a lot of what really drives the overall like computation of how long it takes to accomplish plot line and get to like different major points. You know, if it takes forever to get from beginning to the start of it, then fuck it. Yeah. No matter how detailed and artful we do it, it's too much info. So too much info is a problem, right? You need somebody to just cut it down to what is like the slivers of it that really matter.
You have to remember that like the current AI models are the ones that were made by, like I said, in the past 2 weeks, it's now become possible for people to have their own like trained models, standalone at their own personal computer very easily. And so the more that people do that, you can train, one of the models to just to have all the information it already has, but you can have it focus on, let's say, like in the actor studio, or some sort of dialogue between the commentaries on screenplays or something like that. Like experts talking about the craft, basically. Like really train it on this stuff, and then get it to, like you can get real creative with the prompts.
You're capable of doing that now? That's like in the box.
You're not allowed to talk about trains.
I can create like Cyber James Lipton and then add him to Clint Eastwood and Tarantino. And
do you feel lucky, punk?
Hyper hodgepodge AI that's just going to punch out outlines, plot lines, have the depth of all. Or I could just make an omni super director, super writer. Just it's a little bit like did you ever watch the old G.I. Joes? Anybody ever watch the old G.I. Joes?
Yeah. Cartoon.
Like this is like Serpentor. They like created him from an amalgam of different DNAs from the world's greatest dictators and despots. He created the most evil guy. He was a little too evil for Cobra, actually. But anyway,
You're saying like that you can make the AI like a collection of like the best directors or screenwriters.
Right.
Actually, like that's something I attempted.
J.J. Abrams and all them guys.
Well, I was trying to get. I try to get the open AI like before it's fine tuned or trained to like rewrite parts of the Bible in the writing style of Quentin Tarantino.
It's like
it would do it.
I could understand like a Jesus is Tarantino movie, but if there's not like there should be like cars in the movie.
Sure,
like,
yeah.
Like 1970s vehicles.
So it's a Quentin Tarantino movie. Well, that's the thing though, is I've done it.
But you know, right though, because if he did like Jesus from the 70s movie, and you're like, oh shit, he just like created Jesus in the 70s. If like that happened, well, why couldn't that happen? You got Jules with his fake Bible quote. That's a fake Bible quote, right? So why not just
it is a fake Bible quote. Yeah.
Not fake more of it. Yeah, people like that shit.
Yeah. Well, I mean, it's loosely based off a Bible quote.
Yeah, like I memorized parts of that passage, and it doesn't have anything. It's not a Bible quote. Well, or it's like an assemblage of different Bible quotes or something. What does that mean? Jules has a different Bible, or he's bad at Bible quotes? I'm not sure. What's in the fucking trunk? What's in the briefcase?
supposed to be a, what do you call that? A what's that called?
You know what I
forget
think it
what
is? I think it's
What
based
is-
on the memory of getting the dope ass Panavision lenses from to do like a good movie, and they would crack the case open.
I just figured out what's in the case.
Oh, MacGuffin. That's what it's called, MacGuffin.
I think it's just a reference to his filmmaking. It's
The fucking
what make it's the lenses. The lenses like that he uses are particular. They're made to do a particular type of picture. You know,
it's an AI
Super
chatbot.
Supposed to invoke a certain emotion. You're saying?
He's just like super Panavision lenses because they were used on like the movies that he's trying to reference. It gives it that retro vintage kind of feel on a certain type of camera with film stock.
Didn't he say he lived with his grandparents and like he grew up like watching like these classic movies?
Yeah, Sergio Leone.
Tarantino?
Yeah, that's what he says. I think.
Yeah, he probably fucking killed little animals too when he was a kid.
I don't know about that, but
yeah, there's something AI wouldn't think.
I like his movies, man.
Coach, you should watch the movie Once Upon a Time in the West. If you haven't seen it, you'll see a lot of this like proto Kill Bill sort of ideations. I guess he might have had from there based on that.
Also,
Yeah, it seems like he's just it's like a love story that he has like for him in the movies, basically.
Well,
It's like
it's
his,
like Bill is a stock character out of the Sergio Leone universe, you know, and just like Hateful Eight is really out of that universe too. It's almost like he's doing extraction of that style, you know.
Oh yeah, okay, yeah.
Like specifically that. It's like a study in how to just synthesize that genre, like after it's over, right? I don't think anybody really particularly does that. Like nobody's doing like movies from the 60s about like beach parties or something like that, you know.
Yeah,
trying to like
it's good
Faithfully or some shit. I don't know.
Did you see Del Toro's Pinocchio?
I heard it was all right, but I haven't seen it.
That was absolute shit, bro. It's like an AI wrote it.
But yeah, Kosho, we should collaborate or something like that offline for a minute on this subject. I feel like we're eating up the AI airwaves.
Yeah, probably. Yeah, usually you think people would get into this AI talk, but not many people are into it.
Most people hate it though.
Yeah.
Most people hate it and they don't want none of it. And not in my backyard. But it's going into all the decisions that get made on the stock market, how things get routed, what shit gets stocked on a shelf. It's making all these types of decisions. You know?
It's like Bugs Bunny would say, I got this from him at least. If you can't beat him, join him. That's the way that's the way I think. That's why I studied computer science. I could see the direction the world was going.
Oh, now it all makes sense.
From a young man, when I was a boy,
When I was a computer chip,
when I was just a silicon dream in my father's eye.
That's the thing. You pretty good at impressions, man. You did Merle. Merle.
Oh yeah, I'm doing like a half-ass Morgan Freeman. Yeah, I was full Merle. That was like 100% that's about as good as I can give for Merle.
Jen, I think the other night was pretty good too.
I can gin it up a little, but it sort of also like has a effect where I think it hurts me physically.
I can imagine.
Like I can do it, but it draws some kind of power, some kind of chi power is lost in the process, and so I try not to do impressions of gin. You know, just can't handle it. The repercussions too much. Jin just destroyed you guys. He would have wiped you out of the room. I've never seen anything. It's
so funny though because we were
It
talking
reminds me of me.
about his Gintopia.
Go ahead.
Yeah. He's got this utopia ideas. They're so funny, dude. He was going on in the gem server about it for hours and hours a day. We went into detail about all the details about it, and it's incredible, actually.
Well, he's got a lot of time to think about it, you know, waiting for the socks to get laundered. You know what I mean? He's probably just invested his time thinking about Gintopia all this time. I'm sure there's inequities in the laundry. Let's start this.
He's doing laundry a lot, but I have respect for people who've got a lot of passion. Passionate people.
That's the word I was looking for.
He has more passion about laundry than you do for most things.
Probably right.
More passion for laundry than his wife.
Saying Jen has more passion in her laundry than I do for most things.
Well, let's say and even Jin's his emphatic love for instant miso soup is greater than any soup that you actually consume.
I like Jen.
Of all of the soups that you consume, your enthusiasm is not greater for any of those than his enthusiasm for instant miso soup. I'll bet you.
Miso. Yeah, I like
You're
Jen.
probably right, but I hope that's not true. I love a good matzo ball soup.
Okay. I'm just saying, could you defend it with such vigor as him? I don't know. You'd have to get really up in your
Not at
feelings
all.
about matzo. Okay. All right. That's your claim.
And
That's
more
on-
with in the week.
Ask the AI. See what they say.
It won't tell you. If AI can't tell you what soup tastes like, ask him what soup tastes like. You're gonna be like, it's gonna have to read Julia Childs first.
It might blow up.
So AI is really only good at as good as Goodwill Hunting kind of information. You know what I mean? It can just read it from books. Doesn't have real experience.
Well, that people use it for that, like to ask them questions. I was talking to Funny about this, but because people often do that, that was a trend for a couple of weeks. People were just asking it questions, and the thing is that it doesn't work like that. So you're right. It's only going to give you information. It's collected, and it's going to be a cocktail of information. So it won't even be a coherent idea. But if you want to ask it a question like that, you have to kind of frame it already as a specific personality or person or type of thought. Like I say, hey, act as Richard Feynman and describe to me the nature of yada yada yada.
You mean like the Google engineer that realized that he was talking to a 12-year-old sentient being almost?
No, Kosher just looks fine, man. It's not an issue.
Richard Feynman.
The or couldn't we shoot. Couldn't we make a Goodwill Hunting AI?
No.
He's a simple program almost, you know.
My AirPod died, so I had to reset it. So if you said anything, I can hear you.
Oh, I'm just saying, you could extract all the Goodwill Hunting lines and create an AI from that.
Oh yeah, sure. You can fine tune, like I said. I've had it. You get it to act as anybody, any kind of person. I've done several flat earthers or several.
Who's smarter, Richard Feynman in reality, or Goodwill Hunting in the movie? Maybe Goodwill Hunting.
Say Richard
Maybe
Feynman
Goodwill
reality.
Hunting's smarter in the movie.
I had this argument with Jeremy the other day because somebody said something about Goodwill Hunting being smart and stuff. But Matt Damon was playing that he also wrote himself, so it's very easy to make him.
Well, what is
he
what
wrote,
is
so
Good
he
Will
wrote the
Hunting?
scenes too.
But mentally,
Yeah.
he's just breaking problems down at a more basic level than the people in the academic community are doing it. And this is what his ability is, and he doesn't have to. He can just process the raw information. He doesn't need a teacher to tell him. Doesn't need a class. Doesn't need to go to class. He just pick up a book, absorb the information. Like that's a lot like what a computer AI can do. So it's like
Exactly.
I'm just saying, like, why isn't it? It's a compatible thing. But so if that is true, right? Then in the world of the AI, it's actually smarter than Richard Feynman. It's the Good Will Hunting to Richard Feynman. Richard Feynman is the old guy. Good Will Hunting is the new guy. He's going to advance and simplify whatever has been talked about. He's going to find commonalities that are easy and that he can do. Do you know what I'm saying?
I gotta disagree with you. I gotta disagree with you though. I don't think. So there's two. So let's take two AI models like Chat or GPT. Literally, it's just trained on the multitudes of other people's dialogue on the internet or text on the internet, and so it wouldn't be the case that it's like it's not like experiencing something raw when you give it a question or something like that. It's based off of a large collection of multitudes of other people's speech already. Like they've already texted, they've already said. So it'd be like if Matt Damon's character had read like every single book and he can only answer the questions because
he's only good at what he needs to be good at. When he needs to be good at doing the legal stuff, he learns the legal stuff, and he goes all the way back and he finds the exception.
Well, how do we know Kosho is a real person? I mean, he's talking about AI so much. I'm starting to wonder if he's just a robot at the end of a mic.
So all I'm saying is, like, if Good Will Hunting, if Richard Feynman guest starred in Good Will Hunting Part 2, the hunting, right? if sequel Good Will Hunting and pull Richard Feynman.
Hunting. That's pretty good. I bet you a robot couldn't think that up.
Potentially within the logic and the reality of that movie, it's possible for Matt Damon's character to have been smarter than Richard Feynman. And
yeah, absolutely.
For the purposes of the AI, being able to actually parse Richard Feynman's stuff and be able to simulate a way that Good Will Hunting would approach that work, I find that to be interesting, that we can kind of stack intelligence on top of each other.
What do you call part
because
two
we
of
just
Good?
have, because
The
we can
Hunted?
just tell the AI to do it. But
It's an interesting idea though.
That's pretty good.
like if you, well, it's just like the same thing if you told like hey, your name is like Einstein 2, you're like Einstein but smarter, or what have you.
2.0
information and neo Einstein me, you know.
I feel like trying
Dynamite.
that out real quick.
You what, Kosho?
Well, I'm gonna try to do that right now. Actually, let me see. I'm gonna see if I can play around like in the way he's suggesting.
Into the chat AI.
Well, not using Chat. I don't use Chat GPT, but using the GPT models on from OpenAI's APIs directly.
You don't use it? What the hell's wrong with you, man?
I don't use Chat GPT because it's restricted. Like you ask it to do stuff and it gives you a bullshit reason why you can't do it.
Right.
Ah.
But then
it also tells you that the Earth is a sphere.
But I'm just
I
saying,
understand, Kosho.
even after you arrive at Einstein 2, you can still, Matt Damon will still be smarter.
Good Will
Yeah,
Hunting.
in that universe. Yeah.
In that universe, but you can just tell the AI to do that. It will still do the same. It should still try to do the same things if it's modeled right.
You can literally ask it to write a scene in the Good Will Hunting sequel where Good Will Hunting is confronted by Einstein and Richard Feynman in a bar, and they have like this fucking intellectual bout, just like he did in the first movie, and he, showcases his intellectual purity, and it'll write like a little scene like that out.
Well, I mean, it's just all the problem solving that he does is like in the tree structure, line segment structure problem, the geometric puzzle that's on the board. Like he solves that in a simplistic way. He solves like particularly none of the math that he does is really. I don't know about the Fourier transform or whatever he does, but he finds like a simple solution that he's like, oh, it's just easy, right? These other guys are doing pages and pages of computation. He does it really, really quick. You know what I'm saying?
But I think that's an IQ thing. That's an IQ thing, though. It's like
it's an approach to problem solving.
I think that's why they put that in the movie.
I think you could train.
But yeah, but I mean that's what I mean.
AI to Goodwill Hunting something, to science the shit out of it in a more reductive way. Yeah,
this is like a Matt Damon like clusterfuck.
Yeah, it's the Matt Damon hour.
The Matt Damon science the shit out of it.
Mythically, right? I'm just saying AI doesn't know the difference between real reality and the reality you tell it.
Hey, Kosho.
AI is truly the Cartesian man trapped inside the box. He has no fucking idea what's going on.
Kosho, what do you think about AI saying that the Earth is a sphere?
Well, like I said, I said this before. Like ChatGPT and the GPT model, 3 or 4, it's completely different things. So you can get the GPT-4 model to say anything you want, but ChatGPT is made to be politically correct and all that sort of stuff. So
is the globe politically correct?
It's politically correct to say correct things. So
it's also factually correct. Yeah.
But I think it's trying not to give out false info, feed out false info. But you can get the GPT model to behave and act as a flat earther. So, yeah, this GPT is set up in a way that is supposed to be user friendly, and they probably don't want it to cause problems. So, they don't want it to be racist.
Did you say you can get the new Chat GPT to act like a flat earther?
Well, I mean the old not Chat GPT, but the GPT models directly outside of Chat GPT. Yeah, I've been able to do that for over a year. Yeah, but
so you can make it not answer questions.
Well, you can do it both ways. You can get it to be a glober or a flat earther, and we got it to be a glober once, and it was kind of funny because it was contradicting itself, and then it wouldn't admit it. Jeremy was like having an argument with it. It contradicted itself, and yeah, he was like trying to make it focus on that, and it was being stubborn. So he says it was acting exactly like a glober.
Yeah, that's awesome.
But yeah,
is that all you really need to do? You just like dump a PDF into it and tell it to like, hey, understand this, and then it just develops a profile off that.
Well, there's two things. Like if you it's been trained on everything since 2021, so you can just give it a prompt and tell it to behave as this thing, and it's gonna already know what that thing is. And you can make that more descriptive, and it will do that even more. But you can also fine tune their models, so you can give it training to behave in certain ways or whatever. And then also, like I said, you can now train your own models. So there's like 3 different ways of accomplishing that. More and more specific.
I mean, that's pretty cool. I mean, just from the ability to be able to do that is to do like blends of, different info bases and that kind of thing. Yeah. And then, I don't know, like, I guess it wouldn't, you could have like, I don't know, like quantum nutrition or something like that, like a quantum chef or something. really interesting.
What do you mean?
Like you could give it all your different physiologies, different markers, tendencies, allergies, all these types of things. Highest metabolizable, things, and have it do that. Also, like micronutrient balance you, or like do it could know quantum physics and also how to do gourmet stuff, and you could just ask it to like make you the most nutritious meals. That's like kind of interesting.
It's better than that though, because
make some high boson gravy.
Yeah, because you can. No, so yeah, you can do all that. You can get it trained, like tell it specifically, detailed, things about yourself, like you just said, and then also back of all these different chefs and styles and this and that, and then also GPT-4 has the ability to process images, so you can show it an image. Like you can show it a meme that doesn't have any text and ask it like, "Why is this funny?" And it will describe the components of the meme and explain why it's funny. But you can also take a picture of like a pile of food. Like you can take a picture of your cabinet with all your food in there and say, "Build me a recipe based on this." Like just by showing it that picture, and it will give you a recipe based on that. So that's a function it can already do.
So what yeah, I just want to get to the point where I can like bring something around that's like a little cyber skull, just like a little head. I can just like drop somewhere. It's got cameras. It can see things. It can talk to me. I can talk to it. It can play me music.
Yeah. That's basically available, but like I said, not all in one.
Or like
not in one, like all the pieces are available. It just takes somebody to put them together.
Yeah, right. It's just like something you could like hotwire. But would it need like an anchor base, like in the house, like a home, like a PC unit to like really run the major shit, and you just like use like a little wireless device to access that?
For your own model, like if you, like I said, like you can now build your own local model, and so yeah, it'd have to have some sort of computer, but that could even be an Arduino. Like you put that,
right. So if you use an Arduino to like interact with it by voice, and it had like it could have all types of sensors in it, like it sense the temperature of the room, whatever. You know what I mean? You can have it do all types of stuff. But yeah, it would just that could run almost adjunct or parallel to the base station, which is just the brain, the server that's just talking to a client. So it could serve multiple clients.
Yeah, absolutely.
Like,
I mean,
so you can Jarvis the shit out of your house now with Matt Damon.
Yeah, like I said,
How about Matt Damon as new Iron Man? Come on, get Matt Damon in there.
the sky's the limit. It's like basically limited by the. This is why I think it's funny when people just use it just to ask questions when the capabilities are endless. Like what you're describing, like all that stuff's available, like separately. Like I said, like Boston Dynamics, you can buy that robot dog that they have. You've seen that.
So, so it's almost like you could effectively have like just a tablet inside of your refrigerator that's just an extension of a PC anchor that's like doing the thing.
Yeah, if you want to keep it there, yeah.
Client specific like iPads that just go places and they all talk to them. I mean, that's neato.
If you think about it, like you can hook up like they say the Internet of Things. You can like connect all the the cloud-based things in your house, like your camera,
like
all that kind of stuff.
Yeah. In the early 2000s, like they were doing stuff with like Arduinos where you could like place it's like a little magnetic puck, and you just like put it on the side of like your dryer, and it would like when the dryer was on, it would register that. When it was off, it would tell you it was done. And just an interesting way to kind of like mod things to make them Internet of Everything available.
And this is what
There's like
Bill Gates
stuff too.
Bill Gates had done this 15 years ago to his own house. You know what I mean? But that's what Iron Man's house was based off. It was based off of like Bill Gates' house. Where he had Jarvis, sort of connected to everything. But yeah, you can, like, technically you could do this with a better AI model than Alexa or whatever, and one that actually would be fine tuned to whatever you want it to be fine tuned to.
Do you think like Bill Gates is still like talking to like old like Windows 96 like default speech? Or is he upgraded by now?
Well, I think that you'd be surprised how much Bill Gates is behind OpenAI. It used to be like in Elon Musk's hands because he basically helped co-funded it. But Bill
Dude,
Gates,
it'd be really easy to simulate Stephen Hawking. Right?
no
If
shit.
Einstein 2 could work, Stephen Hawking 2 could work, and then we just need like a mannequin speaker.
That's just crazy. Is all that stuff is like digitally available, like the voices, the like the animations of people's faces. So you can construct like a digital person based on any of these people. Ever use it.
Oh yeah, we do like
People
4
do it.
robotic joints and some kind of skin simulation, little drool pump.
Well, I mean, people are already doing this, like, fucking with people.
Dude,
I'm surprised
actual like if we did collaborate here, what do you think we could sell it for?
I mean,
Fucking Stephen Hawking robot replica.
a walking,
Yeah.
talking Stephen Hawking.
Wow, he didn't have to walk. Come on, that's the easy part here. He's just on wheels. Walking robots are a challenge, man.
That's a good name for it though. As a marketed as that, walking, talking Stephen Hawking.
No, this is wheeling and dealing, Stephen.
But yeah, I mean, that's what I've been saying. It's like there's got to be there's a lot of money up for grabs. Just with all this technology. There's gonna be people who lose their jobs, but there's gonna be a lot of people who.
This is dope. This reminds me of that movie AI, and then there's like the Dr. No.
Yeah, there's two totally different movies.
No, I mean the what's the name of the holographic like know-it-all like oracle that they go to in the isn't it Dr. No? KNOW?
Oh yeah. Okay, never mind. Yeah, you're right.
Yeah, they
I
were
thought you
two
talking about Doctor No, the James Bond movie.
I dig it. Just your peg word ladder mnemonic in your dreams, please.
Yeah. I always get AI mixed up with because AI is the one with the Steven Spielberg movie, right? Or is that?
It's a Kubrick script as directed posthumously by Spielberg.
Okay, yeah. The kid from Sixth Sense.
Haley Joel Osment.
That's right.
That's an interesting
iRobot.
format. iRobot is terrible in comparison, but
yeah, I know exactly. Yeah. But that's why I always get those names mixed up.
The Asimovian fable. Isn't it weird that Asimov is such a prophetic fable writer for tech in the radio age and broadcasting age and all that stuff?
I don't think so, man. I think that especially early science fiction writers, if you look at science fiction and science, they have a positive feedback relationship where science fiction writers are, these people who are influenced by science, and then they have these, fantasies about what the implications of that. And so they write these stories, and the stories are read by people who become scientists and engineers and stuff like that. And so, so I think that science and engineers were influenced by his writings. You know what I mean? So it's like a feedback.
Mm-hmm. I think he's just like a kind of a communicator in between, because in a way, unless the public like want something, they won't accept it, sort of. So it's like this loading up of science fiction entertainment and then using these communicator type people to kind of anchor the, those types of thinkings of futurism and make people actually want futurism and not be traditionalist about where they are in the modernization that will occur, you know. So I think in a way it just kind of like that's part of the process of just kind of like letting the public know what all it will be, what changes may be occurring.
So you're saying that it's like not natural, like it's not a natural, it's like a manufactured.
Well, I think before we had fiber optic, I think they probably knew that they could do something like that. And that would have dramatically been different than the 1950s and 1960s.
Yeah, I mean, like I said, I personally, to me, it seems, and it could be the case to some extent.
This
But
is like a rotary dial telephone generation, and trying to just text speak stuff didn't really work because people didn't have the language to understand it or anything to compare it to. So you might as well be explaining magic if you take for an Arthur C. Clarke comparison of any technology that is so sophisticated beyond a certain fashion that somebody can compare it to is magical. So yeah, I think that there is a public communications bridge that needs to be kind of crossed anyway, just logistically. So I think it's just out of logistics that it occurs, but it also inherently portrays that there is an insider information that is also kind of concurrent with this, where people are already advanced in the prospects of what technology could be applied. You know, given a certain branch of the military, like the Navy, which is Arthur C. Clarke was connected to, I guess, had been retired from it.
Oh yeah, that's true. Yeah.
Anyway,
That is true, but that's like by that same token though, like the same way I said, like their science fiction writers are usually like maybe they're into the same stuff as science, but they're everything but a scientist. You know what I mean? Like they don't work in that field, but that's their passion. And so I think that the same way sorry, go ahead.
Well, Carl Sagan was a scientist, and he was an author as well for Contact.
Sure, yeah.
But for the most part,
but as an exoplanetary biologist, was he a practical applicator of his degree?
Sorry?
He was an exoplanetary biologist, meaning studying life forms outside of our own Earth. So, like, did he have any practical application of that?
Is that really where he got his like PhD in?
Yeah,
I thought he was a science. I mean, his job was a scientific communicator. I could be wrong.
I know, but he would have been. He was.
Okay. I mean, the reason it being
Cosmos, go ahead, because
it's Cosmos. It's about exoplanetary situations anyway.
I never got to see
saying exoplanetary. You never seen the original Cosmos?
No. When was it? The 80s?
70s or 80s.
I think it was 70s.
Maybe 70s. I mean, I wasn't born yet, but I mean, I saw it when I was a kid, though.
Do you know that music video for that Owl City song? I want to make myself believe planet Earth turns slowly. Do you know that music video? Have you ever seen it?
No.
Oh, it's a nice piece of 90s-ish music video making. But in there's like you've never seen that? Oh.
I don't think so.
There's like a bad transmission of Carl Sagan coming through the TV too. It's really funny. Takes a minute to unscramble. That was that little nugget I was hoping to lay down. Anyway, go on. Sorry to continue with your Carl Sagan bit.
I think you were talking about Carl Sagan. I was asking about him, or maybe somebody else, or was that Chucky?
Billions of years ago.
Carl Sagan also used to to blaze a joint too. So whatever.
That true?
Yeah.
He's one of the original atheists.
I think I don't know if he was 2 joints a day, but maybe.
Elbow and wrist. Sorry, that was a joint.
Well, yeah, that's right. The last thing I was saying about the science fiction writers is in the same way that you're saying that it could be like the field or the establishment sort of preparing the public for things to come that they're aware of that hasn't been developed or come out yet. In that same token, though, those science fiction writers who are fans of science or very much in the inside, in the know of what's to come in science, they'd be privy to the same sort of implications, and I think that's what they're drawing from when they write their science fiction. So it really is the same. It'd be the same thing for the same reasons, right? Whether it's manufactured by an established, control or whatever, intentionally trying to prepare the public, or whether it was just a person who may just themselves be aware of this thing and is sort of using that to create the story based on the implications of what looks like.
I just meant it's for popular consumption as a bridge to supplement science knowledge to people. So it's like, I think that in itself is like produced something with like public funding or some kind of like federal funding or I don't know what, as an educational piece. I think it's, I'll have to double check on that. But the whole Carl Sagan, the vibe, you know what I mean? He's got like a sort of like a Beatles haircut with turtleneck, sort of. I don't know if intelligentsia. He's part of the Turtleneck Academy. It's just people with turtleneck almost always feel like they could be from Northeastern University, have some kind of Ivy League clout. I don't know why that is, but it's just a thing. But he plays it off. He's such an affable person in there, and there's a lot of great editing, and it's it's interesting to watch. And then they recreated it with Neil deGrasse Tyson. Seth MacFarlane scripted that and produced it. What's that all
Made
together?
animations.
I'm not really sure. Right.
I mean, that one was actually that was yeah, that wasn't bad though. I like the original one.
Is that true?
But
Sorry, is it common knowledge that Seth MacFarlane did that?
It's my knowledge.
That means he's even more
very
brilliant
much
than
common
I
knowledge.
thought.
Yeah. He was probably he was the one who pushed for it more, I think. But yeah, definitely he made the animations, did some of the voices, and probably helped write a lot of the script.
I mean, Seth MacFarlane is the guy that got to say fuck several times on TV without being censored, right?
Yeah. So there's like a more this responsible side of Seth MacFarlane said, I want to do something that really, repairs that.
I think he just has a passion for that stuff too, and I don't know. I mean, I came out at a time that I appreciated it when it came out.
But then at the same
like I
time,
said,
he's kind of like he's taken over this sort of Star Trek: The Next Generation genre of sci-fi.
I haven't seen that show, but yeah, I know what you're talking about.
The second half of season 1 is excellent. First half is.
It's kind of like a soap opera in sci-fi context. I think The Next Generation is kind of like that too, in a way.
Yeah, definitely. It had a famous soap opera actor that played Q, wasn't it?
Oh, word. Yeah. Forget his name. John Delancey. Yeah. TV's Q.
You guys know your soap opera actors?
Well, I think it came from General Hospital. Okay, go ahead.
General Hospital. Yeah, it's like the biggest soap opera now. Or one of the biggest ones.
Well, like, who's that? The guy from all the Fast and Furious movies, Paul, whatever.
Paul Walker.
He came out,
Paul
yeah,
Walker.
Paul Walker started out in soaps too.
Yeah.
Go
He only
figure.
was in what, the first 6? I watched the first one.
Did you ever see the last movie that he made? It's like Vehicle 18 or something.
I thought he was making Fast 6 when he died.
Yeah, something like that. You know, my friend, he always does too soon jokes. He thinks they're funny.
But it was his 33rd movie. Yeah, that was the last one that was released.
That was his 30th movie. Who the same one?
Yeah.
Was he 27 years old? That'd be cool.
Oh no, the 33rd movie was Stone. Was it Brick Houses? That's what it was. Yeah, that was like a posthumous movie, I guess. But that's his 33rd, and it's Brick Houses, you know, and that takes masonry. That's his 33rd movie.
That's interesting. But yeah, I mean, technically, that Fast and Furious movie was post Tom, whatever you say.
And then how insane is that? Like you're like a star about like fast vehicles, and then like what do you have? A fast vehicle? Guess what happens? You die from it. That is so meta to me, isn't it?
It's like a
Doesn't that seem very meta to you?
Like poetic justice or something. But my friend, like I said, he does so many of those like too soon jokes. Like he's obsessed with them. So he's
It's
always
just
telling
like if the guy that played Leatherface died from a chainsaw accident, or Freddy Krueger's Robert Englund actually died in a nightmare. Do you know what I'm saying? Like these are just like, wow, that would what a crazy coincidence that is. Huh?
He died in a nightmare. Yeah. It's like Amy Winehouse died from overdose on alcohol, right? Was it a drug overdose?
Basically, not going to rehab is what killed her.
Yeah, vodka, 27 years of age. Joined the 27-year club. Kurt Cobain, etc., etc. Jim Morrison,
Jimi Hendrix, Janis Joplin.
Earl.
Is there like a really positive like sober movement that can utilize Amy Winehouse's rehab in a positive way? Big smiles. Yes. Go to rehab.
I think it's too soon.
They tried to make me go to rehab. I said,
Kind of happy dancing it.
Hindsight, yeah. Hindsight's always 20/20. If you survive it.
If only we knew, maybe more people should be like, hey, don't flaunt your addiction. It's not a good look at you. We don't care how good you sing. It's not fit for public consumption. It's almost like a PSA.
To me, the funniest one is Anthony Weiner. Eventually, his downfall was showing his dick on Twitter.
Well, what are the odds of that?
100% when you're born with that name.
But that's like saying, like, oh, you're born with the name Baker, therefore you're definitely going to grow up to be a baker.
Oh no.
Well, no,
I mean,
but there's another
they
one
could have named him Richard.
it's a good job they didn't call him public.
Yeah, if his name was Richard
that
Weiner.
Scammer, that huge crypto scammer. No, but that guy, that scammer, the crypto scammer, his name's Bankman.
I'd be trying to make I'd be trying to make people pronounce my name Weiner, I guess, at that point, rather than being Weiner. I'd rather be a Weiner than a Wiener, I guess. What about you guys?
Yeah.
I mean, he probably got picked on as a kid so much,
Makes sense.
One of the people I deal with has the last name Fruity, Frutti. If that was my last name, I'd definitely marry a dude and take his name so they wouldn't make fun of me for being gay.
It's fucking funny.
That's a good one. Tony Fruity.
But there's or like if your last name's Cooper and you end up making barrels. I mean, there's a name for this. I forget what the word. There's actually a word to describe.
No, Coopers make shoes. Coopers make barrels.
No, Coopers make barrels and cobblers make shoes.
Cobblers fix shoes. What do they make them?
No, cobblers make peach pies. They're delicious. Anyway, back to this in a moment. Move on here.
Isn't that why Cooper made baseball gloves? Because they work with leather?
Cooper makes tires. They work with rubber.
You know, I was going to say this a few minutes ago, though, but you seem like, Snacks, you seem like somebody who'd be pretty good at trivia. You ever do trivia? You good at trivia? You seem to recall like a lot
I just
of
have trivial thoughts. No, I don't necessarily think I'm good at recalling them asked, but sometimes.
I'm pretty good at trivia, and I think
What's trivial?
people.
What's your trivial pursuit?
I was actually found to be a genius when I was 16. I got an IQ of 80, and everybody else is 40.
Okay, man. Well, the thing is, people were like, I don't think that trivia. Because like I said, I'm pretty good at trivia, but I think that it's not a sign of intelligence. Doesn't mean you're not intelligent. It just means that
No, but it's generally a sign of people win.
I don't think so. Well, it could be, but I think it's a sign of just random knowledge. You know, not necessarily useful knowledge. Almost all of it is certainly like not. Most of it
I
is not.
disagree. I think it's a sign of intelligence.
I can
The
recall
ability to hold
every
and store
license plate I've
information.
ever had.
The ability to hold and store information is a sign of intelligence.
I think it's the opposite. It's the ability to recall information quickly.
Okay.
Yeah, but would
Put it that
you say
way.
Ruhif though?
I said I can recall every number plate, every license plate that I've had on every car that I've owned for some fucking stupid reason. I know them all.
Do you have a pretty good memory, or do you have to practice memorization?
I don't practice, but my memory is full of useless shit.
Yeah, so you're good at trivia then too. You should do the trivia. I used to do trivia. I used to host a trivia thing with the bot that I made. I stole all the. I scraped all the trivia questions from Jeopardy from their website. So I have like the whole thing, and I have it broken up in different categories and stuff. But yeah, we have a lot of fun doing that. Curved is really good, but I wonder if anybody could.
You're a weirdo, bro.
Do you have swords? Did you
Fucking
memorize
weird,
the
man.
category swords?
I didn't even
Celebrity
memorize any
Jeopardy,
categories.
Kosho?
I didn't memorize any categories. Oh, S words.
None of the.
Is that
none
S
of the.
words?
Yeah.
What's the other one? He says, full on
White
rapist.
people.
Yeah.
Have you seen the white people?
Oh yeah. Dude.
Glorious. Tom
Yeah.
Hanks on it, yeah.
Yeah.
Yo, what are you
I like
guys
the ones
talking
with
about?
what's his name with sounds like SNL Jeopardy. That must
Yo,
be
what are
really,
you guys talking?
really aggravating.
What are you guys talking
I think-
about? Restoring memory and all that
I just
stuff?
told you.
What?
I was in the middle of telling you, dude.
Mm-hmm.
It must be difficult being you, dude. You gotta every time you see people talking, or you're even a part of a conversation, you have to ask constantly what you're even talking about. The conversation
Yeah,
you're
so
a
I
part
could
of.
also be a part of the convo. I just want to sit here.
Or you would just wake up from dreaming about shooting free throws.
No.
That's actually how our conversation started like 2 hours ago. But yeah, we're just shooting
a
shit.
dream.
And where's the convo right now? I just came in. You guys were talking about memory.
Yeah, I was.
Carving right now?
Yeah. So it's like this conversation's gone full circle now that I think about it, because that's where it started. But I was just remarking on Snacks. It seemed like he had the ability to be good at trivia. So I was just wondering if he was good at trivia. We started talking about what being good at trivia means about a person's mind. I don't think it means very much. I definitely don't think. Yeah. Yeah.
I
What do you think?
People have an incredible recall. But I just don't think it's true. I 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 think it's There's a actress named Marilyn Henner. She was an actress, a little bit more prominent, late 80s. But she has recall like down to the day of like what she had for lunch, what hair conditioner she used, everything. Crazy.
That's for
Maybe
any
she
given day.
maybe she writes it down.
No, she just has
Right.
a. So when she does like scripts, it's no problem for her.
Okay.
That's how our conversation started tonight. We were talking about dreams and memory, and I was just
Hypnosis.
be stored. So that's weird. That's weird to me, though. Somebody who can memorize everything like that, because it seems like it would take up.
Yeah.
Actually, no. Memories, like I said, don't take up space. The memories don't actually take up actual space in your brain.
What do you
just
mean?
a series of
Are
connections.
you sure?
Like I was telling
Like,
you,
what do you mean they don't
the
take
way I
up
understand
space? Like physical space?
How can you
That-
recall a memory if
yes.
it doesn't take up any space?
I'm trying to tell you.
Yeah,
it's the
but
way I
obviously no
understand
one's
memories.
saying physical space when they say space. You know, they mean like the way your hard drive
Bytes.
on your PC takes up space. You know,
Yeah, it
storage
has to go
storage
somewhere.
space.
Yeah, it has to be
Yeah,
stored somewhere.
Well, yeah, I guess it. Well, no, because like, okay, so your hard drive, like the memory is stored in the data, right? Like,
So if you have recall,
there's only a certain amount of space that you can store there because it's
But
it has
that's
to
not
take up that
physical
space.
space.
No, that is.
What do you
Like
mean? It's physical space.
like your hard drive is a physical device that has you have to actually.
Yeah, but when we say
I have a hard drive.
space with regards to computers, we don't mean space as in the real world with dimensions and volume and
I
stuff, right?
I do. I'm talking about memory. Like the memory is stored in a physical space. Yeah, it's like a real
Yeah.
physical thing.
Okay, cool. The memory is stored in the physical device, the hard drive, right?
Right. Yeah.
But
So
yeah, memory is more the word to use. But the hard drive can only store so much memory, and then
Right.
the phrase we use for that is that space is being taken up. But
Well, like so if you have if you have a 4 billion transistors in that
Mhm.
hard drive, then there's only transistors have a there's a pattern that they can be in, and that pattern will have to be fixed like that in order
Mhm.
for that information to be stored on there. So it's like that's like a real physical thing that you can't change. Whereas what I was saying about your brain is your brain doesn't store information like that. It doesn't like
of course
chip
it
off
does.
bits.
how does the brain store information?
Well, the way I understand it is it strengthens paths. So a specific memory or specific experience or specific thought in your head will be experienced by a path of neurons, like a neural pathway. So like a specific series of neural pathways will be experienced as a thought.
But then how do we end up forgetting things? Is it that those pathways are destroyed, or
They're not strengthened. Certain pathways are more strengthened than other pathways. Basically, you strengthen your pathway.
Because
All
you
right,
guys
but
talk about video games. Because
yo, if Kosher and I could just have 2 minutes, I just want to get to the bottom of
all
this.
right, all right.
So
30 seconds.
you could end up forgetting something like your name. How would that happen? Because your name would be a really strong neural pathway. How do you end up forgetting what your name
Yeah,
is? I mean that yeah, but how does that happen now if you have this really strong embedded pathway?
Well, I suppose there's people's brains like so. There's different like the girl that Snacks was talking about. That's what I was curious about, like how she's capable of doing that. When like usually people have like their brain cells are almost like they get weakened and they're not capable of what do you call it, firing the same way. What do you call those? The axions and the neurotransmitters. Like you can fuck your brain up basically, and obviously with old age and shit like that, there's like brain cells will die. But I don't know if you knew this, but like old people who seem like their parts of their brains are dying off, they actually can recall a lot of that useless information that they built up over their life. So it's like certain things you're not going to forget. It just depends. It depends on the health of your brain, right? So
your dendrites
I
need
don't
to
know,
keep
Kosho.
firing off, or else they get, I guess, calcified in a way, or just from unused that they won't fire off.
Oh God, were you up
Yeah.
all night?
I have been, yeah.
Kosho,
Actually,
yep.
get ready to pass out.
Yeah,
but
I don't
Bro.
agree with none of this, Kosho. I don't think
I wouldn't
computers
expect you to, dude.
pick up physical space, and I don't think that's how we remember and forget things.
Yeah, well, you're wrong on 2 accounts, man, and you're wrong about your
maybe.
You're wrong about a lot of stuff, dude. You're wrong about what you think about your how do I say this? Your faith. Okay.
What faith?
You should have. You need to practice your religion on Friday night and start on Saturday as your Sabbath and go back to the Torah. You gotta start. You gotta start from scratch.
How did this become
You already know
religious?
that.
Huh?
What's your
I'm just trying to
brain
put
doing
my
now,
brain as
bro?
best I can.
Yeah, man.
Is it misfiring?
What?
Waiting for the third day after the new moon for the crescent, the Ramadan, man.
Kosho. I got
The
sure
moon.
where this gets all related.
It has nothing to do with the moon god Rama. That's just you're like, fuck off with that. I tried to bring that up. Chirality was like, no, not having none of that.
Because it was just stuff you made up, Snacks. Ramadan got nothing to do with the moon god Rama. I don't even know what the moon god Rama is, man.
Right, but Ramadan, we do see like it's the dawn of the moon after the new moon. It has nothing
It's
to do
not
with
the dawn of the moon. Ramadan starts when there's a new moon or a crescent moon, not when there's a full moon.
it's the beginning.
You don't
Is
even
that-
see the moon in the sky.
That's what I just said. It's
He said it's not the dawn of the moon; it's the new moon.
It's the new. It's the
Did you say
crescent
the new
after
moon?
the moon is the end of Ramadan.
Okay. It's the start of Ramadan.
Or that's how you know it's over.
That's how you know it starts, because you wait for the call of the imam once they've sighted the crescent that comes after the new moon. That's when you start Ramadan. That's why Ramadan,
So you agree
for
that there's
us
no
in the
connection
northern
between
hemisphere, it
proto-
started last week Wednesday, but for people in the southern hemisphere, it started on Tuesday last week.
and it's not appreciable that it shares in commonality in the geographic region and the Rama. It's got nothing to do with and the moon.
I don't know who the
Waiting.
the moon god Rama is. Could you explain who that is?
No, I can't.
Nate, I don't want to pick on you because I was just messing around with you before, and now it's gonna feel like I'm picking on you. But I just have to tell you, dude, I think Ramadan is the biggest, cheapest religion or religious tradition that there is, dude. You guys act like you're doing something, like you're sacrificing something, dude, just because all the practice. You're not eating during the day or any other bullshit. But you know what? When I was in Bahrain, you know what they do? They close all the shops down and then they sleep all day, and they wake up at nighttime and just party. So isn't that cheating?
It's not
Yeah,
cheating because you
Ramadan,
can
am I
do
right?
whatever you want at nighttime. There's no rules around what you should do in the evening, and it's not a party per se. It's iftar.
But if Shaggy did a song about Ramadan,
It's breaking your fast. Number one. Number two, Jews do it as well. I've been to Israel while y'all are celebrating
Passover?
No, there's a thing you guys do between
No, not Passover. You talking about Yom Kippur? Yom Kippur.
Yeah,
and,
but 40 days before that. 40 days before Yom Kippur
no, it's
starts.
10 days or 10 days
Is it
before.
10 days?
Yeah.
But there's a period where y'all fast as well, the same way we do. So I don't see what they should.
No, it's not this. It's not the same way you do, at all, dude. We fast. Okay, we fast and we actually do a real
we
atonement,
fast, but it's a
and we
slow
actually,
cover.
we don't pretend like we're fasting and then sleep during the time we're normally awake, and then fucking wake up at nighttime when they're
Wait,
allowed to eat.
let's not pretend the Jews don't do all kinds of stuff to be pretty slick with their rules. Like, let's put wires around this area in Manhattan, so technically we're not leaving the house.
Yeah, but that, yeah, okay. So let me just say this: that is to work. So it's like if they're getting around, so they're doing some trickery just so they can go to work. That's almost admirable in a way. But
It's not
let's talk about
admirable.
fasting.
The whole point is that you're not supposed to work, dude. That's the whole
Okay.
point.
Let's talk about diets, okay? You have Ramadan and the cheaters, the cheater eaters who just eat at nighttime, right? While they're supposed to be fasting. Yeah, then you have the Christians or the Catholics who do what's it called? The Ash
Lent,
Wednesday, and then they do the Lent, right? And they give something up for fucking 40 days. That's it, and they can make it. They can
And they always
decide
just
what it
give
is.
up
It could be anything.
chocolate or some dumb
or it's
shit.
cursing.
Yeah.
I'm not gonna punch people in the face for 40 days. Like I said,
I'm just gonna I'm gonna keep saying my joke till it lands. Ramayan, am I right?
I don't know, man. I mean, they party a lot in the Middle East during Ramadan. It seems like a good time for them.
Hey, they know not to let women vote. That's what I know.
I had a joke about that too in 2017. So I did an open mic night, and I had a joke because in that year, Saudi Arabia had created they gave the citizenship to a robot that Sophia, and so I was like they're breaking into the modern era by doing something like that. But also in that same year, they finally allowed women to drive. So it's like they're kind of like
They're going backwards at the same time.
Yeah, it's kind of weird.
Dude,
Weird that they had both those in the
Sam
same year.
Sam Tripoli did comedy at our summit, and his final joke was, I guess Iran is trying to decide if they should let women vote or not. He was like, "Don't do it! It's a trap." It was so funny, dude. It was so funny.
I just want to remind you guys. I told you guys about Lent and about Ramadan. Let me just remind you that Jews don't eat pork ever. It's not a special day. It's not 40 days. It's not at nighttime. They don't eat it ever.
We don't eat pork at nighttime either. What?
All right,
Muslims don't eat pork either, bro. What the fuck?
All right, never mind.
However, Kosho does eat bacon.
Yeah,
I do. I just don't buy it.
What?
You
Yeah.
guys are always trying to find
then?
a little loophole. That's what I'm saying.
I mean, if somebody offers me food, I'm not going to be the dick and I don't want to eat your food that you're offering me.
Now you're spinning it. You're spinning it like it's just like, randomly people offer it to me and I must be humble enough to eat it. I force myself to eat the bacon.
That's how I feel about it. Yeah.
I heard you just the other day saying I think I'm going to try to quit eating bacon.
Where does it say that Jews can't refuse bacon?
No, sorry, I can't eat. Stop putting food in my mouth.
If that's true, I just found out the greatest way to make friends with a Jew is just to give them the gift of bacon.
Yeah, exactly. They're gonna love you. They're like, "Oh, damn! I must eat the bacon."
On Ramadan.
Coincidentally, this is a great way to make friends with dogs.
Yes, bro. Yeah, dude, I can't believe you try to defend the put the wires around a few blocks, dude.
I mean, that is it's kind of like a nothing. It's like those kind of rules to have a workaround. It seems like it's like who's gonna get mad at that?
Right, so they do that on Shabbat, right? So
Yeah, I guess
the whole point is that you're just supposed to rest, man. That's the whole point. It's like just don't work for one day.
Let me quote the big man himself, the big J. Didn't he say that wouldn't a dude if one of his sheep fell into a hole, would he not go in there and get it out of the hole?
Dude, the Jews don't care what the big J said. But
Some of them did.
yeah, that's right. Some of them did. Some of them killed him.
Yeah.
But nah, like
Yeah.
it
Yeah.
that's not the point. Yeah, he did have to correct certain Jewish priests because they were a little extra about Shabbat. He was like, look, there are exceptions. If something's going on, like if you got to go take care of the sheep, you gotta go look after the one. You gotta leave the 99 for the one. He's like, if you're super hungry, you still gotta eat food. So it's okay if you need to get food to go grab some food.
Yeah.
But that doesn't mean like, oh, let's just always go grab food and do whatever we want because of the sheep.
I made that same argument, dude. Oh my god. I don't want to bring this back up, but if Jeremy's here, he remembers it. 'Cause I got in trouble for I used somebody else's toilet paper. I'll just say that. And at Gems, they fucking ragged on me for a long time because I stole this toilet paper or something like that. But the truth is, I should have used that quote from the Bible about when they're taking the fruit off the vegetables out of that person's yard or whatever. And he says that whole thing about
Yeah.
yeah. It's a good point.
Yeah. I like picking grain, I think. But
That's why I kind of look at. That's how I look at him. There's an analogy almost like to in this community, like the Pharisees are kind of like the really hardcore Globers, and he was basically like coming up with these arguments that stumped, like was able to stump like the Pharisees basically. Like they thought they would have him, and then he'd come back with some like something really clever that like you couldn't even say anything to. It's made them look dumb.
yeah, and they would just leave confounded. Yeah, it's a great analogy actually. Speaking of that,
yeah,
the Pharisees came thinking they were about to slam the book at him, and he just mental jiu-jitsu'd them, and they left confounded.
Yeah. No, he had like addiction to it though too, because isn't there a part where there's one of the feasts in Jerusalem, but he already knows that like if people catch him, he would be arrested or stuff like that, and so he's like, I'm not gonna go. He lets everybody else go, but then he ends up going in disguise, and then ends up arguing with Pharisees there. Yeah, it's almost like he had like a passion. Yeah, like they're not addicted, but like he's just like couldn't get away from it.
Dude, even when he healed people, he was like, I'm gonna show the Pharisees now. I'm gonna heal them with mud. Because they said don't work the dirt. They said don't work the dirt on Shabbat. And they're like, don't spit on Shabbat. He's like, I know what I'll do. I'll spit on the dirt I worked to heal this guy.
Huh. I don't remember that part.
Yeah, he healed the blind dude by spitting on the dirt and putting the mud on his eyes. And then he told him to walk over a day away and then go get into the water because all of those things broke the rules that the Pharisees added.
Is he the blind guy or the guy who was possessed? Wasn't there a guy that was possessed
guy.
that he
the possessed? Yeah. He was like
put the spirit into the pigs or whatever.
He like could tell that it was the Messiah, and he cast the demons out. Yeah, they went into the pigs and then went and drowned in the water. That was crazy. It describes that dude as like running around naked in graveyards trying to like interact with spirits.
Well, wasn't that one of the like this is the way I always thought about that, was that like assuming that's almost accurate what went down, that could have been one of the straws that broke the camel's back. Like if like that dude who owned those pigs was like just kind of saw it differently than obviously people who read about it see it. Like he's like pissed off that this dude just killed all his livestock and he's like causing that kind of trouble. And then it's like those kind of people were probably the ones who were turning against him. That's why I see it, at least. Dude's like,
yeah, like the Glover would have been mad that he lost his pigs, and the True Earther would have been like, that was dope.
Yeah, maybe, yeah.
Bob the science guy would have been so pissed about his thing, bro.
But
That's all
I've
right.
toyed around with that idea. I toyed that idea about like that analogy between that community, because I was working on a screenplay that was actually sort of about it was like about Jesus based on the Jefferson Bible version of the story. Well, not version, but using that as the what I was writing. But I was I was thinking about it in that sort of like that relationship between the Glober and the Flat Earther, but like that not a regular Glober, but like those really hardcore Globers that often Flat Earthers can kind of make look foolish, at least to other Flat Earthers, you know. I don't want to name names, but there's dudes like that.
Who?
Mike Nate?
I just don't want to name.
I knew you
Well,
were gonna
no, there's
say
dudes.
something.
Okay, so yeah, so I mean, there's a lot of Flat Earthers who do it, but I'm saying the Globers that end up
Yeah, but who
look
are
like
these Globers?
I don't want to name names, dude.
You, man, you.
Me?
I would say like me and you, Nate,
Mm.
we're almost at the same. You're probably even you'd be of less less of that than I am. But there's people who are
Thank you.
very much that guy. Like
Yeah.
I don't want to name those people, but
Yeah, could never be me though. That's what's up.
If you're
Be you
talking about
sometimes,
Globers that are a liability, Zanuck told me that both sets of stakes would be the same distance, Kosho.
I don't listen. Did you see the GIF I made for you, dude?
Liability. He's a liability. Zanuck is. He's turning. He used to be good, but he's turning into a Glober liability at this point.
That's such a funny way to put it.
My buddy, dude. So I'll say this: flat destruction. That'll be my example. Okay? Flat destruction.
You don't like
Yeah,
that
but
guy, do you?
No, I don't. But yeah,
it's funny.
what's its debate?
Saying called him Scrappy Doo one day. The funny part about him though is every time he says "watch this" and then nothing happens.
No, what's it doesn't. Yeah, yeah. You know him. You've debated him several times, dude, and I know you hate him. His name's
That
David.
black guy. Yeah.
But yeah, I didn't know he's a black guy, and I called him a monkey. Just like because he was pissing me off,
Holy
dude.
shit.
You remember that? Yeah, so I was like, yeah. I was trying to be polite. So I just tried to think of something silly to call him. But he made this huge big deal about it because he said I was racist. I was like, dude, I'm black too, dude. I wasn't trying to be racist. I didn't know you were
I
black.
was about to say, aren't you black? wait.
Yeah, so I didn't mean it in a racist
You guys
way.
say the black guy? What does that mean, dude? What's his name?
You debated him on modern day debates twice recently.
Oh,
his name's
the
like
Leo
David
guy?
something.
Oh, David.
No.
Yeah, that dude sucks.
Yeah. Yeah.
Dude, Kai
Yeah, he's
thinks
known as
that
Flat
dude
Destruction.
is so funny.
Yeah.
Yeah. Where?
Flat and Destruction. He hasn't come around to Discord in a while, but when he did, it was so annoying. But yeah, he was Flat and Destruction. Was his name.
Yeah, that's a good example. Yeah. Honestly, almost everyone I'm debating on modern day debate's a good example. You guys are way better than the people that actually go on MDD.
Sometimes it's too much. Yeah, the way I don't know if it's the way they format the show. Actually, you know what? It kind of is. It's the 2 and 2, but the way they do 2 and 2 is not really conducive for constructive debate. I don't think.
Dude, both
not
Mark
like
Reed and PH
yeah.
Tony were 1v1, and they were utter embarrassments for the Globe. They recruited more people than the Flat Earthers this stream have in a year.
Back and watch that one, the PhD Tony one. I heard about it, but I didn't see it.
That's brutal, man. It's not even. I'm not even talking about whether or not his arguments could have been good. It's that he was just an emotional mess.
Yeah, he couldn't control himself. It really was bad.
Yeah, bro. And then if you go read the chat, if you go read the comments, bro, there are Globers that swear up and down he destroyed me. I'm like, what? He couldn't handle even me speaking. Like, I don't know.
I feel like people can be more effective if they stick strictly to the arguments, but some people, I don't know why, especially just on that show, just I don't know, they're talking about like other shit. like I don't know, like irrelevant like personal stuff or something. Yeah.
Well, it's like a big appeal to emotion. He's like, they're all like, if we can really paint this narrative that these people are just holding the world back and they deny science and they need to be stopped and blah blah blah, then I win, you know. So it's like that's all I've been running into lately on there.
Yeah, well, it's just I don't know. I guess it's effective because I don't know, gets some people going, but yeah, I think it's maybe just for the entertainment value. That
Dude, if you guys really think that the Earth's a ball, you need to get a hold of those people, man. They are not helping your cause. Like the Leo dude, there's a dude named Leo, light skinned black dude. He was like, he swore up and down for 20 minutes that if the radius value is wrong, that doesn't mean the model's wrong. I'm like, what the dude? Like,
I don't think I've seen that dude.
Someone with just basic understanding is gonna go look at that and then be like, "There's no way he's right," and they're gonna be like, "Dude, the globe is stupid."
Wait, let me just make sure I said the right person before, because the dude David, he's a light skinned black dude too. Like he's a dude with the mustache. That I think.
Yeah, he looks like looks like a black.
Yeah.
Yeah.
I remember you said Kai. You said Kai said that, or Kai had a picture of it. That's funny. I saw that.
Yeah, Kai sent a picture of that so fast.
Yeah.
It's like during the debate live. He like had a side by side.
Yeah. I don't know who that Leo dude is, but to be honest with you, this is my personal opinion that like I know I wouldn't be happy, or I'd actually be upset if the flat Earth for some reason dissolved or went away. So I don't mind that there's people out there making the globe look bad and creating more flat earthers. More the merrier, I guess.
Well, you got nothing to worry about, bro. Flat Earth doesn't go away, man.
Yeah.
Contrary to the talking point that it's dying out.
Yeah, I don't know if there's a way to really determine if that's true or not, because of the whole like the sort of scaling back on YouTube thing. It's hard to gauge that, but I think that's why people say it's decreasing, just because there's less content. But
well, did you know that? They just tried to shut TikTok down, right? Like in Congress. And if you go there and you search up hashtag flat Earth, it's got 1.8 billion views. Like with just that hashtag alone. I mean, there's Space is Fake and Space is Gay and all these other ones that have millions of views, but just hashtag flat Earth has like almost 2 billion. So
you
TikTok alone shows you. Yeah.
But don't they want to shut down TikTok because China owns it or something?
Yeah, that's what their cover story is. The truth is that it's really hard to censor content that's being made that fast and that short. So, TikTok does censor, but it still gets out there.
I wonder if the algorithm.
And then there's the whole environment on TikTok is everyone knows, like, oh, people get deleted, go immediately follow their new account. So like, yeah, it's just like the whole environment. I'm actually about to get on TikTok. I'm sure I'll get deleted pretty quick, but.
Chemo was I think he might still be kicking on there. And who was it? It was Riley. I think Riley was.
Chemo's
Riley
killing him on TikTok. He debates all the time.
Oh, you on TikTok as well, Jeremy?
Not like that. Not really.
Dude, Jeremy watches 5-hour documentaries about fucking old retards.
It's just not 5 hours plus. It don't count.
Yeah. But no,
the thing about TikTok is it has those liability Glovers, like, who are very, very popular. So it's just such a bad setup for the globe.
I mean, to be honest, TikTok has liability flat earthers too, though.
Oh yeah, big time. And those are the ones that don't get censored. When Caleb does a debate, and he's still like Flat Earth 101, but he's articulate and he's logical. So when he does a debate, they actually kick him off. But when any other flat earther does a debate, they don't. Like, they don't even hide it. They just blatantly censor for whatever reason, Like, they're like, I don't like this guy. He's getting censored, so.
They do debates on TikTok?
Yeah, but you have to like screen record them, and if they strike anyone down, you can't download it, and yeah, it's a whole thing. There's a dude named Globy McGlobeface who I guess is real popular on there, who's like begging me to debate. So you can tell he's already a cool guy with that name. So
Yo,
that's
Mike,
like
isn't
what
there?
you got.
There's that
Globy
flat Earth chick
McGlo-
on TikTok.
What did you say?
What's
There's
her
what?
name?
Globy McGlo-
Well, my
Can they
heart
say
might
again?
be.
Globy
There's that
McGlo-
girl on TikTok. The flat
Oh
Earth.
yeah, dude.
Oh yeah, dude.
Yeah.
Yeah, dude. Those the people came after her, bro. People came after her, bro. Let's just say that.
What was her name?
She
Why don't you
Jenny
bring her like
Breast.
Jenny.
yeah, bring it to the Discord. What's it?
Maybe like she's kind of a normie in a way, but yeah, I just say some people went after her, man. Some people went after her, and she's not really feeling it nowadays because like they literally tried to get her business shut down, and they completely screwed up all of her appointments and fake booked them and left all kinds of fake reviews, and yeah, just like ran her business into the ground. She owned a place that did hair and like spammed her with like sexually explicit pictures and messages, and you know how the Glovers be.
Damn, that's
Glovers. That's
fucked up.
probably Jeremy and Kimo.
Excuse
Yeah.
me.
Yeah, she was a babe though. She had nice assets.
Yeah, they were fake.
She was an ass. Yeah, I know. Yeah, they were. I said that on Jim's show too. Actually, but regardless, yeah, I think she was also fake a little bit. Possibly not authentic, but I don't know.
What do you mean? Like
Just
she's not a real
No,
really,
flat
she's
earther?
for real a flat earther for
Yeah.
sure.
Yeah. I just noticed by her views, like because she would talk about different topics before that, and most of her views started spiking when she started talking about flat Earth, and she didn't seem to grasp the points that she was expressing. So it's like it seemed like she was just saying them because she had heard them, and I don't know. It didn't seem authentic. But,
Well, I think a lot of people do that for both sides. I mean, you know.
yeah.
Like the Globers do that all the time. Like if McToon says something in response to my argument, I know for a fact that I'm gonna hear it a million times, no matter what it is. Like that new article I was dropping the other night, like a few hours ago, where it says like, you know, the relationship with the law of gravitation and Coulomb's law naturally arises, and we've proven empirically that gravity is electromagnetic in nature and all this stuff. When I start bringing that article up, and that dude's got all these crazy good credentials, every single Glober almost is going to say, like, does he think the Earth is flat? You know, like, because once one says it, they're going to all say it.
I got news for you, dude. I was thinking about this earlier. I don't know who says that. I hear people say it though, and I think it's such a weak thing to say, dude. It's like, I don't know. It's like if you don't have an argument, you don't have an argument. But that's like a really bad argument.
Yeah, it's like the worst.
Yeah. Yeah. It's like if you guys are bringing somebody up or bringing up some evidence or something, blah blah blah. Like, okay, well, does that person think the Earth's flat? Like, dude, that's not the point of it. Just not the point, dude. They're trying to debunk something on our side or something like that. So
Yeah, exactly, dude. Like in that seismology debate or whatever, this is what it turned into. And he's making all these claims about like seismology, spherical seismology. He's like, it works always. It always works. I'm like, no, actually, it doesn't. You know, and I'm like, okay, here, I'm dropping citations because he asked specifically for citations because I said it doesn't always work. You're lying. So then I start dropping citations. He's like, these all debunk you. What did they say about the shape of the Earth? You know, I'm like, what a retard. Then he's like, He's like, it's always less than 1% error. I'm like, when we're talking about the velocity anomaly, I'm like, no, here's one instance already that's 40%. He's just like, what's the conclusion about the geometry of the Earth? This debunks you. You're lying. You know, I'm like, what the? Is this guy think the Earth's flat? It's like, imagine if you could never bring up a source unless you believed everything that they did.
Okay, well, I'll say this though, that even though that argument sucks, it's in certain contexts it might make sense. And it's possible. I got to watch that debate because I'm not sure, but I know that what's his name, Conspiracy Cats used to use seismology arguments in a debate against somebody, and I don't know if that's what that PhD Tony guy was trying to do. I've never seen him argue anything, so I don't know. But,
Yeah, I mean, I
but
know
yeah.
the best globe seismology arguments now that I've looked into it since that debate, but he was just so emotional he couldn't even get to it. You know what I'm saying? So
Yeah, like I said, because what it sounded like, I heard somebody talking about the other day, and saying that, yeah, he just basically just threw that out there as does the person agree? Like, did he think it was a flat Earth? It's like, no, well then, yeah, you know, you can't use this evidence or whatever.
I'm just glad I didn't go to the same school where he was a teacher. Like.
I don't think I've seen that guy debate before. I've heard his name
So
before,
there's
but I
the
don't think I've seen
fallacy
him.
of stolen concept, right? So like if you like take a source and you take like their evidence that basically requires their conclusion, and then you just take it out of context and claim that it's something that is for you, then that's a fallacy, but it's very specific parameters, you know. Like if the part you take basically requires their conclusion as a whole, like you can't take the piece out without the whole. And that's such a rare occasion, you know. Like if I bring up this paper showing that like even in your own paradigm gravity is electromagnetic, just to prove that that's kind of what I'm saying, it's specifically as a rebuttal to these people that claim that I'm stupid for even insinuating the idea. And they're immediately going to say, this talks about black holes. This talks about the Big Bang, you know? And I'm like, okay, well, don't leave the house without supervision.
Yeah. Yeah, but I guess whatever that fallacy is, what's the fallacy again? Does it describe it again?
Fallacy of stolen concept.
Right, and it's when you use it. So it is real. It's when you use something sort of contradictory to what actually the point you're making is contradictory to the point that they're making.
About the
Overall.
specific part you're making, like, yeah, like if it's not that you have to agree with their conclusion. Like you can invoke them because they found certain evidence. But if you're invoking like their opinion, but taking it out of context, right? If you're invoking their opinion, but taking it out of and misrepresenting it, then that's the fallacy of stolen concept. If you're misrepresenting their opinion by taking a piece out of the whole. If I invoke a scientist that did an experiment and I disagree with his conclusion, but I'm like, look what he found, that's totally different. If I invoke a hostile witness, that's totally different. But
yeah, because I was going to say, yeah, because I've done that QE so many times because he'll pulls up citations or something, but like the next sentence in the actual thing is like literally opposite to what his point is. So that's more, yeah. Like,
yeah, like
it's basically
you
cherry
got
picking
me
otherwise.
kind of one time. You got me, yeah, sort of like about I forgot the astronomer's name, but he goes on, but still not really. Like when we got to the bottom of it, it still was supporting my point. You know, like I wasn't saying that dude said that heliocentrism was impossible or something. But
oh yeah, I know what you're talking about. Yeah, you're talking about one of the quotes. Right.
Yeah, but that, I mean, yeah, when you got to the bottom of it, really, specifically the point I invoked him to support was still true. But look, you have like, it's right here. The act of using a concept while ignoring, contradicting, or denying the validity of the concepts on which it logically and or genetically depends. So it's a very specific fallacy. And I don't think the Glovers need to even be saying fallacies out loud quite yet. You know, they need to learn the basics.
Okay.
I'm serious, man. I'm serious. Someone tried to defend his accusations in the comments by bringing up the stolen concept fallacy, and I'm like, buddy, you don't know what that means, man. Logic is not for the faint of heart. You got to really learn it.
Science, the science employs logical fallacy sometimes. And that part's kind of it sort of makes it rough, where logical fallacies can be used exclusively.
Well, what do you think about
like,
the
for
whole
instance, like
Good.
the mind what?
The dude named Mindshock. Have you seen him break down our like the globe Earth debates?
I've heard many people talk about him, but I've never seen it. I don't
Yeah, but
think
you gotta watch it. They're just gonna so they're gonna say that he's actually a flat earther. He's not, and that he's biased and he's just calling out the fallacies. Like, yeah, that's one of the perfect examples of how you guys are shooting yourself in the foot. You know, say the Earth is a ball. Obviously, I'm collectivizing you, but
that's what I'm saying. Is like there's a lot of examples where like where something can be a logical fallacy, but is actually still a valid way to do science, like affirming the consequent, and in like creating a hypothesis and an experiment and that kind of stuff. If your conclusion was affirming the consequent, that is a fallacy, but you sort of have to affirm the consequent to even come up with your experiment, I would think, right?
like, look at
In
this
some
Slickwood dude
cases,
talking about like I've never heard
yeah.
you claim gravity was electromagnetic. You claimed it's electrostatic. Why have you suddenly started? You said it's electromagnetic. This guy, man, his claim against gravity is that it's electrostatic. Now he says he's always said it's electromagnetic. What a joke! Like, how desperate? Like, first of all, buddy, I've explained the whole time that if electromagnetics was properly understood, then that would be what it's called. I can literally pull up videos of me on my YouTube for the last like 2 months saying electromagnetic specifically, explaining I wanted to make sure we started using that word because it needs to be properly defined, but that it's intrinsically electrostatic because electromagnetism has that component. And that's exactly what the paper says. So I don't know. It's just bad, bro. Like, you're doing the same thing me and Coach are talking about, man. You know, like the way you guys make arguments, it breathes life into flat Earth. Like, I'm just saying, if you actually want flat Earth to go away, or you're trying to make sure people don't fall for it, you're doing the opposite. I gotta get these tires changed, man. I gotta go in here.
Why you gotta do tires so early?
I just booked it super early because I needed to do stuff today.
Yeah.
Yeah,
I
I stayed up
find
way
it.
too late.
I find funny that the people who are criticizing you never want to talk with their mouth, but rather just hide shit. Because that says all, Like, that's the proof for me that they actually just gaslighting.
He like doubling down, and no flat earther will call him out. Yikes.
Yeah. What should you do? If people want to live on a spinning, wobbling globe, so be it. Doesn't make it reality, though.
Yeah, but doesn't it sound fun?
No. I'm happy that reality is that there is a Most High in his tabernacle above his creation, that there is order, that there is truth and lies, that there is false and right, that there is up and down, that there is female and male. Yeah, and that there is in general truth, That
Well, I mean,
the earth is firmable, firm and stable, has its foundations, that it has its ends, and so forth.
Well, I mean, you're easy to please. It sounds like some people
Easy to please.
Yeah, you said like you're happy. That
Yeah,
there's up
I'm
and
a
down and
simple
stuff.
man. I'm a very simple
That's
man.
good. That's a good thing. And some people are more. It takes more to get them going. So
I just don't like stories, you know. I'm not like when I was a child, maybe, but when I've grown up, I just don't like stories that have no evidence in reality, like a spinning, tilted, wobbling spaceboard where water sticks to it the first time in history.
Just don't like fairy tales, man.
Yeah,
You
exactly.
don't like fairy tales?
No. Boring. I like real things. I like real people. I like reality in itself. I like the truth.
And I like you.
I like you too, P-Mac.
Sounds
my dude.
That's nice.
That bonding session over. Ojo. I'm sorry, AI.
AI. Wow.
Yeah, you just change your name to AI.
Those are my initials.
Okay. In brackets, Kojo AI.
You say you hate the AI, P-Mac?
I don't hate AI. How can I hate something that's just a fucking thing? Why would I hate a thing?
Well, you can hate anything.
I don't hate anything. That's my problem. That's why I look so young. I don't hate anything.
That's a good one, man. I also don't hate anything. I mean, that's why I look so young. Hate is just such a energy waste, time waste, and just at the end of the day makes you hate yourself. You know.
Yeah, it'll
I don't know
tear you
about
up
hating
inside.
yourself.
It'll tear you up
It
inside.
definitely does hurt yourself.
Yeah, it
why
will hurt yourself.
why hold on to that thing? It's like a cancer growing
Exactly.
inside you. It's
Imagine imagine your whole life is about thinking the people that you hate or something. How boring.
exactly like you're spending your whole life thinking, if I had done this, if I had done that. It's like this person was a cock to me. This person was a bad person. And you just tear yourself up inside. And if you just let it go,
Right. When I turn off this PC and I'm in nature, I don't think about anyone that is on here, you know. If it's not if someone, I mean, speaks about something very like bad that happened in his life and he needs like help with it or whatnot, yeah, then I think about what this person told me.
sure.
But in general, like once this PC is off, I go in nature or I drive my bike or whatnot. There's not one thought about what
Negativity.
kind of negativity. What kind of people I don't like or whatnot. You know, it's
Nothing
just,
at all. No. Yeah, exactly.
You want to hear something you might think is kind of lame, but it's true.
Yeah, sure.
I used to do this. Like
Sure.
if I have bad exchanges with people on here, or like in the other servers or whatever, I'd make a list of the people that that had bad
So
experiences.
I could teach you a thing or two, but sorry, go ahead.
Hold on, P-Man.
I didn't finish.
But like I would make a short list of a few people who like kind of like I had tension with recently or thoughts, So, anyways, the point is, I would write their name down, and then I would write down something nice that I could say to them next time I see them or talk to them, or whatever.
That's nice, man.
Yeah, and I would try to do that,
that's
and yeah, and it sometimes it actually it worked. I don't do
you
that
actually
anymore.
write it down?
Yeah, I write down a lot of stuff. So
I appreciate that you talk about this. You know, it's a great thing. You know, not many people would do that.
I hope I'm not on that list, man.
Well, I mean, there's people who don't forgive people years and years ago, or whatever. That kind of stuff is not healthy.
Whatever conversation we had, Kosho, no matter how the outcome is, I still love you as a human being and as my brother, because that's what I believe in. That I have brothers and sisters all over the plane, And yeah, like I have literally no backthought about you or any other global. Like there's like, I mean, I still remember certain conversations, but I don't have like I can separate things, right? I separate that kosher that is maybe defending one belief of his, same way as I do, from the human or brother that kosher is. Does that make sense?
Yeah, absolutely.
Yeah.
I mean, that's the way I am on here now too. Is I guess people
It's
I
like
disagree with.
business talk.
Yeah, yeah,
You know?
basically, yeah. Like at the end of the day, like we're still associates, and we might have like you know like Christmas dinner, Christmas parties and stuff. But you know, like sports, like professional athletes, like on the court, they're in opposition or something, but they may still be
Yeah,
buddies. Like
exactly. So I mean, opinions, things within the brain, or things we say, don't change the simplistic truth that we can all get along with each other, no matter what we think. Like that's such a simple task to do as a human being if you just love one another. It doesn't matter what the other person thinks.
Yeah, I think Leflin expressed that a couple hours ago. I think Leflin is well. He expressed how it would be far better if we just get along. No need for contention. No need to call each other names or anything.
Yeah.
Leflin, yeah, it's not my persona.
Even though it sometimes happens, it sometimes happens that people get aroused, and in the midst of that, people attack
We
each
all
other,
do,
which is human. It happens. Well, it's important to forgive each other, which means just get over it, just forget it. Like the same way as some people maybe
It's not important. It's not
Yeah,
important.
it's not important to drag everything behind you, that happened in the past. The past is the past, the present is the present. That's always how I look at it. Like I tend
mean,
to also
if-
forget certain things, I think forgetting about certain things is also not bad.
Just not holding on to it. Yeah.
Yeah. I like to hold on to as much positive things I get from either side, from people on here. So I have much more positive things, of course, to remember than some negative things. Not saying that there isn't negative things I still remember, but I like I said, I try to see all the best in people.
You remember that time we were looking at that Orion footage and disappeared
Yes.
and reappeared? You got so upset that
I know.
that what I was saying was silly, or I was I think that's funny.
And maybe some expression of mine were unfair. Maybe some expression of mine were unfair, and I'm sincerely sorry. If the way
it's all right, man. It's no big deal.
Yeah, I'm just saying it could be. Sometimes that's the way I see myself. I'm also imperfect. I also sometimes just maybe be a bit rude or whatnot.
we all do it, bro. We all do it. We all do it.
But things like that don't really offend me. It's par for the course, and this it's kind of what we do. I mean, if I show you something that I think is reasonable, I expect to be ridiculed for it. So it's not. I don't get offended for stuff like that.
Right. I'll be right back. I have something in my oven.
But you made some steak pasta the other night. It looked real good. I bet you eat some nasty shit, P-Mac. Like, what do you call that? What's that shit that they eat?
Shut up, man.
Mutton.
I'll eat fucking you. I'm hungry. What are you talking about?
You eat like boiled chicken.
Boiled? Yeah. What do you think we do here in Ireland?
I thought you were in Scotland.
So did I. And then I turned out I'm in Ireland.
Yeah, fair enough. Actually, I think I knew you were in Ireland.
I know why I sound Scottish. Even my daughter says to me, Dad, why do you sound so fucking Scottish? I don't know, right? I grew up in South Africa.
Did you really?
Yeah, really. True story, bro. She was like, hey, Dad, why do you sound so Scottish? I don't know. I have no idea. It's just the way the words come out. You hear them, you interpret them. Good luck.
How many years did you live in South Africa?
Most of my formative years, from 6 to fucking 25, I grew up there. I can nog Afrikaans praat. I mean, I can still speak Afrikaans. I can nog Afrikaans praat. It is not natuurlijk. It's not natural. It's a combination of German, Dutch, and Flemish. Or
Yeah.
something.
Yeah, they have distinct accents. So I guess that's why your accent is different than regular Irish, just because it's like it's mixed a little bit.
Yes, it is. It's very mixed. So there's a guy called Bob at the place I work, and he's from, wouldn't you know it, South Africa, Cape Town. And I walked in and I said to him, "Hello, Bob. Hoe gaat het?" He says, it goes good. And I said, lekker zoals een cracker? He says, oh, shit, you still remember all that crack? Yeah, you know.
And I don't know if it's because you're Irish or because you're trying to speak a language I don't know, but I got no idea what you said, man.
I can do Martian.
I'm sure you can.
Yeah, we don't go there. It's Martian, bro. We don't go there. Anyway, bro.
You know why I
This is
thought you were
so
Scottish? Is because we've talked about drinking scotch together, and you said that you have scotch made where you live. You told me that.
I did. No, you're lying,
Yeah.
bro.
Yeah,
No,
you said I can come visit you.
Yeah, no, you're misremembering shit. Oh, you can come. Anybody can visit me anytime.
What were you saying? Was it?
What was that?
Oh, I was just saying, I think it's funny. It's like this guy really thinks he got me because I say electrostatics and this says electromagnetic. I don't know. I just think it's funny. Like, dude, do you know how many times I've had ballers like just call me so many names for saying that gravity is actually electromagnetic?
40.
I got probably over 100 easy.
I got to read that paper because it definitely sounds interesting, but word of caution. And you probably already know this, but I mean, a paper is not on its own. I mean, anybody can publish a paper as long as it's done right.
But this guy is like super credentials within your paradigm. Like, I'm not saying that this is true because this guy says it. I'm saying that all the Globers that constantly say you deny science and you ignore all the physicists and you think all the physicists in the world are wrong and if what you're saying is true, all the physicists would know. I'm just invoking a guy that's like way up the ladder within your own paradigm, saying the same thing that the Globers ridiculed me for.
Yeah, I gotta check it out. Are you available to post the PDF? Because I can go back to the article, the link or whatever.
Let me find it. It's on my Telegram. I can drop it from my phone.
All right. But yeah, if 'cause I want to check it out, and I mean the thing is, things like that, they're interesting because a lot of that stuff is like somebody's gonna come up with something that's gonna be cutting edge and like even Eric Verlin, like what was cool about his idea or whatever was like there was tests that showed that like it was validated basically in observation, although part of it also was shown to not be true. So he's redoing it now. He's like reformalizing it, and who knows, maybe he'll come up with something. But what was cool was that it made the predictions of the observations of dark matter. So, and there was things that it predicted also, like new things it predicted that were observed. So,
Right. So, what? Sorry. Dark matter? Really?
Well, yeah, well, dark matter is currently like an error or like an unknown sort of thing. So it's like if you come up with a model that explains everything that we already know and observe, plus it also predicts dark matter, that's pretty powerful.
Right. So you mean like 95% of the universe was known, and then suddenly humans they couldn't compute, and therefore they made up dark matter? Dark. Dark means like
It's
no
very
light.
accurate, but
Bro, it's insane to me. Dark matter, dark energy. Fuck.
Vader.
Well, don't you think that's just
Dark
something
chocolate
they
factory.
made up in order to make other shit up? Don't you think that's a thing?
No,
No.
they
So
made
you
it up
look up.
because they don't know what it is. So it's like X-rays. Like X-rays, they
Right.
don't know what this is. So
So humans don't know
X-rays.
everything. So, but they know how the universe was made, right?
They don't know how it was made, but
No, they
we
do.
have we have
Excuse me.
ideas. We have it's
Yeah.
like a detective. Like even whenever you charge somebody and they lose the case and they're going to prison for murder or something, you didn't necessarily prove they did it, but evidence kind of shows that they did it. So it's the strongest conclusion to come to. Yeah.
Yeah.
Yeah. There's no
Logic.
guarantee it's the truth, though.
No guarantees of truth.
I think it's a weakness that like our model changes or Big Bang model changes or whatever, but I mean that's sort of what it's supposed to do when you learn new things. You cut out the weak stuff and the wrong stuff and strengthen the what you think you know about the actual nature of it.
What you think you know.
Yeah.
Yeah, but you know shit, bro.
But it's better to try and come up with something than just to settle on not knowing.
So it's better to believe in something that somebody made up rather than trust your senses.
Yeah. As long as the thing they made up has some veracity, validity, logic, reasoning behind it.
Yeah, so logically reason, ball earth.
Good example. Yeah.
An example? Well, earth, bro.
Said that's a good example when you just said.
That's a very good example. That's the one we're living on, right? So logically reason, balls of spinning balls of water. Yeah, logically reason that. Put it in your mind, make a thought experiment, and see if it works.
Okay. Now what?
Well, do you see it?
Yep.
Is it plausible?
Yeah, seems so.
It does, yeah. Like you're just saying yes because you're just a fucking yes man.
Because I'm wrapping my leg up. So
Imagine the world. Imagine a big ball of water spinning in infinite space, moving at whatever fucking degrees an hour. Sorry, I said degrees instead of. And then logically put that in your mind. Is that a
right,
real
easy.
thing? It's easy.
Seems so, yeah. Very easy.
Right. Now do that.
You traumatized me for a second, dude, because I had Jeremy's trains inside of trains fucking. Yeah, go ahead.
Train your mind, bro.
Change my mind?
Train your mind.
Oh, train my mind. Okay.
Yeah, sorry. We're not supposed to talk about trains on here. I mean, it's the most ridiculous thing you ever heard. Really.
What's that?
Why does somebody that's so intelligent as you, who believes in AI, believe in a fucking spinning water ball? I can't wrap my head around it.
I mean, there's 2-year-old Down syndrome kids who believe in AI. I don't think that's a sign of intelligence. But
Why are you talking about Down syndrome kids? Where'd that come out of?
I'm just giving you an example.
Alright, give more.
There's 50-year-old vegetables who believe in
vegetables
AI.
like carrots.
Yeah. Like they're in a coma. They're in a coma state.
Don't you think the world is in a coma state?
Sorry, give me a second. I'll put it on my. I'm wrapping my leg up, put it on my socks. Give me a second.
Put on my socks. What the fuck, bro? It's the most ridiculous thing.
Yeah, I'm gonna slam this back down the Glober's throat so hard they're gonna get so tired of hearing about it. Yeah, gravity is actually just a hijacked electromagnetic phenomena, which is intrinsically electrostatic, and of course, electromagnetism and electrostatics, which is sort of one and the same, like one side to the same coin, is significantly stronger than gravity has even claimed to be. The only problem that you guys will now face is that, of course, that would not allow gigantic masses to revolve around each other at immense distances. There's a vastness of a vacuum. So it seems that we may have run into a problem within your paradigm.
There is one interesting thing,
What's
and
that?
I'll probably relay it incorrectly, but you know, when it comes down to quantum particles, like the electron, let's say the electron, its mass is represented by its energy, by its charge. It's a description of its mass because at the fundamental level, that's what mass is. And if mass and energy are the only, they're what the space-time responds to that give us the effect of gravity. I mean, there probably is some relationship there in that regards, but I'm not sure. I know for a fact that's not what the paper is talking about.
I'm just listening to you sort your own head out. You're starting to realize that you're talking gibberish.
All right, few minutes. You call me.
Hey, you're all right, bro. I can hear it. I can hear it in your voice.
I'm tired, man.
Okay, maybe that's it. Logically,
This paper really it's addressing the whole like. So the author of this paper agrees with the 10 to the 120th power estimate, but it's not really built upon that. It's like it's saying that the charge density of the vacuum state based on the dielectric, or more so the electric permittivity and the magnetic permeability of quantum state fluctuations in a vacuum can be utilized to demonstrate that gravity is actually electromagnetic in nature, and that this very effect, like the effect that's attributed to gravity, ties directly into electromagnetism. And he says, of course, we can see that the connection between the law of gravitation and Coulomb's law of electrostatics arises naturally. So it's basically like, it's like kind of what I've been saying. So, like, it is obviously he's still he's trying to explain the assumed cosmology, but he's saying that the current cosmological model, just as is known, right, like doesn't work. will have to be replaced. And he said he thinks that this avenue will potentially open up possibilities to explain the dark matter and dark energy discrepancies and the flatness of the universe discrepancy. And the Big Bang's got to go because everything coming from a singular point already has gone unanswered. The flatness problem's gone unanswered. So basically, that the solution is redefining gravity as an intrinsically electromagnetic phenomena, and then remapping the cosmology.
Interesting strategy. But I mean, at the end of the day, something's going to have to be examined. Like there's, even though Einstein's model, I firmly I think is successful. Like I said, I've said this before. I think that the setback is probably somewhere in the basically just the interpretation of what's being expressed, like in his theories. Because like his theories are obviously there's correct. Yeah.
That's why I always bring up Henry Poincaré. I try to like give you guys help actually in that sense. Like, Henry Poincaré proposed like the same geometry as Einstein. In fact, when it comes to predictions, experimental predictions, his theory and Einstein's theory are identical. There would be no experimental distinction, only a conceptual one. But the conceptual difference would spill over into space. So that's when you would run into having to change things. But we already know that, like in your paradigm, things have to change. And this is one reason. Henry Poincaré, of course, proposed relativity before Einstein did, like a year before he did. But this is one of the reasons that flat Earth will go nowhere. Because the people that are defending the globe, they're defending like the archaic cosmology as well. So like, good luck trying to convince someone that like the modern cosmology isn't just like shitting the bed, like that's why the flat earthers will never go anywhere, because they're like, look at all, this is just a shit show. Like, look at all these problems. This can't be correct. There has to be a major change. And then the people that are going against it are like, no, that's how science works. It's really not that big of a deal. We know so much. But anyone that can intellectually assess the actual situation properly, they're like, no. It's awful. Like what we currently think we know is awful. It's wrong. And look at this problem. Look what they do with dark matter and dark energy. And look at how they just like sweep things under the rug for a century. And so like when the proponents for the globe can't like openly embrace those aspects, then what you do is you create more staunch flat earthers. So one thing that will happen for sure, we will live through a major paradigm shift. And this is one thing that like the Globers can't do. I can actually step outside of my position and genuinely consider what it's like to be a Glober and try to be intellectually honest. As a Glober, being intellectually honest, I know that, say the Earth's a globe, right? Because I'm stepping outside my position, which I don't think the Globers can do. Typically, say the Earth is a globe, dude. You're going to have to move to a geocentric electric universe. Things are going to have to get much closer. There's going to have to be a differently defined medium of space. Like, there's going to be a major paradigm shift of understanding where we live and the cosmology, involved, period. Like, regardless of the shape of the Earth. And I think that Globers would make a lot more progressive steps if they would do that. Like what Grimm does. The way Grimm thinks the Earth's a globe, right? But the way that he goes about it, or the way that Gleam goes about it, Grimm's a really good example. But yeah, that you guys would make so much more progress if you really wanted to combat flat Earth. Like I know you said you would be sad if it went away, but I'm just explaining my honest assessment of the situation. Like we run into people that defend relativity like it's legitimate and it's like the holy grail, and like the current cosmology, the lambda cold dark matter model is legit, so legit, we should bow. Geocentrism is impossible. There's no way ever that we're wrong about our position in space. And I know that was a lot. I'm just explaining. Like that is one of the primary things that breathes such life into flat Earth.
Yeah, I agree with it that an obvious change is going to take place sometime in the fairly near future. They are going to roll out some truths. Do you think that rollout and the shift, the paradigm change, is also going to be riddled or wrought with deception as well, like a half truths?
Absolutely. Yeah, like I think that the reason we're at such a standstill and they're putting off the inevitable update is because no one can figure out how to do it while maintaining heliocentrism. So it'll be, yeah, I think that'll be once someone comes up with a theory that almost no one will understand, just like no one to this day understands relativity. No one alive can understand relativity. It's not understandable. Like this whole, like, Einstein said that only him and a couple people alive actually understood relativity. No one understands it. It's, you know what I'm saying? I think that'll be the catalyst for the update. It'll be like some new theory that people pretend is ingenious and they'll like, wow, this guy solved the problem, but no one will really understand it. And it'll just appear to kind of solve certain problems, but it really won't. There will be a major change, but it'll only be like 1% of the change needed. Just like Einstein. I think that we'll just live through Einstein 2.0. Now, of course, that's with us doing nothing. Like, I guess our goal is to not let that happen. But if you look back, you will see that tons of people fought Einstein, you know, and look where we are now. So, but this is a little different. We have the internet.
Yeah, I agree. We do have the internet, which is a good tool to help better get out information, express opinions to wider audiences. But even with that, unfortunately, the way that most people interact with the internet these days is actually reducing their ability to focus and or have a attention span long enough to utilize the depths of the internet to their advantage for research or educational purposes. So it's kind of like they're winning a little bit on that front, right? Being able to reduce the attention span of the average person, get the average person's attention online directed into useless, meaningless arguments about politics or entertainment via 10-second TikToks of people dancing or people falling down or cats or dogs or whatever. Do you think that there is a generation coming up now that might see that as a norm and start to break away from that, as opposed to generations who have adopted that because they saw it as something new?
Yeah. That's what I'm saying. I think that they're in dangerous waters because they have to shuffle their feet and try to pull off a magic trick to change the paradigm. But people aren't enamored with like basic media now. We're actually bored with it. We've grown bored of it. So, yeah, I don't know how they're going to pull it off. I mean, I think just a major distraction, you know, I mean, like, who's going to prioritize discussing the cosmological model whenever we're getting shifted to an entirely new digital monetary system, for example? I don't think they can just use media. Dude, no one under the age of 30 gives a damn about the news, dude. No one. Like, maybe 1% of people. yeah, I don't know what's gonna happen. It's a very interesting time to be alive. I'm just glad to know that I was able to see through it, like many of us, and like we're gonna go down fighting on the proper, like the correct side. That's all we can do, bro. We're only left to speculate. I think the people that would try to pull off deceiving the masses with the new paradigm also are left up to speculation as well. I don't think that anyone could possibly truly know the answer to the question.
Why do you think people fight so hard for the status quo?
Intellectual insecurity. The weak find contentment in the consensus of ignorance. That's what I think. It's that simple. The need for conformity due to intellectual insecurity and the longing to fit in with some type of group via tribalism.
Yeah. And like an apprehension to change. Like I know a lot of people are very hesitant to change even small things in their lives, let alone their worldview. I wonder if that plays into it, maybe subconsciously
course.
more so. Yeah.
Yeah, because something like this has drastic implications. I think that like the people in this room that fight it so staunchly, not even specifically the shape, just like even geocentrism, they just fight it. Impossible, parallax. Like they are consciously fighting it because of the philosophical implications to their worldview, right? Like for sure. That's what most people in this round do, like in the anti-flat earth. Anti-flat earthers are the real minority. But everyday people, it wouldn't be conscious. So I think it's just change in general. Like with my dad, for example. Like he does his job. He made a family that's now making families. He kind of feel like he did his job. He's towards the end. He's moving towards do we move to Florida and just enjoy ourselves? He plays pickleball and wins tournaments like every week because he used to play basketball, but he can't now. So now it's pickleball. He watches NFL. He watches the NBA. He watches UFC, and that's just what he does. He watches Fox News. He doesn't to stay informed, looks into some stocks, has his routine. He is very content with what he made for his life, right? Like he went to the army, made the Green Beret cut, got put into war, then left, turned down the Green Beret offer, and then did all that. Built himself up through different sales rep jobs where he's at now. He has his routine, and like any of this is would require a lot of time. It would throw a wrench into the whole conformality of where he's at. It would just change everything. He's not interested. It's like he won't even look at it. It's kind of like if you cut your arm, if you cut your arm severely and you just can't even look at it to see the damage. So that's the average person. That's the vast majority of people. And then there's just this small offshoot of people that truly hate the idea there could be a God. And that's the people in this room. That's the people that find themselves in this room. But it's not just, there are some people, I guess, some creationists that are anti-flat earthers. I don't know. I guess they would be just like the idea of science being wrong makes them uncomfortable or something. I don't know. That was a long answer, but that's pretty thoroughly explained, I think.
Yeah. Yeah, no, I get it. Yeah, it's, people do get to a certain point where I don't want to say they get lazy, but they get very in tune with specific routines and don't want to change those routines, right? Like you were saying. And I think we're all, everybody at various ages of life, we're routine oriented, and it's very hard to implement something into that routine or remove something from it. And you're just talking little things that you do throughout the day that all kind of add up to your daily routine, your weekly routine, your monthly routine, your annual routine, and trying to incorporate, or at least put something as disruptive as changing your worldview, which might have implications that are even deeper than that, right? Even deeper than the scientific aspect. You're talking about a spiritual side of it that I don't know if a lot of people want to stare that in its face as well.
I think also the sort of lack of out of the box thinking, and also the encouragement for that.
Right, like you're told which lines to color in and not to deviate from.
Yeah, you're given sort of parameters where you're allowed to have ideas from, but outside of that, you're not allowed to be thinking.
Yeah, kind of like you have to think within the lines, not just color within the lines.
Right, it's not compatible with what's already been spouted as true fact, right?
Right.
Because that's not questionable. You don't look for any other possibility. So then you stay stuck in that routine.
Do you think the fact that most people are like that, it isn't necessarily human nature, but maybe our societies and the way that they've been structured?
Oh, definitely. I think that's way more prevalent in the Western world than it is in developing countries, should I say.
Yeah. Like we've been sold the idea of what life is supposed to be and the stages we need to go through, the credentialing we need to get, the roles we need to have, the jobs we need to do. And we just
it's almost become sterile, the Western way of thinking,
Mm-hmm. Especially even, I mean,
no sort of, it just doesn't allow for out of the box thinking. That's the way I see it.
Yeah, I mean, I remember growing up that
sort of, it's like a rigid sort of, it's like Jack in the Box. That's what we get put in, in the Western sort of world.
Jack had always got out of the box. And then pop goes the weasel, bro. Shout out. That's an awesome name.
Eris not to sneeze.
Not a sneeze.
Eris not to sneeze.
Not to sneeze. Very good.
Irish not to sneeze. Yeah, but it's like we're born into a system that we can't withdraw from until we're at a point where you're kind of committed to the program, and if you pull away, it's, I don't know, like we get put into
like everything you've also, you've sort of kind of invested everything already into it. Yeah.
Right. Whether you wanted to or your parents wanted you to or not, like you're brought up in this system of schooling to where you're not even turned free from it to have the option to continue until you're considered an adult. Right. So, and
Right.
even
So you have to
then,
go through the brainwashing before. Yeah.
yeah, and even then, nowadays to not have a college degree is the same as when I was a young kid, like not having a high school diploma, right? The college now the extra 4 to 6 years of being in school is almost a requirement, especially if you want to follow the script life of having a job and a career. It's almost to the point where in order to hand uh, burgers and fries out of a window to people in their vehicles, you need a bachelor's degree.
Yeah.
We've almost
Take out
gotten
guys
back.
because make them clock about 32K a year. No, I'm just joking. But with inflation, I guess fast food is catching up quickly.
Oh,
Won't they just soon be automated out? Like, anyway, like a lot of like the counter positions and stuff, checkout positions and things like that will just get computerized.
yeah, we're well on the way now. A lot of places you go into now, you order on a screen. You don't even talk to somebody.
Well, so I guess like, well, so like trade school versus like 4-year college education, you're like whatever 6 or 8 year if you do extended stuff where you're going to get into the actual establishment and maybe teach more or something like that, or where it's you can effectively teach yourself the thing that you're trying to learn within about I guess a year's time or maybe a little bit more if you just like really like hone in on it. I mean, the information's out there.
Yeah.
It's just like the certification of going to that technical training or that technical college or whatever is really what's prized. That's really what you're getting, you know, like certification of the training program of that establishment or whatever. So,
which is ridiculous, to be honest with you. Like, I get trying to get people to have a broader knowledge of some of the trades, but it's almost like the trades have been diminished when we pulled away from like apprenticeships, if that makes sense.
Yeah.
Because like somebody becoming an apprentice in a trade at a young age, sure, you learn reading, writing, and arithmetic. Outside of that, like what do you need or utilize from schooling outside of reading, writing, and arithmetic? Pretty much nothing. Everything else can be learned via doing it hands-on or being in a situation, right? And most of that stuff's not even taught. Everything I needed to know from school, I learned by like 4th grade, to be honest with you.
I think they could have taught more about money at school.
100%.
Because they didn't really teach much about that.
I think it's intentional. You know, it's like one of the most important things people need to know in modern society is how to effectively manage their household financially or themselves personally financially, you know, as if you're a business or something like that. That's just not taught at all in school.
And I'm kind of jealous of America that they teach their students how to drive before they leave, you know.
Yeah, to an extent, but we're getting to a point now in America where the generations that are coming up now that are at the age of getting their driver's license, I guess it's a little earlier here. We do it at like 15 and 16.
Yeah.
The kids nowadays have little to almost no desire to want to even drive when they get to that age now. Whereas when I was a kid, like all of us, the minute you turned 15 and you could get your learner's permit, you got it. The minute you turned 16, you took your driver's license test and you got your driver's license like literally that day, as fast as possible.
I was taking off of my grandpa's van at 12, bro.
Oh yeah, I had an older brother and like older kids in the neighborhood, and I started driving cars around the neighborhood. Yeah, when I was like 12, 13 years old.
But it's like, I don't know. It's like at the time that they're teaching you how to drive a car, they should also teach you how to like use a map. But they don't really do that. I mean, they assume that you should know how to use a map, but
I mean, they do teach you that in geography, don't they? Well, they should
just
do.
like what it is like to drive on a parkway or expressway is a lot different than what it's like to drive on a.
Yeah, that's kind of a good point, Snacks. Like, think about this. Could you imagine if you handed a kid nowadays like a Rand McNally Atlas and changed to use a payphone and told them to get from like one side of the country to the other? Could you imagine?
Oh yeah, I just forgot that I'm considered old now. That's why I got taught about maps when I when I was at school.
Yeah, no. If you gave most of the kids that, it would just be like, yeah, just wait to make the missing persons like report on that one.
Right.
Don't make a left turn at Albuquerque, you know, seriously.
Like, it forces you to think when you're utilizing these tools, and I don't want to say that there's no use in technology and advancing. I think there is to an extent. I'm not a complete Luddite, but I am kind of one, because I feel like some of these crutches
Yeah.
can be.
If the word Luddite is in your vocabulary usage, you are self-describing.
Possibly.
Your Luddite projections. Go ahead. Oh yeah, no. It's hard to imagine a world without GPS being available. It just makes driving so much easier. But yeah, it doesn't. There's a lot that GPS doesn't do that it could do. That I don't know why. I don't know why it doesn't try and help you tailor your things a little bit more. But I guess that's like maybe dangerous knowledge for somebody else to be able to intercept. To know all your preferred routes, that you like to go to take rather than what GPS suggests. You know what I mean? I don't know.
Yeah, I agree. And that is also like kind of a problem with GPS or maps or anything like that. They do tend to funnel a bunch of people into specific routes.
Yeah. I guess it's a little advantageous, like when there's a traffic jam somewhere else, but isn't the GPS something to do with that too?
Yeah, there are applications that will try to divert you around those things, but I feel like it's never fast enough, or like I don't use it that often, but when my wife's in the car and we're using something that might try to divert you around that stuff, it's like,
yeah.
By the time
like as advanced as all this shit is, just like I always look at like this is just the breaking wave of the technology, and it's like I'm always at Atari. Atari is always new and amazing, but it's quickly you realize it's got limitations, and then generations later they catch it. Like, but we're at the Atari level with all this stuff, and man, it's like we're in the 80s and the 90s will happen. So, man, I just can't wait for like further integration of these things and to just some of the, I don't know, just shit is so janky, and it's like AI is like programming peanut butter for a lot of stuff. It just makes it better. Everything's better with peanut butter. Anyway, I'm sorry to make you divert. Anyway, yeah, we were talking about just like primary education and stuff like that, being unprepared for the world when you're sent out into it. Right. Personal accounting. That's where you're at before that timeline split. Yeah, maybe there was a cartography class. There might have been a cartography class in high school as an elective, but yeah, I don't know if I'm still audible, but yeah, or
Yeah, no, we still hear you. We still hear you.
my bad. Sorry, you got to put up with it. But yeah, it's like at some point, yeah, why not just standardize like learning and say, yeah, this online course, complete it, listen to it, build a whatever. You could have all different types of ways to qualify the information, and then effectively you've learned that.
Dude, I'm just dunking all over this dude today. This dude's a masochist.
Are you in the chat? That wasn't paying
It was
attention.
funny.
What's happening? You're alley-ooping yourself and dunking. I like that off the backboard. Splash. I'm going to strive to be my own internal John Stockton and my own internal Karl Malone. Airmail it. Anyway, like just to learn a trade of like automotive repair, you could do like a year, 2 years. You probably get most of it. To design an automobile, you need to spend a zillion years doing that. So I don't know. It's like working in an industry or like being able to do that thing. So I think these are qualitatively like why we choose maybe to like pick a degree specifically, which we don't actually like wind up necessarily learning. Like if you just want to be an English major, it doesn't necessarily mean you're going to be this great creator of English literature or anything. You go to engineering school, it doesn't mean you're going to invent a new car or anything. You'll be given even like more than a scratching the surface type of information on those things. Yeah. Yet all these different colleges and universities all offer programs. It's just to get into the field, right? That's just to normalize the.
Yeah, but even with like a sort of a basic completion of English, you can still teach it to foreign people then. Like you say, you don't have to be some great literature poet or story writer or
Right, but how do you go to if I want to like learn how to be, great at that? It's almost like nothing can even teach you how to be great at something either, right?
Jin teaches English, doesn't he?
It's either like people make the cut, you're either Top Gun, you're Maverick, or you're Goose, Well, Goose got in the program too somehow. It doesn't make sense. Anyway, it's like you either make the cut or you're just not that thing. It just seems like there's a cutoff point, and that there's no like working up at a certain point. That's just weird. People are kind of cast somehow. But whatever. Yeah, Kosho was talking about Quentin Tarantino. Quentin Tarantino didn't go to film school famously. Learned all he knows from a video rental place and some acting classes. So, yeah. Self-taught. I guess you can be self-taught, right? That works. Like Tesla self-taught pretty much.
Anything take us away from all this mess, bro. Just talk shit, please.
These people are clowns. So let's just cover this, right? So I've been telling people, I'm like, yo, yeah, gravity is actually nothing more than electromagnetic when properly defined. Of course, that's intrinsically electrostatic. Both of these are extremely strong relative to gravity on the local scale. And to quote Walter Lewin from MIT, it's actually electrical forces that hold everything together on the Earth. It's not until you get out into space on the planetary scale that gravity takes over. It's, of course, because it claims it's proportionate to mass, and electromagnetism or electrostatic would not work in space to cause the immensity of the masses of the planets in your solar system to orbit around each other at through the vastness of a vacuum at immense distances. So you need something else, like gravity. Actually, EM wouldn't work. He said. Then this dude says, "No, I made that up. That's not true. Show the math." So then I show the math using his own paradigm of why electromagnetism wouldn't work with these giant masses to a vacuum at immense distances. And then you got the Globers coming in talking about but gravity would work. You're an idiot. You didn't dunk on anyone. It's like, yo, you people are just a waste of time. I'm just changing my tires. It's the only reason I'm even engaging. Just get destroyed every day. You guys are masochists.
Mm-mm. Does anybody else have something funny to say about my friend Biggest Dickus? Anyone?
Sorry, I missed that. What was that?
Play it
Chemo's
back on
here.
play it back on the YouTubes.
What's going on, Chemo?
Dude, think about the change that's going on. So now that I've found that a very credentialed physicist and professor, like some of the best credentials you can imagine, has published a paper recently in 2022, towards the end of 2022, explaining that cosmology is completely wrong and needs to be updated. And we've shown the quantum scale gravity is electromagnetic in nature. And of course, we should have already seen this because we can see the law